Welcome to the Ultimate Web Development Masterclass, where you'll master HTML, CSS, and JavaScript by building incredible modern projects. In this brand new course, we are ditching the copy-paste method to build responsive web apps using HTML5, CSS3, and vanilla JavaScript completely from scratch. Starting from zero, that is completely fine. You don't need any prior coding knowledge to succeed here. We break down every single piece of syntax for HTML, CSS, and JavaScript, ensuring you understand the how and the why. Best of all, every project is standalone, giving you the freedom to jump in and start with whatever catches your eye. Simply browse the project previews, pick what excites you, and start building immediately. The video lessons are modular, so if you already know the basics and want to focus purely on the JavaScript logic, you can skip right to it. Don't worry about getting stuck. All the source code is neatly organized in a GitHub repository linked in the resource section. This isn't just a class, it's a hands-on experience designed to help you build a portfolio of super cool, responsive websites. I'm Sahand, a professional web developer with over 16 years of programming experience, and I am thrilled to be your instructor. I'll be your guide every step of the way, ready to answer your questions and help you master these skills. If you are as ready as I am to master the web and build amazing things, then let's get started. Welcome back to another exciting project. We will continue improving our web development skills together. We are going to build something both practical and fun. In this project, we are building a fully functional random password generator. This tool will create strong and secure passwords for you. You can generate a new password with just a single click. The final version of our project features a clean container. The title Random Password Generator is displayed at the top. The container holds an input field with a copy icon. You can also find a button for generating new passwords. Go ahead and click the Generate button now. A brand new random password will instantly appear. It is a secure mix of letters, numbers, and symbols. When you click the copy icon, the password is instantly copied to your clipboard. A small notification message pops up right away. This confirms that the password was successfully copied for you. Now, let's open a new tab in our browser. First, make sure there's no existing text in the tab. Then, press the Ctrl and V keys together. You'll see the same password that we generated in our project appear instantly. This confirms that the copy function works perfectly. You'll notice that the pasted password is exactly the same as the one displayed in our password generator. This confirms that the copy function is working perfectly. In this project, we are going to focus on building two main features. First, we will create a random password generator. This generator will produce secure passwords with just one click. Second, we will add a copy function. This function will allow users to easily copy the generated password to their clipboard. First, we'll dive into creating a completely random password using JavaScript. We'll make sure this password appears right inside the input field, updating dynamically each time you click the Generate button. Next, we'll explore how to copy text directly from the website. We'll do this by using a button and storing the text inside the system clipboard. This will make it easy to paste the text wherever you need it. We'll also explore how to display a small notification message inside the project. This message will appear whenever an action, like copying, successfully happens. This feature will provide users with immediate feedback, enhancing their overall experience with the project. This project will provide you with hands-on experience as it is designed for intermediate to advanced learners. You will work with event handling, DOM manipulation, and visual feedback. This will give you practical skills and a deeper understanding of these concepts. In the next section, we will begin by creating the HTML structure for our project. We will then gradually build up the rest of the project step by step. This approach will help us understand each part of the project thoroughly. Let's move on to the next section. There, we will start building our random password generator together. Let's dive right in and start building our project. We won't waste any time, so let's get started right away. Let's start by opening Visual Studio Code. This is the tool we'll use to write and manage our project's code. Let's close the Get Started tab now. In the File menu, let's click on Open Folder to start. As always, I'll place the project on my desktop. However, feel free to choose any spot on your computer that suits you best. To begin, let's navigate to your desktop. Once there, you'll see a button labeled New Folder. Click on this button to create a new folder. This folder will be the home for our project files. Let's give this new folder a name that matches our project title. We'll call it Random Password Generator. This will help us keep everything organized and easy to find. We press the Enter key to confirm the folder name. Then, we click the Select Folder button to open the newly created folder. First, close the Get Started tab. Then, navigate to the Explorer section located on the left side of the screen. Right-click within this section and select the option to create a new file. We will create our HTML file. We will name it index.html and press Enter to save it. Over on the right side, you will find our index.html file. It is completely empty and ready for us to start adding our code. To create the basic HTML5 structure, simply type an exclamation mark. This action will automatically generate the essential HTML5 boilerplate code for you. Let's proceed by typing an exclamation mark. This will bring up the auto suggestions. We'll select the first one from the list. This will help us generate the basic HTML5 structure for our project. Let's take a closer look at our HTML5 boilerplate structure. The very first line is the document type declaration. This line is crucial because it tells the browser which version of HTML we are using for this web page. Since we are working with HTML5, we only need to include the word HTML in the opening tag. This is because HTML5 is the latest version of HTML, and it simplifies the syntax. We start with the main HTML tag, which wraps around the head and body sections. This tag is the foundation of our HTML document. The lang attribute in the opening HTML tag is used to specify the language of the web page. For this project, we have set it to English. This attribute helps browsers and search engines understand the language of the content, which can improve accessibility and SEO. The head section of our HTML document is where we include important metadata. This section also contains the title tag, which specifies the title of our web page. The first meta tag contains the charset attribute, which sets the character encoding for HTML documents. HTML5 recommends using UTF-8 for this encoding because it supports a wide range of characters and symbols. This ensures that the web page can display text correctly, regardless of the language or special characters used. We add a special meta tag to our HTML. This tag is specifically for Internet Explorer. It tells the browser to use its most up-to-date rendering engine. This ensures that our website looks and works correctly in Internet Explorer. The final meta tag, known as the viewport tag, plays a crucial role. It manages the browser's initial zoom level and the width of the viewable area. This ensures that the web page is displayed correctly on various devices, from desktops to mobile phones. In simpler terms, this meta tag helps the browser adjust the page's size to fit the screen properly. It ensures that the content is displayed correctly, whether you're viewing it on a large desktop monitor or a small mobile device. To make the code more readable, you can enable word wrap by pressing Alt and Z together. This feature helps you view the entire code clearly without any breaks. In the viewport meta tag, the first part is crucial. It ensures that the page's width matches the device's screen width. This is particularly important for mobile screens, which are much smaller than computer screens. You'll notice the browser's starting zoom level defaults to 100%. The title tag is what you see displayed in your browser tab. It's the name of your web page, and it defaults to Document if you haven't set it yet. To preview our project in a browser from VS Code, we use Live Preview extension. Let's start inside the index.html file, right-click on it, and select the Live Preview option. Look at the browser window on the right side. It appears completely empty, with only the default title, Document, visible. We will now update the title of our project. We will change it to Random Password Generator. Let's close the Explorer panel to free up more space on the right side. Then, let's expand the editor a bit further. Now, inside the body section, we'll add a div with the class password container as our main holder. Within the container, you will notice the heading title displaying Random Password Generator. Notice the title of our project, Random Password Generator, displayed in the Browser tab. Following the H2 element, we create a new div. This div will wrap both the input field and the copy icon. We name this div Input Container. Inside this div, we have an input element. It's set to type text, which means users won't need to type anything manually. This input element has an ID of input and a class of input. Let's create an input field. We'll set its type to text by default. This input field will have an ID, a class, and a placeholder. The placeholder will display the text, "Create password." Notice that users are not supposed to type directly into this input field. The password is generated automatically and can be copied using the icon. To prevent users from manually entering any text, we add the read-only attribute to the input field. This ensures that the password is generated automatically and cannot be altered by the user. Following this div and the input element, add an icon for the copy function. To include icons in our project, use the Font Awesome website. To begin, open your web browser like Google Chrome from the desktop and search for Font Awesome. In the search results, you will find the Font Awesome website. From there, simply click on the icon subsection to access the icons directly. Font Awesome provides tons of icons on their website. Let's take a moment to allow the website to load completely. My internet connection is running a bit slow today. Please give it a moment to fully load. To bring Font Awesome icons into our project, we must include a link from its CDN. Open your browser's search bar now and type in CDN.js. From the search results, you will find the website. Once there, use its search bar to enter Font Awesome and choose the matching package. Scroll down on that page, then click the button to copy the provided link tag. Let's go back to Visual Studio Code now. Right below the title tag, paste the Font Awesome CDN link. Now head over to the Font Awesome website and wait for it to load fully. Use the search bar there to find the copy icon that we need. When you look at the search results, you'll notice that there are many copy icons available. However, most of these icons require a pro subscription. To avoid this, we should choose the free option provided. Click on this icon element to copy its code right away. This element uses an icon tag with specific classes for the copy function. After you've copied the code, switch back to Visual Studio Code. Paste it directly below the input field there. Notice how the copy icon now appears clearly in your project preview. With that in place, let's add a button below. This button will generate a new password each time it is clicked. Let's create a button under this tab. We'll add the class btn to it. Then, we'll press Enter and type Generate inside. When you click the copy icon, a notification will appear. This notification will inform you that the password has been successfully copied. It will remain visible for a few seconds before it automatically disappears. To create the alert section, we'll add a new div right after the password container div. This new div will be named the alert container. This is an empty div with the class alert container. We will add the text and other details inside it later using JavaScript. We have now finished the HTML part of our project. In the next section, we will begin styling our project using CSS. In the previous section, we completed the HTML structure for our project. In this section, let's begin styling our project with CSS. Let's start by creating the CSS file for styling. Let's reopen the Explorer panel on the left side by pressing Ctrl plus Shift plus E. Then, right-click inside the panel and select the option to create a new file. Let's name our file style.css and then press Enter. Let's go back to our index.html file. We'll add a new link tag right below the Font Awesome CDN link. Make sure to place it at the end of the head section. Let's type link there and select the third suggestion that includes CSS. We include a link element to connect the HTML file. This attribute tells us where the link is going. It specifies the URL that the link is pointing to. Since both files sit in the same directory, we simply enter style.css as that URL. Let's save our work by pressing the Ctrl and S keys together. After that, we'll close the Explorer window to keep our workspace tidy. Let's begin styling our project using CSS. Let's start by creating the body section. We'll do this by typing body in our CSS file. We will begin by opening a set of curly braces. To center all elements neatly, we simply apply display flex. To center all elements horizontally, we apply the justify content center property. To ensure that our web page takes up the entire screen, we need to set the height of the body element to 100% of the viewport height. This means that the body will stretch to fill the full height of the user's screen, providing a seamless and immersive experience. Apply Align Items Center to vertically center all the items. This setup works well for the body section. We almost forgot to remove the default margin. It's usually around 8 pixels, so let's set it to 0. This will help us center everything neatly. Let's adjust the font for this text using the font family property. We simply configure it to match a password style. You'll notice the password appears in a special font that evokes a secure style. That wraps up everything in the body section. You can press Alt and Z together to enable word wrap. Following the body section, we will now focus on the main container box at the top. This container uses the password container class. We'll start by copying the selector, then move over to the CSS file. There, we'll add a dot in front of it because it's a class. Finally, we'll open the curly braces to begin our styling. We start by changing the background color to clearly see our progress. We'll color it pink and set its width to 500 pixels. We apply padding to create space and inset the contents slightly. In this step, we apply 20 pixels of padding. Take a closer look at this appealing container design. Let's add rounded corners to the container's edges. To do this, we'll apply a border radius. This will give the container a softer, more appealing look. Adjust the margin size to 10 pixels exactly. In this step, we simply add a subtle box shadow for depth. Look at the subtle shadow effects we've added around this element. In addition, the box shadow property adds depth to the container. The first value in the box shadow property determines the horizontal position of the shadow. This value can be positive or negative, moving the shadow to the right or left, respectively. We adjust this setting to a value of 0 pixels. Observe how we adjust the placement for that vertical shadow. We adjust the value right here to 4 pixels. Let me highlight this clearly for you on the screen. We adjust this value to 8 pixels for proper spacing. We will use the RGBA function to set the color to black. We will also add a 30% transparency to this color. This will give the shadow a subtle, semi-transparent appearance. We set the red, green, and blue components to 0. This means there is no color in these components. Then, we set the alpha value to 0.3. This alpha value represents 30% transparency. You can see this appealing container right here. It has a pink background and rounded corners, making it stand out nicely. The subtle box shadow adds depth, giving it a polished look. Let's add some margin to ensure space appears around the element. In this step, we adjust the margin to 10 pixels. Notice how the mobile screen also shows a beautiful container. We have now completed the construction of the container. We will continue by styling the input section. The input field sits inside a div with the class input container. Right here, we simply label it as the input container. For the input container now, we simply add a basic border. We set the border style to solid. This makes it clear and easy to see. You can clearly see the border appearing on the screen. We will set the width of this element to 2 pixels. This will create a clear and visible border around the input container. That handles the first property. Here, we simply set the color value to black. The color appears black by default, but to ensure clarity, we specify black explicitly. We add some padding to create more space inside the input container. we've adjusted the padding value to 10 pixels. This adjustment ensures that there is ample room for the text and the copy icon, making the input field more user-friendly. To give our element a more polished and rounded appearance, we will add some border radius. This will soften the edges, making the element look more visually appealing. Let us check out this rounded input field next. In this step, we apply a border radius of 10 pixels. We need to position the icon at the very end of the container. At the same time, we want to keep the input field on the left side. This will ensure that the layout remains clean and organized. Let's start by changing the display property to flex. This will allow us to use the justify content space between property. This property will push elements toward opposite sides, creating a balanced layout. To vertically align all our elements together, we can use the align items center property. This will ensure that all items within the container are centered vertically, creating a balanced and visually appealing layout. Additionally, let's ensure that this input field remains free from any background color or additional styling. This will help maintain a clean and focused appearance for the user. We can achieve that by making some adjustments to this input field. You'll notice that this element also belongs to the input class. To select that element, we simply write .input. Shall we start by removing the border? We can proceed because the container already includes a border. We simply set the border to none and the background color to transparent. And let's confirm that everything appears correctly in place. When we focus on this input field, some borderline appears. Let's remove the focus from this element since we don't need it here. In this step, we simply set the outline to none. Let's go ahead and adjust the color right here. We simply add a value right here. Let's add some placeholder text so we can apply styles to it right here. Shortly after that, we will proceed to remove this section. Let's begin by increasing the font size slightly. Let's set the value right here to 24 pixels. We also add some space between the letters using letter spacing. We'll adjust this setting to 4 pixels for proper spacing. Let's go ahead and remove this element. In the upcoming JavaScript section, we will dive into creating a password. We will generate it and then set its value. This will allow us to display the newly created password in our input field. For the time being, let's simply remove that element. In addition, we will style the placeholder to improve its look. We should avoid applying letter spacing to the placeholder text. We can now reference it by adding .input. To target the placeholder pseudo-element, use the double-colon selector. To make the text compact, we set letter spacing to 0 pixels. With that step completed, we can now move on to styling this icon. You can enlarge this icon by adding the fa2x class to its container. We will apply the fa_copy class to style this icon correctly. We copy the class and switch back to CSS. We also update the cursor style to show a pointer. Whenever we hover the mouse over this icon, the cursor turns into a pointing hand. We adjust the opacity value to 0.3 for the default setting. When you hover over the icon, its color changes. This happens because we use the hover CSS pseudo class. We can easily adjust the opacity value to 0.7 as an example. Notice how the elements respond with smooth hover effects. Alright, let's style this button next. Notice that the button has a class named btn. This class is used to style the button and make it stand out. To select that button element, we use the .btn selector. Let's go ahead and change the background color to black. We will adjust the color setting to white here. We can clearly see the text appearing in black color. We eliminate the border by applying border none. let's include some padding to create better spacing. We simply apply 10 pixels of padding above and below, plus 20 pixels on each side. Let's apply a border radius of 5 pixels to round the corners nicely. We'll set the margin to 10 pixels at the top and bottom. Meanwhile, we'll keep the left and right margins at 0. This will ensure that the button is centered horizontally within its container. Let's make the text inside larger by setting the font size to 20 pixels. This copy icon appears suitable for our project needs. When you hover over this element, let's adjust its color for better interaction. Let's proceed by adding this hover pseudo-class. Let's adjust the background color to green as an example. You can see it working just like this example. Let's set the cursor style to pointer on this element too. When you hover over the button, you'll see that the cursor changes to a pointing hand. This visual cue indicates that the button is interactive and can be clicked. Let's adjust the button size slightly whenever someone clicks it. Let's also add the active class alongside btn. We adjust the size by using the transform property with the scale function, setting it to 95%. Watch closely as we click the button. You'll notice it slightly shrinks in size. This adjustment makes the button appear pressed, providing visual feedback. Let's proceed to styling the alert container using its class right here. To style it properly, we target the alert container using its specific class. First, we set the position to fixed for this element. Next, let's assign a suitable width and height to define its size. Let's set the width to 300 pixels to make it visible. Let's set the height to 50 pixels for a compact design. Next, we apply a background color to enhance its visibility. Let's set the background color to light green as an example. You can see the light green background appearing right on the screen. However, let's position it in the bottom right corner. Let's achieve that positioning by setting the right and bottom values to 20 pixels. Next, let's apply a border radius of 10 pixels to round the corners smoothly. Next, we will apply a box shadow, just like the one from our main container. We set the horizontal offset to 0 pixels. We set the vertical offset to 4 pixels. We set the blur radius to 8 pixels. We set the color to black with an opacity of 30%. Inside this alert element, we haven't added any text content yet. For now, let's add placeholder text like password copied inside the alert. With the placeholder text added, let's center it next. To center the text inside the alert container, we'll use the display flex property. This will allow us to align the text both horizontally and vertically. For horizontal alignment, we'll apply the justify content center property. This will ensure that the text is centered from left to right. Additionally, we'll use the align item center property to center the text vertically. This combination will perfectly center the text within the alert container. To make the text more visible, let's increase the font size to 20 pixels. It looks good right now, but we should make this notification disappear after about 4 seconds. This will ensure that the notification does not stay on the screen for too long and does not distract the user. We can achieve this by using a JavaScript function that will hide the notification after a set amount of time. In order to control its visibility, we will add a class named active to the alert element. We apply this class whenever we need to hide the alert. We combine .active with .alert to target it. To hide the alert, we will adjust its position to push it completely off screen. Right now, the alert sits at 20 pixels from the right edge. Let's adjust the right position for the hidden state. We want to change the right value to -300 pixels, for example. By setting it to -300 pixels, the alert slides completely off screen to the right. We'll handle this adjustment entirely with JavaScript. We'll use JavaScript to add and remove this class dynamically. For the moment, we leave it defined right here. Whenever you add the active class, the alert slides out of view. We'll use JavaScript to dynamically add and remove this active class. Additionally, we will add smooth transition effects in the next section. That completes the CSS styling for our project. With the styling now finished, we're ready to move on to the next step. In the upcoming section, we'll be adding interactive features to our project using JavaScript. This will bring our password generator to life, allowing users to generate and copy passwords with ease. So join me in the next section for JavaScript. In the previous section, we completed styling our project. Let's begin this section by using JavaScript to add functionality to our project. Let's start by creating a new JavaScript file. To open the Explorer section, press the Ctrl, Shift, and E keys simultaneously. Once the Explorer panel appears on the left side, right-click anywhere within it. From the context menu that appears, select the option labeled New File. We'll name our new file index.js and press Enter to save it. Let's navigate to the index.html file. We'll add a script tag right before the closing body tag. This step is crucial for linking our JavaScript file to the HTML document. Let's type SC and choose the second autocomplete suggestion that includes the src attribute. Both the index.html and index.js files sit in the same folder. To begin the JavaScript section, we will create an index.js file. Let's save our file first. Then, we'll close the Explorer window. After that, we'll open the index.js file. This will allow us to start adding our JavaScript code. Let's start by selecting the button element in our JavaScript code. We can use either the querySelector method or the getElementById method. Since this button has a class named etn, we'll use the querySelector method to select it. Let's access that element in JavaScript by using the querySelector method. In this step, we are going to create a constant. We will name this constant btn element. We will then assign it to the document querySelector method. To target the class, we will add a dot before btn. Let's add an event listener to the Generate button. This will allow us to create a new password every time we click it. To add the click functionality, we will attach an event listener to the button element. This event listener will respond to the click event type. Next, we will add a click event to the button. This event will trigger a function when the button is clicked. To do this, we will create an arrow function. The arrow function is defined using parentheses followed by a fat arrow and curly braces. Upon clicking the button, we generate a random password using a dedicated function. For this step, we simply invoke the createPassword function to generate the password. First, we'll create a function to generate the password. This function will define the characters that can be used in the password. In the final project files that I've included in the course, you'll find a folder named Random Password Generator. Inside this folder, there is a text file called source.txt. This file contains a list of characters that you can use to generate your passwords. The list includes numbers from 0 to 9, lowercase letters from A to Z, uppercase letters from A to Z, and various symbols. You can copy these characters to use in your password generation process. Let's copy this string of characters. Now, let's move over to Visual Studio Code. Here, we will create a constant. We'll name it characters, or simply chars for short. Then, we'll assign the copied string as its value, placing it inside double quotes. Following that step, we will define another constant. This constant will determine the length of our password. We will name it password length. For example, let's assign it a value like 14 or 16, whichever you prefer. We will build the password based on its chosen length and the characters we select. Initially, we start with an empty string for our password. We then add random characters one by one to this string. This process continues until the password reaches a length of exactly 14 characters. Let's begin by creating a for loop in our code. Simply type the word for, then select the second auto-suggestion labeled for loop. Notice how it sets up an index that starts at 0. This index will continue to increment until it reaches the length of the password. In this case, the password length is set to 14 characters. Within this loop, we will select one character at a time. To do this, we generate a random number. This random number helps us pick a character from our available characters. Let's start by declaring a constant called random number right here. We generate it using the math.random method, which produces a value between 0 and 1. To adjust the random number to fit our needs, we multiply it by the length of the character string. This ensures that the resulting number falls within the correct range, allowing us to select a valid character from our string. Next, we multiply by the length of the character string to adjust the scale appropriately. To convert this decimal number into an integer, we use the math.floor method. This method rounds down the decimal to the nearest whole number. We simply floor the value down to the nearest lower integer. With our random index generated, ranging from 0 to the maximum length of our character set, we start with an empty string. This string is ready to be built into a password, one character at a time. In each iteration of the loop, we add a new character to the password. Inside the loop, we select each character by applying the substring method to our character's string. To select a single character, we use the substring method on our character string. We start at the random index and end at that index plus 1. This method allows us to extract a specific character from our string. This is how the substring method operates. For example, to extract the first character, you would specify 0 and 1 in the substring call. This means you start at the youth position and end at the first position, effectively grabbing the first character. To select the second character, you would specify the indices 1 and 2 in the substring method. This process continues for each subsequent character, with the starting index increasing by 1 each time. For instance, imagine generating a random index of 7 right here. That selects the 8th character in our string. This character happens to be the digit 7. This is because positions in our string start at 0. To better understand this process, let's add a console.log statement. To better understand how the password is being generated, let's add a console log statement. This log will display the random index and the password after each character is added. This way, you can see the process step by step. To see the output clearly, open the Developer Tools console in your browser. Then, click the Generate button to trigger the function. When we click the button, you'll see it generates 14 random numbers in the console. The first number is 38, which selects the hashtag symbol. As you can see, the first character selected is the hashtag symbol. Meanwhile, the index 12 picks out the letter C. Continuing from that example, index 24 selects the letter O next. Meanwhile, index 60 picks a capital G. This process builds our full random password step by step. Each time you click the Generate button, a brand new password is created. This password is then displayed in the input field. With the password fully generated, delete this console log statement. After removing the console log, our next step is to update the input field. We want to display the newly generated password in the input field instead of the placeholder text. To update the input field, let's first retrieve it from the DOM and reference it in our JavaScript code. Observe that the input element uses the class input and the ID input too. This gives us two options for selecting it. We have two different methods to select the input element. One is the getElementById method, which is straightforward and efficient. The other is the querySelector method, which offers more flexibility. Using the ID with getElementById provides the best approach in JavaScript. To select the input element, we'll first declare a constant named input element. Then, we'll assign it using the document.getElementById method, specifying the ID as inputs. This approach ensures we accurately target the input field in our JavaScript code. With the input element selected, we will now assign the generated password to its value. This step occurs right after the loop finishes, ensuring that the newly created password is displayed in the input field. When we click the Generate button, the password is instantly displayed inside the input field. Each time we click the button, a completely new password is generated. The next step involves adding copy functionality to this icon. When you click this icon, we aim to copy the password to the clipboard. Let's reference this icon within our JavaScript code. This icon uses the class name FACopy. To select this icon, we will use the query selector method. Let's create a constant named copy icon element. We'll use the document.querySelector method to select this element. We'll target the class name FACopy for this selection. With the icon selected, we can attach an event listener to it immediately. Next, we will add an event listener to the copy icon. This listener will respond to click events. When the icon is clicked, it will trigger a separate function that we will define later in our code. This function will handle the copying of the password to the clipboard. We'll name this function copyPassword and define it further down in the code. Inside the copyPassword function, we first select the input element. Inside the copyPassword function, we select the input element by calling its select method. When you click this icon after generating the password, it selects the input field. This selection works well on desktop computers. However, for mobile devices, you will need to add the setSelectionRange method. This is necessary if you plan to support phones and tablets. For mobile devices, apply the setSelectionRange method to the input element. For better mobile support, we need to ensure that the text is selected properly. To achieve this, we will use the setSelectionRange method on the input element. This method allows us to specify the start and end positions of the selection. In this case, we will set the range from 0 to 9999. This ensures that the entire text within the input field is selected, making it ready to be copied to the clipboard. This part is specifically designed for mobile devices. If your project does not require mobile support, you can safely remove this line. With the text selected, we need to copy it to the clipboard. To copy the selected text to the clipboard, we first access the navigator.clipboard object. This object provides us with a method called writeText. We then invoke this method to copy the text. The content we want to copy comes from the value property of our input element. In other words, we need to copy the input's value. Let's click the icon to copy the password directly in the browser. See how the password copies right away. Notice how I pasted it without pressing Ctrl+C myself. Let me generate a fresh password, click the copy icon, and paste it right into this spot. With the copying feature functioning smoothly, our next step is to ensure the generated password is displayed in the input field instead of the placeholder text. Additionally, we need to make sure the notification appears correctly when the password is copied. To change the text shown here, we must select the div with the class alert container. Let's start by selecting the alert container element. We'll create a constant named alert container element. Then, we'll assign it using the document.querySelector method. We'll use a dot followed by the class name alert container. This will help us target the specific element we need to work with. After copying the password, let's update the alert container. For the alert text, we need to update its inner text. Instead of merely displaying password copied, we want it to include the actual password. This should be followed by the words copied and an exclamation mark. This way, users will see the specific password they copied, along with a confirmation message. Let's try this out to see the result. As you can see, setting the inner text fails because we cannot access the password variable from this location. This is because the password variable is defined within the copyPassword function and it is not accessible outside of that function. To fix this, we need to reference the password variable directly within the copyPassword function. Let's make this change right here. Let's modify the notification text by including a space for better visibility. After copying the password, we show a notification on the website. This lets users know that the password has been copied successfully. Before you click the icon, the notification stays hidden. This happens because the password variable is only available within the function where it's created. As a result, other parts of the code can't access it. To make the notification appear smoothly, let's add this animation. When we click the copy icon, we need to add and remove the active class. By default, the notification is hidden by including the active class. When you click the button, the active class is removed, revealing the notification. In this step, we focus on the alert container element. Our goal is to remove its active class. To do this, we use the class list remove method. This method is specifically designed to remove a class from an element. By applying it to the alert container, we effectively hide the notification. This action is crucial for controlling the visibility of the alert message. Let's generate a password first. Then, click the copy icon. You'll see the notification appear, but it might seem too quick. To make the notification fade in smoothly, we will add a transition effect to the alert container. This transition will last for 0.4 seconds, creating a gradual appearance of the notification. You will notice the notification appears but disappears too soon. To delay its removal for a few seconds, we use the set timeout method. When we click on this element, we use the set timeout method. This method creates a timer that waits for a specified delay period before running a specific function. For example, we set the timer to wait for 2 seconds. After that time, we target the alert container. Then, we add the active class to it using its class list. We proceed by adding this active class to the container. Let's begin testing this setup right away. Let's generate a random password, then click the copy icon. You'll see a notification appear displaying the copied password. After 2 seconds, this notification will smoothly fade away. Testing again without any password reveals the issue. The icon still triggers and shows the copy message. We certainly do not want the notification to appear when no password exists. To address this issue, we need to add an if statement. This statement will check whether the input element contains any text. If it does, we will then perform all the actions that follow. This ensures that the notification only appears when there is a password to copy. Let's take this code and move it inside the if statement. If no password exists yet, clicking the icon produces no notification at all. However, with the password generated, clicking the icon displays the success message right away. And as you can see, it's working perfectly. That's it for our project, and we've successfully completed everything we set out to build. I really hope you enjoyed following along and picked up several new techniques and ideas throughout the process. This project was designed to be an intermediate to advanced level challenge. It provides you with a fantastic opportunity to enhance both your coding and design skills. I sincerely hope you found this project to be an enjoyable and enriching experience. I am confident that you have gained valuable insights and skills from it. I am looking forward to seeing you again soon for our next exciting project. Welcome back to our tutorial series for another exciting project. In this project, we will build a basic calculator from scratch. Looking at our final project, you can see a modern calculator design. It includes all the numbers from 0 to 9. We also have the operator buttons for addition, subtraction, multiplication, and division. The design is completed with an equal sign and a clear button labeled with the letter C. You can simply type in any arithmetic problem you want to solve. The calculator will handle your equations and expressions. Let's type in an example, such as 45 plus 42. The calculator will then display the result for you. You can also multiply numbers together with ease. The calculator handles multiplication operations perfectly. We can also clear everything from the screen with a single button press. This resets the calculator completely. This calculator is very straightforward and easy to use. It performs all the basic operations you need. For evaluating the expressions typed into the input, we will use a built-in JavaScript function. This function is called eval. We will learn how to attach event listeners to all these buttons. We will do this efficiently by using a for loop. We will learn how to design our calculator with a modern look. We will use CSS to achieve this styling. You will notice interactive hover effects when you move your mouse over the buttons. We have also applied shadow effects to various elements for a sense of depth. Now that we have seen what we are building, we will begin with the HTML structure. This is the foundation for our calculator project. Let's dive into the HTML structure in the next section. Let us begin our exciting project together. We will create a basic calculator from scratch. For reference and comparison, I have placed the completed final version here. This allows us to compare our current design with the final completed version. We can see how our work measures up against the finished project. You can see the final design we are going to build. We will use this as our reference. Our first step is to build the structure of our calculator. We will begin by creating the HTML part of the project. Our first task involves creating all the necessary elements. We need to display the numbers from 0 to 9. We also need the operator letters and the equal sign. Finally, we will place a container around all of these elements. Now we need to add an input field for our display. This is where the numbers and results will appear. Our first step in this process is to create the HTML file. This file will serve as the foundation for our calculator. To begin, we will open up Visual Studio Code. This will be our main workspace for the project. For this project, I personally use Visual Studio Code. You are welcome to use any text editor that you prefer. The choice is entirely up to you. To begin, you will click on the File menu. Then, navigate to and select the Open Folder option. We are going to create a new folder for our projects now. This folder will hold all of our project files. I will create the new folder on my desktop. This location is convenient for easy access. Let us create a new folder for our project now. We will name this folder Basic Calculator. I will type the name of our project folder as Basic Calculator. After typing Basic-Calculator, I will click the Create Folder button. We then need to select this new folder to open it. This action will reopen Visual Studio Code with our project folder ready. Notice the Explorer section on the left. You can see our Basic Calculator folder is open. We are ready to create our files inside this folder. Every file we create for our project will be stored inside this Basic Calculator folder. This keeps all of our work neatly organized in a single location. Let's close the Welcome tab that is currently open. Now we can create a new file for our project. You can do this by clicking the New File icon. Alternatively, you can right-click in the Explorer area and select the New File option from the menu. We are going to create our HTML file now. You can name this file anything you like. The only requirement is that it must end with the .html extension. For our project, we will use the standard name index.html. Our new file is currently empty. We can use an exclamation mark to generate a boilerplate template. This gives us a great starting structure. When you type an exclamation mark, the editor's abbreviation system will suggest a boilerplate. This boilerplate provides the initial template for your website. This foundational template includes a title element for your page. Simply click on the very first suggestion from the editor. This action will automatically generate our complete boilerplate code. The boilerplate includes the essential document type declaration. The document type declaration tells the browser which version of HTML your page is written in. This is essential for ensuring the page renders correctly. We write the word HTML inside the opening tag. This specifies the root element of our document. For the HTML5 standard, you simply need to write the word HTML here. This declaration is all that is required. Next, we have the HTML tag itself. This main tag contains two important sections. These sections are the head tag and the body tag. This lang attribute defines the language of the entire page. It clearly tells the browser which language the content is written in. Our website uses English as its language. The head tag comes next in our structure. This section contains important metadata tags. It also holds the title tag for our page. The first metadata tag defines the character set for the web page. We are setting it to UTF-8. This encoding is the modern standard. Using UTF-8 is the recommended standard for HTML5. This character set includes virtually every character and symbol you could need. This means visitors to your website will be able to view all the content correctly. They will have a smooth and problem-free reading experience. Our next metadata tag handles browser compatibility. It is specifically designed for users who might be using Internet Explorer. This tag instructs Internet Explorer to use its most modern rendering engine. This tag specifically instructs Internet Explorer to use its most modern rendering engine. That modern engine is called Microsoft Edge. Microsoft has officially ended support for Internet Explorer. The browser is no longer being updated or maintained by the company. Internet Explorer will now use the more modern Microsoft Edge engine. This ensures better compatibility with current web standards. Next, we have the viewport meta tag. This tag makes sure the website's width always matches the device's screen width. This setting is important for different screen sizes. A user on a mobile phone will have a much narrower browser width. Another user on a desktop or laptop will have a much wider screen. The viewport tag ensures the content adjusts to fit each device's screen width properly. This setting ensures the browser width automatically adjusts to match the device's screen. Next, we have the initial scale property. This sets the starting zoom level when the page first loads. In this case, it is set to a value of 1. A value of 1 is equivalent to 100% zoom. This ensures the page displays at its default size. Let us open our website in the browser now. This will allow us to see the title of the website. To make our project come alive in the browser, we will use a very helpful extension named Live Server. This extension automatically sets up a local development server for us. Once you have installed this extension, you will notice a button labeled Go Live appear at the bottom of your editor window. We can click on the Go Live button to launch our website. This opens the site inside a local development server. The server uses port 5500. The index.html page will open in your browser. You will notice the title at the top currently says Document. Currently, the title at the top of the browser tab reads as Document. We can easily change this title to match our project's name. Let us change it to Basic Calculators. When we update the title here, the Live Server extension automatically refreshes the page. Now you can see the title has been updated to Basic Calculator. Looking at our final design, we can see we need a main container. This container will hold an input area and a set of buttons. Let me show you exactly how we are going to structure our HTML. I will walk you through the container and the buttons we need to create. Our design will feature a main container for the calculator. This container will hold a display input at the top. Below the display, we will have a separate section for all of the buttons. Let me highlight this section for you. I will use a different color to make it clear. This specific div has the class of buttons. It will contain all of the calculator's buttons inside of it. Each button has its own specific class assigned to it. This helps us style and control them individually. We assign specific classes to each type of button. The number buttons get the class numbers. The operator buttons get the class operators. The equals button gets the class equals. Finally, the clear button gets the class clear. Alright, let us proceed with building this structure now. Let us position the website preview on the right side of our screen. This setup allows us to observe all modifications instantly. Let us arrange our windows for a better view. Please position the Visual Studio Code window on the left side of your screen. You can do this easily by pressing the left arrow key on your keyboard while holding the Windows key. Let us close the File Explorer panel. We will now work inside the body section. This is where we will build our calculator structure. The first element we need is a div container. This div should have a class name of calculator. Now we can do this by typing .calculator. The text editor will then suggest the correct code for us. When you type .calculator into your editor, the autocomplete feature will automatically suggest a div element with the calculator class. You can then press Enter to accept this suggestion. You can press the Enter key to accept this suggestion and insert the element into your code. Now we have our main calculator container in place. Inside this container, we will add an input field for the display. This field will be used to display the numbers and results. We are setting the input type to text. We will also assign an ID to this input field. This ID is important because we will use it later. We need to target this specific input with our JavaScript code. This identification is essential for our project. We will use it later to control the display with our programming. Now, I want to explain what we are going to do next with this input field. We want to set this input field to be read only. This prevents anyone from typing directly into it. Let me explain the read-only attribute. It should be placed as an attribute on the input element itself. This setting makes the input field a display only. This input field is going to display our final result. We are adding a read-only attribute to it. This prevents anyone from typing directly into the display. The read-only attribute turns this input into a display-only element. This means you cannot type anything into it directly. Without the read-only attribute, you are able to type directly into the input field. This is something we want to prevent in our calculator. We want to make sure users cannot type directly into the input field. This prevents any manual entry and keeps the interaction controlled by our buttons. We want to restrict direct typing into the display. The calculator should only be operated by clicking the on-screen buttons. Inside this container, we will create another div element. This div will have a class named buttons. All of our calculator buttons will be placed inside this specific div. Our first button will have a class name of clear. This class is used to identify the clear function. This button will display the letter C for clear. It is important to create a button element here. A div element would not be suitable for this function. Let's create a button element for this clear function. We will give it the letter C. We have successfully created our first button element. You can see it appears on the screen now. The order we place these buttons is very important. We need to follow this specific layout to match our design. Our first button is labeled C for clear. Next we have the / symbol for the division operation. Then we add the star symbol for the multiplication operation. Let's proceed with creating the buttons in this specific order. This arrangement will help us build the correct layout. Moving further along the row after the number 6, you will notice the equals button comes next. After that we have the numbers 1, 2, 3, and 0. Finally, we add the decimal point button to complete the layout. To get our layout to match the reference design exactly, we need to follow this specific order. This next button will be assigned a special class. We will call this class Operator. This button will represent the division operation. It uses the / symbol for this mathematical function. Now we need to add 2 more operator buttons. These buttons will be for multiplication and subtraction. I will copy this button by pressing Alt plus Shift plus the down arrow key. Our next operator is the multiplication sign. We use the star symbol for multiplication. After that comes the minus sign for subtraction. We have finished creating our first 3 operator buttons. Next, we are going to add the number 7. We will also add the numbers 8 and 9. Each of these will be a button. We will give each button a class called number. We need a button here for the number 7. We can duplicate this button 2 more times. Use the keyboard shortcut Alt-Shift with the down arrow key. We can copy this button and change its text to an 8. The next button we need to create will be for the number 9. We can assign it the number class as well. That wraps up our number 9 button. Let's move on to the next step. Next, we will create a button for the plus operator. We will assign it the class of operator. Next, we will create the button for the equal sign. This button will be used to calculate our results. Next, we need to add the numbers 4 and 5. These will be 2 separate buttons. Actually, I meant to say this should be the plus sign button. The next button after the number 9 is the plus sign. This operator is used for addition. Next, we will add 3 more number buttons to our layout. These buttons will represent the digits 4, 5, and 6. We will assign a class of number to this button. We will now create the button for the number 4. We will copy this button element. We can use the same method we used before. Let's change this next one to number 5. The following button will be number 6. Next, we have the equal sign button. This button will use a different class called equals instead of operator. We will now add the final number buttons. These are for the digits 1, 2, 3, and 0. Looking at the buttons we have just created, you can see the numbers 1, 2, 3, and 0. We will now create another button for our calculator. This button will have the class of number. This button will display the number 1. We will copy this button 3 additional times. We can use the keyboard shortcut for this task. We will add 3 more number buttons here. The next 3 buttons will be 1, 2, and 3. We finish this row with the number 0. Next, we are going to create our final button. This button will be for the decimal point. We will give this button a special class name. This button will represent the decimal point. It is going to be a period symbol. We have now finished creating the HTML structure for our calculator. We have successfully created our HTML file containing all the necessary elements. These elements include the buttons, the main container, and the input field. The current appearance is just the default browser styling. It is purely structural HTML without any custom design yet. We will transform this basic structure into an amazing and beautiful modern design. This transformation will happen in the next section using CSS. In the next section, we will focus on the styling for our calculator. We will use CSS to create a modern and visually appealing design. That concludes our work on the HTML structure. We will move on to styling the calculator in the next video. So in the last section, we have completed the HTML part of the project. We successfully created all the necessary buttons, including the numbers, the equal sign, and the clear button. Now, we will focus on the visual design of our project by applying CSS styles. Looking at the finished calculator, you can see we have a modern design. This includes a subtle shadow effect inside the input field. The buttons also have their own shadow effects for a cohesive look. We will also add a hover effect for when you move your mouse over the buttons. This hover effect will include a smooth color transition to make it feel more interactive. Additionally, we have a shadow effect for a modern look. Let us open Visual Studio Code and access the File Explorer panel. You can open this panel by pressing the keyboard shortcut, Ctrl+Shift+E. We will create a new file within our project directory. We should name this new file style.css. Before we can use this CSS file, we must link it to our HTML document. This link is placed at the top of the HTML file. We write the word link to create the link tag. Then, we select the third suggestion from the editor. This specific option is the one for linking a CSS file. This feature will automatically generate the link tag for our style file. The href attribute simply points to our style.css file. Both files are located in the same project directory, which is named Basic Calculator. For the address, we only need to specify style.css. This tells the browser where to find our style sheet. It establishes the relationship between our HTML and the CSS file. Let us begin our styling by applying some foundational styles to all elements on the page. To do this, we will add a star sign to our styles. First, I want to change the box sizing property to border box. This setting ensures that padding and borders are included within an element's total width and height. Setting the box sizing property to border box achieves a specific goal. This setting ensures that any padding and borders you add to elements will be included within their total specified width and height. Without this, the padding and borders would be added on the outside, which could disrupt your layout and cause elements to overflow. Without this box sizing setting, we will run into some layout issues when styling our input fields. The padding and borders would not be calculated correctly. I will show you what happens to our styling if we do not include this border box setting. You will see how the elements behave differently without this important rule. We also want to remove the default margin that browsers add to the page. We will set this margin to 0. This step removes any extra space around the elements. This gives us a clean starting point for our layout. Now that we have completed the basic styling, we will begin with the main calculator container. This is the div element that wraps around all of our calculator components. We can target that calculator container using its class name. We simply write .calculator in our CSS file. This works because we assigned the class of calculator to our main div element. To target this calculator class in our CSS file, we use a dot followed by the class name. This method allows us to apply styles specifically to that container. Let us begin by updating the background color of our calculator container. We will apply a light gray shade using the specific color code F2F2F2. You can already observe the visual difference on the screen. Let's add some padding to our calculator container. This padding creates space inside the container. It pushes all the elements inward from the edges. Let's set the padding to 20 pixels for the calculator container. This will create some breathing room inside the calculator. After that, we will add some margin to the container. First, we set a maximum width of 400 pixels for our calculator. This will limit the overall size to 400 pixels. Now we need to center this container on the page. We want to center this calculator container on the page. This will position it nicely in the middle of the screen. To center our calculator container horizontally on the page, we set the top and bottom margins to 0. Then we set the left and right margins to auto. This automatically creates equal margins on both sides. This simple technique easily centers the element for us. Now that our container is centered with the margin settings, we can move on to adding a border around it. Let's add a border to our calculator container for better definition. We will create a solid line border that is 1 pixel thick. The color for this border will be a dark gray, specifically the hex code CCC. This darker shade will create a nice contrast against our light gray background. We should also add a box shadow to our calculator. This shadow effect will create a subtle depth. It makes the calculator appear to float slightly above the page. Let me explain what the box shadow property does for our design. We want to set the horizontal shadow offset to 0 pixels. Then we set the vertical shadow offset to 2 pixels. You can see we have a shadow along the y-axis. The shadow has a blurriness of 5 pixels. We will use RGBA to define this shadow color. RGBA stands for red, green, blue, and alpha. This format lets us create a color and control its transparency. We do not want a fully dark shadow. Using RGBA allows us to have a shadow with some transparency. This creates a softer and more modern visual effect. We are going to set these specific numerical values for the shadow. This combination will produce a visible color for our effect. The alpha component specifically controls the transparency level. You can think of it as the opacity setting. We use 0 for red, green, and blue to create black. Then we set the opacity level to 30%. This gives us a semi-transparent shadow effect. The correct term is RGBA. It stands for red, green, blue, and alpha. That is the correct way to write the RGBA property for the shadow. This RGBA value includes red, green, and blue color channels. It also has an alpha channel for transparency. This shadow effect gives our design a nice depth. Now we should also round the corners of our calculator. Adding a border radius will make those edges soft and modern. We want to make the corners rounded for a more polished appearance. This creates a softer and more modern look for our calculator. Now we will add a border radius to our calculator container. This will give each corner a nice rounded appearance. We will set the radius to 5 pixels for a subtle curve. You should now see the rounded corners appearing on our calculator container. This completes the styling for the main calculator element. Let us add some margin to the top of our calculator container. This will create some breathing room above the calculator. A value of 30 or 40 pixels for the top margin should be sufficient for this purpose. That completes all the styling for our main calculator container. We have successfully centered it and applied all the visual effects. Now let's move on to styling our input field. This is the area where all our calculations will appear. We can target the input field specifically by its unique identifier. This is possible because we gave it the ID of result. We can target the input field by using the pound sign for its ID. We type result and then open our set of curly braces. Next, we set the width property to 100%. Then we add a padding of 10 pixels to create more internal space. Finally, we change the font size to 24 pixels for better readability. This change will increase the font size significantly. We cannot see the effect yet because the JavaScript functionality is not yet implemented. The JavaScript will handle capturing all the button clicks and displaying the results in this input field. We are going to remove the default border entirely by setting it to none. Instead of a border, we will create a shadow effect for the input field. This shadow will be an inset shadow, meaning it appears on the inside of the element rather than projecting outward. This creates a nice sense of depth for our design. We will add a box shadow that matches the one we just created. This time, we want the shadow to appear inside the input field. we can use that exact same shadow color. This will keep our design consistent. I am going to copy this box shadow property. This gives us 0 for the x-axis offset and 2 pixels for the y-axis. It also gives us 5 pixels for the blurriness and the same color. You can see the shadow currently appears on the outside of the element. I want this shadow to be on the inside instead. To achieve this effect, I will simply add the word inset right here. Now you can see the shadow appears inside the input box. This creates a nice sense of depth for our design. We will also add a border radius of 5 pixels. This will give the corners a smooth, rounded look. That completes the styling for our input section. It is important to demonstrate what happens without the box sizing property. This will show you why that initial setting was so crucial. Let me show you what happens without this important setting. If you remove the box sizing property, you will see a visual issue appear. The padding we added to the input field will now be applied as extra width. This demonstrates why the box sizing property is so crucial for styling elements like input fields correctly. Let us bring back that important box sizing border box setting now. This will ensure our elements calculate their dimensions correctly. Let us move forward with styling our calculator buttons. We will begin by targeting the container that holds all of them. First, we need to target the main container for all the buttons. This is the div with the class name of buttons. Now we target the buttons container using .buttons. We open our set of curly braces for the CSS rule. Inside here, I want to apply the display grid property. We are going to use a display grid for this container. This will turn our button layout into a flexible grid system. The display grid property is what creates our grid layout. It first establishes a structured container for all of our buttons. Currently, the grid places each button in its own separate row. We will design the layout differently. Next, we need to change the display property for our grid. Specifically, we are going to define the grid template columns. We will use the repeat function for our grid columns. This will create 4 equal columns for our layout. Each column will be set to 1 fractional unit. Let me explain what this FR unit means. It stands for fractional unit. Let me explain what this means for our layout. This grid template columns property is a very useful CSS feature. It specifically controls the size of the columns within our grid layout. The repeat function with 4, 1 FR values creates 4 columns of equal width. This repeat function creates 4 equal columns for our grid layout. Each column will be exactly the same width. This is achieved using the fractional unit system. As you can see, we now have 4 equal columns. The term FRs stands for fractional unit. This unit is used to divide up all the available space within the grid container. The FR unit automatically calculates and uses all the available space within the container. It divides this space equally among the columns we defined. The FR unit automatically calculates the available space for the grid layout. It then creates 4 equal columns using that available space for our calculator design. This setup creates our grid container structure. The grid container will hold all our calculator buttons in an organized layout. This grid container will divide into 4 columns of equal size. This layout is exactly what we want for our calculator design. Now we need to create some breathing room between our calculator buttons. Let's add some space to separate them visually. To create some breathing room between our buttons, we will add a grid gap. This will place a consistent space between all the grid items. Let me find the exact CSS property we need for this spacing. To create some breathing room between our buttons, we can use the grid gap property. Let's set this grid gap to be 10 pixels. We will add a 10 pixel gap between all of our grid buttons. This creates clear visual separation. We also want to add a top margin of 20 pixels to the entire button container. Our layout is looking much better with the grid in place. Now, we need to style each button individually to give them their own distinct appearance. First, we will style all the buttons together with a common design. Then we will target special buttons like the clear and equals buttons individually. For example, we will give the equals button a different background color. Now let's target all the button elements. We can do this quite easily in our CSS file. We are targeting the button element directly. This approach does not require any special class or ID selector. We can target all of the button elements directly. We just need to write the word button in our CSS file. We will now style all of our calculator buttons at once. Let's start by adding some padding around the text inside each button. We will set this padding to 10 pixels. Next, we want to increase the font size for the buttons. We will change the font size to 24 pixels, which makes the numbers and symbols much larger and easier to read. Let us remove the border from the buttons entirely. Let's break down exactly what we are going to do with the buttons next. We are going to remove the default border from the buttons. Instead of a border, we will apply a box shadow for a more modern look. We use a clever design trick to create beautiful buttons. First, we remove the standard border entirely. Then we add a box shadow to replace it. This shadow has 0 offset on the x-axis and 2 pixels on the y-axis. We set the blur radius to 5 pixels for a soft effect. The shadow color is black with an RGBA value. We use 0 for red, green, and blue with 30% transparency. This combination gives us the clean and modern design you see here. Let's add a border radius of 5 pixels to these buttons. This will give them nicely rounded corners. We want to maintain this consistent rounded look throughout our entire design. Let's change the cursor to a pointing hand icon. This gives users a visual cue that the buttons are clickable. When you move your cursor over any button, you will see it change to a pointing hand. This visual cue indicates the button is interactive. We will now create a hover effect that changes the button's background color. We achieve this hover effect by changing the background color to a darker gray. We use the color code DDD for this change. The color switch happens very quickly by default. To make that color change happen more smoothly, we are going to add a transition effect specifically for the background color. This creates a gradual shift instead of an instant switch. We will apply a transition to the background color property. The transition duration will be set to 0.3 seconds. This will create a smooth and gradual color change effect. This transition creates a much smoother color change. It makes the effect feel more polished and professional. That completes the styling for all our calculator buttons. They now have a consistent and modern appearance. Now we are going to target and style each button individually. We will apply specific styles to different types of buttons. Let's start by applying some specific styling to our clear button. This button needs to stand out from the others. We are going to style the clear button next. The clear button has a CSS class named clear. We can target this specific button in our style sheet by using a dot followed by the class name. Let's style the clear button with a red background color. We will use a specific shade of red for this button. The text color for this button will be white for good contrast. We will set the text color to white using the hex code FFF. This creates a clear contrast against the red background. The clear button now has a nice red background with white text. You can see this styling for the clear button matches our final design goal. The red background with white text creates the visual distinction we want. Looking at our calculator now, the equal sign appears larger than intended. We will adjust its size in just a moment. Next, we need to apply specific styles to the number buttons. Looking at our HTML file, you can see that all the number buttons have a class of numbers. We can target all these number buttons in our CSS by using the class selector with .number. This will allow us to style all the numerical buttons at once. We are going to apply a different background color for the number buttons. This will make them stand out from the other elements. The background color for the number buttons should be white. This is the hex code for white. We have now styled the clear button with its distinct red background. The number buttons will feature a clean white color scheme. The decimal button shares the same styling as the number buttons. It will have a white background color and a dark gray text color for a consistent appearance. Now, regarding the decimal point, we do not actually need a separate class for it. We can manage its styling efficiently with the existing number class. We can target both the number buttons and the decimal button together. We simply use their class names separated by a comma. We can target both of these groups together. Next, we want to change the text color to a dark gray. We will use the hex code 333 for this color. After that, we can style the operator buttons. We target them using the operator class. All the operator buttons like minus and division have this class. This makes it very simple to style them all at once. Next, we will change the background color for the operator buttons. We want to use a blue color for these operators. Let me just verify that color code is correct. It should be 0074D9 for a nice blue background. The text color for these operator buttons will be white, which is FFF. The equal sign has the class name of equals. The equals button has its own specific class. This class is called equals. We target the equal button with its class selector. We will set its background color to a pleasant green shade. The specific color code we are using is 01FF70. We need to make the equals button span 3 rows. We can achieve this using the grid row property. To make the equal sign span across 3 rows, we use the grid row property. We set this property with the value span 3. We will use the grid row property with a value of span 3. This will make the equals button stretch across 3 rows. This grid row property expands the equal button to span 3 rows. You can clearly see this visual effect in the layout. Using display grid makes designing a calculator layout very straightforward. This approach handles the arrangement of elements with ease. We set the text color to white using the hex code FFF. That completes the styling for our calculator. The design is fully responsive and will look great on both mobile devices and larger screens. The design remains consistent across different screen sizes. It looks great on both mobile devices and larger screens. You can see the design maintains its clean appearance at various zoom levels. It adapts beautifully whether you are viewing it on a large screen or a smaller mobile device. This design works beautifully across different screen sizes. We can maintain this exact layout on both mobile and desktop devices. We have now successfully created and styled our entire calculator project using CSS. The design looks modern and professional with all the visual effects we wanted to achieve. Now that our calculator looks great, we will bring it to life with JavaScript. We will add the functionality that makes the buttons work. We will add event listeners to each of these buttons. This will allow the calculator to respond when you click on them. We will gather all the information from these buttons. Then we will trigger a function to calculate the final result. This result will be displayed in the input field at the top. We also need to implement a clearing function. This will be activated by pressing the C button. This functionality will be quite straightforward to implement. We will use a special JavaScript method for the calculations. This method is called eval. Most calculators online use custom code to handle the math manually. However, there is a newer built-in JavaScript method that simplifies this process. I will demonstrate this efficient technique in the next section. We will now move on to the JavaScript part of the project. This is where we will add all the functionality to make our calculator work. In the last section, we have completed the CSS section of our project. Let's enhance our project with new capabilities. We will be using JavaScript to add these interactive features. In this section, we will implement the core calculator functions. These functions will handle all mathematical operations. The first step in this process is straightforward. We need to create a new JavaScript file within our project folder. Let us return to Visual Studio Code. Press Ctrl-Shift-E to open the Explorer panel. You will see your project folder named Basic Calculator on the left. We will create a new file inside this folder. I will name my JavaScript file index.js. Just like we connected our CSS file earlier, we must now link this new file to our HTML document. This time, we will not place the script in the head section. We need to add it right at the end of the body section. This is a crucial step because we must wait for all the HTML elements to finish loading in the browser. Only after they are fully loaded can we successfully access and manipulate them with our JavaScript. We begin typing the letters SC and wait for the autocomplete suggestions to appear. We select the second suggestion from the list, which includes the source attribute. This script tag connects our HTML file to an external JavaScript file. The src attribute specifies the file's location. Since our JavaScript file is in the same folder as our HTML, we can simply write the file name, index.js. This relative path is all we need to link the file correctly. Our first step involves accessing the HTML elements from our JavaScript code. This access allows us to manipulate these elements and add interactive features. Our goal is to add event listeners to each of these buttons using JavaScript. To do that, we first need to gain access to the container div that holds all of the buttons. We could add an event listener to each button individually. That approach would work perfectly fine. There is a much simpler method available to us. We can use a for loop to go through all the buttons inside this container. This loop will allow us to target each button one by one efficiently. To select all the button elements on our page, we will create a constant variable. We will call this variable buttons elements because it will hold all our button elements. We want to get every single button on the page. We can do this by targeting the document object. We then use the querySelectAll method. This method allows us to select everything with the button tag. Let us test our selection by logging the buttons element to the console. I will copy this line and place it in our file. You can open the browser console by pressing the F12 key. After you refresh the page, you will see we have captured all the buttons. This appears as a node list containing 17 items. Let me clarify the button count for our calculator. We have 10 number buttons from 0 to 9. We also have 4 operator buttons for addition, subtraction, multiplication, and division. This gives us a total of 14 buttons so far. We must also include the decimal point button and the clear button. Finally, we have the equals button for calculating the result. We have successfully selected all the buttons with our code. This gives us complete access to each button element. Looking at these buttons, you can see they have different classes. Some are designated as clear buttons, while others are marked as operators. Our next step involves adding an event listener to every single button. This will allow our program to detect when a user clicks on any button. Let us delete that console log statement for now. Instead, we are going to create a for loop. We will create a for loop to go through each button. We will initialize a variable called I and set it to start at 0. This variable, I, will increase until it is less than the total number of buttons. We can get that total number by checking the length property of our button elements collection. The length of our button elements is 17. This condition checks if our counter is less than the total number of buttons. Using the button's element length property is the correct approach for this. We need to correct the for loop syntax by adding a semicolon here. We place another semicolon after the condition. Then we increment the counter variable by 1 each time the loop runs. We will use the increment operator to increase the value of I by 1 with each loop iteration. The variable I begins at 0 and increments by 1 each time. It continues through each iteration until it reaches the end of the button elements list. The loop begins counting at 0. It continues incrementing until it reaches 16. That brings our total number of iterations to 17. Each button will be processed individually by this loop. Our loop begins counting at 0 and continues until it reaches 16. This process gives us 17 complete iterations. During each iteration, we attach an event listener to a different button. We need to target the entire collection of button elements. Then we want to access each individual button within that collection. We add an event listener to each button element. We achieve this by using bracket notation with our index variable I. This loop gives us access to each button element individually. The index value I will be 0 for the first button. It will then increment to 1 for the next button. This continues sequentially until it reaches 16 for the final button. Next, we will attach an event listener using the addEventListener method. This method allows us to detect when a user interacts with our button. We want to listen for a specific user action. We are going to add a click event listener. Every time someone clicks a button, we want to execute a corresponding function. We need to create a function for the click event. This function will handle what happens when a button is pressed. Every time a user clicks one of the buttons, we need to trigger a function. This function will then retrieve the specific value associated with that clicked button. For example, we can demonstrate this by logging the button's text content to the console. The text content is the label we see on each button in our project. The clear button shows the letter C. The following button shows the division symbol. Then we have the multiplication symbol and the numbers 7 and 8. Let's test this functionality by checking the console output. Each time we click a button, its text content should appear in the console. Let's open up the browser console one more time to see the results. Each time you click any button, you will see its value appear. For example, clicking the 0 button displays 0 in the console. This happens because we are capturing the text content from that specific button. We are successfully getting the text content from every single button. This includes the 2, the 3, the equal sign, the plus, and the minus. All of the buttons are working correctly, even the clear button. This confirms that we are correctly capturing the value of each button. We now have access to all the button values. I will replace the console log statement. Let us store the text content in a variable. We can call this variable button value. We have captured the button's value at this point. Now we can proceed to implement conditional logic based on that value. Now, for the clear button, we need to add a specific condition. We can write an if statement to check if the button value is the letter C. When that condition is true, we should call a function to clear the results. Every time someone presses the C button, we want to call this clear function. We must remember to create that function first. We will name this function clear result. Let us create this function for now to prevent any errors. We will add the actual functionality to it later in our development process. Let us move forward with completing this conditional statement structure. We need to finalize the if and else if conditions for our button interactions. Next, we need to add another condition. We will use an else if statement for this. This condition will check if the button's value is the equal sign. When the user clicks the equal sign, we will call a function to calculate the final result. This function is named calculateResult. Let us create that function and name it calculateResult. We will continue writing the rest of the if statement. The next scenario we need to consider is when the button value is a number. This could be any digit from 0 through 9. It could also be the decimal point. Otherwise, the button value could be any number from 0 to 9. It might also be the decimal point. We want to show this value on the display. This action appends the button's value to whatever is already there. Our goal is to display the number or symbol on the screen. We also need to add it to the existing sequence of inputs. We are going to call this function append value. We will pass the current button value into it. Let's create this append value function now. We will define it right here. Next, we need to create a new function for appending values. This function will be called append value. That covers the creation of our 3 main functions. Our event listener now handles 3 distinct scenarios based on which button is clicked. When the button value is the letter C, we will trigger the clearResult function. This function will completely erase the current calculation from the display. If the button's value is the equal sign, we will call our calculation function. This function will process the mathematical expression and display the final result. We want to add that button's value to the display. This action will append the number or operator to the existing input field. Let us begin by implementing the append value function. Let's talk about the append value function. This function receives the button's value as its input parameter. We are passing this value when we call the function. This value becomes the function's input parameter. We now need to access this specific input value. We can write this value directly into our display field. We need to display the value we captured on the screen. We can accomplish this by writing that value into the input field element. Looking at our HTML file, you will see we have an input field. This input field has a special identifier called an ID. We gave this input field the ID of result. To access this input field in our JavaScript code, we can specifically target it using its unique ID. We need to get the input element at the start of our code. We will target it by its ID and store it in a variable. I'm going to call this variable input field element. This variable will be equal to the document object. To access the input field, we will use a specific method. This method is called getElementById. We will use this method to target the element with the ID of result. Since we already know the input field's ID is result, we can directly target that element by using that exact ID name. Now we have access to the input field element inside our append value function. We want to target that specific input field where our results are shown. We are going to set the value of this input field. We do not want to replace the current value entirely with the new button value. Instead, we want to add the new button value to the end of the existing value. We accomplish this by using a plus equals operator. This approach appends the new value to the existing one. For instance, if the current value displayed is 2 and you press the button for 3 next, the display will update to show 23. Let me demonstrate how this works in our live application. You will see the numbers appear on the display as we click them. Let me type the number 1 on the keyboard. We can see the number 1 appear in the display area. The number 1 will remain on the display. Pressing the number 2 button will then append that digit right after the 1. When you press the number 1, it appears on the display. Then, when you press the number 2, it is added right next to the 1. If we were to press the equals button immediately after entering a number, that number would be replaced entirely. For instance, typing a 4 and then pressing equals would leave just a 4 on the display. If we press the 5 button next, it will replace the current display. Our new input will overwrite that entirely. To preserve the existing numbers on the display, we use the plus equals operator. This ensures the new value is appended to the previous one. This approach is very similar to writing the full expression. We are essentially telling the value to become itself plus the new character. Using the plus equals operator is a helpful shortcut for this task. It allows us to append the new value directly to the existing one. This approach will function in a similar way. Let me demonstrate with an example. If you press the number 1 followed by 5 and then 2, you will see the numbers appear consecutively as 152. I will copy this line to demonstrate both approaches for you. The plus equals operator accomplishes this task. I will comment out the alternative method for your reference. This shows how both techniques produce a similar result. That is the method we will use for our calculator project. We have successfully captured the value from the button. This value is now stored in our input field. When we click the plus sign, we want to trigger an evaluation. This process will calculate the final result for our mathematical expression. Inside the calculate result function, we will work with the input field element. We want to take the current expression and evaluate it. We want to replace this current value with the result of a calculation. We can do this using a special JavaScript function called evaluate. This function will process the mathematical expression we have built. The eval function is built directly into JavaScript. It takes a string of text. Then it processes that text exactly as if it were regular JavaScript code. For example, we can evaluate a simple expression like 2 times 5. When we press the equals button, the display will show the result of 10. The eval function processes that entire string of characters as a mathematical expression. We receive the final calculated result from whatever operation was typed. For instance, if we enter the number 1 and then press the plus sign and another one, the display will show the string 10 plus 1s. When we press the equals button, the evaluate function will calculate that expression. The result displayed will be the number 11. That makes sense with the plus equals sign. Our goal is to take the current value inside the input field. We want to evaluate that mathematical expression. Then, we will display the final calculated result back into that same input field. Let's try a simple example to see how this works. Imagine we type in the number 45 and then add 5 to it. When we click the equal button, the display now shows the correct result of 50. That calculation worked perfectly and gave us the correct result. For example, we currently have 50 displayed in the input field. If we press the multiplication button and then 5, we will get 250 when we press the equal sign. When a user clicks the equal sign, it will evaluate the entire mathematical expression currently displayed. This process calculates the final result for the user. The evaluate function processes mathematical expressions. It takes a string of numbers and operators as input. This function then computes the final result for you. You should now have a clear understanding of how the evaluate function works. When I have seen other online tutorials for creating a calculator, many of them handle the math in a different way. They often write separate logic for each type of operation, like addition or multiplication. Some online tutorials create separate conditions for each operator. They might write code that checks if the operator is multiplication and then performs a multiplication. This approach requires many different checks and can become quite lengthy. The method we are using with the evaluate function is far more efficient. It handles all the calculations in a single, clean step by processing the entire expression. That clever trick with the evaluate function is the core of our calculation logic. The only remaining feature to implement is the clear button. When someone presses the C button, we want to completely clear out the input field. This will reset the display to be empty and ready for a new calculation. Inside the clear result function, we will set the input field's value to an empty string. This action will completely clear the display for the user. We want to completely clear the input field. We will set its value to be an empty string. For instance, if our calculator display currently shows some numbers, pressing the C button will completely clear the display. This action removes everything instantly. We can perform a calculation and see the result displayed. Then we can clear the entire display with a single press. This basic calculator project demonstrates the core functionality. It provides a solid foundation for your web development journey. You could also add parentheses to your calculator for more complex mathematical expressions. This would allow you to group operations together and change the order of calculations. You can incorporate parentheses for more complex calculations. You might also add a feature to delete the last character entered. Adding the ability to delete just the last number you entered is also a very simple feature to implement. For example, imagine we type the number 45. We might want to delete just the last digit, the 5. To do this, we would add a new button to our calculator. That new button would trigger a function. This function would not add a new value. Instead, it would remove the last character from the display. I encourage you to try implementing this feature as a practice exercise. Feel free to share your completed work with me afterward. You have successfully created a simple and basic calculator. This project demonstrates the core functionality of a working calculator application. I hope you found this project enjoyable and educational. You have learned several important programming concepts through this practical exercise. We have learned how to use the eval function for calculations. We also learned how to add an event listener to multiple buttons using a for loop. Finally, we learned how to clear the display, calculate results, and append new values. We have accomplished many valuable skills in this project. We will continue our learning journey with another exciting project in the next one. So see you soon in the next project. In this video project, we will build a currency converter from scratch. You can see the final project has two currency selectors. These selectors help you choose different currencies. For our first currency, we have the US dollar selected. The second drop-down is set to Australian dollars. You can choose from 7 different currencies. These include the euro and the Canadian dollar. You can also select the Indian rupee and the Japanese yen. Finally, the list includes both the Australian and US dollar. Every change you make will send a request to an API. This request will first return the current exchange rate. For example, 1 US dollar equals 81 Indian rupees. The converter then uses the amount you type in. Typing 3,000 US dollars gives a result. The output is almost 244,000 rupees. Whenever you adjust either value, the interface updates instantly. It sends a fresh request to the API with every single change. This new data automatically populates the final converted amount. It also updates the current exchange rate for you. We will use JavaScript to fetch the data from the API. We will then display the information and populate the input fields. This is done by updating their properties dynamically. Let us now move forward to the next section. We will begin building the HTML structure for our currency converter project. Alright, let us begin building our currency converter project now. You can see the final version of our project here. This serves as our visual reference. You can see we have a title at the top of the page. It clearly says Currency Converter. We have 2 drop-down selectors on the page. You can use them to choose different currencies. For the first currency selector, you could choose US dollars. For the second selector, you might pick Japanese yen. You will then see the current conversion rate between them. The application also displays the final calculated amount. You can also adjust the conversion rate directly in this section. This gives you another way to control the values. You can enter any number you want into this field. This gives you the freedom to convert any amount you need. Let us begin our project by creating the HTML structure first. This is the foundation for our currency converter. I'm going to open Visual Studio Code now. You can use any text editor you prefer for this project. I'm going to open a brand new window for this project. I will close the current window that is open. This will give us a clean workspace to begin. Let's proceed with closing this window. We are beginning this project with a completely blank slate. Let us go ahead and close that Get Started tab. We will navigate to the File menu. Then we select the Open Folder option. I usually create my new projects on the desktop. This helps keep everything organized and easy to find. I will navigate to my desktop location. I will create a new folder here. I will name this folder after our project. The project name is Currency Converter. After typing the project name, we press the Enter key. Then, we choose the folder by clicking the Select Folder button. This action opens our project folder in the Explorer panel. From this location, we can create our 3 essential files. We will need an HTML file, a CSS file, and a JavaScript file. Let us close the Get Started tab one more time. In the left side Explorer section, click here to create a new file. We will name this new file index.html. We have created our HTML file on the right side. This new file is currently completely empty and ready for our code. We can quickly generate the basic HTML structure. We just need to type a single exclamation mark. We type a single exclamation mark into the editor. This action triggers an automatic suggestion from Emmet. When we select the first auto-suggestion, it provides a complete HTML boilerplate. This boilerplate includes the document type declaration. This declaration specifies the type and version of HTML we are using. Since we are working with HTML5, the document type declaration is simplified. We only need to specify the word HTML here. Next, we have the HTML tag. This tag acts as the main container. It wraps around both the head and body sections of our document. The lang attribute specifies the primary language used on the page. We are setting this to English for our project. This helps browsers and screen readers process the text correctly. Next, we have the head tag. This section contains all the metadata tags for the web page. It also holds the title tag for the browser tab. The first meta tag defines the character encoding for the page. We are using UTF-8 for this purpose. This encoding is recommended by HTML5. It includes all necessary characters and symbols. This ensures text displays correctly in all languages. This next meta tag is specifically for Internet Explorer users. It tells the browser to use the latest rendering engine available. This means it will use Microsoft Edge's engine instead of the old one. This ensures a more modern browsing experience. The next metadata tag controls the viewport settings. This tag specifically handles the viewport's height and width for different screens. It ensures your website looks good on all devices. This setting ensures the width of your web page matches your device's screen. It will automatically adjust to fit any screen size perfectly. The initial scale controls the browser's starting zoom level. We set this value to 100%. Currently, the title tag displays the word Documents by default. If we open the browser at this point, we can see our website. It will be displayed on the screen. I happen to be using the Live Server extension for this. Click the Go Live button in your editor. This action will launch the website directly in your browser. My default web browser is Google Chrome. The page automatically opens in that browser. Right now, our website page is completely blank. We can only see the title document in the Browser tab. Let me position my code editor on the left side. I will place the live website on the right. This setup lets us see all changes happen in real time. Let's move the Explorer section to the left by dragging it. You can now see the document title is set to Documents. Let's update the page title to match our project. We will change it to Currency Converter. The title has now been successfully updated to Currency Converter. Let us begin creating the HTML structure for our project. We will write the necessary code inside the body section. Looking at our final version, you can see we have a main container. This container holds all of our project's elements. Inside it, we have a title for our application. This title is marked up as a heading 1 element. This container holds our currency selectors and input fields. Let me sketch out the layout for you to make it clearer. Let's look at the main container. It holds a currency selector and an input field. We also have another container for the second currency. We can create the first currency section as a template. Then, we can simply duplicate it to create the second section. This works perfectly because both sections are structured exactly the same way. To complete our layout, we need one more element. We will add a simple paragraph at the very bottom of the page. Let us begin creating the structure for our currency converter. Let us continue with the body section of our document. We are now going to add the main container. Let's create a main container for our project. We will give this container a specific class name. We can type the word container and add a dot. This dot will let the editor automatically add the class for us. When we press the Enter key, a new division element is created. This element is automatically assigned the class of container. We will style this container later using CSS. We can do this by targeting the class name we just assigned. This container holds all of the other elements for our project. We will place everything else inside this main container. Next, we have our main heading tag. This is where we will display the title of our project. Let me show you what our website looks like right now. Here, in our HTML structure, we have created the main heading tag. This heading will display the title of our application. The H1 tag displays the main heading for our page. This heading clearly states the name of our application as Currency Converter. We can now see our heading that says Currency Converter. We will style this element later using CSS. For now, we are focusing only on building the HTML structure. Following the main heading, we have a new container. This container holds a currency selection dropdown. It also includes a number input field. Next, we will create a div element. We give it a class name like Currency Container. Inside this container, we will place our currency selection drop-down menu. We will now add a select element for our drop-down menu. This will allow users to choose a currency from a list. Our select tag does not include a name attribute. We are adding an ID to it instead. This ID will help us identify which specific selector we are using. We will use JavaScript to target this specific drop-down menu. This allows us to retrieve the currency information the user has selected. We will assign an ID to this select element. Let us call this ID currency first. We need to give this select element an ID to identify it. Let's call this one currency first since it's for the initial currency selection. Looking at our select element, we can see it is currently empty. It does not contain any options for the user to choose from. We need to populate our drop-down list with choices. We will add the different currency options inside this select element. Let's create our first currency option. We will set the value to Australian dollar. The text displayed will also be Australian dollar. We have successfully added our first currency option to the list. We can easily copy this option to add more currencies. I plan to include 7 different currencies for this demonstration. You can easily add more currencies later if you want. Let's copy this option 6 more times with the keyboard shortcut. We need to add 7 currencies in total. For the second option, I can use the Ctrl-D shortcut. This selects both instances of the word. Then I can change it to Canadian dollar. We now have Canadian dollar as our second option. The third currency we are adding is the euro. Please write these currency codes exactly as shown. The API we are fetching data from requires this specific format. It will not recognize any other variations or spellings. The API requires the exact currency code format. Writing it lowercase will not work correctly. Spelling out the full currency name like Australian dollar will also fail. It is very important to write the currency names exactly as shown. The API we are using requires this specific format to work correctly. For the next currency, I will select the Great British Pound. For the next currency, I will add the Indian rupee. Following that, we will include the Japanese yen. Finally, we will add the US dollar as our last option. We have successfully added all 7 currency options to our first drop-down selector. Our next step is to add the input field for the amount. Next, we need to place an input field inside this same container. This input will allow users to enter numerical values. Next, we add an input field to our form. We will set its type to number. This ensures only numerical values can be entered. This input field does not need a name attribute. We are assigning it an ID called worth first. This ID represents the value for the first currency. The initial value is set to 1 by default. This value appears when a new user visits the website. The minimum allowed amount is set to 0. We do this because currency values cannot be negative. In accounting, you might encounter negative values. However, for a currency converter, we do not use negative amounts. We have now completed this first currency container. It holds the currency selector and the input field for the amount. Now we can easily create the second currency selector. We can simply duplicate the first container we just made. This will save us a lot of time and effort. We can quickly duplicate this entire container. Just hold down the Alt, Shift, and down arrow keys together. We need to make a few small changes to this second container. For this second selector, we need to update the identification. The first one uses the identifier currency first. This one should be changed to currency second. The list of currency options inside will remain exactly the same. For the second input field, we assign the ID worth second. This unique identifier is important for our JavaScript code. Everything else is working correctly in the second container. The key difference is functionality. You can only edit the first input field. This second input field is actually disabled for user interaction. You cannot directly type in this box to change its value. We will disable the second input field for the user. This prevents any manual changes to its value. Since the field is disabled, we do not need to set an initial value. The disabled state handles everything for us automatically. Let's make the US dollar the default currency. This selection will appear automatically every time the page loads. Currently, Australian dollar is the default selection. We can change this by using the selected attribute. Let us set the first selector to default to US dollar. For the second currency selector, we can set Indian rupee as the default. We have completed most of the HTML structure for our currency converter. There's just one final element left to add. Let's add the final paragraph element to our project. We will now add a paragraph element at the very end of our container. This paragraph will display the exchange rate information. Next, we add our final paragraph element. This paragraph will have a class called exchange rate. It will also have an ID with the same name. We can hard code this text for the initial setup. We will make it dynamic with JavaScript after applying the styling. All the real exchange rate data you see displayed comes directly from an API. This information is fetched live from an external service. That wraps up the HTML section for our currency converter. We will begin styling everything with CSS in the next video. We just finished building the HTML structure in the last section. Our project now has all its core elements in place. Let us begin styling our project using CSS. Looking at the final project version, you can see a container here. This container is covering all the elements on the page. You will notice the website's background is a bright yellow. Inside that, we have a container with a different greenish color. Everything appears perfectly centered on the page. You can see this with the paragraph text and the main heading. Both elements are aligned directly in the middle. You can see we have two currency containers. The drop-down selector is positioned on the left side of each container. The input field for the amount is positioned on the right. To begin this process, we should create a brand new CSS file. This file will hold all of our styling rules. Let's open up the File Explorer panel on the side. You can open the Explorer section by pressing Ctrl-Shift-E. Let's create a new file now. We will name this file style.css using all lowercase letters. We have our CSS file ready for use. Before we can apply its styles, we must connect it to our HTML document. We do this by adding a link in the HTML file. Let's go ahead and close the Explorer section now. We will add the link at the top of our HTML file. After the title tag, we add a link element. We set its relationship to stylesheet. This connects our HTML to the CSS file. We are adding a link to our CSS file. This link establishes a relationship with the HTML. We define this as a style sheet. We write the destination as style.css. This works because both files are in the same directory. Our CSS file is now properly linked. We can begin applying styles to our project. Let's begin by styling the main body section of our page. This body element covers the entire visible area of our website. Our goal here is to update the background color. We also want to center all of the content on the page. Let us navigate to our style.css file. We will begin our styling by targeting the body section. Let's add our opening curly brace for the body section. Let's start by changing the background color. We are going to set it to yellow. Let's save our changes and refresh the page to see the result. The background color has now been changed to yellow. This gives our page a bright and vibrant base. To center everything on the page, we need to do two things. The first step is to change the display property. We are changing the display property to flex. This will allow us to control the container's position on the screen. We are going to change the display property to flex. We also need to define a height for the body. Let me quickly correct that point about the height. We need to set the body's height to cover the entire screen. We will use 100% of the viewport height for this. This means it will occupy the full height of your display. Now we can center this container perfectly. We will use Flexbox properties for positioning. Set Justify Content to center for horizontal alignment. Use Align Items Center for vertical positioning. Next, I want to change the font family for all the text. I will set it to Courier New for a clean, monospace look. This font gives us a clean and professional look for our text. Courier New is very readable and works well for web projects. That completes the styling for the body section. We should also remove the default margin and padding from the body. This gives us a clean slate for our layout. Notice that the unnecessary scroll bar has also disappeared from the screen. We have finished styling the body section. Next, we will style the container element. Let's go back to our index file. We added a div with a container class. This container wraps all of our content. Now we are going to style this container div. We want to change its background color to a nice green. We also want to center all of the content inside it. Now we will target our container div in the CSS. We know it is a class selector. Therefore, we must use a dot before its name. We will target the container class by typing .container. Then we open a set of curly braces for our style rules. This container class is correctly targeted for our styling. Let us start by changing the background color for this container. We will update its appearance first. Let's choose a dark cyan color for the background. This provides a pleasant greenish tone. Let's change the text color to white. We will use a color property for this. The specific color I have chosen is called Alice Blue. This gives us a very light color that is not pure white. Let's add some padding to create space inside the container. This will make the content more comfortable to read. Let's add some breathing room between our text and the container edges. This padding will make everything look less cramped. Let's decide on the padding for our container. I think 20 pixels might be a bit too much. 10 pixels should be sufficient for the spacing we need. Next, I want to round the corners of this container. Let's add a nice rounded corner to our container. We can set the border radius to 5 pixels. The current styling looks good for now. We might need to add more styles later for larger screens. For the moment, we will leave the container as it is. Let's move on to styling the currency container elements. We have 2 of these containers to style. Looking at our layout, we have 2 currency containers. The first one is up here at the top. The second one is down here at the bottom. We need to style both of these currency containers. Let's apply the same design to each one. I will copy the currency container class name. I will paste it into our CSS file here. Now I can start adding some styling properties to it. First, I want to add some padding to this element. Let's set the padding to 20 pixels. This padding gives us some nice breathing room between the elements. Next, we are going to change the display property. We will set it to flex. We want to create some separation between the currency dropdown and the input field. We will distribute the space evenly between these 2 elements. We can achieve this spacing by using the Justify Content property. We will set its value to space between. This will push the selector and the input apart. They will now appear on opposite sides of the container. This layout is coming together nicely. The spacing between our elements looks well balanced now. We have completed the styling for the currency containers. Next, we will style the dropdown selector and the number input. Let's focus our attention on styling the select element. We need to target this specific part of our form. Looking at the HTML file, we can see the select element. It is nested inside the currency container. To target that select element, we can use its parent container. We add a space after the container class name. Then, we write the word select for the tag. We do not need a dot for this element. We open a new set of curly braces for this rule. Now we can specifically target the select element for styling. Let's add some padding to this select element. We will set it to 10 pixels. Adding this padding increases the size of the select element. This makes the text inside much easier to read. That looks much better for the select element. Next, we need to style the input field. We will target the input element for our next styling steps. We can apply the same approach we just used. We target the currency container class first, then we add a space after it. Next, we write the word input to select it. This works because the input is a direct child of that div. This currency container div holds two elements. It contains a select dropdown and an input field. This input element is nested within the currency container div. We target the input field by writing this CSS selector. This approach lets us style the input specifically. Let's remove the border from this input field. We will set the border property to 0. This will give it a cleaner look. Let's change the background color for the input field. We can set the background to transparent. This means the input will have no color of its own. The input's background is transparent. This lets the number show clearly. We should increase the font size. Let's set the font size to 25 pixels. This will make the text much larger and easier to read. We want these numbers to appear on the right side. To achieve this, we will adjust the text alignment property. We are changing it from left alignment to right alignment. This positions the number neatly on the right side for better readability. Let us change the text color to match the heading above. We will set it to Alice Blue for consistency. The input field is now fully styled and looks great. We have completed all the styling for the input section. We will need to add more styling to our container element later. We are not completely finished with it yet. We can see the heading and paragraph are no longer centered. They have shifted over to the left side of the container. We want these elements to be perfectly centered on the page. Let's align them both in the middle. To center the text inside the container, we simply add the text align property. We set its value to center instead of left. That looks perfect with everything centered. Our final styling task is to format this paragraph. Looking at the HTML structure, we can see the paragraph element. This paragraph has a class assigned to it called exchange rate. We can copy this class name from our HTML file. We then add a period before it in our CSS file. This allows us to target the paragraph element specifically. Now we can style it just as we want. Let's set the font size to 16 pixels for better readability. We will also add a font weight of 600. This makes the text slightly thicker and bolder. This adjustment gives the text a bit more visual weight. Let us take a moment to observe the updated appearance. This paragraph looks great at different screen sizes. The styling remains consistent and readable. You might have noticed a line appearing around the input field. This outline shows up whenever you type a new number. We can easily remove that outline around the input field. We just need to target the focus state of the selector. We also want to remove any outline from the input when it is clicked. This gives us a much cleaner look for our form. Focus is the state of an element when it is active. This happens when you click directly on the element. It also occurs when you use the tab key to navigate to it. To target the focus state of an element, you need to add a colon here. We can remove the focus outline entirely. Just set the outline property to 0. Alternatively, you can set the outline to none. This removes any outline that appeared when focusing on the input field. You will no longer see any visual border around it. Our styling work is now complete. The project's visual appearance is fully implemented and looking good. In the next section, we will tackle the project's JavaScript. We will learn to use a currency converter API. We will fetch all the necessary exchange rate information. This data will update based on the user's selections. The results will be displayed in the output field. That covers everything for the styling of our project. We will begin the JavaScript part in the next section. We finished working on the project's styling in the last section. We successfully completed all the CSS for our currency converter. In this section, we are going to bring our project to life. We'll start adding interactive functionality using JavaScript. We have built the user interface with HTML and CSS. Now, it is time to bring it to life by adding functionality. We need the application to update instantly. This happens whenever you change a currency or type a new number. The result will appear immediately in the output field. Every time you change any of these three inputs, we will fetch fresh data from the currency API. This API provides all the real-time exchange rate information we need. Let's begin by creating our JavaScript file. Let's open the File Explorer panel now. You can do this by pressing Ctrl, Shift, and E together. On the left side, we will create a new file. We should name this file index.js. We previously connected our CSS file to the HTML. Now, we must do the same with our JavaScript file. Let's close the Explorer section on the left. We can do this by pressing the Ctrl and B keys. We need to place our script link at the end of the body. This ensures all the page elements are fully loaded first. Then our JavaScript can safely perform its calculations. If we load the script too early, the page elements will not be available. The JavaScript code would then fail to interact with them. We load our CSS at the very beginning of the page. For JavaScript, we place it at the very end. This ensures all the page elements are loaded first. Then our code can safely interact with them. We add the script tag at the end of the body. The source attribute points to our index.js file. This works because both files are in the same folder. Our JavaScript file is now properly connected. We can start adding interactive features to our project. Let us break down what comes next in our project. We need to complete several important steps. First, we need to access the elements from our page. We need the first currency selector and its corresponding input field. We also need the second currency selector and its input. Finally, we need the element that will display the exchange rate. We need to access 5 different elements from our web page. These are the elements we want to bring into our JavaScript code. Let's switch over to our JavaScript file now. We need to import all 5 of these elements into our script. Now, each of these 5 elements has its own unique ID. Let's look at the paragraph element. It has been assigned the ID of exchange rate. This input field has an ID of worth second. We use this ID to target the element in our JavaScript code. This selection menu has an ID of currency second. The first selection menu has an ID of currency first. The first input field has an ID of worth first. We need to select these specific elements from our document. We will do this by targeting their unique ID attributes. We will use the getElementById method for this task. For our first element, we create a constant variable. We can name it currency, first L, where the EL stands for element. We get this element by targeting the document object. The document object represents our entire web page. We can use the getElementById method to target that specific element. The element's ID is currency-first. We have successfully stored that first currency element in our JavaScript code. Let us retrieve this input element next. We will target it using the same method we used previously. We will name this input element worth first element. This follows the same pattern we use for the first element. To do this, we will target the main document object. We use the getElementById method to select our element. We pass in the ID name worth first. We can copy these 2 lines of code for the first currency. Then we will create the same 2 elements for the second currency. This will give us the second set of inputs. I will copy both lines using the keyboard shortcut. I need to change the text from first to second. I will select the first instance of the word first. Then I press Ctrl D to select the next matching word. This allows me to change both to second simultaneously. The only change required here is the capitalization. I need to make this first instance lowercase. I also need to change the second instance to lowercase as well. We have successfully retrieved these 4 elements from our document. The final element we need to target is this paragraph. It has the ID of exchange rate. I will copy the ID exchange rate. Now, I will create a constant variable. I will call this variable exchange rate element. This will be set to document.getElementById. We use the copied ID exchange rate. We have successfully selected all 5 elements from our web page. Now we can use these elements in our code. We can read data from them or change their values. We need to retrieve the information from these 2 drop-down menus. We also need the value from this input field. We need to get the values from these 3 elements. We also need to update the values for these two outputs. We need to add event listeners to these three elements. This will let us monitor for any changes. The purpose of this event listener is to monitor for any changes. When a change is detected, it will trigger our function. This function will then fetch the latest currency data from the API. We want to trigger our function for 3 different inputs. Any change in a number or a currency selection will start the process. The first step is to create a function. We will define this function now. Let's create a function to handle the currency updates. We can call this function something like update rate. We will use this function with our first currency element. We need to add an event listener to the currency first element. This event listener will detect whenever changes occur in this selection. It will trigger our update rate function automatically. We want to detect any change made to this drop-down selection. When a change happens, we will automatically call the update rate function. We want this function to be called automatically. It should happen every time a change is made to this specific element. Let us test this functionality right now. We can check if our event listener is working correctly. Let me test this by adding a console log statement. We can use a simple message like called. Let's test this change to see if it works. Let's open the console using the F12 key. I will move it to the bottom of the screen. You can now see the browser's developer console panel. This console will display our logged messages. Let me demonstrate by changing this first dropdown. For example, I will switch the currency from euro to Japanese yen. Let's check the console now. We should see a log message appear there. Let me refresh the browser page for a moment. We can try the functionality again. Let's test our event listener for the first currency element. We should check if it triggers correctly. Let me check if we have correctly selected the currency first element. We have added an event listener to this element. It will be triggered whenever a change occurs. This event listener will call our update rate function. Let me give this another attempt now. It seems our function is not working as expected. Let me quickly check if this connection is set up correctly. We need to check the script tag for our index.js file. I'm going to pause the video for a moment. Let me find out what went wrong with our code. I will be right back as soon as I find the solution. I just found the mistake we were making. We were working on the wrong version of the website. I just realized we were testing on the wrong website. We were using the final project version for our tests. My apologies for that little mix-up with the tabs. Let us now switch to the correct tab. We need to ensure we are working in the right project file. Now let's test our event listener by changing the first currency. We are selecting euro instead of US dollar. You should see the word called appear in the console log. This confirms our event listener is functioning correctly. We can see it is working as expected. We should also add an event listener to this second selector. We will include the input field as well. Next, we will add an event listener to the second currency selector. This listener will be triggered whenever its value changes. It will then call our update rate function to refresh the data. Now, we change the second currency selector. This will also trigger the console log message. Let's add the same event listener to the first number input. We target the first input element by referencing its identifier. We then attach an event listener to this element. This listener will specifically monitor for any numerical input changes. We have two options for this event listener. We can use the change event or the input event. Let's use the input event for this field. We want to monitor any changes made within this input field. Whenever a user types or modifies the value, we will trigger the update rate function. Now you can see the function is called with every change. This happens when we type a new number or press the enter key. You can see the console log updating immediately. This happens every time we modify any input value. We have successfully added the event listeners. We need to complete our update rate function. This function will fetch the live exchange rate data. Next, we need to get the live currency data. We will use a website that provides an API for this. To find the currency exchange API we need, you can search Google for Exchange Rate API. You will see a website called exchange-api.com in the search results. This service is completely free for you to use. To get started, you just need to provide your email address. This will allow you to receive your personal API key for free. I have already signed up for this website myself. I successfully obtained my personal API key. The service is completely free to use. You can see that no credit card details are required. You only need to provide your email address to get started. You simply need to provide your email address on their website. This will allow you to receive your personal API key for free. I already have my API key from signing up previously. Unfortunately, I cannot go through the sign-up process again for this demonstration. The process itself is very straightforward and easy to complete. I will now show you how to use that API key. You will need it to fetch the currency data. Let's navigate back to our project website. We should position our browser window on the right side. Let's move on from just logging to the console. We are now ready to fetch live data from the currency API. We will use the fetch function to make our request. This function needs the specific address for our currency conversion API. The API address needs to be dynamic for our request. We will fetch data based on the first currency selected. The result will then be calculated for the second currency input. This dynamic approach allows our application to fetch current exchange rates. We can get the most up-to-date information every time. Now we need to add a backtick character to our code. The backtick is located on your keyboard above the tab key. It is not the same as a single quote. You can find the backtick character on your keyboard. It is typically located above the tab key. This character is different from a single quote. The website provides the exact address you need. You will find this address after signing up for their service. You could certainly copy that URL directly. I will type it out for you to see the complete address. The website address uses v6.exchangerate-api.com. After the /, you will add v6. Then, you need to include your unique API key. You get this key from the website. I will get my API key from my email inbox. I have copied my API key from my email. I am going to paste that key right here in the code. You should use your own API key for this project. I will be changing my key after this video. The free plan has usage limits you should be aware of. This API key allows for 1,500 requests every month. You will need to pay for any requests beyond that limit. I strongly recommend that you get your own personal API key. This is the best approach for your project. After the /, we type the word latest. Then we add another / immediately after that. Next, you will need to specify the first currency. You need to use a $sign and curly braces here. This is because you are inserting a dynamic variable into the address. We can retrieve the value of this first element. We just need to access its value property. We copy the first element name, replace it inside the backticks. Then we add a dot and the word value. This gets the current value from that element. This allows us to capture the currently selected value. This API call fetches the exact currency we select. When we choose US dollar, we receive data for US dollars. If we pick Australian dollar, we get data for Australian dollars. After this step, we have completed the fetch request. Next, we need to handle the response we get back from the API. To get the response from the API, we use the .then method. This will process the data we receive. Once the fetch request is complete, we receive a response from the API. The response from our request arrives here within these parentheses. You must convert this response into the JSON format. This conversion process makes the data readable and usable for our program. JSON is a special format for organizing data. It makes the information from the API easy to use. The raw response from the API is not directly usable. We need to convert that raw response into a JSON format. To convert that response into usable data, you simply write .json. This calls the JSON method from JavaScript. Once we convert the response to JSON, we can then access and use the data. We then add another .then method to the chain. This next step will give us the actual data we need. This data is now ready for you to use. You can access all the conversion information from the API response. Now we can return this data and start putting it to use. Let me show you what this data looks like in the console. Let's check this in the console. I will log the data we received. Let's check the console to see if our code is working correctly. Let us open the browser's developer console. You can do this by pressing the F12 key on your keyboard. Let's test our function by changing the first currency to Australian dollar. We should see the API data appear in the console log. As you can see, the request was successful. Now, we are receiving all the data from the API. This data contains all the currency conversion rates we need. The specific conversion rates we need are stored inside the conversion rates object. This object contains all the data for our currency calculations. Inside the conversion rates object, we have all the currency values. These values are based on the Australian dollar. We requested the Australian dollar from the API. We received all the currency conversion rates for it in return. For example, the Canadian dollar is listed at 0.8991. The euro is shown at a different value. This demonstrates how all the currency data is provided. For instance, the euro conversion rate is displayed here. This is all live, real-world financial data. It reflects the exact rates at this moment during the recording. You have access to every single currency conversion rate through this API. This allows you to perform accurate and up-to-date calculations for your project. Let's move forward from just logging to the console. We want to retrieve the actual conversion rate. Then, we will display this rate in the designated exchange rate element. I will create a constant and call it rate. This rate will be equal to the data we are fetching. We find this data inside an object property called conversion rates. The question is, which specific conversion rate we need. We want the rate for the currency selected in the second dropdown. We need to find the specific conversion rate. This rate depends on the currency in our second dropdown menu. We need to know which specific conversion rate to use. We get this from the second currency selector. We need to tell the API which specific currency rate we want. We will get this information from the second drop-down menu. This selector allows us to choose the specific conversion rate we want. We base this selection on the value chosen in the second currency dropdown. We need to obtain the value from this second currency element. We can get that value directly. We specifically need the conversion rate for our second currency. We will get this rate from the API response data. Let me take a moment to check what is happening here. We need to change these parentheses to curly braces instead. This correction will fix our code structure properly. This fix ensures our function returns the data correctly. We are now getting the direct response we need. Let's check the console log now. We should see the actual conversion rate displayed there. Let me open up the console log now. I will press the F12 key to do that. Let's observe the euro conversion. It shows 1 euro equals 84.77 Indian rupees. It also equals 1.03 US dollars. This data we are fetching corresponds to our second currency selection. We have successfully retrieved the live exchange rate data. We have all the data we need to populate this field. Let's use it to update the display dynamically. This will complete the functionality we want. Changing this text is actually very straightforward. We can accomplish this with just a simple command. We target the exchange rate element to update the displayed text. We change its inner text property with the new calculated conversion rate. This will show the user the latest exchange information immediately. We should update the text content for this element. The value will change dynamically based on the user's input selections. Let's start by adding a backtick to create our dynamic text. We will say 1, followed by the first currency. We want to display the exchange rate information here. For example, we can show 1 US dollar to Indian rupee. We need to display the value from the first currency selection. We target the currency first element and access its value property. Then we can add an equal sign for clarity. We also include the second currency value using the same method. Let us test this change to see if everything is working correctly. Let us select Australian dollar from the drop-down menu. 1 Australian dollar currently converts to Indian rupees. We just missed adding the rate variable here. This is an important part of the calculation. We can place the rate inside this text. We will add the rate value first. Then we add a space and the rest of the text. Let us select Canadian dollars from the drop-down menu. We can see the conversion rate instantly updates on our screen. The conversion rate shows 1 Canadian dollar equals 60.63 Indian rupees. This amount updates automatically with any changes. We have successfully implemented the functionality. The currency conversion is now fully operational and updating in real time. There is a small issue when someone first visits the website. They will only see the hard-coded text we started with. The display shows 1 US dollar equals a fixed value. To fix this issue, we can call the function once when the page first loads. This will run the function one time at the very beginning. Let's call the update rate function once at the start. This will run the function immediately when the page loads. When a user first visits the website, they see the default currency options. The initial selections are set to US dollars and Indian rupees. We have successfully resolved that initial display issue. The function now runs automatically when the page loads. Now, we need to calculate the value for the second input field. This will be displayed in the box on the right-hand side. Next, we will update the second input field. We want to set its new calculated value. This value comes from multiplying the first input's value. We will multiply it by the exchange rate we just fetched. We take that exchange rate and multiply it by the first input's value. This calculation gives us the converted amount. For example, if you multiply 1 by 81, you get 81. This shows how the calculation works. If we enter the number 2, the result becomes 163. Let us change the input to 3. The output will now show 244. That completes our currency calculation functionality perfectly. This ensures the output value will always reflect the current conversion. You might notice this value displays 4 decimal places. We can easily adjust the number of digits shown. You can control how many decimal places appear. Simply use the JavaScript toFix method. This method lets you specify the number of digits. You just write the number of digits you want to see. For example, you can choose to see 3 digits. You could also set it to show only 2 digits. That looks like everything is working correctly now. That concludes our currency converter project and the JavaScript functionality. We have successfully added dynamic features to our application. I hope this tutorial was enjoyable for you. I trust you gained valuable knowledge from building this project together. That concludes our currency converter project. I hope you found this tutorial helpful and learned some valuable skills. I look forward to seeing you in our next project together. Alright, welcome back to another exciting project, and thank you for joining me as we create something fun and visually engaging. In this project, we're going to build an auto text effect animation that types out words one by one to create a smooth and modern typing look. When you check the final version of our project, you'll see a typing effect that displays different career titles one after another, giving life to the text on the screen. We'll create this effect using JavaScript, and as you can see, each career title changes automatically in a clean, looping animation. For example, the first title says YouTuber, then it changes to Web Developer, followed by Freelancer, and finally Instructor. You might notice that Instructor uses an instead of a, and will use the ternary operator in JavaScript to make that conditional change happen correctly. So, I'll see you in the next section, where we'll start working on the HTML part of our project and bring this animation to life step by step. Let's begin building our exciting project together. Let's begin by opening Visual Studio Code. Let's close the Get Started tab first, then click on File and select Open Folder. I usually create the project on my desktop, but you can choose any location on your computer. We begin by clicking right here and selecting the New Folder button to create our project folder. Let's name this new folder Auto Text Effects Animation and press Enter to confirm. Let's proceed by clicking the Select Folder option and then closing the Get Started tab right here. Let's begin by creating the HTML file for this project. Over on the left side in the Explorer section, we'll right-click and select the New File option. We'll name this new file index.html. We type index.html as the file name and then press the Enter key. Our index.html file is currently empty on the right side, but we can quickly generate a standard HTML structure by typing an exclamation mark. Type an exclamation mark in the editor and press Tab to select the top auto suggestion. Take a look at the standard HTML5 boilerplate we start with. To view the full code easily, press Alt-Z and enable word wrap in your editor. As you can see, the doc type appears here, informing the browser about the HTML version used in our page. Inside the header section, we include 3 meta tags along with a title tag. The charset attribute specifies the HTML character encoding, and UTF-8 contains all the characters and symbols you'll need so users can view your page correctly, which is the standard recommended by HTML5. The second meta tag is specifically for Internet Explorer, instructing it to use the most recent rendering engine. The viewport meta tag guides the browser on adjusting the page size for different devices. Specifically, this part sets the page width to match the screen exactly and starts the zoom level at 100%. You'll notice the title tag inside the head section, which defines the text appearing in your browser tab. Let's launch the browser directly inside Visual Studio Code using the Live Preview extension we've installed. Let's activate the preview by right-clicking the file and selecting Show Preview from Live Preview. We can see the browser preview is currently empty except for the title that says Document. We will update the title to match our project name, the Auto Text Effect Animation. We drag this line to collapse the Explorer section, giving us more space to view all the code. Within the body section of our HTML, we include a single container element. And inside this div container, we include an h1 heading that says, I am a YouTuber. Later in the tutorial, using JavaScript, we'll create automatic text effects that transform YouTuber into other careers like web developer or freelancer. For the moment, we have manually set the heading text here. In the next section, we will apply CSS to style our page effectively. That covers our HTML setup, and we will move on to styling next. In the previous section, we completed the HTML portion of our project. Now, we will begin styling our project with CSS. To begin styling our project, we need to create a CSS file. To open the File Explorer panel, we can use the keyboard shortcut Ctrl-Shift-E or find it in the View menu. We can right-click in this left panel to create a new file, or simply click this icon here. Let's name the file style.css and press Enter to create it. But before we can start styling with CSS, we need to link our new file to the HTML. Next, we will navigate back to our index.html file and place our cursor just below the title tag. Let's include the link tag by typing link and selecting the third auto-suggestion for CSS. You can see we now have a link tag that connects our HTML to the external style sheet file. Since both our HTML and CSS files are in the same folder, we can simply write style.css for the href value. The href attribute specifies the link's destination, which is the target URL. Perfect. Now we have everything linked up correctly. With that link in place, we have connected our style sheet. Let's save the file, close the Explorer panel, and open our style.css file to begin styling. Let's open our browser preview and make the window a bit larger before we begin styling the body section. Let's remove the default margin from the body, which is the space surrounding it, by setting the margin to 0. You can see the margin has now been removed. To center our content properly, we will change the display property to Flex. Next, we will set the Justify Content property to Center. We can now see our text is perfectly centered horizontally. Next, we'll set the height to 100% of the viewport and align the items to the center. Look closely, and you'll notice the text centered perfectly both horizontally and vertically. Now let's give the background a nice salmon color. Let's go ahead and change the font for this text. Now let's say we want to use a custom font from Google Fonts. Let's head to your desktop and open Google Chrome or whichever browser you prefer. In this step, we will search for Google Fonts. Once you see the search results, go ahead and click on fonts.google.com. Check out these various text fonts displayed right here. Try typing something simple here, like I am a YouTuber, to easily compare how fonts appear with your chosen text. I've actually decided on a font. I have decided to use the permanent marker font for this project, but feel free to choose any font you prefer for yours. We then click to select this style, and over on the right-hand side, we click on the Imports tab to copy the code from the style tag. Let's head back to Visual Studio Code and paste that copied code at the very top before the body section. Let's turn on Word Wrap with Alt-Z to see all the code clearly, and then we can go back to the browser where you'll find the font family permanent marker with cursive as a backup. Let's copy this code and head back to Visual Studio Code to paste it right below. You can see the new permanent marker font taking effect. That covers everything we need for our CSS styling. In the next section, we will use JavaScript to change this YouTuber's text to other career options and add a dynamic auto-typing effect. We will continue with JavaScript in the next section. In our previous section, we completed the project's visual styling. Now that our project looks good with CSS, we're going to bring it to life by adding JavaScript functionality. Our first step involves creating a new JavaScript file. To open the File Explorer, we can press Ctrl-Shift-E. From the left side panel, we can right-click to select the New File option. Let's give our new file the name index.js. You might notice that the code files occasionally appear on the right side, right next to the browser. You can easily bring them over by simply dragging the tab right here. This gives us a real-time view of the browser. Before we can use our JavaScript file, we need to link it in our HTML. Now we will navigate to our index.html file and add a new script tag just before the closing body tag. Within the script tag, we type the letters SC and then select the second autocomplete suggestion, which is the one containing the src attribute we need. The src attribute is the part that points to where our JavaScript file is located. You will find both the index.html and index.js files located in the same directory. For the source URL, we simply need to type index.js. With our JavaScript file properly linked, we can begin adding functionality. Let's navigate to the index.js file and close the Explorer panel by dragging this divider line. Let's start by selecting the main container for our project. We want to focus our JavaScript manipulation specifically on this container div. To grab the container div using its class, the method we need is called querySelector. Now let's create a constant variable named container_element using document querySelector, targeting the class container with .container inside the parentheses. We can press Alt and Z together, which enables word wrap, making our code much easier to read. Now that we have our container element selected, our main goal here is to manipulate this container element. For instance, you can target the container element and update its inner HTML to an empty string or any other text you choose, and notice how it appears right on screen. Before we add that functionality, we need to move our HTML content into the JavaScript string, so we cut the h1 tag from the HTML file and paste it into our backtick template. Right now, we're seeing the same text as before, but we want to make this YouTuber title dynamic. To add multiple career options to our project, we will create a constant variable named careers and assign an array to it. Next, we create an array for the careers, starting with the capitalized YouTuber, followed by examples like web developer, freelancer, and finally instructor. To display the different careers dynamically, we can replace this hard-coded text with a variable that targets our careers array, allowing us to access the first element for YouTubers or the second for web developers. To see a different career like instructor, we simply change the array index number. To avoid hard-coding values, we will create a variable named careerIndex and set its default value to 0, then replace the hard-coded number with this new variable, and finally, we need to move this entire operation inside a function called updateText. Now, we'll call this function once to display the initial text, but since we want a typing effect, we also need a new variable to track our position within each word, so let's create a character index variable starting at 0. The slice method extracts specific portions from a string based on indices. To grab only the first character, specify 0 as the start and 1 as the end. That pulls out exactly the character at position 0. For the first two characters, change the end index to 2 instead. Now make that ending index dynamic by using the current character position. So we will use character index instead. Currently, the index starts at 0, but we will increment it using the ++ operator while setting up a setTimeout function to call this repeatedly after a short delay. For the delay, we will use 400 milliseconds, and since we only have one line of code to run, we can simply call update text directly. Now, when we refresh the page, you'll see the word YouTubers type itself out completely, but the next career in our list doesn't appear yet. To handle the typing effect properly, we need to add a condition that checks if the character index has reached the end of the current career string's length. Inside the condition, we check the length of the current career string. When our character index has been incremented and reaches the end, we can then proceed to increase the career index. So we will increase the career index by 1. Once YouTube finishes typing, we move to the next career, but we must also reset the character index to start from the beginning for the new word. Let's correct that by setting the value to 0 instead of incrementing it. Let's watch the text type out step by step. First comes YouTube, followed by web developer, then freelancer appears, and instructor begins. However, notice how instructor cuts off before the final letter shows up. That issue arises because we need to place the character index increment at the beginning of the loop rather than at the end. Let us cut this section and move it to the top. That typing effect is now working perfectly for all the careers in our array. Looking at the word YouTuber, we should add the letter R to the end. We can see the careers changing from freelancer to instructor, but the animation stops after instructor. To make the animation loop correctly, we must also reset the career index back to 0. In this step, we include a condition to check when the career index reaches the end of the array, determined by the length of the careers array. When we reach the end of the careers list, we should reset the career index to 0. Now we have the text cycling through YouTuber, web developer, and freelancer, but the word is being used for instructor when it should be an. The reason we need to change this is that we should be saying, I am an instructor. The current hard-coded A here needs to be updated. To fix the grammar for words like instructor, we should check if the career starts with a vowel and use an instead of a. We can do this by creating a variable that checks the first character of the current career string. If that first character is a vowel, like I, we use am, otherwise we stick with a. This gives us correct phrases like, I am an instructor. This quick project covered a surprising number of useful concepts for you to learn. I truly hope you enjoyed following along and picked up some valuable skills. If you have any questions, please feel free to ask them in the comments section. I look forward to seeing you in our next project together. Welcome back to another exciting project. Thank you for joining me once again. We are about to build something interesting together. In this project, we will build a live countdown timer. It will show the exact time left until the new year begins. You will see the final project has a live countdown. The numbers will go down every single second. They are slowly counting down to the year 2022. The countdown is already actively running as I record this video. It is currently December the 6th, 2021. This means we have about 25 days left to go. We also have 2 hours and 50 minutes remaining. We are counting down until we welcome the new year. We will use JavaScript to perform all the time calculations for us. It will grab the current date and time directly from your computer. Then it will automatically update all the numbers inside this countdown display. This means your timer will update itself automatically. It always displays the precise time remaining. This works perfectly no matter when you visit the page. Let us move on to the HTML structure next. I will guide you through the initial setup process. Welcome to our New Year Countdown project. This is where we will build a live timer together. Let's get started by opening Visual Studio Code. Once it's open, go ahead and close the Get Started tab. Head up to the File menu at the top of the screen. From there, select the Open Folder option. I am creating this project folder on my desktop for this demonstration. You can choose any location you like on your own computer. We will now click directly on the desktop area. Then we will select the New Folder button. This action will create a new folder for us. Let's name this folder New Year Countdown for our project. Then we can press the Enter key to confirm the name. After that, we can click the Select Folder button to proceed. Let's close that Get Started tab one more time. Now we will move over to the Explorer section. We will create our HTML file there. Let's right-click in the Explorer panel. Then we select the New File option from the menu. We will name this new file index.html. After that, we will press the Enter key to confirm our choice. The right side of our index file is currently blank. We can easily fix that with a quick shortcut. Just type a single exclamation mark into the editor. This will automatically generate a basic HTML template for us. To quickly generate the HTML boilerplate, we just type an exclamation mark. Then, we select the first auto-suggestion that pops up. Our HTML5 boilerplate is now fully set up. It starts with a special document type declaration. This declaration tells the browser we are using the modern HTML5 standard. Now we have the main HTML tag in our document. This element wraps around both the head and body sections. The HTML tag is the very top element in our document. Its language attribute specifies the primary language for the entire page. We will set the language attribute to English. This simple step ensures our web page is properly identified as English content. Now, let's take a closer look inside the head section. Here, we find 3 important meta tags and a single title tag. This first meta tag contains the character set attribute. It tells the browser which character encoding your page uses. HTML5 recommends using the UTF-8 character set. This standard covers almost every character and symbol you might need. It ensures your text displays correctly for all users. This next meta tag helps with browser compatibility. It tells Internet Explorer to use its most modern engine. This ensures the page looks correct and functions properly. The viewport tag tells the browser about the page's dimensions. It also manages how the page will be scaled. Let's press the Alt and Z keys together now. This will enable word wrap in our editor. It makes our code much easier to read. This content attribute has 2 distinct parts. Each part controls a different aspect of the display. This first part tells the browser to make the page's width fit your screen. It ensures the content scales perfectly to your device. Think about the screen on your smartphone. It is much narrower than the large monitor on a desktop computer. This next part determines how much the page is initially zoomed. It controls the starting magnification level for your browser. This value is automatically set to 100% by default. This means the page starts at its normal zoom level. We also have the title tag right here. This tag is responsible for setting the page title. You will see this title displayed in your browser's tab. Let's take a look at our web page right inside Visual Studio Code. We can do this using the Live Preview extension. Let's open a live preview of our page directly in the browser. On the right side of our screen, the preview browser window appears. It currently shows a completely blank page. The browser tab displays the default title, Documents. Let's create more working space on the right. We can close the Explorer panel for now. Let's update the page title to match our project name. We will change it to New Year Countdown. You can see this new title appear instantly in your browser tab. Let's move forward with our index file. We will now work within the body section of the document. Let's add our first heading element inside the body section. This heading will display the text, Countdown to New Year. Now we will create a new div element for the upcoming year. We will give this element a class of year. This is where we will display the next year, which is 2022. I'm recording this video in December of 2021. This means the upcoming new year will be 2022. I have written 2022 for this demonstration. You should use the upcoming year based on when you watch this tutorial. Remember that your actual target year depends on your current date. If you are following this tutorial after December, you should use next year's date instead. Now we will create a special container just for our countdown timer. This is where all the numbers will appear. This countdown container is where we will show the time remaining. It will display the number of days, hours, minutes, and seconds left. Now, we create a new div element inside this container. We will give it the ID of day. We will set this to 0 for the moment. Right now, we are using a temporary placeholder value. This static number will be replaced with live data very soon. Let's quickly make 3 copies of this line. Just hold down the Alt and Shift keys and press the down arrow key. Now we need to update the text for our second timer unit. We will change the word day to hour. It looks like my keyboard language switched for a moment there. Let's rename this second element to hour. This change will accurately represent the hours portion of our countdown timer. Now we will create the display for the minutes unit. Next, we will create the display for our seconds unit. This will track the remaining seconds until the new year. Right now, these numbers are set to 0 as placeholders. We will replace them with live countdown values using JavaScript very soon. We have now completed the HTML structure for our project. The foundation for our countdown timer is fully in place. Now let's move on to the next part of our project. We will focus on styling our timer with CSS. We just finished building the HTML structure for our project. Our project looks a bit plain right now. Let's fix that with some visual flair. Let's begin by creating our CSS file. This is where we'll write all our visual styling rules. Let's open the Explorer panel on the left. You can do this with the shortcut Ctrl+Shift+E. Let's head over to the Explorer panel on the left side. We can right-click anywhere in that empty space. Then, we simply select the option for a new file. Let's name this new file style.css. Then press the Enter key to confirm. We need to connect our CSS file to our HTML document. This step makes sure our styles are applied correctly. We will now go back to our main HTML file. We need to place a link tag immediately after the title. We just type the word link. Then we select the third autocomplete suggestion for the CSS file. This link tag creates a vital connection. It now successfully links our HTML file to the external style sheet. Both files are located in the same folder. We can use just the file name for the link. Let's save our HTML file using the keyboard shortcut Ctrl+S. This action ensures our new CSS link is properly activated. We have closed the Explorer panel for a more spacious workspace. Now we will open the CSS file to start styling our project. Now we will start adding our visual styles. We begin by targeting the body element of our page. First, we will type the word body and add an opening curly brace. Next, we will remove the default margin from the page. Let's remove the default margin from the page by typing margin 0. To center our content, we will set the display property to flex. We're going to set the display property to flex. This allows us to arrange our page elements in a flexible layout. Currently, our flex direction is set to row. This makes the items line up side by side. By default, flex items sit side by side. We will stack them vertically instead. To center our items horizontally, we use the Align Items property. This property works perfectly with Flexbox. To perfectly center everything vertically on the page, we first need to set the body's height. We will make it take up the full height of the viewport. We center our content vertically with the Justify Content property. We set this property to center for perfect alignment. Let's choose a nice font for our entire page. We will set the font family property to cursive. Let's give our page a nice background color. We will use a pleasant shade of slate blue. Our body section is now fully styled and complete. We have successfully centered our content both horizontally and vertically. Let's shift our attention to the heading and the year display. We will now apply some visual styling to these elements. Let's style our heading element next. We can start by targeting the H2 heading specifically. Let's make the text color pure white. This will ensure it stands out clearly against the background. We can make this text uppercase quite easily. We just need to use the text transform property for this task. We will create more space between each letter. Let's set the letter spacing to 4 pixels. Our heading is now fully styled and looking great. Let's make the upcoming year text look more visually appealing. We will apply some custom styling to the year 2022 display. We are going to target the year using its class. We target this class by starting our selector with a dot character. Now we will make the year text much larger. We set the font size to 5 EM units. The EM unit in CSS is a relative measurement. It always scales based on the font size of its parent element. For instance, if a parent element uses a 16 pixel font size, a single EM unit would then equal those 16 pixels. Let's change the text color to a clean, bright white. This will make our text stand out clearly against the background. Let's increase the font weight to make the text stand out more. Let's make the text a little bit bolder. We can apply a bold font weight here to achieve this effect. Let's apply a bold font weight to this text. That really makes the year stand out nicely. Let's increase the font weight to make the text stand out more. This will give it a bolder appearance. The year display now looks absolutely perfect. It has a clean and prominent appearance. Now we will focus on styling the number placeholders for our countdown. These zeros represent the days, hours, minutes, and seconds. To style our countdown container, we will use its class name. We specifically target the container with the class called countdown. I just noticed a small spelling mistake in the class name. I missed the letter T in the word countdown. Let me quickly correct that now. Let's add a 30 pixel margin to the top of our container. This will push the countdown timer down a little bit. We will also give it a semi-transparent black background color. We use the RGBA color function to create a black background. We set the red, green, and blue values all to 0. For the transparency, we use a value of 0.1. This gives us a 10% opaque black color. You can see the background color appearing on screen right now. We need to make this container stretch fully across the entire width. Let's set the width property to 100% to achieve that. We will set the text color to white for clear visibility. Then we make the container 120 pixels tall. Finally, we changed the display to flex. This makes all the zeros line up neatly side by side. We will center everything horizontally with the justify content property. Then we will center the items vertically using align items. Now let's style the individual numbers inside our countdown container. We will target the divs within our countdown class. Now let's style each of the individual numbers inside our countdown container. We will apply a margin to each of these elements. We will set the top and bottom margins to 0 pixels. Then we will set the left and right margins to 15 pixels. This adjustment gives each number a little more breathing room. It creates a nice separation between them. Let's increase the font size to 2.5 EM units. This will make our numbers much more prominent on the screen. The spacing between our numbers is much more balanced now. This adjustment has really improved the overall layout. We need to shift these zeros upward a little bit. This creates some extra space at the bottom for our labels. We need to add descriptive labels for each time unit. These labels will appear below their corresponding numbers. This will clearly identify what each number represents. We will now shift those numbers upward slightly. We can achieve this by applying a negative margin to the top. This will move the zeros up by 25 pixels. We could have made this adjustment differently. The current method achieves the same goal perfectly well. The styling for our countdown numbers is now complete. They are perfectly positioned and formatted for our timer display. Now we are going to add descriptive labels for our time units. These labels will clearly identify the days, hours, minutes, and seconds. To add these labels, we can use their specific ID names. This approach makes them very easy to target. We will be adding descriptive text labels underneath our countdown numbers. We can easily accomplish this by using CSS before pseudo elements. We will now target our main countdown container using its class name. To label the day, we will use the before pseudo element. We begin by setting the content property to an empty value. Right now, these labels are completely invisible on our page. We need to target each element individually. This means we will style them one by one. We will position these labels using absolute positioning. This technique allows us to place them precisely on the page. First, we will target the day element. Let's add some text content to this pseudo element. This will create the visible label for our timer. We will set the content property to display the word days. You can now see that the label for days has appeared. It is positioned directly below the number. Let's duplicate this line 3 more times. You can do this by holding down Alt and Shift together. Then press the down arrow key. For our second label, we will change the content to hours. This will clearly identify the hours unit in our countdown timer. Let's make sure all our labels have consistent formatting. We should capitalize this text to match the others. We will update the content for this next label. Let us set it to minutes for the minute counter. For the minutes label, we will type in the word minutes. This final label will be for our seconds counter. It will track the smallest unit of time in our countdown. Let's finish by labeling the last unit of time. We will call this one seconds to complete our countdown display. Let's style all of these labels together in one go. We will now position these labels absolutely. This means they will be placed precisely where we want them. We are using absolute positioning for these labels. This means their position will be relative to their direct parent container. We set the position of the parent element to relative. This allows us to position the labels absolutely inside their container. We will set the bottom property to a negative value. This moves the labels downward by 30 pixels. This adjustment pushes the labels down below the numbers. They are now positioned perfectly underneath each timer unit. We then set the left property to a value of 0. We set the font size for these labels to 0.35 em units. This makes the text noticeably smaller than the main numbers. This change reduces the text size just enough. The labels become easier to distinguish from the numbers above them. We will now set the line height to 35 pixels. This will give our text more vertical breathing room. We can also convert all the labels to uppercase letters. We do this using the text transform property. We can use the text transform property for this task. This property will convert all the text to uppercase letters. We will also increase the spacing between each individual letter. This is done by setting the letter spacing property to 1 pixel. We will set the font weight to a value of 500. This makes the text slightly bolder than normal. We then set the width to 100% for full alignment. We also define a fixed height of 35 pixels for the labels. These changes might not be obvious at this zoom level. You will see them clearly once we zoom in closer.
The changes we just made might be subtle right now. You will see the full effect clearly when we adjust the view.
We can center these labels perfectly. Let's add text alignment center to our rule. Let's make sure these labels are perfectly centered. We can add text alignment center to our CSS rule. This will position the text right in the middle. We can center these labels perfectly. We just need to add a text align center property to our rule. We will now adjust the width of the parent container. This change will ensure all our elements align perfectly. Setting each container to 100 pixels wide provides plenty of room. This ensures each time unit has a comfortable and clear amount of space. This adjustment creates much better spacing between our labels. Each unit now has comfortable breathing room. Our project's visual design is now fully complete. Our next section will bring these numbers to life with JavaScript. They will update automatically every single second. Our JavaScript code will make these numbers count down. They will update automatically each second. This creates a real-time countdown to the upcoming new year, 2022. Our CSS styling is now complete and looking fantastic. We will jump into the JavaScript portion next. We have just finished styling our project with CSS. The visual design is now complete and looking great. Now we are going to make our timer dynamic and interactive. We will use JavaScript to power the live countdown. Let's begin by creating our JavaScript file. This is our first step into making the timer dynamic. We can open the Explorer panel with the keyboard shortcut, Ctrl-Shift-E. Then we find a blank space on the left side. We simply right-click there and choose the New File option. We will call this New File Index.js. Press the Enter key to confirm the file name. We need to connect our JavaScript file to our HTML page. This step lets the browser know to load our script. Now we need to connect our new JavaScript file to our web page. Let's go back to our main HTML file. We will place the script tag just above the closing body tag. We begin typing the letters S and C. The editor will show several autocomplete suggestions. We select the second option from this list. This gives us a complete script tag with the source attribute already prepared. Both files are located in the same project folder. We only need to type the file name index.js for the link. We have created our JavaScript file. We can close the Explorer panel now. This action gives us more screen space to work. Let us save our file with Ctrl+S. We can then begin accessing the page elements with JavaScript. We need to target 4 specific containers on our page. These containers display the days, hours, minutes, and seconds. We will use JavaScript to update these numbers automatically. Looking at our document structure, we can see these 4 div elements. The very first one has been given the ID day. The ones that follow it have the IDs, hour, minute, and second. We use JavaScript to select specific elements from our page. We can access any element by its unique ID. This method is called getElementById. Let's create a constant variable called dayElement inside our index.js file. We will use the document.getElementById method to grab that specific element. We are targeting the element with the ID of day. Let's enable word wrap by pressing Alt and Z together. This will make our code much easier to read. Let's make sure our countdown heading is perfectly centered on the page. Let's center that heading by setting its text alignment to center. We can also hide the scroll bars on the page. This is done by setting the body's overflow property to hidden. Let's head back to our JavaScript file to continue the project. We need to select the rest of our countdown elements. Let's grab the hour element next. We will use the exact same method called getElementById for this task. Next, we will select the minutes element using the same method. We will use the getElementById function to grab it. Now, we will create a constant variable for the minutes element. We will use the same method we used for the previous elements. Next, we will grab the element that displays the hours. Next, we will create a constant for the seconds element. We will call this constant second element. We assign it using the getElementById method. We will use the ID second for this element. Excellent! We have successfully retrieved all 4 elements from our document. Our next step involves getting 2 important pieces of data. We need the current date and time right now. We also need the exact moment when the new year begins. We will create a variable for the new year date. To get that date value, we can use the newDate constructor. We assign this to a newDate constructor. In my specific example, we will set the target date to January 1st, 2022. We set the time to 0 hours. We also set it to 0 minutes and 0 seconds. This specific time represents midnight exactly. To get the exact timestamp, we use the getTime method. We will call this method right away. Let's name our main function update countdown. This function will handle all the countdown calculations. we need to call this function immediately. This ensures our countdown starts right when the page loads. We need to call this function as soon as the page loads. This will start our countdown timer immediately. Let's just remove this extra letter A that appeared. Now we need to get the current time from the system.
We will call this function when the page first loads.
Our next step involves retrieving the current system time. We will get this information directly from your computer's clock. For context, the current time is 8:56 p.m. on December 6, 2021. This is the exact moment I am recording this tutorial. We will get the current time from your computer's clock. JavaScript will handle this task for us automatically. Let's grab the current time by creating a new date object. We are getting the current moment right from your computer's clock. This gives us the exact date and time for our calculation. To get the current time, we will create a new date object. We will leave the constructor empty for this. We leave the parentheses empty when creating the new date object. This automatically retrieves the current time from your computer. Then we apply the getTime method to that object. Let's verify this by checking the output in the browser's console. Let's open the browser's developer tools now. We need to check the console output to see our results. It is important to remember that these values are measured in milliseconds. This value represents time in milliseconds. Milliseconds are thousandths of a second. Every time we refresh the page, we get a new number. This shows the value is constantly changing. This value updates continuously as time progresses. You will notice a new number appearing each second. You can see the current time value updating constantly. It generates a new number with every passing second. Let's also check what the New Year date looks like in the console. This will help us confirm we have the correct target date. We are working with two different time values here. One represents the current moment. The other represents the target new year. This specific New Year date value stays exactly the same. It remains a fixed point in time. You can see the New Year date stays the same. It does not change when you refresh the page. The current time is always ticking forward. It never stays the same for a single moment. Let's update that variable name from New Year Today to New Year Time. This new name better describes the actual value it represents. Our next step involves calculating the time difference. We will find the gap between our current moment and the new year. Let's calculate the time remaining until the new year. We will find the exact difference between our current time and the target date. You can see this gap shrinking every second. Our target new year date stays fixed in the future. Meanwhile, the current time is always moving forward. Let's check this gap value by logging it to the console. You can open the console right here in your browser. You can see this gap decreasing every time you refresh. This happens because time is constantly moving forward. You can see this gap shrinking with each page refresh. This happens because the current time keeps moving forward every second. The New Year's time remains fixed at the same moment. We have successfully calculated the exact time difference we need. This gap represents the milliseconds until the new year. Now we are ready to calculate the exact time remaining. We will break it down into days, hours, minutes, and seconds. Let's take a moment to understand our time measurements. Both our current time and the New Year time are stored as milliseconds. This large number represents tiny fractions of a second. Let's start with the basic conversion for our countdown. Every second contains exactly 1000 milliseconds. This is the foundation for all our time calculations. Let's create a constant called second. We will set its value to 1000 milliseconds. This represents the total number of milliseconds in a single second. Next, we create a constant to represent 1 minute. We calculate this by multiplying our seconds constant by 60. This gives us the total milliseconds in a single minute. That gives us exactly 60,000 milliseconds in 1 minute. We can calculate how many milliseconds are in 1 hour. We do this by multiplying our minutes constant by 60. This calculation provides the total milliseconds in a complete day. This works because a full day contains exactly 24 hours. we have successfully defined all our time units. This includes everything from seconds all the way up to days. Let's start by calculating the exact number of days we have left. This is our first major time unit to determine. Our first step is to calculate the number of days remaining. We create a constant called d. We set it equal to math.floor. This is because we are dividing the gap by the day constant. We need a whole number for the day's value. Since we are performing division, the result might be a decimal. We want a whole number for our day count. The mathFloor method gives us this clean integer. We can then use console.log to verify the value of d. The console clearly shows the value for d is 25. Without using mathFloor, our days calculation would show a decimal number. You would see something like 25.12 days remaining. This decimal value would change every single second. We don't need the decimal part for our days display. That leftover fractional time is very important though. We will use it to calculate the remaining hours, minutes, and seconds. We use the floor method to round down to whole days. The leftover time is then used for calculating hours and minutes. This remainder gives us the remaining hours and seconds. Next, we will calculate the remaining hours. We will now use the math.floor method for this calculation. This ensures we get a whole number from the remaining time gap. To determine how much time remains after accounting for full days, we use the modulus operator. This gives us the leftover time from the total gap. To calculate the time left after the full days, we use the modulus operator. This operator works with our total gap and the day constant. This leftover time is what remains after we've calculated the full days. We then take this remainder and divide it by the number of milliseconds found in a single hour. Looking at the console output, we can see the hour value is 2. This means we have exactly 25 days remaining until the new year. We also have 2 hours left to go along with those days. By using the math.floor method, we get a whole number of days. The leftover time is then used to calculate the hours. This remainder gives us 2 hours in this case. This remaining time calculation gives us both the hours and days left. We now have the complete breakdown of the remaining duration. This leftover time represents the hours remaining. We use it to calculate both our hours and days. Let's calculate the minutes remaining using the mathFloor method. We take that leftover time value from the hours calculation. We take that leftover time. We then divide it by the number of milliseconds contained in 1 hour. This calculation isolates the remaining hours from our total time gap. We take that leftover time after accounting for full days. We take this leftover time and divide it by the number of milliseconds in 1 minute. We calculate the seconds next. We use the remaining time from our minutes calculation for this. We take the leftover time after calculating minutes. We then divide this remaining value by our second constant. This final step gives us the number of seconds remaining. We have successfully calculated all 4 time units. We now have the exact days, hours, minutes, and seconds remaining. We have our calculated time values ready. Let's put these numbers into their display elements. Now we will update the day element with our calculated value. We will now assign the calculated number of days to the day element. Let us check the result right here on our web page. Our day element now displays the calculated value of 25 days. Now we will update the hour element with our calculated value. You can see the 2 hours now displayed on our timer. This shows our JavaScript is working correctly to calculate the time. We will now update the minutes element. This displays the calculated number of minutes left until the new year. For our seconds element, we update the inner text property. We assign it the calculated value stored in our s variable. Look at your screen right now. You can see the live countdown is working perfectly. It shows 25 days, 2 hours, 53 minutes, and 57 seconds remaining. You can watch the numbers tick down every single second. Our timer is steadily counting down to the new year. Manually refreshing the page every second would be a terrible user experience. We need our countdown to update automatically for the viewer. To make our countdown timer update on its own for viewers, we use the setTimeout method. This method calls our countdown function again after a specific delay. To automate this countdown process, we use the setTimeout method. This method will call our update countdown function repeatedly every single second. We need to set a 1-second interval for our timer. This means we must specify a delay of exactly 1000 milliseconds. You can see the numbers actively changing on your screen right now. The countdown updates automatically every second. This happens because our JavaScript function runs continuously in the background. This demonstrates our logic is functioning flawlessly. You can see the updates occurring precisely as we intended them to. This means our timer is now fully automatic and self-updating. The seconds will refresh themselves every single moment. You will not need to do anything manually to keep it running. The timer operates completely on its own, without any manual intervention. It updates the remaining seconds continuously and in real time. That wraps up our dynamic New Year countdown timer project. I truly hope you enjoy creating this countdown timer project. This project provided you with valuable educational insights. You gained a clear understanding of each step in the process. I truly hope this project has sparked your creativity. Feel free to use these concepts for your own exciting projects. Welcome back to another exciting project. We are building a BMI calculator together. In this project, we will calculate your body mass index. We often refer to this as BMI. The calculation uses your height and your weight. Our final project has two input fields. One field collects the user's height in centimeters. The other field collects the user's weight in kilograms. We have set some default values for our inputs. The height field starts with a value of 180 centimeters. The weight field begins with 80 kilograms. When we click the Compute BMI button, the calculation happens instantly. It uses the height and weight you entered. The result shows your BMI score and weight condition right here. Our default example of 180 centimeters and 80 kilograms results in a normal weight condition. For example, if we change the weight to 90 kilograms, the result now shows we are in the overweight category. For example, if we weigh 100 kilograms, the result shows obesity. For example, a weight of 50 kilograms would indicate an underweight condition. The program calculates the body mass index. It uses an if statement to check the result. This determines the final weight condition for the user. We will begin by setting up the project. We are using a modern neumorphism design style. Next, we will write the JavaScript code. This code will perform the BMI calculation for us. We will display the final results inside the input field. The text information will appear in this section at the container's end. So see in the next section for the HTML part of the project. Welcome back to working on our BMI calculator project. We are going to continue building it together. In this section, we will build the structure of our page. We are focusing on the HTML foundation. I have opened the final version of the project for reference. This will help us compare our website with the final result. We can also become familiar with the project structure. Looking at the final project, you can see a title at the very top. Next, we have two number input fields. After those inputs, there is a button. Finally, there is another input field that displays the calculated BMI result. We also have some additional information text. This text appears at the very bottom of the container. Our next step involves creating a main container div. We will assign it a class of container. All our subsequent work will be placed inside this container element. We are going to start by creating our HTML file. This file will form the foundation of our web page. I will be using Visual Studio Code for this project. You can use any text editor you prefer. Just choose one you are comfortable with. We start by closing the Welcome tab that appears initially. Next, navigate to the File menu in the top left corner. We can click on the Open Folder option. This allows us to create a new folder. We can then open that folder directly inside Visual Studio Code. I am going to create our new project folder on my desktop. This location is easy for me to find and access. I click on the desktop location first. Next, I click the New Folder button. We will name this folder BMI Calculator. Now that we have created the folder, we can click the Select Folder button. This will open our new folder inside Visual Studio Code. The folder is now open inside Visual Studio Code. You can see it displayed in your editor workspace. We can see our project folder is now open. It appears inside the Visual Studio Code Explorer panel as BMI Calculator. Let us close the Get Started tab once more. We are now inside the Explorer section. We are also inside the folder we created earlier. To create our new file, we click on this New File icon. We will name this file Index. We will add the HTML extension to it. Currently, our HTML file is completely blank. We can generate a standard HTML template quickly. Just type an exclamation mark in the editor. We simply type an exclamation mark on the keyboard. Then we select the first auto-suggestion from the Emmet abbreviation feature. This creates our basic HTML template. The first line declares the document type. This tells the web browser how to interpret our code. For HTML5, we only need to write the word HTMLs here. This simple declaration tells the browser you are using the latest standard. Next, we have the main HTML tag. This tag wraps around two important sections. These sections are the head and the body of our web page. Inside the opening HTML tag, we find the lang attribute. This attribute sets the language for the entire web page. We are setting the language for our web page to English. We do this by typing the letters EN inside the opening tag. The head section comes next in our document. This part contains important metadata tags for the page. It is also where we place the title tag. The first meta tag defines the character set for our web page. We specify UTF-8 for this attribute. This encoding is the standard for HTML5. It supports nearly every character and symbol. This ensures all visitors can correctly view the text on our site. Our next metadata tag handles browser compatibility. It instructs older Internet Explorer browsers. They should use their most modern rendering engine. That rendering engine is called Edge. This metadata tag specifically helps users who are still using Internet Explorer. It ensures their browser uses the most modern rendering engine available. The viewport meta tag sets the page width to the device width. This ensures the layout adjusts for different screen sizes. On a mobile device, the page width will be smaller. On a larger laptop screen, the page width will be bigger. The viewport tag also controls the initial zoom level. This setting is called the initial scale. We set this value to 1 for our page. A value of 1 means 100% zoom level. Next, we have the title tag for our web page. This tag sets the title that appears in the browser's tab. You can see it currently says Documents by default. Let us open the browser to see our page. We can view the changes in real time. We can use the Live Server extension to view our project. Simply click the Go Live button in your editor. This will automatically open our website in your default web browser. In my specific case, this opens the page in Google Chrome. If we look at the Browser tab, the page title currently says Document. Let's move our browser window to the right side of the screen. This will let us view the live changes easily. We will position our Visual Studio Code window on the left side. Let's close the Explorer panel on the left side. This will give us a lot more room to see our code. Let us change the title of our web page. We will update it to the name of our project. The new title will be BMI Calculator. You can see the title has been updated in the Browser tab. It now displays BMI Calculator as its text. Let us look at the final version again. You can see a container element there. All of our content will be placed inside that container. Let's begin by creating our main container inside the body section. We will use a div element for this container. We type a period followed by the word container. We then press the Enter key. This action accepts the auto-suggestion. The editor will generate a div element for us. This div will have a class named container. We will begin by creating the heading inside the container. This heading will be a large title using an h1 tag. We will also assign it a class called Heading for Styling. I have added this class for styling purposes. We will use CSS to style our website later. We need to target each element by its class. We are adding a class called Heading to this element. Inside the h1 tag, we will type out the full text. We will write body mass index, which is commonly abbreviated as BMI. Finally, we will add the word calculator at the end. Let's check our browser preview now. We can see our title displayed at the very top. This title is now correctly set as Body Mass Index Calculator. It appears at the very top of our page. Following the title, we have two input fields. The first input field is for your height. The second input field is for your weight. Next, we add a label for the height input. The label will display the text your height. After the label, we write the unit centimeters. Finally, we place the input field right here. We assign the class name input to this element. We will use this class later for styling purposes. We also give this input field a unique ID of height. Currently, the input accepts regular text. We need to change its type to number. This ensures the user can only enter numerical values. This also allows us to increment and decrement the value with arrows. This input element uses the class name input for styling purposes. It also has a unique identifier of height for our JavaScript code. We will style this input field using its class. We will also target it with JavaScript using its unique ID. This allows us to retrieve the number the user types in. Let's set a default value for this height input field. For example, we can pre-fill it with 180 centimeters. When you first load the page, the height will be set to 180 centimeters. You can easily change this number to your own height. We also need to add a placeholder for this input field. This placeholder text will appear inside the box when it is empty. It serves as a helpful guide for the user. For the placeholder text, we will use enter your height in centimeters. You will see this placeholder text if the input field is empty. Our first input field is now complete. It is ready for the height information. Let us copy the first input for height. We will use the keyboard shortcut Alt, Shift, and the down arrow. This creates a duplicate line of code. Now we need to change a few details for the weight input. Replace the word height with the word weight. We must also change the unit from centimeter to kilogram. The input class remains the same. We will change the ID from height to weight. The default value should be 80 kilograms. The placeholder text should say, enter your weight in kilogram. We have now successfully created the first two input fields. These fields are for the user's height and weight. Next, we need to add the Calculate button to our project. This button will allow users to compute their BMI. We are going to give this button a class. This will help us style it later. This button will have a class called btn. The class name btn is simply short for button. I typically use the class name btn for my buttons. We also need to add an ID to this button. This ID will be used later when we work with JavaScript. We can simply call this ID btn as well. We need to write some text inside this button. Let's write the text compute BMIs or calculate BMIs. Next, we are going to add the result display. This will be another input field. It will show the calculated BMI value. Next, we will create an input field for the final result. This input will have the class of input. We will give it the ID of BMI result. This result input field does not need a placeholder. We will disable this input entirely. This prevents anyone from manually changing the calculated value. This input field is just for displaying the calculated BMI result. We do not want users to be able to type into it. We are going to disable this input field. This prevents anyone from typing into the result box. Following the button element, we have this additional information text located here. Next, we will create a heading element for the information text. This heading will have a specific class applied to it. The text inside will read weight condition. We will then place a span element right after this text. The dynamic result from our calculation will appear inside this span. We want to separate this text into its own element. This specific part will be dynamic content. We are going to update it later using JavaScript. We will assign this span an ID of weight condition. This ID will allow us to target the element with JavaScript later. Excellent! We have now completed the HTML structure for our form. In the final version, you can click the Compute BMI button. You will then see a weight condition result. This could display normal weight for a healthy input. For someone weighing 120 kilograms, it shows obesity. The result changes based on the calculated BMI value. The specific category displayed here depends entirely on the calculated BMI value. This value is determined by both your height and weight. We will use JavaScript to populate this element with dynamic content. For the moment, we are leaving the text area empty. That concludes the HTML structure for our BMI calculator. We have built all the necessary elements for the user interface. The current layout is a bit messy and unstyled. We will fix that in the next section using CSS. We are going to make it look beautiful and polished. It will match the final version you can see here. Next, we will focus on the visual design of our project. We are moving on to the CSS part of the tutorial. We just finished building the HTML structure for our project. That part is now complete. In this section, we are going to style our project using CSS. We will make the website look visually appealing. Our first step is to create a brand new CSS file. We will do this directly within Visual Studio Code. Let's navigate back to the Explorer panel. You can press Ctrl-Shift-E on your keyboard. Let's go up to the top of the Explorer panel. We will click the New File icon. We will name this file style with a .css extension. We have created our CSS file. We can start writing our CSS code inside this new file. Before we can use our new CSS file, we must connect it to our HTML. We will add a link in the HTML code to do this. Let's navigate back to our main HTML file. We will now add a link to our new CSS file. Navigate back to the index.html file. Place your cursor right after the closing title tag. Begin typing the word link. You will see several auto-suggestion options appear. Please select the third option from that list. This specific option is the one designed for linking a CSS style sheet. This link tag establishes the relationship between our HTML and CSS files. The href attribute points to the destination of our style sheet. This works because both files are located in the same directory. Inside the href attribute, we type style.css. We have our CSS file linked and ready. Let's begin by styling the body section of our web page. Let us begin with the body selector. We need to remove the default margin that browsers add automatically. We will set this margin value to 0. The margin has now been successfully removed from the body. Now let's change the background color for the entire page. The background should have a nice gradient color. You can see this in the final project preview. It transitions from a light blue to a light green. To create that gradient, we use the background property. We type in linear gradient for the effect. We want the color to start at the top right. That starting color will be a light green. Then it transitions to the bottom left. The ending color will be a light blue. We specified the direction as to left bottom. The first color we want is light green. It transitions from light green to light blue. Now, if you look at the final version of our project, you will notice the gradient color is repeating. This happens because we have not defined a height for the body. The background repeats when there is no height set. To center all of our content, we will use a flex display. This approach will neatly align everything in the middle. We are setting the display property to flex. Next, we set the minimum height to 100% of the viewport height. This ensures the element fills the entire screen vertically. The gradient now fills the entire screen completely. You can see it is a single, continuous color. The screen now occupies the entire browser window. It is using the full 100% of the viewport height. Notice how the size remains at 100%. This happens even when you adjust the zoom level. To center everything horizontally, we use the Justify Content Center property. For vertical centering, we simply apply the Align Items Center property. Next, we will change the font for all the text. I want to use a font called Courier New. We set the font family property to Courier New. This is the font you see here. This particular font is my personal favorite. You can absolutely use any font you prefer. You could also import different fonts from online sources. Google Fonts is an excellent resource for this. I have covered font importing in some of my previous tutorials. We have finished styling the body section of our page. The background gradient and layout are now complete. Now we are going to style the main container element. This container wraps around all of our content. Let's focus on the main container for our styling. This is the div element we created earlier with the container class. This element has a class attribute. We can target this class in CSS. We do this by adding a dot first. Then, we simply type container. Let's set the background color for our container. We will use RGBA, which stands for red, green, blue, and alpha. The alpha channel controls the transparency of the color. We choose the values 255, 255, and 255. This combination gives us a pure white color. We then set the transparency to 30%. This creates a nice transparent effect. We can see the background gradient color behind the white container. This creates a glassy, modern look for our container. This effect is often called neumorphism in design. Next, I will add some padding to the container. This creates space around the elements inside the container itself. We will set the padding to 20 pixels. This padding creates space inside the container. We change the display to flex. This initially lines items up side by side. Then we change the flex direction to column. This stacks all the items on top of each other. Our container is already looking much better. We still have several important styling details to address in this section. Next, let's give our container rounded corners. We can do this using the border radius property. Let's set the border radius to 5 pixels. We can now observe the rounded corners taking effect on our container. Let me zoom in a little closer. Now you can clearly see those rounded corners on our container. Next, let's create a nice shadow effect. We will add this shadow to the bottom of our container. We will apply a box shadow to the container. We set the horizontal offset to 0 pixels. The vertical offset is set to 10 pixels. This creates a shadow at the bottom. We will add a 10 pixel blur to soften the edges. This blur effect will appear on all sides. The current shadow is a bit too dark for our design. We can adjust this by using a color format that includes transparency. This will make the black shadow much less intense. We set the red, green, and blue values all to 0. This combination gives us the color black. We then set the transparency to 30%. This creates a beautiful shadow effect for our container. The container is touching the edges on smaller screens. This connection to the walls does not look good. Let's add a 5 pixel margin to the container. This will push all the content inward slightly. Let's take a look at our container. Everything seems to be shaping up nicely with the current styling. Now let's style the heading for our page. We can target the heading using its class name. Now let's style the main heading. This heading is our h1 element with the class of heading. We will target the heading class in our CSS file. We can change the font size to 30 pixels. This will make the heading a bit smaller. Now let's style the input fields. We have 3 separate inputs in our project. All of them share the same class name. We have 3 separate input fields here. They all share the same class name. We can target these input fields using the class selector.input. Let us begin by adding some padding around these elements. Let's add some padding to our input fields. We'll set 10 pixels of padding on the top and bottom. For the left and right sides, we'll use 20 pixels. Let's increase the font size to make the text more readable. We will set it to 18 pixels. We should also update the background color for a better appearance. I want to set the background color using RGBA values. We will use 255 for red, green, and blue to create white. The initial transparency is set to 30%. This 30% transparency seems a bit low for our design. Let's increase the transparency level to 40%. This will make the background a bit more visible. You can see the current border appears as solid black. Let's change that color to something more subtle. Let's change the border color to use RGBA as well. We will set the transparency to 50%. This creates a more beautiful and subtle border effect. Let's add some breathing room around our input fields. We will set the margin to 10 pixels. This padding creates some breathing room around each input field. It makes the layout more spacious and easier to read. Our input fields are looking quite good now. They have a clean and modern appearance. Let's move on to styling our button element now. We will apply CSS properties to make it visually appealing. Let's target the button element for styling. You can see it has a class called BTM. To target our button in the CSS, we use the class name btn. Let's set the background color to a light green shade. This will give our button a fresh and vibrant appearance. We need to get rid of the default border on the button. We can easily do this by setting the border property to none. Instead of keeping this border, I will add a softbox shadow. This will make the button stand out and look more modern. Let us make this button look more attractive. We will begin by adding some padding around the text. Let's add some padding to the button. We will use 10 pixels on the top and bottom. Then we add 20 pixels for the left and right sides. We also want to round the corners. We can set the border radius to 5 pixels. Let us add a margin to this button. We will use the same margin value as the inputs. Next, we will set the font size to 20 pixels. This will make the button text larger and easier to read. Next, we will add a softbox shadow beneath our button. We set the horizontal shadow offset to 0 for perfect centering. We also set the vertical offset to 0 for even spacing. This makes the shadow spread equally around the entire button. We choose a blur radius of 4 pixels for gentle softness. We use an RGBA black color to control the transparency precisely. We keep the alpha at 30% for a subtle glow. When you move your mouse over the button, the cursor should change. It will show a pointing hand instead of the default arrow. This change gives us a pointing hand cursor. This cursor change clearly shows the button is interactive. Now let's add another effect for when we hover over the button. I want the shadow to become more prominent during a hover. We target the button for the hover effect. We use a special hover pseudo class in our styling. We target the hover effect specifically for our button. We change the box shadow to have 0 offset on both axes. We then set the blur radius to 8 pixels. This creates a larger blur than the previous shadow. We also set the color to black with 30% transparency. This change happens too quickly for a smooth effect. We can make this change feel smoother by adding a transition. We will apply the transition to all properties. We will set the duration to 300 milliseconds. We will also use an ease effect for a natural feel. You can see how the transition creates a smooth, gradual change. This makes the hover effect feel much more polished and professional. The final element we need to style is the wait condition text. You can find this text displayed at the very bottom of our container. We target this text element using its class name. The class for this text is InfoText. We adjust the font size to 20 pixels. This makes the text larger. We also set the font weight to 500. This makes the text appear thinner and sleeker. We have now completed all the styling for our project using CSS. The visual design is fully implemented and ready for the next step. Our website now looks just like the finished example. The styling is complete and matches the design perfectly. In our next section, we will make the button functional. We will add the ability to calculate the BMI. We will also calculate the weight condition category. This result will be determined by the calculated BMI value. We will use JavaScript to get the information from the inputs. We will then calculate the BMI. The result will be shown inside this specific input field. We will then display the corresponding weight condition. This will appear right here in the info text section. Get ready for the next section, covering the JavaScript part. In the previous section, we fully completed the project's CSS styling. In this section, we start adding interactive features to our project. We use JavaScript to react when users enter their details. We calculate BMI, update results on screen, and make everything feel responsive. Looking at the finished application demonstrates how the output changes instantly. For example, I will choose a height of 160 centimeters. I will also select a weight of 50 kilograms. After that, we can click the Compute BMI button. This action will calculate the person's body mass index. The result is based on a specific mathematical formula. Let me show you the formula we will be using. This BMI value will determine the person's weight condition. The possible categories are normal, obesity, underweight, or overweight. We will create these conditions using JavaScript if statements. These conditions will be based entirely on the calculated BMI value. The first step in our process involves creating a new JavaScript file. We need this file to write our code. let us open the Visual Studio Code editor. We are going to open the File Explorer panel. You can do this by pressing the keys Ctrl, Shift, and E together. On the left side, you will find the Explorer section. Click the New File icon there. We are going to name this new file Index. We then add the file extension JS. This extension stands for JavaScript. We have created our JavaScript file at this point. We must now connect it to our HTML document. This process is similar to how we linked our CSS style sheet earlier. We navigate to the index.html file. We place the link right before the closing body tag. This is a crucial step. We must ensure all page elements are fully loaded. Our JavaScript needs to manipulate those elements. The script would fail if it ran too early. We start typing the letters SC. This triggers the autocomplete feature. We select the second suggestion from the list. This option includes the essential source attribute we need. The src tells the browser where to find your JavaScript file. In this example, both index.html and index.js are inside the same folder. Because they share the same location, the src only needs index.js. This keeps your path short, clear, and easy to manage. At this point, the JavaScript file is linked and ready. We can start using it to add behavior to our page. We can close the Explorer panel by dragging it left. This gives us extra space to write our JavaScript code. Let me walk you through the steps we will follow. To make this button react to clicks, we add an event listener. Each time the button is clicked, it will trigger our function. In the final version, clicking this button still does nothing. It does not trigger any action or calculation. We will first select this button element and access it. This button element has an ID called btn. This unique ID helps us easily select it using JavaScript. Using this ID, we can easily target the button in JavaScript. To do that, we create a constant named btn element. This will be equal to document, which represents the whole web page. Next, we use the getElementById method to target our button. We simply pass its ID name into the method. This button uses the ID btn. This ID helps JavaScript find and control it. At this point, we successfully have access to our button element. At this stage, we can attach an event listener to it. To add the click event, we call btn element.addEventListener. For this button, we want to listen for the click event. This means our code will run only when the user clicks it. After that, we want to run a function when clicking. Inside this function, we will calculate the BMI step by step. In this example, I will name the function calculateBMI. At this stage, we need to create the calculateBMI function. I will create a function called calculateBMI. This function will run each time the button is clicked. Let us log a simple message to test our function. In the final version, press F2 to open the console. After opening, look at this area where messages will appear. To open it, click here and switch to the console tab. The console looks empty at first, which is completely normal. When you click the button, the function runs and prints clicked. This message appears because our function includes a console log. Every time we click the button, another clicked message appears in the console. This shows our function runs correctly each time we click. The event listener also responds perfectly, confirming everything is set up. Instead of just logging clicked, we will use these inputs. We will calculate the BMI using the height and weight. At the top, we have two input fields. One is for the height, and its ID is height. The other is for the weight, and its ID is weight. In the next step, we will access both input elements in JavaScript. We use the getElementById method to target each one. After that, we read their values and store them for calculation. Instead of console logging, we will create a new constant for height. We will call it HeightValue to keep the name clear. This constant targets the document object inside the browser window. It uses getElementById to select the input with ID height. After selecting that input, it reads its current value using .value. In the same way, we need another constant for the weight. I copy this line using Alt-Shift-Down arrow. After that, I change each word height to weight using Ctrl-D. I will remove the word height from both places. I will replace it with weight value to match the weight input. At this point, we have both values ready to work with. Let me log these values in the console. This helps us confirm they are correct. If I log the height value, we can clearly see that number. Logging the weight value as well confirms both inputs are captured. Each time we click the button, both input values appear in console. For example, change the first input to 50 and the second to 20. Next, click on Compute and you will see 50 and 20 displayed. We have access to both input values in JavaScript. This means we can use them directly to calculate the BMI. At this step, we calculate BMI using the height and weight. The correct formula is weight divided by height squared in meters. We receive the height in centimeters from the input. We must convert centimeters to meters by dividing the height by 100. After this conversion, the height value is in meters. We keep the weight in kilograms without any conversion. At this point, the height is in meters. This means we can correctly calculate the BMI. At this stage, we define BMI value using our formula. In this formula, use weight value divided by height value squared. I realize I explained the formula incorrectly the first time. Let me restate it clearly. In other words, it is weight divided by height times height. This gives us height squared in the denominator for our BMI. The height value is squared at the bottom of the fraction. The weight value goes on top as the numerator. The height must be in meters, not centimeters, before calculation. The weight must be in kilograms for the formula to work. At this point, we have successfully calculated the BMI value. At this stage, we can log the BMI value to double-check everything. With a height of 180 and weight of 80, the BMI becomes 24. If I change height to 100 and weight to 92, BMI becomes 21. At this point, we have correctly calculated the BMI value. Next, we want to display this BMI value inside that input field. To start, we first select this input inside JavaScript. We do that by using the getElementById method. We place it near the top because we only select it once. We do not need to select it every time we run. We only grab this element once and reuse it inside the function. In this step, I will create a constant named BMI input element. This constant will be equal to document.getElementById. The ID we are targeting is the BMI results element here. This input field uses the ID BMI results for targeting. At this point, I copy that ID and paste it inside getElementById. At this stage, we have the BMI value calculated. We will assign this value directly to the BMI input field. At this line, I simply type BMI input element as our target. Because this field is an input, we must update its value. We set its value equal to the BMI value we calculated. At this point, I paste the BMI value into the input. At this stage, clicking Compute BMI displays 24 inside the result input. If we change it to 190, the BMI updates correctly to 22. At this stage, we have finished the first part successfully. We calculated the BMI using the inputs. We also displayed the result clearly inside this BMI input. In this next step, we calculate the weight condition using BMI. In this part, we will add clear BMI-based weight conditions. These ranges follow standard health guidelines used by medical professionals. When the BMI value is below 18.5, we consider this person underweight. At the end, we need to display that text information here. In this part, we added a span element for showing messages. This span does not contain text yet. It only has the ID weight condition. For this reason, we must link this span to our script. At the top, I will create another constant named weight condition element. This constant will use document.getElementById to select the span. We pass in the same ID we copied, which is weight condition. At this stage, we update the span's text using our element. We change its inner text based on the BMI value. For an underweight result, we display the message underweight inside the span. In this example, a person is 180 centimeters tall. Their BMI result is 24. For example, imagine this person weighs only 50 kilograms. That weight is considered underweight for this height. If we calculate the BMI, the result is below 18. In this case, the BMI comes out to 15. At this point, the displayed weight condition clearly shows as underweight. In the next step, let us add the remaining conditions. For this part, add an else if with a second condition. When the BMI value is greater than or equal to 18.5, and when the BMI value is less than or equal to 24.9. In this range, update the weight condition element inner text. Replace underweight with the label normal weight for this category. For example, with 180 centimeters and 80 kilograms, the BMI is normal. This is normal because it is above 18.5 and below 24.9. Next, we will add the remaining BMI range conditions together. We still have 2 more conditions to add. First, use else if when the BMI value is 25 or higher. If the BMI value is 25 or higher, it becomes overweight. When the value is between 25 and 29.9, keep the label as overweight. If the BMI reaches 30 or more, change the condition to obesity. Whenever the BMI value is 30 or higher, label it obesity. This is a 2-step process. First, we calculate the BMI value. Next, we use that BMI to decide the correct weight condition. With these conditions in place, our BMI calculator works correctly. At this point, our height value is 180 centimeters. With these inputs, the BMI falls within the normal range. If a person weighs 90 kilograms at 180 centimeters, they are overweight. If your weight is 120 kilograms, the result shows you are overweight. That value is extremely high, which clearly indicates a severe obesity condition. It seems the last condition is not working correctly here. This condition must check for BMI values strictly greater than 30. I made a small mistake in that condition earlier. At this point, a BMI of around 30 means obesity. This correction works properly, and the BMI categories are now displayed accurately. We have completed the final part of the project. We calculated the weight condition from the BMI value. We also displayed that condition clearly inside this span. That completes our project, and you have built a working BMI calculator. I hope you enjoyed this project and learned valuable new skills. You have learned helpful skills like calculating values using clear formulas. You practiced calling functions to organize code into reusable steps. You also added an event listener to make the button interactive. This project was simple, yet it clearly showed each JavaScript concept. I hope you enjoyed this project and learned useful JavaScript skills. Join me in the next project to practice even more. Welcome back to another exciting project, where we'll continue learning and building creative web elements step by step. In this project, we're going to design and create a fully functional analog clock from scratch. As you can see from the final version of the project, our clock features a sleek design with the RegEx logo in the center, displaying the current time in real time directly from the browser. We're going to use JavaScript to dynamically retrieve the current time from the system and then convert those values into rotational degrees, allowing the hour, minute, and second hands to move smoothly just like a real clock. In the next section, we're going to begin by creating the HTML structure, which will serve as the foundation for our analog clock project. So, I'll see you in the next section, where we start building this elegant and functional analog clock together. Let's begin building our project. I will keep this final version open as a reference point. Now, I open Visual Studio Code. Then, close the Get Started tab, and from the File menu, select Open Folder. Let's make a new folder for our project. I will place this project on my desktop, but feel free to store it wherever you prefer on your system. To begin, I will create a new folder, naming it Clock, and then select it by clicking Select Folder. Next, close the Get Started tab, and in the Explorer on the left, let's create an index.html file. We can simply click here, or right-click and select New File. We simply name it index.html. This empty HTML file can be quickly populated with an HTML boilerplate using an exclamation mark and emit, which generates the doc type declaring the HTML version, typically HTML5 for modern pages. Following this, we find the HTML tag, which encloses all content, and its lang attribute defaults to English, setting the page's language. Following this, we introduce the head section, which contains essential meta tags and the page's title. Beginning with the first meta tag, it sets the character set, and for HTML5, UTF-8 is the recommended encoding. The compatibility meta tag instructs Internet Explorer to utilize its most recent rendering engine, Edge. Following this, we find the viewport meta tag, which tells the browser how to resize the page. For instance, we set the device width to equal the screen's width and the initial zoom level to 100%. After that, we have the title tag, which appears in your Browsers tab. Let's open the browser to see our progress. For this, I employ a convenient extension called Live Server, which is completely free. A single click here will launch your project, and every time you save, the changes will instantly appear. Presently, the title displayed the word Document. Let's arrange our browser on the right and our code on the left. We can now hide the sidebar with Ctrl-B. Let's update the browser tab title to Clock. We can now see this change directly within the tab. Taking a look at the final version, you can see the body background uses salmon color. Next, we will add a container for our clock, which we will call Clock. Therefore, we need to add a div element inside the body, assigning it the class Clock. Within this container, we will include the numbers 9, 12, 3, and 6. Next, we have the hands for the second, minute, and hour. We will also include the RegEx logo. There are 3 elements we need to add inside this div. The first div element will contain our numbers. We will add a div with a class of numbers. Within this div, we'll place our numbers. We'll create one div for example, the number 12. We simply type the number 12. Upon checking our reference, you should see the number 12. Let's duplicate this 3 more times using Alt-Shift-Down arrow. This duplicates the div 3 times. The next number is 3. The next number will be 6. And the last number we need is 9. Our next step is to add the clock hands. Next, we'll create a div that covers all the clock hands and name it arrows. Within this division, we will create a dedicated division for the hour hand. We can then duplicate this 2 more times with Alt-Shift-Down. The second hand is for the minutes. The final hand will represent the seconds. To complete our design, let's incorporate the RegEx logo. Let's search for RegEx on Google. Our next step is exploring the images. We will use the tools to filter by transparent color. We need to refine our search to RegEx logo, since it is presently displaying only watches. The first result is from Wikipedia. Let's select this first result. You can see that this image has a transparent background. Therefore, we can simply copy this by right-clicking and selecting Copy Image Address. We no longer need this window open. Let's rearrange our windows once more. After this div, we will add an image tag, and for the image source, we paste the link we just copied. With that, the RegEx image should now appear. However, as you can see, it is quite large, but we will style it later with CSS. For now, we will leave it as is, and for the alt text, we will simply say RegEx logo. With that, our HTML structure for the project is complete. In the next section, we will begin styling the project with CSS. In the previous section, we finished building the HTML structure of our project. Let's dive into styling our project with CSS. First off, let's create a new CSS file. To begin, open the Explorer section with Ctrl-Shift-E, then create a new file named style.css. We now have the style sheet, but to link it properly, we need to add a reference to this file within our HTML. Inside the HTML file, right after the title and before the closing head tag, we will add a link tag. When we type the word link then, choose the third auto-suggestion, which includes CSS. Here, the link tag connects our HTML to the external style sheet, where rel specifies the relationship and href points to the style.css file in the same folder as index.html. Our next step is to style our page. To make this change, head over to the style.css file, then close the Explorer section using Ctrl-B. With that ready, let's begin. Let's begin by focusing on the body section. To begin, we'll remove the default margin and padding. To ensure consistent spacing, we will set both the padding and margin to 0. Notice these elements are now closely aligned with the wall. Next, we will reduce the RegEx's logo size to improve visibility. Before continuing with the main body, let's add the image element. With the image in place, it looks much better already. Moving on, let's focus on the body section. To make the background of our body section really pop, let's set it to a lovely salmon color. Next, we'll set the font family across our website to Cursive New. Next, we will set the height to fill the entire viewport. With that in place, we can visually center everything by simply changing the display property to flex. Next, we will center the content using Justify Content Center. They are now centered horizontally, but for perfect vertical alignment, we must set Align Items to Center. With the main body section complete, let's now implement the clocks functionality. The rounded gray clock in the final version is actually the div with a class of clock covering everything. However, we must style this element first and shape it into a perfect circle. We target the clock class with a dot, since it's a class selector, and now assign a width and height to it. Before adjusting the width and height, let's update the background color, making the change visible. The background has a light gray color. You'll notice it appears as a small square. With that in mind, let's adjust the width to 350 pixels and set the height to 350 pixels too. To make it perfectly round, we'll set the border radius to 50%. We also added some border and shadow effects for a subtle 3D look. Let's give it a border with a width of 5 pixels. We set the border style to solid, but it defaults to black, so let's change that to dark gray instead. I'm simply changing its color to a dark gray. Furthermore, let us add the shadow effect. To create this shadow effect, we simply add the box shadow property. We will add a box shadow with 1 pixel for the horizontal offset, 1 pixel for the vertical offset, and a 4 pixel blur radius. As you can see right now, the shadow appears completely dark. However, I prefer the shadow not to look so dark. I'd like the shadow in pure black with around 70% transparency. For the black color in the shadow, we set the RGB values to 0, 0, and 0. Regarding the alpha value for transparency, we assign it 0.7, which equals 70%. With that complete, we finish styling the clock. With the clock styled, let's add the RegEx logo inside it. To properly position this RegEx here, we need to set its position to absolute relative to its parent, which is the clock. To position the RegEx logo inside the clock effectively, we must first set the clock's position to relative. Let's set the clock's position to relative, and then position this logo absolute. This setup lets us place the logo precisely where it belongs. For example, if we aim for the center, we simply state left 50%. This positions the edge right at the center, but to center it perfectly, I adjust the translate property we need to apply the transform property using translate. Next, apply a CSS transform with translate and -50%. This adjustment places it perfectly in the center horizontally, while vertically we position it using top 50%. Let's adjust its size to 60 pixels for proper scaling. This size adjustment makes the logo fit perfectly. Additionally, let's set its z-index value to 2 for proper layering. This setup positions the clock as the base layer in our design. Next, we have the Rolex and the arrows. I also want those arrows positioned above the Rolex logo. To place those arrows above the Rolex logo, we set the z-index of this element to 2. Therefore, we assign the clock a z-index of 1. We also assign a z-index value to the numbers. The numbers need a z-index of 2 since they layer on top. We assign a z-index of 3 to the arrows and a z-index of 4 to the center circle. Take a moment to watch the seconds tick by and observe how the second hand moves over the logo. You'll notice the hand positioned beneath this circle. As you can see, the second hand passes behind it, making the logo appear firmly attached to the clock face. With the logo set, we begin positioning the numbers around the clock. We have 4 numbers in total. You will notice a div element with the class numbers, where each individual number also has its own distinct class. To begin targeting them, we select the numbers class first. For example, we style the numbers and the division elements. However, for their exact placement, we use their individual class. For instance, imagine the numbers 12, 9, 3, and 6 appearing in these positions. Let's go ahead and implement it that way. We target the numbers class and the div elements it contains. This way, we target all of them together. To begin, we should position them absolute, but relative to the clock. Our clock element has a relative position. First, we set their position to absolute. Next, let's adjust the font size to 27 pixels. Notice how all of the elements are stacked together, but later we're going to individually position them. Please bear with me for this part. To give it some visual pop, let's also make the font weight bold. This means we need to make it a little thicker. Next, we will refine the color scheme. For the color, I'll use a light golden reddish yellow. The color is a soft yellowish hue. Let's also enhance this element with a shadow effect. For the horizontal shadow, I specify 1 pixel. Apply 1 pixel for the vertical shadow and 2 pixels for the blur radius. For the color, we could use RGBA, setting it to black with 70% transparency. With that, this part is complete. Our next step involves addressing each number individually. Let's start by targeting the number 12 first. We simply type .12. What exactly did I just write, you might ask? We want the number 12 positioned right at the top. We will set the top position to 6 pixels and the left position to 50%. As mentioned earlier, this parameter brings the edge to the center. To perfectly center it, we use a transform with a translate of -50%. With that in mind, let's now move on. Let's copy this code now for the number 3. Alternatively, we could retype it. For the number 3, position it 6 pixels from the right edge. As you can see, it's now positioned 6 pixels from the right edge. Next, let's position it 50% from the top. However, this actually isn't 50%. To properly center the element, we add the transform translate adjustment. This simply translates the element along the x-axis. This property called translate x handles the horizontal shift. However, for the 3, this translates to a y-axis movement. To center it vertically, we use transform translate 50%. With the 3 positioned correctly, let's handle the 6 next. To place the 6 at the bottom, position it just 6 pixels away. Next, we use left 50% and transform translate x to -50%. And moving on, we have the number 9. The 9 should have a left value of 6 pixels. Next, we have this. It doesn't matter if it's from the top 50% or the bottom. We just say transform translate y minus 50%. Having correctly positioned all these numbers around the clock, we can proceed. With the numbers positioned around the clock, let's begin styling the hands. By the way, those handles actually refer to the clock hands. You can see that a div with the class of arrows contains each handle, each with its own class. First, we apply this method to all of them. We simply target the arrows div. We apply the common one, and then for particular one, we use their own classes. To center them properly, we target the arrows class directly. We simply use arrows for this. We wanted the arrows centered, so we simply set their display to flex. We also need to set both the width and height to 100%. To center it, we use justify content center. This centers the content horizontally, while align items handles vertical positioning. This setting easily centers the item perfectly. Right now, you cannot see them yet because those elements lack any defined size. To begin, we need to carefully position this circle. However, we haven't created a dedicated element for this circle yet. To achieve this, we can use the before pseudo class. For this pseudo element, we type .arrows before in the code. To create this pseudo element, start by adding an empty content property for the before pseudo class. Remember that you always include content with just an empty string. Next, we apply a width of 25 pixels. Let us check the display now. Unfortunately, the element remains invisible. To make the element visible, let's also set its height to 25 pixels. Next, we apply a dark green background color. With the updated color, the circle is now clearly visible. With display flex applied, it aligns perfectly in the center. To make it a perfect circle, simply set its border radius to 50%. Next, we'll add a subtle box shadow. For the vertical shadow, specify 1 pixel, and for the blur effect, use 2 pixels. Next, we'll use an RGB black with 70% transparency. This setup works perfectly now. As we discussed earlier, this z-index value should always be positioned above all other elements. Let's confirm the layering order here. The RegEx logo sits at z-index 2, the clock hands need 3, and the center circle gets 4. Moving forward, we need to target all the arrows. To achieve this, we directly target its div element. To better see the effect, let's add a width and change the background color. The background color should therefore be white. But you cannot spot them right now because they lack any size or dimensions. We should give each of them a width of 7 pixels. You see a little bit movement here. However, since we will position them next, their appearance will change soon. To position them properly, we first set the property to absolute, allowing the hands to extend outward without interfering with the center circle. Let us give them a height of 120 pixels. You can see the hands now, but they overlap completely in a stack. The handles are currently centered, but we want this one positioned here. Therefore, we must adjust the transform origin. We'll simply place the transform origin right at the bottom. Position the origin at the bottom center to rotate the hand from its base. As we mentioned earlier, we set it to bottom 50%. We position it 50% from the top. When we need to move it, it will shift from its bottom center. You will also observe the handle positioned beneath the RegEx logo. Our goal is to position it above this logo. To layer the hand above the logo, we set the z-index to 3. The logo appears above the circle because the circle has a z-index of 4, while the RegEx is set to 2. In addition, let's make this clock hand end a little sharper. To make it perfectly round, simply set the border radius property to 50%. Notice how we have 50% at the top and 50% at the bottom. However, what I really want is rounding only at the tip right here. To round only the tip, we set those values to 0 on the other sides. Next, let's enhance it with a stylish box shadow. Let's simply apply a box shadow. Actually, I want it exactly to be like this. We will now copy that, and then paste it here. After applying the shadow, it appears a bit too intense here. We just changed this transparency value to 3. This is how it appears. With that in mind, let's adjust their positioning. To fix this, we will target the hour. To target the hour hand precisely, we use its class name in the style sheet. The goal was to make it smaller in width while keeping its height at 80 pixels. We will also rotate the hand slightly using the transform rotate property. We have rotated the hand by exactly 30 degrees. You can clearly see the hand's position correctly now. Indeed, it's working perfectly. Let's move on to the next step now. Let's apply those same adjustments to the second hand. To achieve this, simply copy the code. In the copied code, replace hour with second to target the hand. For the second hand, we adjust the height differently. We'll maintain the identical height for this hand. And this one we rotated for 250 degrees. Regarding the height, we don't actually need to specify one for the second element. We set its background color to a vibrant goldenrod. You will notice the color doesn't change. The functionality is good, but the background color remains unchanged. Let's target the second hand in the same way as the arrows. This now correctly targets the element because we need to overwrite its existing classes. Therefore, we must specifically target them. We also apply this to the hour. With the hour now properly scaled, our display looks much better. At this point, the styling looks completely finished. This completes our CSS styling, giving the clock its final visual look. To make the watch function correctly and match our computer's exact time. As you can see, this value is close to 12. But notice that it now matches my computer's exact time. Moving forward, we will employ JavaScript to retrieve computer information dynamically. With this information, we will adjust the placement of the seconds, hours, and minutes. This watch displays the precise time synchronized with your computer's clock. Let's dive into the JavaScript part of our project. We've just finished styling our project with CSS in the previous section. Now that we've styled our project with CSS, let's begin incorporating JavaScript to add exciting functionality. Our goal is to retrieve the current date and time from the browser and then convert the time components, such as seconds, minutes, and hours, into degrees for our clock. The first thing we need to do is create a JavaScript file. To create the JavaScript file, let's open the Explorer section by pressing Ctrl and B, and then, on the left side, right-click and select New File. Let's go ahead and create a file named index.js. To effectively use this file, we must link it within our HTML. To begin, inside the index.html file, just before the closing body tag, we will add a script tag. Let's type sc and select the second autocomplete option, the script tag with the src attribute. The src attribute specifies the location of our JavaScript file. Let's simply type index.js to reference our file. With JavaScript now set up and ready, let's grab those important elements to make things happen. Let's retrieve a few essential elements. To begin, we need to get the hour, minute, and second elements. To select these, we can use the query selector method. Let's declare a constant, naming it hour element. Assign it to the document object using the query selector method. For the selector, add a dot before hour since it's selecting a div by its class name. To free up more screen space, let's close the Explorer panel. Next, conveniently duplicate this line 2 more times using Alt-Shift-Down. A neat trick to select both instances is by using Ctrl+D. This selected line will represent the second element. With our elements now selected, we can proceed. To better understand this process, let's add a console.log statement. To illustrate, let's simply console log our element. At this point, open your browser's developer console by pressing F12 and navigate to the console tab. As you can see, the element with an hour class is returned. We want to update this div element using the current time from the browser. However, to update the information, we need to fetch it every second since the browser provides static data. Let me demonstrate that approach for you right away. To begin, let's create a function we'll call updateClock and execute it once here. A primary objective here is to capture the current time or date. To determine the current time, we can simply use newDate. By creating a new date, we obtain an object that captures the current moment, storing it in our current date variable. To better understand this process, let's add a console.log statement. At this point, we are retrieving both the date and the time, but the output is simply a string. Specifically, we care about the hour, minute, and second. Observe the output, which is now 8:36:27. Try refreshing the page yourself, and notice how that value changes with each new request we make. We have two methods for getting it every second. One of these methods is the setTimeout method, and the other one is setInterval method. Let's try implementing the setTimeout method. Let's begin by typing setTimeout into the code. The setTimeout method takes two arguments. The first of these is a function. We will use an arrow function, and the delay specified will trigger this function's execution. Since we're calling this function, there's no need to create a new one. We just put the function's name here. Observe in the console how the current date and time update every second. Right now, we are particularly interested in the hour, minute, and second. For instance, to retrieve only the hour value, let's simply add a method here and call it getHours. This method retrieves the current hour value. To retrieve values like minutes or seconds, you can simply use getMinutes or getSeconds. In this example, our indices are 3, 4, 5, and 6. With these approaches, we can get all three things. Therefore, instead of console logging, we simply create a constant and name it, for example, hour. This constant equals currentDate.getHours. Let's duplicate this line 2 more times using Alt-Shift and the down arrow key. And this is going to be minutes. And this should be capital, and this is going to be seconds. At this point, we're capturing all three, hours, minutes, and seconds. To better understand this process, let's add a console.log statement. We are retrieving the hour, the minute, and also the second. So that is okay, but our clock is analog. So we need to convert these things to a degree. Let's change the hours to degrees. Let's declare a constant for our degree calculation. To convert it to a 12-hour format, we simply divide the hour by 12. To convert this value to a full rotation, we multiply it by 360 degrees, as a circle contains 360 degrees. To make this hour visible in our clock, we must adjust its style. Recall that within the style, we applied a transform to rotate it either 30 or 250 degrees. For instance, if the rotation is 30 degrees, it positions here, but if it's 60 degrees, it moves over to this spot. Now we want to change this one dynamically using JavaScript here. To achieve this, we will target our hour element and change its style's transform property, because here we are applying a rotate function. Since this part is dynamic, we need to use backticks for variable inclusion. Next, we simply specify rotate and use a dynamic variable such as hour degree appending deg, which stands for degrees. At this moment, our hour is 8. Following the same logic, we need to apply this for the minutes and seconds as well. Duplicating this line twice, we then change hour to minutes, and since there are 60 minutes in an hour, the value should be 60 instead of 12. Following the minutes, apply the same adjustment to seconds by replacing the name and using 60 as the divisor. The timing now functions perfectly, showing the current time on my computer. Another approach I mentioned earlier involves using setInterval instead of setTimeout. Let me comment out this direct function call right here. Now we can implement setInterval to run the update clock every single second. This will achieve exactly the same continuous update effect. That concludes our project for today, and I hope you enjoyed the journey while picking up some useful skills along the way. Looking forward to seeing you in the next tutorial. Welcome back to another exciting project, where we'll continue building simple yet powerful web applications together. In this project, we are going to create a fully functional weight converter that can instantly convert pounds into kilograms. As you can see from the final version of the project, we have an input field where we can type any number we want to convert from pounds. For example, if I type in 100, you'll immediately see the converted value displayed right below, showing the equivalent weight in kilograms. After around 10 seconds, the result will automatically disappear and the input field will reset itself back to empty. We're going to use a built-in JavaScript method called setTimeout to make this automatic reset happen at just the right moment. We've also added an error handling feature to make the project more realistic and user-friendly. For instance, if you type a negative number like -100, you'll see a message saying, "Please enter a valid number," helping the user understand what went wrong. We'll also learn how to make that error message fade away automatically after 2 seconds using a simple JavaScript function. So, I'll see you in the next section, where we'll start writing the HTML structure and begin building this weight converter project step by step. Alright, welcome back to the project. Let's begin building the HTML structure for our clock project in this section. I've loaded the completed version in the browser to help us compare it with our code. Let's begin by creating an HTML file for our project. For this tutorial, we will use Visual Studio Code as the text editor, though you may choose any editor that suits you best. After launching Visual Studio Code, please close the Welcome tab and access the File menu. Let's go ahead and click on the Open folder now. By following this approach, we create the folder we want and build our project inside it. Let's begin by creating our project right on the desktop. To get started, let's create a folder on the desktop and name it after our project. To get started properly, let's rename the folder to Weight Converter. After pressing Enter, the folder name updates successfully to Weight Converter. Let's click the Select Folder option to choose the right folder. Let's close the Get Started tab once more, and notice how the Explorer section now defaults to our newly created folder called Weight Converter. Let's create our HTML file right here by clicking this icon, naming it index.html, and pressing Enter. You can see the new file appearing in the editor on the right. You'll notice the file starts completely empty, but try typing an exclamation mark and let the auto-suggestion generate the HTML boilerplate for you. This creates the doc type, HTML tag, head tag, and body tag automatically. I'll quickly walk you through each of these elements before we begin building our project. The first line declares the doc type, informing the browser about the HTML version in use. In HTML5, simply place the basic HTML attribute right here, using only HTML without any extras. The HTML tag wraps the entire website content, including both the head and body tags. Inside the opening HTML tag, the lang attribute specifies the page's language, and for this project, we selected English. Next comes the head tag, which contains the metadata tag along with the title tag. Our first meta tag handles the character encoding with a default UTF-8 setting, which HTML5 strongly recommends since it supports almost every character and symbol available. This approach ensures that visitors to your website can clearly read all characters and symbols without any issues. We include a meta tag to set the viewport for better compatibility with older browsers like Internet Explorer, even though it no longer receives support. This directive instructs Internet Explorer to utilize its latest rendering engine, Microsoft Edge. Microsoft now focuses on developing Edge and has stopped supporting Internet Explorer. Your Internet Explorer browser will automatically switch over, and use Edge instead. Next comes the viewport meta tag, which matches the page width to your device's screen size. For instance, picture a mobile device with a smaller screen, where the browser width adjusts down to match that compact size. In contrast, imagine viewing on a larger screen, such as a tablet or laptop. Next, inside this meta tag, we adjust the starting zoom level for the page to 100% by adding a simple value of 1 here. We include a title element that defines the page's name. I'll demonstrate how the title appears in the browser. Let's launch the browser now with the extension you may have installed already, and I strongly suggest getting it if not. You can now click the Go Live button to automatically launch your browser on port 5500 while displaying the index.html file. You can see that the title refers to the document. Let's position the website preview on the right side to view changes in real time. To create more room on the screen, let's close the Explorer panel. Let's go ahead and update the page title right now, then watch it appear in your browser's tab. Let's assign the page title to our project's name, Weight Converter. Observe how the changes appear right in your browser window. With our JavaScript file created, let's begin adding it to the browser by placing the script tag inside the body section. Take a close look at the final version, and I'll draw it for you. We have a container positioned inside the body, right at the center of the screen. The content inside this container features a simple empty div that uses the class container. Moving forward, you will notice the main title created with an h1 element, naming our website as a weight converter. Right after that, another div appears containing a label and an input field positioned on the right side. As you can see, we also include another important detail right here. To make this clearer, let me highlight it using a different color. Notice that this spot displays the weight result clearly. Let me illustrate with a quick example by setting the pounds value to 100 right here. Observe how the kilogram value appears as 45. Remember, if you leave that part empty by mistake, an error will appear right away. For instance, we simply insert a 0 right there. Let's include another paragraph right here to address errors properly. With our setup complete, let's begin incorporating these elements into our website. As I mentioned earlier, our div with the container class holds everything inside it. Let's begin by typing .container and then use the emit abbreviation. We can select the div element using its container class name. Within this container, let's place an h1 element as the main heading for our website and assign it a class named heading. Later in the tutorial, we will style this heading using CSS and that class. Next, type h1.heading and press enter to create an h1 tag with the heading class, then add the project name weight converter inside it. Observe how this heading appears immediately in the browser. In the next steps, we will apply CSS to style this element and target it using that class name. Following that step, we will add the label connected to this input field. These elements will reside inside a div container. Let's create a div element with the class input container. This element will include a label dedicated to pounds. Let me simply add the pound word right here. Inside this label, replace the text pounds to indicate the unit clearly. Let's place an input element right after the label. This action creates an input field set to accept numbers along with a name attribute. We can simply delete this name since we don't need it. We don't require the name attribute for this project. We will assign the ID value input to this element so that JavaScript can target it later. To proceed, we must add an ID to this element, and we'll also style it with a class named input. You can adjust the step value for this input field. Let me demonstrate exactly what this step involves. Whenever we adjust that value, it increments step by step. However, feel free to adjust these steps however you prefer. For instance, suppose we want the value to change by 0.1 each time. This setup ensures the value increases by 0.1 with every adjustment. That wraps up our work on the input container in this section. Next, include a paragraph displaying your weight in kilograms, followed by an empty span element that we can update later using JavaScript. To demonstrate clearly, we will include a hard-coded example right here. As an illustration, let's use 300 here. However, we'll compute this value later using the real-time input and display it right in this spot. We will assign this span an ID named result. Let's also include the error handling now. In this next step, we will create a paragraph element featuring both a class named error and an ID named error, allowing us to modify it easily later on. Let's place the word error inside the paragraph to use it for styling effect. This placeholder text lets us preview the styling clearly. Later on, JavaScript will help us display this dynamically. JavaScript lets us modify the text content, adjust the color, and make other changes to elements like this one. We've wrapped up the essential parts of the HTML section for the moment. Having incorporated the head tag along with the inputs and label, we have now added the paragraph that includes the span element. We have also included an additional paragraph to handle errors. In the upcoming section, we will style our project with CSS to achieve a new morphism design. Please check out the next section to explore the CSS styling for our project. We have just completed the HTML structure for our project in the previous section. In this section, we will begin styling the project with CSS. Looking at the final version, notice our container centered perfectly in the browser window, both vertically and horizontally. Notice that we have a title included right here. Let's adjust the color first, and then we'll explore the input section. Additionally, we include two essential sections, one for displaying the result and the other for managing an error. Additionally, we will apply a linear gradient background to the screen using these three colors for a vibrant effect. Let me demonstrate for you how to implement this within the CSS file. The first step requires us to create the CSS file. Let's begin inside Visual Studio Code by opening the Explorer section. In the Explorer section on the left side, we click this icon to create a new file, name it style.css, and press Enter. With the file now open in the Editor tab on the right side, remember to connect it properly within the HTML code before moving forward. With that in mind, let's return to the index.html file. Let me close this panel to free up some space. Immediately following the title tag, let's include a link element to connect our style sheet. Let's type link and select the third autocomplete option for the CSS style sheet. By adding this link tag in our index.html file, we connect it to the style.css where the href attribute points to the file's location. And since both are in the same folder, we just enter style.css right here. With the CSS file prepared, let's begin styling our project. Let's begin styling with the body section right away. Let's adjust the background color and center the content using display flex. To target the body element, simply write the word body in your selector. Let's view the final working version inside the Browser tab. Let's eliminate the default margin by changing it to 0. This step eliminates spacing around every element, allowing us to set the background color by declaring background. Let's apply a linear gradient background using 3 vibrant colors. To achieve this effect, let's define the gradient heading to the left top, starting with yellow as the first color, light blue as the second, and yellow again for the final one. Notice how the background displays yellow, blue, and yellow again, repeating 3 times because the screen height remains undefined. To resolve this, assign a minimum height of 100% for the full viewport, ensuring it matches your device's exact screen size. I have just adjusted the zoom level here for clarity. By removing the zoom level, you'll see the element matches the browser's full height. At that point, switch the display to flex so everything centers perfectly. To center our elements horizontally, adjust the Justify Content property to center, and for vertical centering, set Align Items to center. For the body section, let's also switch the font family to Courier New. This font, Courier New, happens to be my favorite choice, though you can select any other one that fits your project better. Let's adjust the font color to dark cyan. You might not notice it clearly yet, but let's add a background color to the container. This approach will provide a more reliable continuous update. Following that step, we will add the container element that covers everything. Take a look at this div element with the container class. Let's add a div element and assign it the class named container. We selected this way because the element uses a class name. Let's place a period right here and follow it with the word container. Let's begin by adjusting the background color to make everything easier to see. In this step, let us set the color using RGBA format. RGBA stands for red, green, blue, and alpha, where alpha adds transparency to your colors. Let's add 255 to create the white color and include a value for alpha to control transparency levels. I want this set to 0.3 for transparency, allowing the color to show through clearly. This approach creates a glassy design effect, commonly known as neomorphism. With that understanding in place, let's continue ahead. After completing that step, we will add padding to enhance the spacing. This property creates space around the element inside the container, and we will set that space to 20 pixels. To make this container more visible, we can add a subtle box shadow. To boost its visibility, let's add a subtle box shadow around the element. Let's add a box shadow next, setting the horizontal offset to 0 and the vertical offset to 4 pixels. You will notice it displayed right here on the screen. With a blur radius of 10 pixels, the shadow softens around the element's edges, and the 4-pixel offset on the y-axis creates a gentle vertical spread. Let's proceed to adjust the color right away. We certainly prefer a different color instead of green. We can use RGBA values once more, but this time set red, green, and blue to 0 for black while adding 0.3 for transparency. This approach creates a dark black shade with added transparency, mimicking a subtle shadow effect. To give this container rounded corners, apply a border radius of 10 pixels. Observe how this defines the container's overall size. Let's adjust the width to 85% right now. This setting ensures it spans exactly 85% of the full container size. Notice how the space around this element shifts whenever we resize the browser window, yet on larger screens, I prefer keeping it smaller. The easiest approach involves setting a maximum width of 450 pixels, just like this. Now the container looks perfectly balanced and appealing. That wraps up our work on the container section. Let's proceed to the next part of our tutorial. With that container in place, the next element is this heading titled Weight Converter. With the container ready, let's style that heading right here. The heading size looks perfect right now, and everything else is set without needing changes. Next, we place this input container that wraps around the label and input elements. Let's begin styling the input container right away. To select that class, we add .inputContainer, positioning them side by side while keeping space between. Let's switch the display property to flex and set justify content to space between. This approach separates the two elements inside the div, and we apply align item center to position them directly in the vertical center. You might not notice it right away, but enlarging the input pushes the pound symbol slightly off-center without using align item center to keep it properly in the middle. Let's increase the font size to 18 pixels and set the font weight to 700 for a bolder appearance. Let's proceed by selecting this input element. Observe how this input element carries the class input, which lets us select it easily using .input. To improve the layout further, let's add 10 pixels of padding right here. Take a look at the final version. It includes a placeholder that we haven't added to our website yet. To add a placeholder attribute, place it inside the input element and set its value to enter number. All you need to do is type enter number inside the quotes. Let's examine how the styling and effects appear right on screen. Once we've configured the padding properly, let's adjust the width next. Let's adjust the width property to 70% here. This technique ensures our design adapts smoothly to various screen sizes. When the screen size increases, our input field expands accordingly, and you can test this by opening the developer tools to select the mobile responsive section. If you reduce the overall size, notice how the input size shrinks accordingly. This technique enables us to build a responsive design effectively. However, suppose you set the width to 200 pixels. It displays correctly at first, but it overflows the container when the screen size shrinks. For optimal responsive design, we should use percentages for the width. Let's move this over to the right side properly. After setting the width property, let's now include a background color. Let's set the background to an RGBA value with white color and 30% transparency, plus adjust the border color to enhance its visual appeal. We'll set the border color to white using RGBA with 50% transparency for a stunning visual effect. Let's make the text larger by setting the font size to 18 pixels. We can also add an optional border radius for rounded edges. Let's apply a border radius of 10 pixels. Let's proceed with setting the color for our elements. When you enter the text, you'll notice the color appears black. Let's choose dark green as the color for this element. Furthermore, when we click on it, that border should not appear at all. To remove that outline completely, set it to none. Removing this outline remains entirely up to your preference. This outline feature is highly recommended for all websites because it greatly helps people with disabilities navigate and grasp the content easily. However, for our custom website, we will remove it to match our preferences. You have the option to keep the outline visible while also changing its color. You can choose whichever method works best for your project. Following the input field, we will now style the error message. Let's adjust the text color for this paragraph using the error class. Let's set the error text color to red. To target that element, I access its style property and change the color to red. We just completed the CSS styling section of our project. Our website now adapts seamlessly to every screen size, from mobile phones to desktop computers, with a vibrant linear gradient background and a stylish glassy effect from the RGBA container colors. In the upcoming section, we will enhance our website by adding more features to reach the final version. Next, we'll convert the pounds value into kilograms and display an error message if the input equals 0 or goes below 0. As we move to the next section, we will add more functionality. In the next section, we will dive into the JavaScript features for our project. Welcome back everyone to continue our project. We've just wrapped up the CSS styling for our project in the previous section. Let's enhance our project further by incorporating JavaScript for interactive features. Let's examine the completed version featuring this input field. Watch what happens when you adjust the input value above, as the display updates instantly to show the kilogram conversion from the pounds entered. For instance, try typing a negative value here and you'll see an error message appear that says, "Please enter a valid number." You'll see the error disappear after exactly 2 seconds. Notice how the error message vanishes after 2 seconds, and if you input 10, the displayed number will clear after 10 seconds. You'll notice both elements clearing out as well. Let's focus carefully on this next part. We'll use setTimeout to execute a function after a specified delay. For instance, after 10 seconds or just 2, we can remove an element or clear input values by setting them to an empty string. In this part, we will explore using the setTimeout method. Additionally, we will learn how to retrieve data from the input field and simultaneously update the outputs in other sections. Before moving forward, we will create a new JavaScript file. Let's return to Visual Studio Code and open the Explorer panel by pressing Ctrl+Shift+E. Let's create a new file right here and name it index.js. To make our JavaScript file work with the project, let's link it inside the HTML right before the closing body tag. Unlike the link tag for our style.css file that sits in the head section, place the script tag right before the closing body tag. We place the script tag right before the closing body tag to ensure all page elements load fully before JavaScript accesses them. Placing the script tag in the head or at the top would block access to those elements since they load afterward. Let's begin by typing SC and then selecting the second autocomplete suggestion, the script tag with the src attribute. By setting the src attribute to index.js, we have linked our JavaScript file correctly. Now we can use JavaScript in our project. To free up more screen space, let's close the Explorer panel. Let's move the website to the right side of the screen to watch the changes update live. Let's begin by fixing this error in the HTML file, since we will generate that text using JavaScript. Therefore, we prefer keeping everything hidden right from the start. Now we go to the JavaScript file, and first we add an event listener to the input. Remember from earlier, our input element has an ID named input, which lets us select it using the getElementById method. Therefore, create a constant and name it input element. We can call the getElementById method here, passing the ID input, since that matches our input element's ID. With this element now selected, let's attach an event listener to the input. Let's attach an event listener to our input element, specifying input as the event type. Whenever the input changes, we want to call the updateResults function. With that explanation in place, let's define the function right at the top of our script. Let's start by creating a function named updateResults, and inside it, add a simple console.log statement that outputs the word change for testing. Let's press F12 to open the browser console right now. Let me move this down to the bottom for better visibility. You can see this output displayed right in the console. To illustrate the effect, let's adjust this value by changing the number. Whenever you spot a change in that output, we log the word change right in the console. We have successfully set up the add event listener and called the function properly, so replace that console log with a simple adjustment. Let me also use console.log to display the content inside this input field. Since we now have access to this input element, we can easily retrieve its value by adding .value. For instance, let's try entering 100 right here instead, and you'll notice it displays 100 here. As an illustration, consider entering 100.4, and you will see all the details displayed right here. You can easily retrieve the value of this input by accessing its value property. With that covered, let's first handle the error case. In this step, we will create an if condition right here. For instance, we can check whether the input element's value falls below 0 or remains empty. If none appears, that simply means it holds no value whatsoever. If the value appears empty or falls below 0, we need to handle it appropriately. To retrieve the user's input value, simply access input.value. Let's go ahead and close this if statement right away. In this case, we need to show an error message clearly. Let's begin by selecting the error element on our page. The error element carries an ID named error, allowing us to select it directly with the getElementById method. Let's create a constant called errorElement and assign it to document.getElementById with the ID error to select that specific element on the page. With that established, we can now access and adjust this error element effectively. Let's add the error element right here, and to update its inner text, we can set it to something like, please enter a correct or valid number. When the number reaches 0, observe the update appearing in the error element. Let's examine this element we selected, noting its ID is error and the inner text matches it precisely. To demonstrate the error handling, enter -10 into the field. Look closely and notice the error message displays, please enter a valid number. One thing I notice is we missed including 0 in this check. Let me adjust the condition now to include 0 by adding less than or equal to 0 right here. Let's see what happens when we enter 0 or a number less than 0. You'll notice the message appears asking to please enter a valid number. If the value exceeds 0, we want to clear the error after a set period. We can accomplish this by including the setTimeout method right here. Let's start by typing setTimeout right into the code. The setTimeout method requires two main arguments, a function and a number for the delay. Let us examine the second parameter, which sets the delay in milliseconds before executing the function. For instance, let's delay its execution by exactly 2 seconds. Keep in mind that the delay measures time in milliseconds, where 2000 equals exactly 2 seconds. Within this function, we want to clear the error message. Let's add that by setting the error element's inner text to an empty string. After 2 seconds, the error message appears briefly before disappearing. However, notice that triggering a new error does not reset the previous timer. If you keep entering the code incorrectly, you'll see many error messages appear, but once it's fixed, those errors will vanish completely. To keep our clock ticking smoothly, we must reset the setTimeout every time the time updates. Before we implement the setTimeout function, let's assign it to a variable for easier management. Let's start at the top by declaring a let variable and giving it a clear name. To manage the timer effectively, assign the return value from setTimeout to a variable like errorTime, and before starting a new one, call clearTimeout to clear errorTime setTimeout to prevent overlaps. This approach effectively resets the previous setTimeout. Take a look at the display below, and you'll notice the error message keeps appearing without ever disappearing. As long as I keep entering invalid values, the error message will persist until I pause. After clearing that element too, let's also remove the value from the input to empty it completely. Let me enter -0.2 to trigger the error message appearing on screen. After that clears in 2 seconds, the input field should also empty itself completely. Since we already selected the input element, target it now to clear its value. We can easily place the clearing code for the input value right inside this function. By referencing the input element's value, we can easily modify it and set it to an empty string as an example. We subtract 1 from the count right away. After 2 seconds pass, the display clears completely and the error message vanishes too. As you can see, we maintain access to the input value from the top, even inside this function. With that, we have finished covering error handling. Assuming everything runs smoothly without errors, let's proceed to the next steps. When we detect a positive number or notice an item present at this location, we can proceed with alternative actions. Before moving forward, we need access to this 300 value. Let me go ahead and remove this hard-coded 300 value. Let's access the ID for our results element right now. Let's include that element in this section too. Let's declare a constant named result element and assign it to the document's getElementById method, which targets the element with the ID of result. With this element ready, we can begin to adjust the result element. In this step, we assign the value directly to the result element. To begin with, retrieve the value from our input element using inputElement.value, then divide that value by 2.2. This calculation provides the converted value in kilograms. Let us test it right away. Notice how the converted number appears right here on the screen. If you enter letters instead of numbers, an error will appear. To ensure accurate calculations, please convert this value to a number by placing a plus sign right before it. This method will change the string value into a number. When working with an input element set to type number, remember to add the plus sign before it to convert the value into a proper number, which prevents common errors from occurring. To limit the display to just 2 decimal places, apply the toFixed method in your JavaScript code and specify 2 as the parameter, resulting in a cleaner output with precisely 2 decimals. With that step completed, let's close the console. Since we finished setting that up, we no longer need the panel open. Let me also clear this line completely and remove the output that appears after 10 seconds. Feel free to pause the video, try this step on your own, and compare your results with mine after seeing what follows. Take a moment to pause the video and complete the challenge yourself. I encourage you to try completing this step on your own. Practicing independently builds strong skills, and since I demonstrated it earlier, you will find it quite familiar. With that in mind, let's implement this step by step. To begin with, let's implement the setTimeout method. As previously mentioned, setTimeout requires a function plus a number that sets the delay before calling that function. Imagine delaying the function call by 10 seconds. Within this function, start by assigning an empty string to the result element. Additionally, assign an empty string to the input element's value. Let me explain the problem that arises from this approach, as it creates a conflict where the display gets overwritten after every 10 seconds, resulting in a messy appearance that prevents further updates. For continuous updates, you must recall setTimeout inside the function itself. Let me create a new variable named resultTime and assign it the setTimeoutResult, so later I can call clearTimeout using that variable to stop the timer. This means that any changes we make inside this function will reset the timeout to 10 seconds. Whenever we update that number, we effectively reset the setTimeout. Notice that right after I stop typing, within about 10 seconds, the input field will clear itself, and this number will disappear too. And with that, we have wrapped up our project successfully. I hope you enjoyed the process and picked up valuable skills. We explored the setTimeout method thoroughly, including ways to restart it effectively and invoke functions during input changes. Watch the numbers update together in the output as you type. We also covered handling errors by using targeted conditions in our code. I hope you enjoyed the journey and picked up valuable skills along the way. I'm looking forward to seeing you in our next project. Welcome back for another exciting web development project. In this project, we are building a dark mode toggle button. You can see the final project has a toggle button. When you switch it on, the page turns dark. Flipping the switch back returns you to the light mode. You will also notice a very smooth animation. The toggle slides elegantly from one side to the other. We will learn how to use CSS keyframes. This will let us create a beautiful sliding animation. We will use JavaScript to update the background color. This change happens whenever we flip the switch on or off. We will store the user's preferred mode in the browser's local storage. This ensures their selection is remembered. After refreshing the page, you can see the dark mode persists. This confirms our settings are saved properly. We can switch the toggle back to light mode. The page will refresh and remain in light mode. This demonstrates the saved preference is working correctly. This ensures the user's preferred mode is always remembered. They will see the same setting when they return to the site. Let's dive into building our project. We will start by creating the HTML structure. This foundation will support our dark mode toggle. Let us dive into the HTML structure in the next section. Welcome to the first step of our project. Let's begin by opening up Visual Studio Code on our computer. We close the Get Started tab first. Then we navigate to the File menu. We select the Open Folder option from that menu. I will create my project folder on the desktop. You can choose any location on your computer. We will click on the desktop. Then we select the New Folder button. This action creates a brand new folder. Let's give this new folder a name. We will call it Dark Mode Toggle. This is the official name for our project. Press the Enter key to confirm the folder name. Next, click on the new folder to open and select it. We close the Get Started tab one more time. On the left side, find the Explorer section. Right-click in the empty space there. Select the New File option from the menu. This will create our new HTML file. We name this new file index.html. After that, we press the Enter key to confirm the file name. You can now see your index.html file on the right-hand side. It has been successfully created and is ready for you to edit. To quickly generate the basic HTML structure, type an exclamation mark. This creates a standard HTML5 document template. We simply type an exclamation mark on the keyboard. Then, we select the first autocomplete suggestion that appears. Let's use the keyboard shortcut Alt-Z to activate word wrap. This will make the code much easier to read. The document type declaration appears at the top. It tells the browser which HTML version we are using. Our page is written in the latest HTML5 standard. Since we are using HTML5, the document type declaration is very simple. We only need the word HTML in this section. Next comes the HTML tag itself. This main container wraps around two important sections. These sections are the head and the body tags. This attribute tells the browser the page's language. We set it to English for correct text interpretation. Since our page is in English, we set the language to EN. This ensures the browser correctly identifies the language being used. Inside the head tag, we have three meta tags. We also have a title tag here. The charset attribute defines the HTML character encoding. The UTF-8 standard is recommended by HTML5. It covers nearly all characters and symbols in the world. This ensures your website visitors can read all the content correctly. This next meta tag is specifically for Internet Explorer. It instructs the browser to use its most modern rendering engine. That engine is called Edge. This viewport meta tag instructs the browser about page sizing. It controls how the content scales on different screens. This part of the command defines the page width. It ensures the width always matches the device's screen size. This viewport setting adjusts the page width to match the device screen. On a mobile device, the website will fit the phone's width perfectly. On a larger computer screen, the content will appear much wider. This viewport tag also determines the page's starting zoom level. It ensures the page initially loads at 100% zoom. The title tag is very important for your web page. It defines the text that appears in the browser's tab. Let's see our changes in real time. We can use the Live Preview extension for this. We can right-click on the file. Then we select the Live Preview option. We choose Show Preview from that menu. A preview of our web page now appears on the right-hand side. You can see the default title is currently set to Document. We can close this Explorer section so we can have more space for coding and seeing the browser. Let's update the title of our page. We will make it match the name of our folder. The new title will be Dark Mode Toggle. You can see the new title in the browser's title bar. Next, we place an input element inside the body section. We define its type to be a checkbox. This input does not need a name attribute for our project. We can leave it out of our code completely. We assign an ID of dark mode to this input element. We also give it a class of input for styling purposes. We will style this element later using CSS. The class we just added will make that possible. Next, we create a label specifically for this input. The input has an ID of dark mode. Therefore, the label's for attribute must also be set to dark mode. We also assign a class of label to this label element. Inside this label, we create a div element. This div is given a class called circle. This circle currently appears as a simple empty shape. We will design its appearance using CSS in a later step. When we click the toggle, the circle slides to the right. If we click it again, the circle moves back to the left. Our HTML structure is now complete and ready for the next step. We will begin styling the button using CSS in the following section. The next step involves styling our toggle button. We will use CSS for this purpose. That completes our HTML structure for the toggle. We will begin styling it with CSS in the next video. In our previous section, we completed all the HTML for our project. We have added an input element to our project. It has a class named checkbox. You can see this element displayed in the browser. We added a label element to our project. Inside this label, we placed a div element. This div has been assigned a class named circle. We are now ready to make our project look visually appealing. We will begin styling our project using CSS. The next step is creating a new CSS file. This file will hold all of our styling instructions. Let's open the File Explorer panel now. You can press Ctrl-Shift-E on your keyboard. Alternatively, use the View menu and select Explorer. I personally prefer using the keyboard shortcut. I press Ctrl-Shift-E to do this. We will right-click in the Explorer section on the left. Then we select the New File option to create our CSS file. We will call this file style.css. We press the Enter key to confirm the new file. To use our CSS file, we must link it to our HTML document. We will add a link element inside the head section. Let's navigate back to the index.html file. We need to place a link tag inside the head section. This link tag goes right after the title tag. Simply start typing the word link. Then select the third autocomplete suggestion for CSS. We have successfully linked our CSS file to the HTML document. The link tag establishes a relationship with our external style sheet. Its href attribute points to the style.css file. Since both files are in the same folder, no additional path is required. We save the file with the link tag in place. We return to our new style sheet to begin writing our CSS. Let us begin by styling the label element. We need to make it visible on the page. This will allow us to see our progress. We are targeting the label element with a class. We add a dot before the class name. Then we open a set of curly braces for our styles. Let's set the label's dimensions. We will give it a width of 80 pixels. We will also set the height to 40 pixels. The label's background is currently white and blends into the page. We should change its background color to a light gray. Now we can clearly see the element on the screen. The label is not visible right now. We need to position it absolute to see it. Let's position this label using absolute positioning. This will give us precise control over its placement on the page. We will place the label inside the body tag. We use absolute positioning to control its width and height precisely. We can now see the label appear on the screen. Let us add a border to this element. We will make the corners of the label perfectly round. We set the border radius to 20 pixels. This value is half of the label's 40 pixel height. It creates completely rounded corners on our element. Let's make that checkbox invisible. We can do this by targeting the inputs class. We are going to target the input element by its class. We will set its visibility property to hidden. This will make the checkbox disappear from view. We select the second option from the auto suggestion list. Let us center the toggle on the page. We will achieve this by applying styles to the body section. Let's style the body element next. We start by removing the default margin. We set the margin property to 0. Next, we change the display to flex. This allows us to center the toggle easily. We set the height to 100 viewport height. We use Justify Content Center for horizontal alignment. Then we use Align Items Center for vertical alignment. The current layout looks good with the label centered perfectly. Let's style the element with the class of circle. We will define its appearance and position. Let's go ahead and style the circle. We will give it a width and a height. Now we will define the width for our circle element. We will set the width to 34 pixels. Let's make the circle visible by changing its background color to red. We will also set its height to 34 pixels. We can see the circle appear in the browser now. Let's make it perfectly round using a border radius of 50%. We also need to set its top position to 3 pixels. This requires us to set the circle's position to absolute. The dimensions for the circle are set to 34 pixels. This specific size is chosen because the label's height is 40 pixels. Our label height is 40 pixels. The circle inside is 34 pixels tall. Subtracting gives us 6 pixels of total space. We will split this space evenly above and below. This gives us 3 pixels of padding on the top. It also gives 3 pixels of padding on the bottom. This positioning ensures the circle is perfectly centered within the label. We have an equal amount of space on all sides. We also need to shift the circle 3 pixels from the left. This final adjustment centers the circle perfectly. Let's change the circle's background color to white. This gives us a clean and attractive toggle switch. That completes the styling for our basic toggle switch. Our next goal is to change the background color. This should happen whenever the user clicks the toggle. We should change the cursor style to a pointer. This provides a clear visual cue for users. We see a pointing hand cursor when hovering over the label. This indicates the element is interactive. We then create a rule for when the checkbox input is checked. When the box is checked, we want to modify the label's background color. We can add a conditional statement for when the checkbox is selected. When it is checked, we can change the label's background color. For example, we can set the background color to a salmon shade. You can now see the background color change when you click. This provides immediate visual feedback for your toggle action. Our next goal is to move the circle to the right. This will happen whenever we click the label. Let's add an animation to make the circle move. This will happen when someone clicks the toggle. To create this animation effect, we must define a keyframes rule. Next, we will define a keyframe animation. We need to give this animation a specific name. Let's create a keyframe animation for the toggle. We will name this animation Toggle On. At the start of the animation, at 0%, we set the transform property. We set the translation along the x-axis to 0 pixels. Then we copy this keyframe block for the 100% state. At the end of the animation, we want the circle on the right side. We will transform it by moving it 40 pixels to the right. The label we are styling has a total width of 80 pixels. This is the container for our toggle switch. Our label has a total width of 80 pixels. The circle inside it is 34 pixels wide. We also want a 3-pixel gap on the right side. We will set the transform to 40 pixels for this position. This gives us exactly the distance we need. Let's turn on Alt-Z to see all of our code. We will set this animation for the toggle off state. This is for when the circle moves back to its original position. When we click the toggle again, the circle should slide back to its original position. This animation needs to work in the opposite direction. For the toggle off animation, the starting position should be 40 pixels. The final position should be 0 pixels. Now we will add the animation. We need to create a condition for it. This condition will target the input when it is checked. Inside the label, we will also target the circle element. We target the circle inside the label by using the dot selector. This circle will now have an animation named Toggle On applied to it. We set the animation duration to 0.4 seconds. The animation timing function should be set to linear. We also set the animation fill mode to forwards. Let's click on the label. We can see the circle moving to the right. We use the forwards value for a specific reason. Without it, the animation does not remain in its final state. When you click the toggle, the circle moves to the end. It then immediately snaps back to its starting position. The forwards value makes the circle stay at its end position. This keeps it locked on the right side after you click. We want the circle to move back when we click again. This animation should trigger from the right position. We will add the toggle off animation to the circle element. We will call this animation toggle off. It has a duration of 0.4 seconds. The timing function is set to linear. The animation will also use the fill mode of forwards. Our animation is now working perfectly. The toggle moves smoothly from one side to the other. Our next step involves adding JavaScript to the project. We will introduce interactivity with JavaScript code. Next, we will add a dark mode effect to the body section. We also need to save this user preference. We will store the mode setting in the browser's local storage. Once a visitor enables dark mode, their preference is saved. Every future visit will automatically display the website in dark mode. We will explore how to implement this feature in the next section. In our previous section, we completed all the styling for the project. We used CSS to make everything look great. We created a smooth animation for our toggle bar. This animation makes the switch look dynamic and interactive. In this section, we will make our project interactive. We are going to add functionality using JavaScript. Our goal is to switch the body's background to a dark theme. This change happens when the user toggles the switch on. We will then revert it to a light theme. This reversion occurs when the user toggles the switch off. We will also save the user's chosen mode. This data will be stored in the browser's local storage. This way, returning visitors will always see their preferred mode. The website will remember their dark mode setting. Our first step involves creating a new JavaScript file. This file will contain all the code for our project's functionality. We navigate to the left side of the editor. We find the File Explorer section there. We perform a right-click with the mouse. Then we select the New File option from the menu. This will create our new JavaScript file. Let's give our file a name. We will call it index.js. We bring our new JavaScript file into the project window. As you may know, we must link this file to our HTML. We add a link to the JavaScript file within our HTML code. Let's navigate back to our HTML file. We will add a script tag just before the closing body tag. We type the letters SC. Then we select the second auto-suggestion. This is the one that includes the src attribute. Both our files are in the same main project folder. This means they share the same directory location. For our source attribute, we can just type index.js as the path. Our JavaScript file is now properly connected. We can start writing our interactive code. Our first task in the JavaScript file is to select the input element. We need to work with this toggle input. We need to determine the current state of our toggle input. Specifically, we want to know if it is checked or unchecked. This input element has a class of input. We can select any element by its class. We use the query selector method for this. We are going to create a constant variable for our input element. We use the document's query selector method to select it. Inside the parentheses, we write .input to target the input class. Let's enable word wrap by pressing Alt and Z together. This will make our code much easier to read on the screen. Let's log the input element to the console now. We simply type the variable name input element. Next, we open the browser's developer tools. We can find the console panel inside the dev tools. There, we see the logged input, which is a checkbox. We can check the input's current state. We add the .checked property. By default, this value is set to false. Let us refresh the page now. We can observe that the value remains false. We have successfully confirmed that the checkbox starts in the unchecked state. When the toggle is off, the body should be in light mode. When the toggle is on, we switch to a dark background. We will create a function called updateBody. This function will check if the input is checked. If the condition is true, we will change the body element's style. Currently, we have not selected the body element in our JavaScript code. We need to access this element to change its background color. To select the body element, we can use the query selector method. This method works perfectly for selecting any HTML tag. We will now select the body element from our document. We use the query selector method for this task. Inside the parentheses, we simply type the word body. We set the body element's background color using the style property. We check if the toggle is on. If it is checked, we set the background to black. If the toggle is not checked, we set the background to white. We have successfully implemented the color change logic. The background now switches between black and white. At this point in our code, the checkbox is unchecked. This means the current status is set to false. We will manually set the input's checked property to true. This is a good way to test our function. Let's call the function to update the body. We do this by writing updateBody. You can see the body's background color has changed to black. If we switch the checked value to false, the background returns to white. Next, we will add an event listener to our toggle input. This listener will specifically watch for a change event. When we toggle the switch on, we update the body's appearance. This update is based on the current check status of the input. Now we need to add an event listener to the input element. We have already selected the input using its class. We have already selected the input element. Now we add an event listener to it. We use the inputElement.addEventListener method. We will listen for the input event. This event triggers whenever the toggle switch changes its state. All we have to do is call our updateBody function. This will apply the new background color. We call this updateBody function within our event listener. This ensures the function runs every time the toggle is clicked. When we toggle the switch on, the page transitions to dark mode. When we toggle it off, the page returns to the light or daytime theme. Our toggle functionality is now working perfectly. The background changes smoothly between light and dark modes. Let's make this color change smoother. We will add a transition effect to the body. This makes the visual change more pleasing to watch. Let us add a smooth transition to the body element. We will set the transition duration to 0.4 seconds. Now you can see the color change happen smoothly. The transition makes the effect much more pleasant to watch. Our next step involves saving the user's preference. We need to store the toggle state in the local storage. This will say whether the mode is on or off. The next step involves saving user preferences. This ensures a returning visitor sees the same mode. Their previous setting is automatically applied. Next, we need to create a new function. We will call this function update local storage. We will use the browser's local storage for this task. We will save this setting with the key name mode. We need to convert the checkbox state to a string. Local storage cannot save raw, true, or false values directly. We will use the JSON object for this task. It helps us convert the Boolean value into a string format. It looks like we have a small typo in our code. We need to capitalize the JSON method we are using. We should capitalize JSON correctly when writing it. It stands for JavaScript Object Notation. We need to convert the checkbox state into a string for storage. This is done using the stringify method on the input element's checked property. We write inputElement.checked inside the parentheses. Let us now open the Web Developer Tools. Navigate to the Application panel on the left. Inside this panel, select Local Storage and then choose our website's address. We need to call our function as well. We need to update the local storage. We should do this inside the event listener. This happens right after we update the body. When we click the toggle button, we can see the result. A new key appears in the local storage panel. This key is named modes, and its value is set to true. When we toggle the switch off, the stored value changes to false. We have set the toggle to true and refreshed the page. The setting remains true in the local storage. We must now initialize this value when the page loads. We cannot simply set the input element check property to false. We need to retrieve the saved value from local storage instead. We retrieve the saved mode from local storage. We use the getItem method for this task. The specific item we want to get is called mode. Let's check what we have in local storage now. We can see the value is true. The value we get from local storage is always a string. We must convert this string back to a true or false value. We can easily do this using the JSON parse method. We need to parse this string back into a Boolean value. This conversion allows our code to correctly understand the saved setting. As you can see, the toggle mode is currently set to false. This means the light mode is active. We can turn the toggle on manually. A user can now leave our website and return later. When they refresh the page, the website will still be displayed in dark mode. You can see the persistent setting working here. Let us improve the appearance of this button. We can make it look more polished. Let's improve the toggle button's appearance for dark mode. We will change the salmon color to white. We will also change the circle's background color to black. The toggle button now looks much more polished. It has a clean white color in dark mode. The circle's background becomes black for a sleek appearance. That concludes our project for this tutorial. We have successfully built a dark mode toggle with local storage. I hope you enjoyed building this project with me. You have learned several important concepts about adding functionality with JavaScript. I hope you enjoyed building this project. I look forward to our next coding adventure together. Welcome to another project, and I'm excited to have you here as we continue building practical and creative ideas that you can apply to your own learning journey. In this project, we are going to create a testimonial slider, which is a very common feature used on modern websites to showcase client feedback or highlight important reviews in an engaging way. As you can see from the final version of the project, we'll design a clean testimonial box, and at the very top, we'll position a profile image that sits neatly in the center and is styled into a perfect circle for a more professional look. Inside this testimonial box, we'll also include the testimonial text itself, along with the author's name, giving our design more personality and making it feel authentic and trustworthy. We're going to create and generate these quotes using an AI quote generator. For the profile images, we'll use free, high-quality photos from Unsplash, and later on we'll update both the images and the testimonial text automatically every 10 seconds using JavaScript to make the slider dynamic. So stick around, because in the next section, we'll get started with the HTML structure, which will be the foundation before we move on to styling and adding functionality. Let's begin building our testimonial slider project. To begin, let's open Visual Studio Code. Let's close the Get Started tab first, then go to the File menu and click Open Folder. For this tutorial, I plan to create the project on the desktop, but you can choose any location on your computer. Let's select the desktop by clicking on it. With the desktop selected, we click the New Folder button to create a new one. Let's name the folder Testimonial Slider and then press Enter. Let's click Select Folder to choose our new folder, close the Get Started tab once more, and then create an HTML file in the Explorer section on the left side. Next, right-click in the Explorer panel and select New File. Look over to the right side, where our index.html file appears completely empty. To kick things off with the HTML structure, type an exclamation mark and select the first auto-suggestion that appears. As you can see, we now have a complete HTML5 boilerplate generated. The first line features the doctype declaration, which informs the browser that the page uses the HTML5 version. For our project, we simply include HTML in that declaration. Following the doctype declaration, the main HTML tag appears and wraps both the head and body sections. The lang attribute here specifies the language of the page, and in our case, we have set it to English. Moving forward, we see the head tag that contains the meta tags and the title tag. The shawset attribute sets the character encoding for HTML5 pages, and UTF-8 is the recommended option because it supports nearly all characters and symbols. This ensures that anyone viewing our page will display all characters and symbols correctly without any issues. Moving forward, we encounter a meta tag that instructs Internet Explorer to use its newest rendering engine. Continuing further, we see the viewport meta tag, which guides the browser in resizing the page for various screen sizes. To better view the full line, let's press Alt and C to enable word wrap. You'll notice the content attribute instructs the browser to match the page width to the device's screen size. This setup ensures that even though mobile screens are narrower than desktop ones, our website displays smoothly across various widths and sizes. Continuing with the viewport settings, the initial scale defines the starting zoom level of the page, set to 100% in our example. Following the viewport meta tag, we encounter the title tag. This title tag defines the name that appears in the Browser tab. You can see this title displayed in the Browser tab. To preview the browser directly inside Visual Studio Code, you can use the Live Preview extension that we installed earlier. In this step, right-click on the file and select Show Preview from the Live Preview menu. Observe on the right side our browser preview, which appears completely empty, yet shows the default title document. Here, we can update the document title to fit our project. To create more space for editing the index.html file and viewing the browser preview, let's collapse the Explorer panel. In the following step, update the title to Testimonial Slider, our project name, and notice how it appears in the Browser tab. Moving forward to the body section, let's create a container div to hold our testimonial content and name it Testimonial. Let's give this div the class name Testimonial Container. With our Testimonial Container div now in place, let's add an image tag inside it to include a profile image. To find a suitable profile image, we will use a website called Unsplash. Switch over to the desktop and open Google Chrome from there. Type Unsplash into the search bar and press Enter. In the top search result, click on unsplash.com to visit the site. Next, use the search bar on Unsplash and enter user as an example term. Browse the results for profile pictures and select one, such as the image of this man, by clicking it. To grab the URL for this image, simply right-click on it and select Copy Image Address. After copying the URL, we switch back to Visual Studio Code and paste it into the src attribute, which specifies the image source location. Take a look at the browser preview where the image now appears, and for the alt attribute, we add the text user image. In the next step, right after the image, we add a paragraph to hold the testimonial text and give it a class named text. To include sample testimonial text, we can search online for a simple testimonial generator website. Looking at the search results, the top one is testimonial generator, com, so we click on it to visit the site, which is an AI-based generator where we simply enter the name of our service or product, such as Apple, and it creates a testimonial. Here we have the generated testimonial, but it appears quite short. In the next step, click the Generate button once more to create another option. This version offers 2 lines, which works well for our needs. Copy the text now, return to Visual Studio Code, and paste it inside the paragraph tag. Scroll down in the browser preview to view the testimonial appearing there. After adding the testimonial text, include an h4 tag with the class username right below it to hold the person's name from the generator. Copy that name, switch back to Visual Studio Code, and paste it inside the tag. With the name in place, we have finished the HTML structure for this project. Moving on to the next part, we will apply CSS to style both the testimonial box and the slider. Following that, JavaScript will enable the slider to advance automatically every 10 seconds. See you soon in the upcoming section. In the previous section, we completed the HTML part of our project. In this section, we will add CSS styles to our project to create an attractive testimonial slider. In the next step, let's create a CSS file by opening the Explorer in the left panel with Ctrl plus Shift plus E, then right-clicking in the Explorer and selecting New File. Let's name the file style.css and then press Enter to create it. Before we start styling our project with CSS, let's link the new CSS file inside the HTML code. Now let's switch back to the index.html file and add a link tag just below the title tag by typing link and selecting the third auto-suggestion for the style sheet. Let's close the Explorer panel now to free up more space for our code editor and browser preview. Let's save the HTML file by pressing Ctrl plus S. Then switch to the style.css file to begin styling our project. To begin styling, let's first reduce the size of this image to make it easier to work on the rest of the page. Let's begin by selecting the image using its HTML tag. Since an image appears on the page, we can target it by referencing its tag. To target the image, we simply start by writing img as the selector. Let's set the width to 100 pixels and the height to 200 pixels. This setting provides us with square pictures to select. With the structure in place, we can clearly view the website displaying all testimonials and the names section, ready to proceed with building the project. Let's begin by creating the body section. To begin our HTML setup, we will remove the default spacing around the body element by setting its margin to 0. You will notice that our layout currently has no margins. In the next step, we apply Display Flex to center the items horizontally. We apply Justify Content Center to align the items horizontally in the middle. However, notice that another div with the class testimonial container matches the body's size exactly, so we see no changes in our browser yet. Moving forward with the HTML structure, let's install that container now. For this testimonial container, let's adjust the width to 500 pixels as an example. Now we see the changes in this preview. Let's adjust the height setting to 300 pixels right here. To make this section stand out clearly, let's apply a background color. Let's set the background color to slate blue. You will notice that this section sits exactly in the middle. You can see the equal margins on both the left and right sides. In the next step, we'll center this section vertically by setting its height to 100% of the viewport height. In addition, we set the Align Items property to center. This adjustment centers the section vertically on the page. To give our text a more elegant look, let's adjust the website's font using the font family property. We'll set the font family to cursive for a more elegant text appearance. We have now finished styling the body section. With the body styled, let's continue with the testimonial container. To enhance the container's look, let's add a box shadow and rounded borders. To round the borders, we apply the border radius property. Let's apply a border radius of 10 pixels and add a subtle shadow effect to the container using the box shadow property. The first value sets the horizontal position of the shadow. We set the first one to 0 for no horizontal offset and the second to 4 pixels for the vertical shadow position. You can clearly see this vertical shadow in the preview. The third value controls the blur radius of the shadow. In this step, let's set the blur radius to 8 pixels. You will notice a subtle shade forming around the box. However, this shadow looks a bit too dark and doesn't resemble a real shadow yet. To create a more realistic shadow effect, we need to decrease the transparency level of the color. To adjust the transparency effectively, we can use the RGBA function for setting the color. In this step, let's start writing RGBA to define the color. RGBA stands for red, green, blue, and alpha values. To create a black color, we set the red, green, and blue values to 0. We set the alpha value to 0.3, providing 30% transparency for a subtle effect. To clearly see the full line of code, enable word wrap by pressing Alt+Z. Moving forward, let's set the minimum width to 300 pixels to prevent the container from shrinking too small. Let's adjust it to 400 pixels for a better result. Next, let's add some margin around the box. Actually, let's use padding instead to add some space around the text inside. Let's specify the top and bottom padding to 40 pixels as an example. We'll set the left and right padding to 20 pixels. In addition, let's add a small margin around the container. We'll add a margin of just 5 pixels around the container to ensure some space remains even on smaller screens when the size decreases. This ensures proper spacing across various devices. To improve visibility, let's set the background color to white. In the following step, let's position this image at the center top inside the container. For the image, let's first round it completely by setting the border radius to 50%. In the next step, we will set its position to absolute to place it at the top. To position the image absolute within the testimonial container, we set the container's position to relative. So, we simply adjust the container's position to relative. To center the image horizontally, we set the left property to 50%. However, this setting positions only the left edge of the image at the center point. Notice how the left edge of the image aligns with the center point. To center the image perfectly, we will apply the transform property. To perfectly center the image horizontally, we apply translate x with a -50% value. Next, we will position the image at the top of the container. We position the image by setting its top value to negative, given that the image height stands at 100 pixels. By setting the top value to -50 pixels, half the image's height, we position it perfectly, so half appears above the container. With this setup, the image now occupies the top section of the container. That positions the image perfectly for our design. We see that the container currently has too much height. To adjust the container's height, let's reduce it to 200 pixels. Let's adjust the padding to shift the content downward slightly. This value represents the top padding setting. These values represent the left and right padding. So, let's increase the top padding to 70 pixels and decrease the height to 100 pixels. This adjustment appears perfect for our layout. Let's reduce the size of the name text here. To adjust its size, we target the h4 tag with the username class. So, we append the username selector at the bottom with a dot in front. We set the font size to 12 pixels.
Yeah,
Let's adjust the font size to 13 pixels for a finer appearance.
13.
In addition, let's lighten the font weight to make it thinner.
Yeah.
Let's set the font weight to 100 for a very light appearance. This gives the text a sleek and elegant look. With these final touches, we have completed the CSS styling for our project. After wrapping up the CSS styles, we'll head to the next section to introduce JavaScript and add interactive features to our project. In the coming section, we'll automatically cycle through the testimonials every 10 seconds, which let us see the next testimonial slide smoothly. That wraps up our CSS styling for now. I will see you in the next section for the JavaScript part of the project. In the previous section, we finished styling our project using CSS. In this part of the tutorial, we will add interactivity to our project using JavaScript. To get started, let's create a new JavaScript file. In this step, press Ctrl plus Shift plus E to open the Explorer panel on the left side. Then right-click inside it and select New File. Let's name the file index.js and press Enter to create it. Before we start writing JavaScript for our project, we need to connect the JavaScript file to our HTML code. Let's begin by closing the Explorer panel on the left side. To close the Explorer panel, simply drag this vertical line toward the left edge. Let's switch back to the index.html file and add a script tag just before the closing body tag. Type SC in the editor and select the second autocomplete option, the one that includes the src attribute. The src attribute specifies the location of the JavaScript file we're linking to. Since both the index.html and index.js files are in the same directory, we simply write index.js as the value. Simply enter index.js as the value for the src attribute. With the script tag added, we are ready to incorporate JavaScript into our project. Let's switch to the index.js file and start by creating an array that holds all the testimonials. To create this array, declare a constant variable and name it testimonials. Let's open an array and create the first object inside it. We'll begin by adding the person's name as the first property. To start, let's copy the details from the first testimonial since we already have that information ready. Let's copy this name from the first testimonial. Let's switch to the index.js file and paste the name right here. Let's enclose the name in double quotes or single quotes to create the string property. Let's add a comma after the name and move on to the next property. We'll add the photo URL as the next property using the one shown here. Let's copy this photo URL, including the double quotes, and paste it right here in the code. To view the entire photo URL clearly, press Alt plus Z to enable word wrap in the editor. Let's finish this property entry by adding a comma right after it. Let's proceed by moving to the next line. Moving on, the next property is the testimonial text. Let's copy the testimonial text from the source and enclose it within double quotes. Simply paste the copied text here and adjust it to fit within the quotes. This setup looks correct for the testimonial text. With the first testimonial complete, let's add the next one. To create the second testimonial, duplicate the first object structure and update the name along with the other details. Let's head back to the testimonial generator website to create additional ones. Let's click the Generate button to create another one. There it is, we now have a second testimonial ready. Now, let's copy this second testimonial to our code. Let's return to Visual Studio Code and the index.js file. For the second testimonial, let's paste this text into the object. For the profile picture, let's search for additional user images. Let's select the square orientation for this image. This selection provides us with a square picture. Let's go ahead and select this square image. We right-click on the image and select Copy Image Address. Let's return to Visual Studio Code and update the photo URL from the previous testimonial with this new one. That update to the photo URL looks good now. The name for this testimonial appears right here as well. It seems we overlooked copying the name from the generator. Let's copy the name from the generator right away. Let's return to Visual Studio Code and paste the name for the second testimonial. With the second testimonial ready, let's create another one. Let's copy the testimonial text once more for the third one. Let's paste this testimonial text directly below the second one. Let's head back to the testimonial generator website. Let's proceed to generate another testimonial. Let's generate another testimonial just like this one. After generating this one, let's copy the testimonial text. Let's return to Visual Studio Code and paste the copied text right here. We also copy the name from the generator and paste it right inside the name. Let's select another image for this testimonial profile. This one looks like a great choice for the profile. After selecting this image, right-click on it and choose the option to copy its address. Let's return to Visual Studio Code and paste the image address right here. 3 testimonials work well to demonstrate the slider, though you can include as many as you prefer. With the array now holding our 3 testimonial objects ready, let's proceed. Moving forward, let's create a function to update the testimonials. Let's begin defining the function named updateTestimonial. In this function, let's retrieve the name from the testimonial. Let's begin by defining a variable for the index. We set the index variable, named IDX, to 0, and then destructure the name, photo URL, and text from the current testimonial. We retrieve them using destructuring inside brackets. Within the brackets, we list the name, photo URL, and text to extract them. We assign these extracted values from the testimonials array at the specified index. Notice that we used testimonials without an S for the array name. We need to add the S here to indicate multiple items in the array. Now that we have added the name correctly to indicate the array,
so we have testimonials, and we want the one with the index IDX, which is 0 now.
Using JavaScript, we will update the photo, the text, and the name. With that setup in mind, we retrieve those 3 elements. These 3 elements consist of the image tag, the paragraph for the text, and the h4 tag for the name. Specifically, that includes the paragraph for the text, the image tag, and the h4 tag for the name. At this point, we can select an element using the query selector method. Let's start with the first element, which is the image. We declare the image element and set it equal to document.querySelector. The element we're targeting here is the image. In this case, we specify img to target the image element. After selecting the image element, we move on to the text. In the following step, declare the text element by assigning it to document.querySelector. The testimonial text resides in a paragraph element with the class named text. Therefore, we can use .text rather than just paragraph since it targets the specific class and keeps the code clearer for future reference. Moving on to the name element now. In this step, we will define the username element as a variable. Type document.querySelector to select the element. In this case, the username element has a class named username. To target that specific class, we simply write .username right here. With all elements selected properly, we can now update their content. To update the image or text content, we use simple properties like setting the image's src to our photo URL variable. For the text element, we simply set its inner text to the text variable. Moving on to the username element, set its inner text to the name variable. Let me fix this element, which is for the text, not text element. For the username element, we set its inner text to the name variable. In the next step, we call this function right at the top. You won't notice any change right now because we're showing the same details from the first item in the array. To advance through the testimonials, we increment the IDX value and employ the setTimeout method to trigger a function once the timer expires. The setTimeout method sets up a timer and then calls a specified function once the time has passed. In this setup, we specify the function to execute once the timer expires, along with the delay time in milliseconds as the second argument. In this example, we set the delay to 2000 milliseconds, which equals 2 seconds. The first argument is the function we want to execute here. With this implementation, every 2 seconds delivers a fresh testimonial. When you refresh the page, it starts from the beginning again, but once it reaches the end, it stops cycling through. However, we need the slider to reset and loop back to the beginning. To make the slider loop continuously, we can add a condition right here. To create the loop, we add a simple condition. To loop back to the start, check if the index equals 2, then reset it to 0. With this condition added, you'll see the testimonials changing endlessly in the slider. Right now, the testimonials are changing too quickly. Let's adjust the timer to 10,000 milliseconds for smoother transitions. This change creates a smoother viewing experience. And with that, we've successfully completed our project. I hope you've enjoyed this tutorial and found some useful skills you can add to your toolkit. Remember, every project brings you one step closer to mastering your craft. I can't wait to see you in the next project. Stick around, keep coding, and let's keep building amazing things step by step. Welcome back to another project, and thank you so much for joining me once again as we continue learning new and exciting things step by step together. In this project, we are going to build a simple yet very practical to-do list application using JavaScript, where we can add, check, and delete our daily tasks easily. When you take a look at the final version of this project, you'll notice that we have an input field right at the top where we can type in any task we want to add to our list. For example, we can type something simple like buy milk or any other task we want to remember for later. As soon as we press the Enter key, the task is added instantly at the bottom of the list, appearing smoothly without needing any page refresh. You'll notice that the page stays exactly the same when the new task appears, which makes our application feel fast, modern, and user-friendly. Even if we refresh the page completely, all the tasks still remain on the screen because we are saving them permanently inside the browser's local storage. In this project, we're going to learn step by step how to set items, get them back, and manage them inside local storage using JavaScript so our data always stays safe. You'll also see two small icons beside each task. One is a check icon, and the other is a trash icon that lets us control each item individually. When we click on the check icon, that task will be marked as completed or done, letting us visually see our progress. And when we click on the trash icon, the selected task will be instantly removed from the list, keeping everything clean and organized. Even after refreshing the page, you'll see that the checked items remain saved, and the deleted ones are gone completely from the local storage of the browser. In the next section, we'll begin by creating the HTML structure for our to-do list, which will serve as the foundation for everything else we build. So, I'll see you in the next section, where we'll start writing the code step by step and bring our to-do list to life. Alright everyone, let's get our project started. Let's begin by opening Visual Studio Code, closing the Get Started tab, and selecting Open Folder from the File menu. I am going to create this project on my desktop, but you are welcome to choose any location on your computer. Let's click on the desktop, then select New Folder, and name this new folder To-Do List. With that, we press Enter and click the New Folder button. Let's close the Get Started tab once more, and then in the Explorer section on the left, we will create an HTML file. To create our new file, we simply right-click and select the New File option. Let's name this file index.html and press Enter. You will see our new HTML file is empty, but we can quickly generate a complete template by typing an exclamation mark. We simply type an exclamation mark and then select the first auto-suggestion that appears. Now we have our HTML5 boilerplate, and the very first line is the document type declaration that tells the browser which version of HTML we are using. Since we are working with HTML5, we simply type the word HTML here. Next, we have the HTML tag that wraps all of our page's content, including the head and body sections, and the language attribute within it defines the page's primary language. For this project, we will set the language to English. Moving into the head section, we find 3 meta tags and the title. The charset attribute specifies the character encoding, and for HTML5, we use UTF-8 as it includes nearly all characters and symbols. Next, we have a meta tag specifically for Internet Explorer, instructing it to use its most modern rendering engine, called Edge. Next, we have the viewport meta tag, which controls how the browser scales the page. This first part sets the page width to match the device's screen. For example, a mobile screen is naturally smaller than a computer screen, and the second part of this setting controls the initial zoom level. To help us see the complete code, we can turn on word wrap using Alt-Z. Setting the initial scale to 1 means the page loads at 100% zoom. The title tag defines what appears in the browser tab. Let's take a look at our browser preview now. To see our page in the browser directly inside Visual Studio Code, we can right-click and select the live preview extension we installed earlier. Let's click here to see the browser preview on the right side, which currently shows an empty page with the default title Documents. Next, we will change the title to To-Do List to match our project name, and then move to the body section where the main content visible in the browser will be placed. Next, we will add a form element for our to-do list and assign it a class of form. Since we don't need an action for this form, we can delete that part and add an input field with the class of input. We will set the input type to text. You can see our input field now, and we will add a placeholder text inside it that says, "Enter your task." That placeholder text looks perfect. We also want to disable the autocomplete feature. Let's set the autocomplete attribute to off. The autocomplete attribute simply disables those automatic suggestions for our text input. Next, we will add an unordered list tag and assign it the class of list for our task items. For our first list item, we will add an example task like buy milks and include 2 icons. We will add 2 icons for each list item, one to check items off and another to delete them entirely. To add icons to our project, we can use the Font Awesome website. Let's open up our Google Chrome browser and search for Font Awesome. We click on the first result, which is fontawesome.com, and then we select the icon section. We can browse through the many available icons and search for a checkmark. We click on the check square icon and copy the provided HTML tag, which is an I tag with the classes FAS and FA check square. The icon has been copied to our clipboard. Let's make this panel a bit smaller so it's easier to see. Right now we can't see the icon because we need to link to the Font Awesome library in our HTML code. Let's head back to the browser and open a new tab where we will search for cdnjs. The first result that comes up is cdnjs.com. We then click on this link and search for Font Awesome in the search bar, clicking the top suggestion. Now we need to scroll down a little until we find the link tag we can copy. Let's head back to Visual Studio Code and paste that link tag just below the title, right before the head section closes. Perfect. Now the checkmark icon appears in our browser preview. Next, we will add the trash icon for deleting items. Let's navigate back to the browser and reopen the Font Awesome tab we had earlier. Now let's search for a trash icon using the search bar. Let's click on the first result here. Just be sure to avoid the other icons that require a paid license. The free ones are solid black and not faded. We select the first free trash icon and copy its HTML tag containing the FOSS and FA trash classes. We return to Visual Studio Code and paste the copied trash icon right after the checkmark icon. You can see the 2 icons are now sitting side by side. Let's copy this list item and change the text from buy milks to call David as an example. Now we have 2 items in our list, and we will add a checked class to the first one so we can style it later with a different color and a line through the text. In the next video, we will begin styling our project with CSS. That wraps up our HTML setup for now. In the previous section, we completed the HTML portion of our project. Now we are ready to bring our project to life with CSS styling. The very first thing we need to do is create our CSS file. To open the File Explorer, we can press Ctrl-Shift-E. Now, in the left-hand Explorer panel, we can right-click and select the New File option. We will name this new file style.css and then press Enter. To apply our styles, we must first connect our CSS file to the HTML document. Next, we will switch over to our index.html file and add a link tag right after the font awesome link, positioning it at the very end of the head section. We type the word link and then select the third auto-suggestion for the style sheet. This link allows us to use CSS in our project. We can close the Explorer panel by dragging this divider to the left. Now let's move over to our style.css file and begin styling our project. Let's begin by styling the body element first. Let's start by typing body and then opening our curly braces. Our first step is to remove the default margin. We are setting the display to flex so we can center the items horizontally. Let me just expand my browser window a bit more. To center everything horizontally across the page, we'll use the Justify Content property with a value of center. Let's go ahead and change the background color to something like green, or perhaps this color right here. Next, let's begin styling the form itself. Now that we have finished styling the body, let's move on to the form. Remember that our form also has a class of form. We will target the form class using the .form selector, and then we position it absolute with a top value of 30%. The reason we avoided using a full viewport height with centered alignment is that our list needs to be able to grow and scroll without being confined to a fixed screen height. By setting the position to absolute, we position the form relative to the body, moving it down by 30%. Let's go ahead and add a box shadow to give our form a nice shadow effect. For the horizontal shadow position, we'll set it to 0, then set the vertical shadow to 4 pixels, and finally set the blur radius to 8 pixels, which you can see taking effect here. We can clearly see the shadow effect now, but it is a bit too dark for our liking. To make the shadow less intense, we can use the RGBA color function to add some transparency to the black. Next, we write RGBA with parentheses and set all color values to 0, then use 0.3 for the alpha channel to create a 30% transparent black. I'll quickly press Alt+Z to enable word wrap so we can see all of our code clearly. Next, we will set the form's width to 400 pixels and experiment with the background color. Let's go with light pink instead, that looks much better. Let's round the corners of our form by adding a border radius of 10 pixels. That wraps up all the styling for our form section. Now let's move on to style our input field. Now, we need to style the input field, which has the class of input. First, we'll set the input's width to 100%, but you can immediately see it's actually overflowing. The reason we're seeing this overflow is that the browser is including the border width in the total element size calculation. So the solution is to set the box sizing property to border box. Setting the box sizing to border box is precisely the solution we need. As soon as we set the box sizing to border box, you can see the input now perfectly matches its parent's width. Next, we will add a padding of 20 pixels and round off the top corners of the input field. Let's apply a border radius of 10 pixels to the top left and top right corners, while keeping the bottom left and bottom right corners at 0. Now let's also remove that dark border around the input field by setting the border property to none. Now that looks much better, so let's change the font size to 20 pixels for better readability. This change gives us a much cleaner and more attractive font style. You might notice the placeholder text is a bit too bright. To change the placeholder text color, we will target the pseudo element. To style the placeholder text, we target the input class and use the placeholder pseudo element to set the color to a light gray. That covers everything we need for styling the input field. Let's move on to style our unordered list section. The unordered list element has a class named list. Next, we will style the unordered list with the class of list by removing its default padding and margin. This gives us a much more compact list without the gaps. Next, we need to get rid of these bullet points. The reason we have these dots is that list items have bullet points by default. Those bullet points you're seeing come from the list items themselves. Now, inside the list, we target the list items and set the list style type to none to remove those dots. Then we add some padding of 20 pixels, change the font family to cursive to match its parent. Next, let's add a dotted border to the top of each item to create some visual separation between them. Now we need to update the color for both the text and the border. That should make the border color much more distinct now. Now let's move on to styling these buttons. We'll position the check and trash icons on the right side. To style the buttons, we need to target the trash and check classes. Now, to style the trash icon, we need to target it specifically by using its class. Let's begin by styling the trash icon and setting its color to red. You can see right away that the trash icon is now red. We set the position to absolute so we can move the trash icon to the right side. Now we need to set the parent element's position to relative because we want these icons to be positioned absolute relative to their direct container. We set the right position to 10 pixels to move it over, and setting top to 50% would normally align the top edge of the icon to the middle of its parent. To center it perfectly, we use the transform property with translate y set to -50%. Next, we change the cursor to a pointer so users get a visual cue that these are clickable buttons, and we apply the same styling to the check button, but set its color to green and position it 20 pixels from the right edge. For the check button, we can copy this same code block using the keyboard shortcut and then change the class name to match our check icon. The main difference here is that we set this color to green and position it at 20 pixels instead of 10 so it doesn't overlap with the trash icon. Let's try increasing that to 40 pixels for the right position. That positioning looks good for our buttons. Now let's change the form's background color from pink to yellow. I think the yellow background looks much better. Let's go ahead and change the form's background color from light pink to yellow. The yellow background makes the red and green buttons really stand out nicely. Feel free to choose any color that fits your personal style. Next, we want to style our list items that have the checked class. For the items we've checked off, let's make the text appear lighter with a line through it, and we'll also change the check button to a gray color. To target the checked list items, we first select the list, and then find the list items with the checked class, where we change the text color to a light gray and apply a line through decoration. We will add a text decoration of line through to create a strike-through effect through the middle of the text. Let's try changing that to a darker gray instead. That is a much better visual balance for our list items. We should also update the color for the check button. Next, we target the list items with a checked class, and then specifically target the check icon to change its color to dark gray. That's looking much better now. So now, if we add this checked class to any list item, you can see we get this exact effect. Let me demonstrate this by cutting the checked class from this list item and pasting it onto the next one, which immediately applies the strike-through effect. In the next section, we will implement this exact behavior dynamically using JavaScript when the button is clicked. So clicking this button toggles the effect on and off. When we click the trash icon, we want to delete the entire note. Now that our styling is complete, we will bring our project to life by adding functionality with JavaScript. That concludes our CSS styling, and I will see you in the next section. In the previous section, we completed styling our project with CSS. Now we're ready to bring our project to life by adding interactive features with JavaScript. The very first step is to create a new JavaScript file. To open the File Explorer panel, we'll use the keyboard shortcut Ctrl-Shift-E. Now, in the left sidebar of the Explorer, we can right-click and select New File. Let's give our new file the name index.js. We drag this new JavaScript file into our workspace right after the CSS file. Before we can use our JavaScript file, we need to link it inside our HTML. Now we return to our index.html file and scroll down to the very end of the body section, where we will add a new script tag by simply typing SCs and then selecting the second auto-suggestion, which conveniently includes the source attribute we need. Now we have our script tag, and the src attribute defines where the file is located. Since both our HTML and JavaScript files are in the same folder, for the source URL, we simply need to type index.js. Perfect. Our JavaScript file is now properly linked and ready to use. With our JavaScript file successfully linked, we can now begin implementing functionality. After saving the HTML file, let's switch over to our index.js file. Now we need to access the form element from our HTML using JavaScript. As we discussed earlier, the form element uses a class called form. We can retrieve that form element using the query selector method. We'll create a constant and use document query selector to target the form element by its class. To select an element by its class using the query selector method, we must begin the class name with a dot. We can press Alt+Z to activate word wrap for better code visibility. Since we no longer need the Explorer panel open, let's go ahead and close that as well. Now we are going to add an event listener method to the form. This is where we can capture whatever the user types into the form by using the submit event within our event listener. Now we will attach an event listener to our form element. The add event listener method requires two parameters to function correctly. The first parameter specifies the event we want to listen for, and the second parameter is the function that will execute when that event occurs. The event type we will be listening for is called submit. When the form is submitted, we will trigger a function. Now we need to trigger our to-do list function, which will add whatever is written in the input field to a new list item. Let's open the browser now to see what happens when we submit the form. To see how the form currently behaves, try typing some text into the input field and pressing the Enter key. If you look closely at the icon here, you will notice the page refreshes when we submit, but we actually want to prevent that refresh so the new item gets added without reloading the page. Now let's return to Visual Studio Code, where we can access the event and prevent its default behavior. To prevent the page from refreshing, we will add the preventDefault method. To prevent the page from refreshing, we call event.preventDefault with parentheses. This method effectively stops the page from refreshing. Let's test this in the browser by typing a task and pressing Enter. You'll notice the page no longer refreshes. Now let's head back to our Visual Studio Code editor. Next, we'll call the function we just created, which we'll name ToDoList. Let's make sure we use camel case for this function name as we created here. Now, we will define the ToDoList function to gather information from our form. Next, we need to capture whatever value the user types into the input field. To capture that input value, we need to first select the input element within our JavaScript code. Since our input field has a class name of inputs, we can use the same query selector method we just used to retrieve that element. Next, we create a constant called inputElement using document query selector with .input inside the parentheses. To see this in action, we can open the browser's developer console by clicking the hamburger menu and selecting Open DevTools, then navigate to the Console tab. If we try typing something in the input field right now, nothing appears in the console. Now, if we place this console log inside the form submission event handler, for example right here, and then we type something and press Enter, which submits the form, we can see the result. We can see the text we typed into the input field right here in the console. For example, if we type hello and press Enter, we can see hello appear in the console. That means we can retrieve whatever text was typed into the input field by using inputElement.value. Now we will remove that console log statement and work within the function that gets executed here. Now let's create a new function for this task. Next, we will create a variable to hold the new task. we assign the value from our input field to the new task variable. Now that we have captured the input value in our new task variable, we need to create a new list item element to display it. We have been hard coding our list items so far, but we can create them dynamically with JavaScript. We will now create a constant called li_element using the document.createElement method. Now we want to set the text inside that list item, so the li_element.innerText would be the new task. To display this list item in our interface, we must append it as a child element to the unordered list. Now we need to access this unordered list from our JavaScript code. This unordered list element has a class called list. We will retrieve that element in the same way we did before using the query selector method. Now we need to grab that unordered list element by its class name list using the document.querySelector method. Now we will append this newly created list item to our unordered list. Next, we use the appendChild method to add this list item element into our unordered list. Let's test this out by typing something into the input field and pressing enter. You'll see a new list item appear with the exact text we just entered. First, we take the value from the input field and store it in our variable. Then we set the inner text of the list item element to that value and append it to the list. That's working perfectly for adding new tasks. Now let's make sure we clear out the input field after submitting. Once we submit the form, we should clear the input field. Next, we will set the input field value to be empty after submitting. For instance, when we type hello and press enter, we see the new task appear in the list while the input field is cleared because we reset its value to be empty. Now we need to create the check and trash buttons inside each list item. We can create these buttons using the same createElement method. We are going to place each of these icons inside its own separate div element. This will allow us to add click event listeners to these buttons later. Next, we will create a constant for the check button element. We will create this element using the document.createElement method, making it a simple div container to hold our check icon. We can set the inner HTML property of our check button element by using backticks and pasting the icon code we copied earlier. Let's copy the icon code for the check button. Let's copy this icon tag and paste it into our JavaScript code. To make this icon appear inside our list item, we need to append it as a child element. Now, we'll append the check button element as a child to the link element we created earlier. Let's test this by adding a new task like hello, and we should see both the text and the check button appear. Now let's create the trash button using the same approach we just used for the check button. Next, we create the trash button element using document.createElement, and we specify div as the element type because we want it to be a div container. Let's do the same for the trash button by copying the second icon section and pasting it here. Let's test this by adding a new task like hello again. I notice we haven't appended the trash button as a child element yet, so we need to add that line to connect it properly. Let's test it again by typing hello and pressing enter, and now we can see both our text and the icons appearing correctly. Now, let's remove the two hard-coded list items we created earlier so we can focus solely on the items generated by our JavaScript code. Let's return to our JavaScript file now. Next, we need to add an event listener to the check button. When we click on the check icon, we will add the checked class to apply the strike-through and change the item's color. We have already styled these elements with CSS, and now we simply need to add the checked class. Next, we'll add an event listener to the check button element. For the click event, we want to trigger a function that adds the checked class to the list item. We will now target the list item element's class list property. We use the toggle method so a single click adds the checked class and another click removes it. Let's test this by typing hello again, and we can see it appears here. When we click on this checkmark icon, the checked class gets added to the list item. This action toggles the class and updates the styling. When we click the check icon again, the styling returns to normal since we removed that class. Let's test this functionality directly in the browser. We can observe the classes being added and removed in real time. Now let's head over to the browser and add a task. Then open the developer tools by pressing Ctrl-Shift-C. Looking at the form section in our list now, you can see the new item we just added. We can see the text says hello and there are two div elements. Let's open up this first div to see that it contains the check icon. When we click on the check icon, the class checked is added to the list item. And if we click on that same button again, we remove the checked class from the list item. Perfect. That functionality is working exactly as expected. Let's return to our code editor in Visual Studio Code. Now let's add functionality so that when we click on the trash icon, we completely remove this task from our list. Next, we add an event listener to the trash button element for a click event, and within that, we simply call the function to remove the list item element. We simply call the remove method on the list item. Let's test this out in the browser to see if it works. Let's test this by adding a couple of tasks, and you'll see that clicking the check button still works. And also clicking the trash icon will successfully remove any task. That's working exactly as we intended. As you can see, we have a problem where any task we add will disappear if we refresh the page, because we haven't stored that information anywhere. The issue is that our data is not being saved. The important thing to note is that we aren't using a traditional database. For this project, I want to use the browser's local storage to save our data. For this project, we will use the browser's local storage to save our information. You can find the local storage in your browser's developer tools under the Application tab, where you'll see our website's URL listed. As you can see, the local storage is currently empty, and our goal is to save our to-do items there. To store our tasks, we will create a function called update local storage. Now we are going to create a new function that will check all the list item elements. First, we create a constant for all the list items by using document query selector all to select every li element and store them in a variable. We will start by creating a variable named lists as an empty array and then loop through each list item with the for each method. This means we will trigger the function once for every single element in our list. We loop through each list item using for each, and for every single task, we create an object that gets added to our main list array. The first property we'll store is the task's name. We also need to save if the item is checked or not. To check whether the task is marked as completed, we test if the list item contains the checked class, which will give us a true or false value. This check property will be true if the element has the checked class and false if it does not. Once we have this variable ready, we can save it to the local storage. Next, we will store this data using the local storage set item method. First, we need to set the name of the variable we want to store in local storage, which we will call list. Since local storage can only save strings, we must convert our array into a string using the JSON stringify method, and we simply pass in our list variable. Next, we need to call this function from within our to-do list function. Next, we need to call the update local storage function. Let's test this by typing hello and seeing that a new key called list appears in the storage section. As you can see, this entry has two parameters. You can see the first item has the name hello and the checked status is set to false. However, if we check an item, the local storage doesn't update because we haven't called the update function within our event listener. We should also update the local storage whenever we check an item or remove a task. Let's add a few sample tasks and observe them appearing in our list. Now if we mark the first task as completed, you can see its checked status changes to true in the storage. Notice how the checked status has now changed from false to true. Let's go ahead and click the trash icon to remove it. As you can see, when we remove an item, it also disappears from our storage. We have now successfully stored our task data in local storage. However, you might notice that when we refresh the page, our tasks disappear because we haven't yet used the stored data to rebuild the list. The problem is that we stored the data but never retrieved it. Now we need to initialize our list variable at the very top, before the form event listener, so we can call it and retrieve the data from local storage. Next, we need to retrieve our stored data by accessing the local storage. Now we need to use the local storage method again, but this time we'll use getItem to retrieve the data instead of setItem, which we used to create the storage item. To retrieve our stored data, we should use the getItem method. The specific key we want to retrieve from storage is called list. The problem is that this method returns a string, which we cannot directly use to build our list. To use this data effectively, we need to convert it from a string back into an array. To convert this string back into an array, we use the JSON parse method. What we need to do now is cut this line and place it inside the parentheses here. Now let's check our progress by using console log to display the list, and if we look in the console section, we can see that we are successfully retrieving the array that exists in our local storage, which confirms it's properly stored as an array rather than a string. For example, if we remove the JSON parse method right here, you can see we get back a string instead of an array. By using JSON parse, we successfully convert that string back into a usable array. Now that our list variable holds the complete array of tasks, we need to loop through each one using the forEach method. Now for each task in our stored data, we want to pass it into our to-do list function. To make this work, we need to call the to-do list function for each task and pass the task data into it. Now you can see we are retrieving both tasks from storage, but the actual content is missing because we haven't implemented the code to extract the task name and checked status yet. After retrieving the task from storage, we assign the task's name to our new task variable. Let's head back over to the Application tab again. As we can observe in the console, the name appears as undefined. Let us delete these existing tasks and create a fresh one. You can see the result displayed in your browser right now. Now, if we refresh the page, you can see that our Hello task remains in place because we are retrieving it from the local storage. Let's add a few more items to our list. Even when we delete these items and refresh the page, we can see that the same information is still there. However, if we check an item and refresh the page, you'll notice it becomes unchecked because we haven't yet incorporated the check status into our storage logic. Now we need to add an additional condition to check if the task is marked as completed. To complete this condition, we need to add the double ampersand symbol. This condition ensures that both values are set to true. Now we need to perform this step after we've created the list item because we need to reference that specific element. After creating the list item, we need to add the checked class to it if the task was previously marked as complete. Perfect. Now let's add the class for checked items. This demonstrates that our checked state is now persisting through page refreshes, and we can also delete items and add new ones like buy something to see the complete functionality working together. As you can see, our application is now fully functional. We can check items off the list, see the visual changes, delete tasks directly, and add new ones. That wraps up our interactive to-do list project. I hope you found this project enjoyable and educational. This was a substantial project, but learning to build a to-do list is incredibly valuable for any student as it covers so many fundamental concepts. I genuinely hope you had fun and learned a lot from building this project. Thank you for following along, and I will see you in our next project. Welcome back to our tutorial series. We are starting a brand new project today. We are building an age calculator for this project. It will determine your exact age from your birth date. Looking at our final project preview, you can see a container box. Inside this box, we have a title that says Age Calculator. Directly beneath the title, there is a date input field. For example, you can click right on this field. This action opens a date picker where you select your birth date. I will select a date from the year 2002 for this demonstration. Let us use that as our example birthday. When you click the Calculate Age button, the application determines your current age based on the date you selected. It then displays the result clearly, for instance, showing that your age is 21 years old. Our next step is to create the structure of the page using HTML. After that, we will style everything with CSS to achieve a modern and clean design. We will then use JavaScript to make everything come alive. The script will take the date the user enters. It will instantly calculate and display their exact age. That wraps up our overview of the final project. We will now move on to creating the structure for our age calculator. Join me in the next section to start building the HTML. Welcome to our age calculator project. We will build this application completely from scratch. In this section, we will focus on building the HTML structure for our project. We will create all the necessary elements for the age calculator web page. This includes setting up the visual parts you see on the screen. We will also add the input fields for the user. These are the core components people will directly interact with on the website. I have placed the final version of our project right here for you to see. This allows you to compare your own work against the completed example at every single step, giving you a clear target to aim for as we build it together. The very first step in our project is creating a new folder on your computer. This folder will hold all of our project files to keep everything organized. In my case, I prefer to create this folder on my desktop, but you can choose any location on your computer that is convenient for you. Now we will go ahead and create a brand new folder to hold all of the files related to this project. I'm going to name the folder after our project, calling it Age Calculator, so it's clear and easy to find later. Once you have created this folder, you can open it directly in Visual Studio Code. Just right-click on the folder you just made. From the context menu that appears, select the Open with Code option. This will launch the editor with your project folder already loaded and ready. We can go ahead and close the Welcome tab inside Visual Studio Code. You will notice the Age Calculator folder is now the active workspace for our project. Let's create our first file in two simple ways. You can click the New File icon at the top of the Explorer panel. Another method is to right-click on the empty space in the Explorer area. This action will open a menu where you can select the New File option. We will give this essential file the name index.html. This gives us a completely empty file where we can begin writing the HTML structure for our project. To quickly create the basic HTML5 structure, we can type a single exclamation mark. After typing the exclamation mark, just press the Tab key on your keyboard. This action will automatically generate the entire boilerplate code for you. Now we have our document type declaration. This line tells the browser exactly which version of HTML we are writing our page in. Since we are working with HTML5, we only need to specify the word HTML in this declaration. Next, we have the HTML tag. This tag includes a language attribute. We set this attribute to English. This tells the browser the primary language for all the text on our page. Next, we have the heads section. This area contains metadata tags and a title tag. These elements provide important information about our web page. Our first meta tag sets the character encoding for the web page. HTML5 specifically recommends using UTF-8 for this purpose. UTF-8 is the global standard because it covers nearly every character and symbol from all writing systems around the world. This comprehensive coverage guarantees all users can see the text on our site correctly. It prevents any problems with displaying special characters. Next up is the compatibility tag. This tag specifically handles older Internet Explorer browsers. It instructs them to use their most recent rendering engine. This ensures the website displays properly for all users. Next up is the viewport meta tag. This tag instructs the browser to adjust the website's width. It ensures the site's width matches the screen width of your specific device. This viewport setting makes the website display correctly on different devices. It adjusts the layout to fit perfectly on a mobile phone's smaller screen. It also scales things appropriately for a larger desktop monitor. The initial scale setting controls the starting zoom level for the page. It is set to 100% by default. This means the website loads at its normal size without any automatic zoom. Next, we have the title tag for our web page. Right now, it just says Document as a placeholder. We will change this to match our project name. To preview our project in real time, we can use the Live Server extension in Visual Studio Code to see our changes instantly. If you have not installed this extension yet, you need to open the Extensions panel first. You can do this by pressing Ctrl+Shift+X on your keyboard. Then you can search for Live Server in the Marketplace. This particular extension is essential for our Age Calculator project. You should install this Live Server extension right now. Once you find the Live Server extension, click the Install button. I already have this extension installed on my system. It is ready to use right away. With the extension installed, we can click the Go Live button. This action opens our project in the default web browser. We can then see our web page appear instantly. To launch the website in your browser, you simply click the Go Live button here. This action opens your project directly in the web browser. I suggest you place your web browser window on one side of your screen. You should place your Visual Studio Code editor on the other side. This arrangement allows you to see your code changes appear instantly in the browser as you type. Currently, you can see the page title in the Browser tab. It currently displays the default text, which is the word document. Let's update the title of our page to Age Calculator. This clearly reflects the purpose of our project for anyone who visits the website. You can see the title updating instantly. This happens because I have autosave enabled in my editor. Every time I type something new, the autosave feature kicks in. This ensures the file is instantly updated. Then, the change appears live in the browser right away. Next, we move into the body section of our page. We are going to add a main container here. In the final version of our project, you can see a container element. This container has a clean white background. The main page body behind it is a soft gray color. To create this container, we will add a div element. We will assign it a class name of container. Simply type the word dot followed by container. This action prompts the editor to suggest a div element with the class of container. You can accept this suggestion by pressing either the Tab key or the Enter key on your keyboard. Next, we add a heading for our calculator. We use a heading 1 tag for this purpose. We will write the text as Age Calculator. Next, we will create a form container. Inside this container, we will add a label. The label will instruct the user to enter their date of birth. Following the label, we will add an input field. Finally, we will include a button. We are going to add a label for the birthday input field. This label will display the text asking the user to enter their date of birth. Next, we will add the input field for the date. This input field will have a specific type set to date. When you click on this field, a date picker will appear. You can easily select your birth date from the calendar. This input element uses a special date type. We will assign it an ID called birthday. This ID will be important for connecting our form to the JavaScript later. We will also add a name attribute to this input field. We will set this name attribute to birthdays. Perfect. Let's add our input element to the form now. For now, we can hard-code a placeholder text such as "Your age is 21 years old" to test the layout visually. For demonstration purposes, we have temporarily written a static age. We have hard-coded the text to read, "Your age is 21 years old." That gives us a good placeholder for our results. Right now, we have hard-coded the age display for demonstration purposes. In the next section, we will use JavaScript to calculate the user's actual age based on their birthday. We will also style the entire project to match the final version. This styling will center the container on the page and add a hover effect to the button. We will also stack the elements vertically as shown in the example. That wraps up everything for the HTML portion of our age calculator. Now we will move on to the styling. In the next section, we will build the CSS for our project. In our previous section, we successfully built the HTML foundation for our project. In this section of the tutorial, we will style our project using CSS. We will apply the visual design to make it look like the final version. Our goal in this section is to design the project. We will make it look exactly like the final version. Our next step is to create the main container for our content. We will then center this container on the page for a balanced layout. Our first step in this process is to create a brand new CSS file. This file will hold all of our styling instructions. I will open the File Explorer panel using the keyboard shortcut, Ctrl-Shift-E. We can create a new file in this panel and name it style.css. To make our styles take effect, we must connect our CSS file to the HTML. We do this by placing a special link inside the head section of our HTML document. To do this, we will navigate into the head section of our HTML and place the link there. For example, I place this code at the end of the head section right after the title tag. I simply type out the word link into my editor. I then select the third auto-suggestion from the list that appears. This specific suggestion is the one designated for linking a CSS style sheet. That selection automatically generates a complete link tag for me. This tag establishes the relationship between the HTML document and the external CSS file. It also sets the address for the CSS file to style.css within the href attribute. Now we are ready to begin styling our project. We will use our new CSS file to add the design. Let's begin by styling the body section of our page. We start by removing the default margin from the body. This eliminates any unwanted space around the edges. We will set the margin value to 0. This removes all default spacing around the body. This step removes the default margin that browsers automatically add. Next, we will add a padding of 20 pixels to the body. This creates some breathing room and space around the edges of our page. Let's update the font family for the body. We will set it to a sans serif font like Montserrat. We should place this font name in double quotes. This ensures a modern and clean look for our text. We need to wrap the font name in double quotes. If the system cannot find this specific font, it will use a generic sans serif font as a backup. Let's change the background color for the body. We will set it to a light gray shade. Let's change the background color to a light gray shade. We will use the hex code F7FR7FR7 for this. The body section is now fully styled. We have set the margin, padding, font, and background color. Now let us begin styling our container element. This is the div element that has a class of container. Now I will write .container to target our container class. I want to change its background color to white. You can write the color as the word white. Alternatively, you can use the hexadecimal code FF. Let's add a box shadow to our container. We will start with 0 offset for both the X and Y directions. Next, we will set the blur radius. Initially, I considered 20 pixels, but I believe 10 pixels would look much nicer. For the shadow color, we can use RGBA values. RGBA stands for red, green, blue, and alpha. We will set the red, green, and blue values all to 0 for a black color. For the alpha channel, which controls transparency, we will use 0.2. This gives us 20% transparency for a subtle shadow effect. Now we can see the box shadow effect applied to our container. Let's add some padding of 20 pixels to create comfortable space inside the container. Let's adjust the browser zoom level to see the actual size of our project. If we open the preview now, we can observe its current appearance. You can now see the container has taken on its full size. Next, I will set the maximum width for our container to be 600 pixels. This controls how wide it can become on larger screens. To perfectly center the container on the page, we will set its top and bottom margins to 0. Then we set the left and right margins to auto, which handles the horizontal centering. You can see it is now centered nicely. Even on smaller screens, we still have some breathing room around the container. This space comes from the 20 pixels of padding we previously applied to the body element. The container styling is now fully complete. It has a clean white background with a subtle shadow. We have centered it on the page and added rounded corners. Let us also add a border radius to the container. This will give the container's corners a nice, soft, rounded appearance. We will now add a border radius of 5 pixels. This will give the container those nice, rounded corners we want. Next up, we will style the main heading of our page. This heading is the H1 tag that displays the text, Age Calculators. Let's style the heading by targeting the H1 selector. Let's make the heading stand out more. We will increase the font size to 36 pixels. This creates a much stronger visual presence. The heading now stands out with a much larger font size. This increased prominence makes it far easier to read at a glance. To perfectly center the heading, we apply the Text Align Center property. Next, we remove any top margin by setting it to 0. We also add a bottom margin of 20 pixels to create space below the heading. Our heading styling is now complete. The H1 element has been fully styled. Let's move on to styling the form section. We will target this part using its form class. We will now target the form section for styling. We can select it by using its class name. We are going to change the display property to flex. This will initially place all the form elements side by side. Next, we change the flex direction to column. This stacks the elements vertically on top of each other. Finally, we use align item center to horizontally align everything to the center. Next, we will focus on styling the label element. We can target the label directly in our style sheet. We target the label element next in our CSS file. We make the font weight bold for emphasis. We also add a margin to the bottom of the label. This margin creates space below the label. A value of 10 pixels works well for this spacing. The label is now styled to our preference. Let us turn our attention to the input field. We will apply several styles to make it visually appealing. To style our input field, we can simply use the input selector. Let's begin by adding some padding. We will set the padding to 8 pixels. This padding creates some comfortable space around the input field. Let's style the border for our input field. We will use a simple 1-pixel solid line. This border style is clean and functional. This creates a solid line border for a clean look. We will use the color CCC for this border. This color code gives us a pleasant light gray shade. Let's add a border radius of 5 pixels to create nice rounded corners. We will set the width to 100% so it fills the available space. We can also set a maximum width of 300 pixels. This means the input field will expand up to that point but will not get any wider. This ensures the input field takes up the full available width on smaller screens. It will not exceed a maximum width of 300 pixels on larger screens. If the available space is larger than that, the maximum width will be fixed at 300 pixels. These settings give our input field a clean and functional look. They provide a good balance of padding, border, and width constraints. Our input field now looks great with its styling. We can move on to the button element. We will apply some styles to the button next. It appears we forgot to add a button in our previous step. We missed the button in our form. We need to add a button element right after this input field. Now we are going to add a button to our form. This button will allow the user to submit their information. We will add a button with the text "Calculate Age" on it. This button will be used to trigger the age calculation. Let's begin styling our button by targeting the button element in our CSS file. We need to select a background color for our button element. We will add this color property in the next step. Let's give our button a pleasant blue background color. We will use the hex code 007BFF for this. Let's change the text color to white. This will make the button text much easier to read against the new background. We will also remove the button's border entirely. We remove the border entirely by setting it to none. Next, we add some internal space with padding. We use 10 pixels of padding on the top and bottom. For the left and right sides, we use 20 pixels of padding. Let's give the button some rounded corners. We'll set the border radius to 5 pixels. This gives our button those nice rounded corners. Let's add a top margin of 10 pixels to create some space. We will also set the cursor to a pointer. This will change the mouse cursor when hovering over the button. When your mouse cursor hovers over the button, it will change into a hand. This clear visual change indicates the button is clickable and interactive. Let's make the button respond when a user hovers over it. We can achieve this effect using a special hover pseudo class. This will let us change the button's appearance as soon as the mouse pointer touches it. Let's change the background color when a user hovers over the button. This provides a clear visual cue that the element is interactive. For example, we will change the background to a darker blue shade. This creates a nice visual change when you hover over the button. We can also add a smooth transition for the color change. This transition will take about 0.3 of a second. For example, I want to add a transition effect for the background color. This transition will last for 0.3 seconds. It uses an ease function for a smoother visual change. You will see the color shift happen gradually and smoothly. We are now going to style the final element. This is the paragraph that will display the calculated age. We can target it using its unique ID of results. To target the results section, we use its unique ID. We then apply a top margin of 20 pixels to this element. We set the font size to 24 pixels. We also make the font weight bold for better visibility. This provides a clear and prominent result. That should cover everything we need for styling the result paragraph. The styling for this element is now complete. Our project styling is now complete. Let us adjust the container's position for better visual spacing. We will add a top margin to move the entire container down a bit on the page. Let's add a margin of 50 pixels to the top of the container. This will push the entire calculator down from the top of the page. Here is the final result of our styled age calculator. You can see our complete design with all the visual elements in place. As you can see at the top, we have our title nicely styled. The input field and button have also received their full design. The result section is now styled and ready as well. In our upcoming section, we will work with JavaScript to bring our project to life. We will retrieve the birth date information from the input field. We will then perform a calculation to determine the user's age. Finally, we will display the calculated age inside the designated results area. In the next section, we will add the JavaScript functionality. We will make the calculator work by dynamically reading the input data. Then we will calculate the user's age and display the final result. We have just finished working on the CSS portion of our project in the previous section. In this section, we will build the JavaScript functionality for our project. We will write code that calculates a person's age based on the birthday they enter into the input field. Our first step involves creating a new JavaScript file. This file will contain all our logic. Let's head back over to Visual Studio Code now. Let me open up the Explorer section. I will do this by pressing the Ctrl, Shift, and E keys together. Let's create a new file in this directory. We will name this file index.js. After creating the file, we need to connect it to our main web page. I'm going to close the style CSS file now. This will help us focus on the JavaScript code. Next, we will connect our new JavaScript file to the main web page. We do this by adding a special script tag inside the index.html file. This tag should be placed at the very end of the body section. This ensures that all the page content loads before the JavaScript runs. We start typing the letters SC to accept the script tag suggestion from the editor. We then set the source attribute to index.js. This address works perfectly because both our files are located in the same directory. We only need to use the simple file name for the source. We put the script tag at the very end of the body for an important reason. We need all the HTML elements to be fully loaded by the browser first. This ensures our JavaScript code can successfully find and interact with those elements. If we load the script earlier, those elements would not yet exist on the page. Our first step is to set up an event listener for the Calculate Age button. We want the application to respond when a user clicks on it. Let's focus our attention on this specific button. Our next step involves targeting this specific button with our code. We need to create a reference to it in our JavaScript file. To bring the button into our JavaScript, we need to target it in the document. We will add an ID to the button element. We can call this ID btn. Then we will create a constant variable for the button element. This constant will be named btn element. We set this variable to target the document object. We use the getElementById method to find our button. We pass the ID name btn to this method. This allows us to access the button in our JavaScript code. Now that we have access to the button element, we can add an event listener to it. We use the addEventListener method for this purpose. We attach an event listener to our button element. We set this listener to wait specifically for a click event. When a user clicks the button, it will trigger our custom function to run. We will call the CalculateAge function. Then we will define that function right after this line. Let's create our function now. We will call this function CalculateAge. For this initial test, I will add a simple console log to confirm our button click is working. We will log the word clicked to the browser's console. Let's move our website over to the right side of the screen. We will open the browser's developer console by pressing the F12 key. I will clear any existing messages from the console log. Now, we can click the Calculate Age button to test our function. You can see that our console log is working correctly. The word clicked appears in the console every time we press the button. Now we are moving beyond simple console messages. Our next goal is to compute the user's actual age using the birthday information they provided. We need to retrieve the data entered by the user into the birthday input field. This is our first step to begin the calculation process. The input field we are using has an ID called birthday. We can select this element in our JavaScript code using a similar method to what we just did for the button. Let me duplicate this line of code. I will use the keyboard shortcut Alt+Shift plus the down arrow key. This action will create a copy of the line directly below it. I need to change the ID from btn to birthday. I will select both instances using the keyboard shortcut Ctrl-D. I will select both of these instances with my cursor. I am going to change the text to say birthday. We are assigning the element with the ID of birthday to a constant variable named birthday element. This constant now gives us direct access to the birthday input field. We have successfully stored the input element in a variable. This gives us full access to its properties and methods. First, we need to get the value from the birthday input field. We can do this by accessing the value property of our birthday element. Let us check what information we have captured from the input field. We will now print this value to the console for verification. Let me change the input value to the 4th of April, 2023. When I click the Calculate Age button, the console logs the value we just entered. Let's try selecting a different date, such as January 13th, 2006. You will see that the new date is printed in the console. This happens because our code is logging the value. We have successfully retrieved the input value. We need to check if the user has entered any information. If the birthday value is an empty string, we will display an alert. This alert will ask the user to please enter their birthday. Currently, the input field is completely empty. When I click the Calculate Age button now, an alert message appears. This alert tells the user to please enter their birthday. This validation step prevents any calculations from running with empty input. It ensures we only proceed when we have actual data to work with. Otherwise, if a birthday value has been entered, we will proceed to calculate the age. We will store the result by calling a function named getAge. We will pass the birthday value into this function to perform the calculation. Next, we will create the function that handles the calculation. We will write the function that calculates the age. This function will take the birthday value as its input. The first step involves getting today's date from your system. We need this current date to perform the calculation. We will subtract the user's birth date from this current date to find their age. To get today's date, we will create a new date object. This object will automatically pull the current date and time from your browser. This date object is a built-in constructor method provided by JavaScript. It allows us to create new instances that represent specific moments in time. This constructor method pulls the current date directly from your browser. Let us check what the current date is by logging it to the console. I will remove the previous log statement first. Let me enter a date and click the Calculate Age button. You can see we are getting the current date from the browser. This gives us a full timestamp, like the 6th of April 2023 at 11 o'clock. Our next step is to use this current date for the calculation. For example, if we want to get just the year from the current date, we can use the method called getFullYear. Let us choose a date first to avoid any errors. We will clear the console and then click the Calculate Age button. We can see the result of 2023 printed in the console. We can use that exact same approach to retrieve the year from the birthday value. This method will work perfectly for our calculation. Let us attempt to console log the birthday value using the getFullYear method. We choose a date and click Calculate Age without getting an error. We must remember this value is a string and not a date object yet. We need to create a new date object by passing the birthday value into the constructor. This conversion is essential for using date methods properly. To get the year from the birthday, we need to create a new date object from the input value. We can then call the getFullYear method on that new date object. Let us test this process to see the result. We can see that the console now displays the year 2023. This output comes from the birthday value we just entered. Let us test this with a different year. For example, imagine the user was born in 1985. Now we can click on the Calculate Age button. The result shows the birth year we entered. We have the current year from the current date object. We also have the year from the user's birthday date. We can now calculate the person's actual age. We do this by subtracting their birth year from the current year. We calculate the age by subtracting the birth year from the current year. We get the current year from the current date object. We also get the year from the birthday date object. That makes sense because we have successfully subtracted the years. Let's test our calculation by logging the age to the console. For this example, I will enter the year 1975. You can see the console now shows an age of 48 years old. This current calculation for age is not always entirely accurate. The issue involves how we account for the months and days. For example, I am recording this video in April of 2023. The person born before April would be considered 1 year older. Someone born after April would be younger by a year. We need to account for the months as well in our calculation. This is important because a person's birthday might occur later in the current year. If their birthday has not yet passed this year, we must subtract 1 from the calculated age. If the person's birthday falls later in the current year than today's date, we need to subtract 1 year from the calculated age. This adjustment ensures the age is not overestimated. We need to adjust the age calculation by subtracting 1 year in certain cases. This adjustment is necessary when the person's birthday has not yet occurred in the current year. Now we need to account for the months as well. Next, I will create a constant variable to store the months. This variable will be named months. We can simply copy this same line of code. We will replace the getFullYear method with another method called getMonths. We now have access to the month values from both dates. This will allow us to compare them for a more accurate calculation. We are going to set up a conditional check at this point. This check is necessary to handle different date scenarios. We need to check if the month difference is a negative number. This situation occurs when the current month comes before the birthday month in the calendar year. Alternatively, if the month difference is 0, we have to check the days. This means the person's birthday month is the same as the current month. After this condition, we check for the day of the month. We compare the current day with the birthday day. We use the getDate method for this comparison. We check if the current day is less than the birthday day. We need to account for 2 specific situations where the calculated age needs to be adjusted. If the current month is earlier in the year than the birth month, the person has not had their birthday yet. We also need to check the day of the month if the months are the same. If the current day is earlier than the birthday, we also subtract 1 from the age. To decrease the age by 1 in this situation, we can use the decrement operator. We simply write age minus minus. For instance, if our calculated age is 24, using the double minus operator will decrease that value. This operation will change the final result to 23 years old. This approach will solve our problem with the date calculation. After this adjustment, the function will return the calculated age. We will return the calculated age value from this function. This return value is what the main function will use. This function returns the calculated age as its output. We then receive that age value here inside our main calculate age function. Let's take that calculated age and log it to the console to see the result. Let's test our calculation with a specific example. We will choose a date and see the result. Let us test this with a specific example. We will choose the year 2022. Let's pick January 6th of 2012 as our example. The calculation shows the person is 11 years old. This result is now displayed correctly in our application. However, if the birthday is in a month after April, for example May, we get a different result. Let's run a test to see if our calculation is correct and identify any issues. We want to change the age value later in our code. Using a constant variable prevents us from doing that. We cannot use a constant variable in this case. We should use the let keyword instead. Let's change the age variable from a constant to a let so we can update it. Let us test this functionality once more to ensure everything is working correctly. Let us test this with a birth year of 2012. We tested January 6, 2012 as the input. This date correctly calculated an age of 11 years old. Let us test a birthday that occurs after the current month. For instance, if we select a date in October, the result is 10 years old. This person would be 1 year younger. That is because their birthday falls after the current date in the calendar year. Our calculation is now working correctly and providing the accurate age. Now we need to display the calculated age to the user on the web page. It should appear right here in the result area instead of just being logged to the console. We need to retrieve the element from our web page that will display the result. This will let us show the calculated age to the user directly on the page. We need to target the paragraph element where we will display the result. This paragraph has been assigned the specific ID of result. We need to locate that specific paragraph element on the page. We can do this by using its unique identifier. We create a constant variable called result. This variable will store a reference to our result paragraph. We use the document method getElementById to locate this specific element. We pass in the string of result as the element identifier. We will update the text content of our result element. This is how we display the calculated age to the user. We will set the inner text of the result element. We will create a dynamic message that says your age. The backtick character is located on your keyboard. You can find it above the tab key. We are going to create the text for the result display. We start by writing the phrase, your age is. We then use a $sign and curly braces to insert the age variable. After that, we need to check if the age is exactly 1. If it is, we use the word year. If the age is any other number, we use the word years instead. This ensures the sentence is grammatically correct for every age. Let me add a quick condition here to handle the grammar properly. Next, we need to handle the grammar for the final output. We check if the calculated age is greater than 1. If it is, we use the word years. Otherwise, we use the singular form year. We then append the word old to complete the sentence. For example, if someone was born in February of last year, the calculation would show their age as 1 year old. For a person born much earlier, like in January 1990, your calculated age would be 33 years old. We have successfully implemented the age calculation feature with JavaScript. This marks the completion of our project's core functionality. Let us take a moment to review the steps we have completed. We have successfully implemented the core functionality for our age calculator. We've obtained the necessary elements from our web page. We accomplished this using the JavaScript method called getElementById. We have set up an event listener for the calculate button. This allows our code to react when a user clicks on it. When someone clicks the button, it triggers the calculate age function. Inside this function, we retrieve the birthday information. We get this value by accessing the birthday element's value property. If the birthday field is left empty, we will display an alert message. This message will ask the user to please enter their birthday. Otherwise, we will call another function named getAge. We will pass the birthday value into this function. This function will calculate the person's age. It does this by comparing the current date with the provided birthday. To calculate the exact age, we have a special condition. This condition checks if the person's birth month is before the current month. It also checks if the current month is the same as the birth month. If the current day of the month is before the person's birthday, we also adjust the age. In any of these cases, we subtract 1 from the calculated age. This gives us the final, correct age to return. We will then insert this calculated text into the result element using the inner text property. We also implemented a conditional check to ensure the final sentence is grammatically correct. That completes our JavaScript age calculator project. We have successfully built a functional application from start to finish. I truly hope you enjoyed building this project with me. I hope you gained valuable knowledge and practical skills from our work together. I am excited to see you in our next project, where we will learn even more together. Welcome back to another exciting web development project. We are building something really fun today. In this project, we will build a web application. This application will be an anime pics generator. Here on the screen, you can see the final project in action. We have a prominent button right here. When you click the button, our application will call a special web service. This service provides a random anime image along with its title. Every time we click the Get Anime button, a loading effect appears first. After a moment, a brand new image loads onto the screen. This is a completely random picture along with the anime's title. You will learn how to work with an API for this project. We will fetch data from the API using a try and catch method for error handling. You will also learn to add a loading effect. This effect displays before the data appears in your browser. We will also explore how to create this entire user interface with CSS. You will learn to craft the beautiful background color and all the visual design elements. Let us start by setting up the project's foundation. We will begin with the HTML structure in the next section. I will meet you in the next section for the HTML setup. Alright everyone, let's get our project started now. I have placed the final version of our project right here. You can use it as a visual reference throughout our tutorial. You can see we have a container here. It contains a button and a title. The title says, Anime Pics Generator. When you click this button, it will fetch data from our API. This data includes an anime image and its corresponding title. Both the image and the name will then be displayed on the screen. Let us begin by creating the HTML structure for our project. This is the foundational part of our web page. I am opening Visual Studio Code for this project. You can use any text editor you prefer for following along. I will create a completely new project window. I am closing the current window we have open. I close the Get Started tab. Then I click on the File menu. From there, I select the Open Folder option. This allows us to create a new folder and then choose it for our project. I will create this new folder directly on my desktop. This makes it easy to find later. I am going to navigate to the desktop location. Then I will click on the New Folder button. This action will let me create a brand new folder. I name the folder for our project Anime Pics Generator. I press the Enter key to create it. I notice I missed the letter A in the word generator when naming the folder. Let me correct that spelling right now. Once we press the Enter key, the new folder will be created. With the folder created, we can now click on the Select Folder button. This action will choose our newly made project directory. This action will open our new folder right here in the editor. Inside the Explorer section on the left, we can begin adding our project files. We will place all our files into the folder we just created. Let's close that Get Started tab once more. On the left side, find the Explorer section. Click on the New File icon to create a file. We will name this file index.html. Press Enter to confirm the file name. The new file has been created and opens on the right side. The editor is completely empty right now. We can generate a starting template by simply typing an exclamation mark. When we click on the suggested boilerplate option, it automatically generates the foundational HTML structure for us. This structure includes the document type declaration at the top. This declaration specifies the type and version of HTML we are using for our page. For the HTML5 standard, we only need to write the word HTML. This simple declaration is all that is required. The HTML tag is the main container for everything on the page. This tag contains two essential sections, the head and the body. The head holds behind-the-scenes information for the browser. The body contains all the visible content that users will see. This lang attribute defines the language of the web page. It helps browsers and search engines understand the content's language. For our project, we have set the language to English. You can choose any language you want for your own website. Inside the head tag, we find several important elements. These include metadata tags for various purposes. We also have the title tag for the page. The first metadata tag defines our character set. This char set is set to UTF-8, which is the modern standard recommended by HTML5. This character set includes nearly every character and symbol you can imagine. It ensures users from all over the world can view our website correctly. Next, we have another important meta tag for compatibility. This tag specifically instructs Internet Explorer to use its most modern rendering engine. The engine it uses is called Edge. This specific compatibility tag exists for a reason. It ensures users on older Internet Explorer browsers get the best possible experience. Next, we have the viewport meta tag. This tag controls how your web page is displayed on different screen sizes. It ensures your content looks good on both mobile devices and desktop computers. This viewport tag controls how wide the content area appears on your screen. It ensures the content's width matches your device's screen width. For instance, the width of your content on a mobile device will be much smaller. This is a significant difference compared to viewing the site on a desktop or laptop computer. The initial scale sets the starting zoom level when the page first loads. We configure this value to be 1.0. This setting represents 100% of the original size. For example, if you set the initial scale to 0.8, that would be a zoom level of 80%. This means the page would appear slightly smaller when it first loads. Next up is the title tag. This displays the title text that appears in the browser's tab. You can see this title right now. Just open your web browser to check it. To help us see the changes in real time, I am using the Live Server extension. When you install this extension, you will notice a Go Live button appear at the very bottom of your screen. When you click this option, it will open the website in your default web browser. I am currently using Chrome as my main browser for this project. You can see the Browser tab currently displays the word Document. This matches the default title text we have in our HTML file. I will position the browser window on the right side of my screen. This allows us to watch our changes update in real time. Let's hide the Explorer panel on the left. We can do this by pressing Ctrl and B on the keyboard. This will give us more space for our code editor. This gives us much more room on the left side of the screen. Now we can see our code more clearly. Let's change the title of our web page next. We want it to display the name of our project. Currently, the title simply says Document. Let's update the title now. We need to change it from Documents to our project name. The new title should be Anime Pix Generators. We can see the Browser tab title has been updated. It now displays our project name. The Live Server extension automatically refreshes the browser view. It performs this update instantly every time you save your file within Visual Studio Code. Let us continue building our HTML structure. We will make our current file match the layout of the final version we saw earlier. Looking at our final version, you can see we have a main container element. This container holds all the different parts of our application together. Let me sketch this out visually for you. You will see the structure clearly. Let me walk you through the layout we are creating. We start with a main container. Inside this container, we have a title for our project. Next, we have a button for users to click. Finally, we have another separate container. The second container will hold the anime image and its name. We are adding this separate container for the anime details. We want this container to be hidden when the page first loads. It will only appear after the user clicks the button. When someone clicks the button, the anime information will appear. This container will then become visible on the screen. Next, we will need an image element. This element will display our anime pictures. Let me draw the structure for you using a different color. This will help us visualize the layout better. We also have an image element. Following that, we will display the anime's title. First, we need to establish this main container structure. We have a main container that holds all the elements on the page. Inside this main container, we have two main components. The first component is our title and button. The second component is another separate container. This inner container is designed to hold both the anime image and its name. Now that we understand the structure we are building, we can proceed with creating the HTML elements. For creating the main container element, we use a div tag. This div serves as our main structural container. The div element is essentially an empty container element by default. It does not have any inherent dimensions on its own. Next, we will place our main container inside the body section. We do this by adding a div element. We assign it a class called container. To create this container, we can simply type a dot followed by the word container. This uses a helpful shortcut feature. Now if we press the Enter key on our keyboard, it will automatically generate a div element for us. This div will have a class named container already applied to it. This shortcut is made possible by using an extension called emit. Next, we need to add an h3 tag for our main title. This title will display the text Anime Pics Generators at the top of our page. Let's copy this exact text from our reference image. We can paste it into our heading tag. Let's proceed with adding the button element next. We will use a simple button tag for this purpose. Now that we have added our heading tag, the title should appear on our website. You can see it says Anime Pics Generator. Now we will add a button element to our project. This button will be responsible for fetching data from the API. Let's create a button element for our project. This button will have a class name of btn. It will also have an ID with the same name, btn. To add a class, we use a dot symbol before the name. For adding an ID, we use a hashtag symbol instead. For the ID attribute, we use a hashtag symbol. This hashtag indicates that we are defining an ID selector. Now when we press the Enter key, we can see our new button appear. This button has both a class and an ID. The class is named btn, and the ID is also named btn. Inside the button element, we will add the text Get Anime. This text will serve as the button's label for users. Let's check our browser window now. We should see the button with the text Get Anime displayed on our web page. Next, we need to create a separate container. This container will hold both the anime image and the name of the character. Next, we create another container div. We will assign it a class name of anime container. Inside this container we just created, we will be placing an image tag. This image element will display the anime artwork we fetch from the API. For the image source, we do not have an alternative text. That is acceptable for our current setup. For the image source, I will perform a quick search online for an anime image. I will choose any suitable result from that search. I will select an image from the internet for this demonstration. For instance, I can use this particular image you see here. Simply right-click on any anime image you find online and select Copy Image Address. Then paste that copied link directly into the source attribute of your image tag. You can now see the anime image appear on the web page. This gives us a visual reference for our project. I am adding this placeholder image for a specific reason. We will use it to style our layout in the next section. We need an image placeholder for our website styling. This placeholder helps us design the layout properly. In the next section, we will use JavaScript to fetch a random image from the API. This will replace our placeholder image with a new one each time. We do not require a permanent placeholder image in our code. The application will fetch images dynamically from the API. We will remove this placeholder image later. We will do this after we finish styling our project. Following the image, we have the name of the anime character or artist. Let's add another heading for the anime name. We will use an h3 tag for this element. This title was originally an h1 tag. We are changing it to an h3 tag instead. Let's change this heading to an h3 tag instead. This heading level will be more appropriate for our design. We do not need such a large heading for this title. A slightly smaller heading will work much better for our design. Next, we will add the name of the anime. We use an h3 tag for this. We also give it a class called anime name. We will write down anime name as a placeholder text for now. This will help us style the element properly. Adding a class to the image is important for our CSS styling. This element will also become dynamic later when we add JavaScript functionality. Next, we need to add a class to our image tag. We will call this class AnimeImg. That wraps up our image element setup perfectly. Our HTML structure is complete and looks correct. We have finished writing the markup for our project. In the next part of our tutorial, we will style the website. We will use CSS to transform our basic HTML structure. Our goal is to create a beautiful user interface for the project. You will see how we achieve the final look from our reference. We've just finished building the HTML structure for our project in the previous section. We put in the title and a button. We also added an image. Finally, we included an anime name tag. This name tag is just a simple heading element. Let us begin by creating our new CSS file. Inside Visual Studio Code, we need to open the File Explorer panel. You can do this by pressing the keyboard shortcut Ctrl-Shift-E. Let's create a new file for our styling. We will name this file style.css. Before we can see our styles take effect, we must connect our new CSS file to the HTML document. Let's go back into our index.html file. Find the title tag and place your cursor right after it. Now, type out the word link. You should see an auto-complete suggestion appear. Select the option that specifically mentions linking a CSS style sheet. Let's begin by styling the body section of our web page. As you can see, the body section has a beautiful background color. This color is actually a gradient that transitions smoothly. We call this effect a linear gradient. You will also notice all the content is perfectly centered on the page. To center everything perfectly, we will use Display Flex. This allows us to use Justify Content Center for horizontal alignment. We will also use Align Items Center for vertical alignment. Let's begin by targeting the body section. We do this by typing the word body. We then open a set of curly braces to contain our styles. The first step involves removing any default spacing. We will set the margin to 0. This eliminates any unwanted space between our content and the browser's edges. Let's change the background color of our page. We set the background property next. We want that gradient color we discussed earlier. It begins with a blue shade on the left. The color then transitions smoothly to yellow on the right. To create that gradient background, we need to use the linear gradient function. This gradient moves from left to right. You write the direction as to right inside the function. After the direction, you add a comma. The first color you specify is light blue. After another comma, the second color you define is yellow. Notice how the background shifts from a light blue on the left. It transitions smoothly across the screen until it becomes a vibrant yellow on the right. Now we will use Flexbox for the layout. This display property allows us to bring all the elements to the center of the page. We change the display property from block to flex. We also need to define a height for the body. Without a set height, we cannot center the elements vertically. We must give the body a height of 100% to achieve this vertical centering. We set the height to 100% of the viewport height. This ensures the height always fills the entire screen. The layout remains consistent regardless of your zoom level. To center everything horizontally, we use Justify Content Center. This pulls all the elements to the middle of the screen from left to right. Then, to center everything vertically, we use Align Items Center. This moves all the content to the middle from top to bottom. Currently, the image is very large, making it difficult to see the centering effect. Once we reduce the image size, you will clearly see that everything becomes perfectly centered both vertically and horizontally. You might remember earlier we gave the image a specific class name. That class name is AnimeImage. We will target the AnimeImage class using .AnimeImage. Let us make the image smaller by adjusting its dimensions. We will change the height to 300 pixels. We will also set the width to 300 pixels. Now we have successfully centered everything on the page. You can see all the elements are aligned both horizontally and vertically. Let's change the font family for the text. I will set it to Courier New, which is a common monospace font. Now let's style the container element. We want to give it a clean and polished appearance. The viewers can see a white container on the screen. This container has a white background color. Our goal is to create this container element. Next, we will style the main container for our content. This container is a division element with the class of container. It wraps around all the other elements on our page. We will now target the container class in our CSS. We do this by typing .container. We want to give the container a white background color. However, a pure white can be a bit harsh on the eyes. I'm using a color called Alice Blue for the background. This color is a very light shade of white. It is not a pure, stark white color. This softer tone is much easier on the eyes. Next, we will add a border radius to the container. This will give it nicely rounded corners with a radius of 10 pixels. This property creates a nice, rounded corner effect on our container. Let's also apply a box shadow to give it some depth. We definitely want to add a box shadow to this container. It gives the design a nice sense of depth. This shadow effect makes the container appear to lift off the page. The box shadow property requires several values to define its appearance. We set the horizontal offset to 0. This means the shadow won't extend to the left or the right side. We then set the vertical offset to 10 pixels. This creates a shadow that appears directly below the container. You can now observe a shadow appearing at the bottom. This shadow extends about 10 pixels downward. It also has a blur effect of 20 pixels for a softer look. You can see the shadow now appears on the left and right sides as well. This effect is created by the blur property of the box shadow. The shadow appears quite dark at the moment. We should adjust it to be a bit lighter. We select a black color using RGBA values. We set the red, green, and blue channels all to 0. For the transparency, we use a value of 0.3. This creates a shadow that is only 30% opaque. This creates a shadow with 30% transparency. It makes the shadow appear softer and more subtle. You can see the shadow looks much better now. It has a nice soft effect with that transparency. To center all the text within the container, we can apply Text Align Center. This moves all the text to the middle. Next, we should add some internal spacing. This creates space between the container's border and the elements inside it. We are adding some internal spacing with a padding of 10 pixels. This creates comfortable breathing room between the container's edge and the content inside. Next, we will define the container's width. We will set this width to 450 pixels for a consistent look. Setting the width to 450 pixels gives us a nice container size for most desktop views. This fixed width remains consistent even on larger screens. Let's check how the container looks on mobile devices. Open the developer tools by pressing Ctrl-Shift-C, then select the mobile view option. You can see on a mobile screen the container touches the edges of the viewport. To prevent this from happening, we can add a small margin around the container. A margin of 5 pixels will create a comfortable space. This margin creates a nice breathing room around the container. It ensures the container does not touch the edges of the screen. This adjustment ensures our container looks great on mobile devices. It prevents the layout from touching the screen edges on smaller screens. Let us move our view back to the main editor panel. We will continue our work from there. We have finished styling the main container for our project. It now has a nice background color and a subtle shadow effect. Let's move on to styling the button next. Next, we need to style our button element. We can specifically target the button using its class selector. Our button has a class applied to it. This class is named btn. To target our button in the style sheet, we use its class name with a dot. We will target the button by using its class name. Then we open a set of curly braces to begin writing our styles. Let us give our button a nice green background color. This will make it stand out visually on the page. We want to change the text color of the button to a light blue shade. This will make the writing on the button easier to read. This button is looking a little small right now. We can make it larger by adding some padding around the text. We will add some padding to create space around the button text. We will add 10 pixels of padding on the top and bottom. For the left and right sides, we will add 30 pixels of padding. We should also increase the font size for better readability. Let's set the text to 16 pixels. Let's create some breathing room between the button and the image. We can add a margin to the bottom of the button to push it away from the picture. Let's add some space below the button. We can do this by setting a bottom margin of 30 pixels. Let's give this button some rounded corners by adding a border radius. This will soften the edges and make it look more modern. Next, we set the border radius to 6 pixels to create rounded corners. Then, we want to change the mouse cursor when hovering over the button. We set the cursor property to pointer to indicate it is clickable. This change ensures the cursor becomes a pointing hand when you move your mouse over the button. You will see the cursor's appearance change from a standard arrow to a hand icon. The cursor changes from a regular arrow to a pointing hand icon. This visual feedback indicates the button is interactive. We have successfully styled the button with all its visual properties. The button's interactive states are now fully defined. Now let's talk about styling the button for its disabled state. When you look at the final project version, you will notice something important. After clicking the button to make a request, it turns gray and becomes disabled. This prevents users from making multiple requests while an image is still loading. You can observe this behavior in the final version. The button becomes gray and disabled until the new image has finished loading. We need to create a specific style for when the button is disabled. This will help users understand the button's state visually. Next, we will style the button for its disabled state. We can target the disabled button directly in our CSS. When the button is disabled, we want to change its background color to gray. We also want to change the mouse cursor. Instead of the pointing hand, we want to show the Not Allowed symbol. Right now, you see the button in its normal enabled state. You could go into the index.html file and manually add the disabled attribute to the button tag. This would let you see how our new disabled styles look. Notice how the button has turned gray. This change indicates it is disabled. The cursor now shows a Not Allowed symbol to confirm you cannot click it. Let's go ahead and remove the disabled attribute from the button for now. We will be adding this disabled state back later using JavaScript to control the button's functionality. For the time being, we will leave the button in its default enabled state. We have finished styling the button with all its visual properties. The button now has a complete appearance and interactive states. Now let's move on to styling the image element. We want to make some visual changes to our image. We have already set the image height and width in our previous styling step. Next, let's make the image perfectly circular. We can achieve this by setting the border radius to 50%. This will curve all the corners completely. This will make the image perfectly rounded. I also want to add a border around the image to give it a nice frame. We will add a border around the image. We set the border width to 3 pixels. We want the border to be a solid line. You can see the solid border appearing clearly now. Right now, we see a black border around the image. Let's change that border color to green instead. That border looks much better in green now. Next, we will focus on styling the anime name tag. We want to make it visually distinct and appealing. Let's recall the class we assigned to the anime name. We used the class anime name. I will copy this class name from the HTML file. Then I will add a dot before it in the CSS file. Finally, I will paste it into the selector to target and style it. We can now target this element specifically in our CSS file. We begin by applying a margin property to create some space around it. We add a margin of 20 pixels around this element. This creates some nice breathing room between the different parts. I want this element to have a background color. It should be the same green color as the button we just styled. Let's set the background color to green for this element. This will make it visually consistent with the button style. Next, we will change the text color to Alice Blue for better readability. We will also add some padding to create space around the text. Initially, we might try 20 pixels of padding. After reviewing, we can adjust that down to 10 pixels for a more balanced look. We will now add a border radius to this element. This will give it nicely rounded corners with a 6-pixel curve. We should increase the text size to 17 pixels for better readability. We have actually made it a bit smaller than before. Next, we will add a font weight of 600 to make the text bolder. This styling gives us a clean and polished look for the text. The font weight makes it appear bold and prominent. The styling is looking really good at this point. We have achieved the visual design we wanted for our project. Next, I want to hide this entire section for now. In the final version of our project, when a user first visits the page, the image and the name will not be visible. These elements will only appear after the button is clicked for the first time. We want to hide that anime container for the moment. We can achieve this by targeting that specific container in our styles. We will target the container with the class name AnimeContainer. Then we will set its display property to none for now. This will completely hide that section from view. This CSS rule will hide the container for now. Later, we will use JavaScript to display the anime container. It will appear dynamically when a user clicks the Get Anime button for the first time. We have now completed all the styling for our project using CSS. The visual design is fully implemented and ready for the next step. Now we will bring our project to life by adding dynamic functionality. We will accomplish this by using JavaScript in our next section. So see the next section for the JavaScript part of the project. We have now finished the CSS portion of our project. We completed the styling work in the previous section. In this section, we will create a new JavaScript file for our project. This step will add more functionality to our application. Looking at the final project, you can see what we are building. When you click the Get Anime button, it fetches data from an API. This process retrieves a new image and a corresponding character name for you. Sometimes, the API does not have the artist name available. In those cases, you will see the word unknown displayed instead. When you click the button, you will notice a loading indicator appears. The text in the name section will change to say updating. The image area will also display a loading animation while it fetches the data. We need to obtain the API endpoint for our project. This API will provide the data we require. Now, let's get into the actual JavaScript functionality. We need to manipulate several elements on the page. We are going to work with 4 specific elements on the page. We need to manipulate these elements using our JavaScript code. First, we have this button element that we need to target. We also need to update the source of the image element. Additionally, we must change the text content for the name. Finally, we need to manage the display property of the main container. Right now, the container is not visible at all because its display property is set to none. Once we have successfully fetched the information from the API, we want to change the display property of this container. We need to make it visible on the page. We want to change the display property for this container. We need to make it visible when we have the information. Let me correct that. This container currently has its display set to none. This container is currently set to display blah. This means it is visible on the page. We need to toggle the display property of our container. Sometimes we need to show it as block. Other times we need to hide it by setting it to none. We will switch between these two states based on whether we have data. Our first step involves creating the JavaScript file for this project. This is a necessary action to proceed with the coding. Let us open the Explorer section by pressing the keyboard shortcut Ctrl, Shift, and E. We will create a new file in the Explorer section. We will place this new file on the left side panel. We will name this new file index.js. Just like we did with the CSS file, we must also link our new JavaScript file. This link needs to be placed within the HTML document's code. This connection allows our web page to use the JavaScript we write. Let's close the Explorer panel now. We can do this by pressing the Ctrl and B keys together. To connect our JavaScript file, we must place the script link right before the closing body tag. This positioning ensures that all the HTML elements are fully loaded before the browser begins reading and executing our JavaScript code. To add the JavaScript file to our web page, we will use a script tag. We specifically need the script tag option that includes the source attribute. This source attribute is what points to our JavaScript file. The src attribute specifies the destination file we want to load. Since our index.js file is in the same folder as our HTML file, we simply write its name here. We have successfully linked our JavaScript file to the HTML document. This means we can now start writing and using JavaScript code in our project. We need to bring 4 different elements into our JavaScript code. These are the specific parts of our web page we want to control and update with our script. The first element we need to select is the button. We can see the button has an ID attribute. This ID is set to btn. Next, we need to get the image element. We also need to get the h3 tag for the character name. Finally, we need to target the entire anime container as well. For the button element, we create a constant called btn element. We use document.getElementById to search the document. We target the button by its ID, which is btn. This method allows us to get a reference to the button. We store that reference in our btn element variable. We use the getElementById method for a specific reason. This approach works because our button has an ID attribute. That ID is called btn. We can specifically target that button element by using the getElementById method. This method searches through the document for an element with the exact ID we provide. We have successfully retrieved the button element. It is now stored in our JavaScript variable. The next element we need to access is the main container for our anime content. We can target this container using its specific class name. I have copied this class name. Remember, this is a class selector, not an ID. First, we write down the name of the constant for the container element. We can call it anime container element. This constant will be equal to document.querySelector. We use querySelector because this element uses a class, not an ID. Since we are targeting a class, we need to add a dot before pasting the class name. We will use a dot before the class name anime container because we are targeting a class. This line of code will successfully grab that specific element from the page. It then stores that element inside our variable for later use. Next, we need to select the image element for our project. We can create a constant variable called AnimeImageElement. We assign this variable by using document.querySelector. Since we are targeting a class, we need to use a dot before the class name. The class we are looking for is called anime-img. The final element we need to select is the character name. We will target the element with the class anime name. I will now copy the class name for the anime name element. We create another constant variable for this element. Let us call this variable anime name element. This variable will be equal to document.querySelector. Since we are targeting a class, we add a dot before the class name. We type .anime-name to select the correct element. The first element we selected was the button. Since we were targeting an ID attribute, we used the getElementById method. This specific method does not require a dot or a hashtag symbol before the ID name. We did not add a dot for the ID or a hashtag for the class. We have successfully obtained all four of these essential elements. Each element is now stored within its own JavaScript variable. Now we need to add an event listener to this button element. This will allow us to respond when a user clicks on it. This function will fetch data from the API. It works just like the final version of our project. When we click the button, it activates a specific function. This function's job is to retrieve data from the API. It will then fetch the information we need for our project. We will now add an event listener to our button element. We accomplish this by using the addEventListener method. We are going to add an event listener to this button for the click event. This listener will trigger a specific function whenever the button is clicked. We will create a function for this event listener. This function will handle fetching our data from the API. Now, we are going to write the entire function from scratch. This function will call the API to fetch our data. It will retrieve the information we need for our project. Now, I want to show you the specific API we will be using for this project. Let's open up a web browser and search on Google. We will need to visit a specific website for our API. We need to search for a website called Catboys. Let's take a look at the Catboys API website. We are going to use an API called the Catboys API. To find the API documentation, search for Catboys API on Google. You will see a result for catboys.com. This website has a dedicated API section at catboys.com/zappy. Clicking on this link will take you to their API documentation page. This page displays all the different API endpoints they offer. For instance, we can use the Catboys API to get a random image. The base URL for this is api.catboys.com. We simply need to add a / and the word image to that address. This specific API endpoint will return a random image for our project. The API provides more than just an image. It also gives us the image URL and the artist name. Let me test this API directly in the browser to show you how it works. You can test this API directly in your own browser by clicking the Try It Now button. This will show you exactly how the API works. Notice how every time you refresh this page, you get a completely new image along with a different artist name. We want to use this URL for the image. We also want to use the artist name from the data. The URL we receive points directly to an image file. The artist field provides the name of that specific character. The great news about this website is that you do not need an API key. You also do not need any other special setup or authentication. We have learned about the API we will be using. Let us return to our code editor to continue building the project. To retrieve data from the API, we will use a JavaScript method called fetch. This fetch method is how we make a request to get the information we need. There is always a chance that the API might return an error. We need to be prepared to catch that error if it happens. JavaScript provides a powerful way to handle potential errors. We can use a specific method for this called try and catch. When you start typing the word try, you will see a suggestion appear. This suggestion is for the try-catch statement. If you select that option, you will see the code structure for a try and catch block. This structure helps you handle any potential errors gracefully. This structure helps us manage potential errors gracefully. We can catch any issues that occur during the API request. When we fetch data from an API, an error can occur. We use a try and catch block to handle this situation. This allows us to intercept the error and understand what went wrong. To get the data we need, we will create a constant called response. This response will be the result of fetching information from our chosen API. Let's look at the website for the API, which is catboys.com. The base URL we will use is api.catboys.com. We can copy the API base URL from the documentation. Then we paste it into our code. Adding a / and the word imgs to the end will give us the image endpoint. We will specify the endpoint as imgs to fetch an image. Let us continue with our code now. We need to transform that response into a JSON format. This conversion allows us to work with the data easily. Let us examine the final version again. When we click the button, we see a loading effect while waiting for the data. We need a way to show the user that we are waiting for the API to send back the data. This is where we can implement a loading indicator. We can achieve this by adding a loading effect while we wait for the response. We need to add an await keyword before fetching the data. This will pause the code execution until the data is received. Now let's write the word await. This keyword is very important for handling the API request. The await keyword will pause the code execution. It waits for the fetch operation to fully complete before moving on to the next line. To use the await keyword effectively, you need to make your function asynchronous. This is a specific rule in JavaScript you must follow. When you use the await keyword in your code, you must also declare your function as asynchronous. This is a fundamental rule of JavaScript that ensures your code waits properly for operations to complete. This function needs to be asynchronous because it contains an operation that requires waiting. We must pause the code execution until that specific operation completes successfully. This function now needs to be asynchronous because it contains an await keyword. The await keyword will pause the execution of the function on that specific line. It waits for the fetch operation to complete before moving on to the next line of code. We must wait for the API to respond with the data. This waiting ensures the image and name are ready before we display them. We also need to wait for the response to be converted into a JSON file. This conversion step is crucial for working with the data in our JavaScript code. Now that we have made the request and converted the response, we can access the data object. This data object contains the information we need from the API. Now I will create a constant variable to store the data. We will wait for the response from the fetch request. Then we convert that response into a JSON format. We do this by using the .json method. To convert the response data into a format we can use, we need to parse it as JSON. We do this by using the JSON method on the response object. This step is essential for accessing the data we receive from the API. This data is now ready for us to use. We can work with the information we received from the API. Let's test our code by logging the data to the console. Open your browser's developer tools by pressing the F12 key. Let's open up the browser's developer console now. We can do this by pressing the F12 key. Let's click on the Get Anime button now. We can see in the console that we have successfully received the data from the API. Let's check what we have by using console.log to see the data. We have successfully received the data from the API. The information is now available for us to use. This data provides us with the URL for the image we need. You can copy this URL and paste it into your browser's address bar. you will see that it leads to an image. Perfect. We have successfully received the data from the API. We can see the artist name for this image is listed as unknown. This happens when the API does not have the specific name available. The API provides us with the image URL and the artist's name. These two pieces of information are what we need to use. We will use the URL for the image and the artist name. Every time you click the button, it fetches a completely new and random image. If we paste the image URL now, it will show a different picture. This happens because the API provides a new random image each time we make a request. That fetch worked perfectly and returned the data we needed. We have successfully retrieved the data from the API. All the information we need is now stored inside this data variable. First, we need to change the container's display so it becomes visible. We need to make that container visible now. We will change its display property to block. This will make the container appear on the page. Let us now delete this console log statement. We do not need it anymore. We have successfully retrieved the data from the API. Now we can use this data to update our page elements. For example, we can update the anime image and name. The first thing we need to do is target the anime container element. We will change its display style property. We will now change the display style for the anime container. We need to set its display property to block. We are going to access the style property of the container element. Then, we will change its display property. We will update the container's display property. It will change from none to block. This makes the container visible on the page. Each time we click the Get Anime button, we will see the container appear. This happens because we wait for the API response to complete. Then we change the container's display from none to block. That change makes the container visible so we can see our results. Next, we need to update the displayed image. We will change the source of this image. The new image will come from the API data. Our goal is to change this displayed image. We want to set it to the new image we are getting from the API. This image information is located inside the data object we received. Next, we will update the source of our anime image element. We will set it to use the URL we received from the data. Each time you click the button, you receive a different image. Currently, we do not have a loading effect in place for these changes. Some images will load almost instantly on a fast connection. Others might take a little longer depending on your internet speed. The speed of loading varies significantly. It depends entirely on how fast your internet connection is at that moment. Now we can update the anime name element as well. Changing the anime name element is straightforward. We simply need to update its text content. We need to set the inner text of this element to the artist name we received from the API. We will now update the anime name element. We want to set its inner text to the artist name from our data object. This time, the name is unknown. The previous name was also unknown. However, these are actually two different characters. Each time we click the button, we receive a different character from the API. The name displayed will vary depending on which character is returned. We have successfully completed that functionality. The button now fetches and displays new data correctly. We can also catch any errors that might occur during the fetch process. We will use console.log to display the error details in the browser's console. This helps us understand what went wrong. In the final version of our project, we want to disable the button immediately after a click. This prevents the user from making multiple requests while waiting for the image to load. This prevents too many requests from being sent at once. We replace the image with a loading spinner. We also change the name text to say updating. This happens while we wait for the data to arrive. This is where we see the waiting indicator appear. It shows that our request is currently being processed. Before we start fetching the data, we can update the button's state. We should disable the button to prevent multiple clicks. We select the button element and modify its disabled property. We set this property to true to disable the button. We are going to disable the button by changing its disabled property to true. That makes sense because now when we click the button, it becomes disabled and cannot be clicked again. Let's test this by clicking the button now. You can see the button becomes disabled after we click it. The button is currently disabled. We want to re-enable it once the data fetching is complete. We can do this by setting the disabled property back to false. When we click the button, it becomes disabled immediately. This prevents multiple requests from being sent. Once the image and text data have loaded successfully, the button becomes enabled again. We will change the button's disabled state to true. We also want to update the text inside the button. We can set its inner text to show the word loading with 3 dots. When we click the button, we can see the loading text appear. This shows us that the request is in progress. The button now displays the loading text, but we must restore its original state afterward. We need to change it back to display the getAnime text. After we finish fetching the data, we change the button text back to getAnimes. This returns the button to its original state. When we click the button, it shows loading text. After the data is fetched successfully, the text changes back to getAnime. This ensures the user knows when the request is complete. When we click the button, you will see the loading text appear. After the data is successfully fetched, it will change back to the original text. I believe the concept is clear to you now. When we click the button, it shows a loading message. After the data is successfully fetched from the API, the button text changes back to getAnimes. You should now understand how this process works. We are setting up the loading state before making the API request. Then we wait for the data to arrive and update the interface accordingly. You should now understand the basic concept of how this loading functionality works. We have 2 await statements in our code. These await statements are very important for our loading functionality. They ensure our code waits for the API response before continuing. This is how we create the smooth loading effect. Before we make the API request, we add the loading indicators. After the data is received, we revert everything back to its normal state. That covers the basic structure of our loading effect. Let's apply the same loading effect to the image and the name elements as well. Let's handle the anime name element next. We want to update its text content. For the anime name element, we want to change its inner text. We will set it to say updating while we are waiting for the API response. You can see the name currently says unknown. This will change to updating when we are waiting for the API response. Let's focus on this specific part of the process. When we click the button, the text will change to say updating. This message will stay on the screen while we wait for the data to arrive. Now we need to implement a loading animation. This visual indicator will show users that the request is being processed. Let's find a loading spinner for our project. We can get one from a website called Loading.io. To find a loading spinner for your project, you can search for a website called Loading.io. This website offers a wide variety of free loading animations for you to use. Many of the loading icons are available for free. Some premium options do require payment. You can search through the available loading effects on their website. You can find many different icons and loading animations on this website. Most of them are available completely for free. I want to show you a specific loading animation for our example. The one I want to use is this circular spinner you see here. Let's choose this frozen color spinner for our loading effect. We will make the spinner appear smaller on the screen. We should also reduce its thickness a bit as well. I want the background to be completely transparent. Everything else about this loading spinner looks perfect. I will download the SVG file for this loading animation. This will give us a vector graphic that loads quickly. This website is completely free for you to use. You can download the loading animations without any cost. You can click on the SVG option first. Then you need to select the Animate feature. This action will download the animated version for you. You will see a free download option appear. Simply click on the download button to get the file. The file has downloaded successfully and is now ready for use. I have downloaded the spinner file successfully. The file is now ready for use in our project. I will drag the downloaded file directly into the editor. You should open the Explorer panel to see the file. Then we can paste the file's content right into our project directory. The spinner file has been successfully added to our project directory. This is just the code itself. That is why it loads so quickly. The great thing about SVG code is that it loads incredibly fast. SVG files offer excellent benefits for your website. They load incredibly fast for your users. This speed advantage makes them a great choice for loading animations. Next, we should give this file a more descriptive name. Let's rename the file to spinner.svg. Let's close the Explorer section now to keep our workspace tidy. we are going to set the source for our image element. We will set it to the URL we received from the data. While the data is loading, we temporarily show the spinner image instead of the final anime picture. This loading image appears in place of the actual data URL we are fetching. We will set the source to our spinner.svg file. This displays our loading animation while we wait for the API response. Let's test our website now. Each time you click the Get Anime button, you will see the loading spinner appear. The actual image will then load and display once the data has been fetched. Let's take a look at our project now and see how the loading effect works when we click the button. This is the standard approach developers use for loading effects. It creates a smooth user experience while data is being fetched. This approach uses the await keyword to pause the code execution. The program waits until the API response arrives before it continues. If you skip using the await keyword, the code will immediately send the request. It will then proceed directly to the next line of code without waiting for a response. Without the await keyword, the code would continue running immediately. It would not pause to display the loading effect. To properly handle this asynchronous operation, you must use the await keyword. You also need to declare the containing function as asynchronous. Before you send the request to the API, you should activate your loading effect. After the data has been successfully fetched, you will then take that information and display it on the page. We need to handle any errors that might occur during the fetch process. When an error happens, we should reset our interface back to its normal state. This ensures the user can try again without any issues. For instance, we will also change the button text back to its original state. We will update the anime name to display an error message. It will say an error occurred, and to please try again. Let me demonstrate what happens when an error occurs during the fetch request. Let us open the Web Developer Tools by pressing Ctrl-Shift-C. Then, we will navigate to the Network tab. Let's make our first request to the API now and see what happens. Let's open the Network tab in our Developer Tools. We can simulate a slow connection for testing purposes. You can even go completely offline to see how errors are handled. To demonstrate how error handling works, try switching to offline mode in your network settings. Then click the button to make a request. You will receive an error message because the browser cannot fetch data from the API without an internet connection. Look at the screen now. You can see an error message displayed. It says an error happened and asks you to try again. The button also returns to its original state. It now displays the text, Get Anime once more. This allows you to try the request again if needed. If an error happens, you can try again. Each time you get an error, the button will reset so you can make another attempt. Once you are connected to the internet again, you can make a new request and successfully retrieve an image. When an error occurs within your website, the try-catch block effectively captures that error. This allows you to display a helpful error message directly to your user. Your website can now effectively catch and display any errors that occur. This was the final step for our project. That brings us to the end of this project. I truly hope you enjoyed following along and learned some valuable new skills. This brings us to the conclusion of our website project. We have successfully implemented all the core features. We have successfully completed all the functionality for our website project. You have learned how to fetch data and handle loading states. This project covered many important JavaScript concepts. We learned how to fetch data from an API and use try-catch for error handling. We also implemented loading effects to improve the user experience. Finally, we dynamically changed the styles on the page using JavaScript. I hope you found this project enjoyable and educational. You have learned several important JavaScript concepts through practical application. I look forward to seeing you in our next tutorial. Welcome back to another exciting project. I'm thrilled you're here to follow along step by step as we build something fun and interactive. In this project, we're going to build a fully functional and visually appealing image slider. You can use it on your own websites. As you can see in the final version of the project, we have an image slider. It automatically changes images every few seconds. For example, every 5 seconds. This gives it a smooth, dynamic look. In addition to the automatic sliding, we also have 2 buttons here. One button allows you to go to the previous image, and the other button lets you move to the next image. When you click the previous button, the slider moves to the previous image. If you are already on the first image, it automatically loops around to the last image. Similarly, when we reach the last image and click the next button, the slider smoothly returns to the first image. This creates a continuous and smooth user experience. We've also added a very attractive box shadow and beautiful modern icons from Font Awesome. These elements enhance the overall design and make the slider look professional. In the next section, we will start building our project. We will create the HTML structure first. This structure will be the foundation for everything else. After we finish the HTML, we will move on to styling the slider using CSS. This will make it look visually appealing. Finally, we will implement all the functionality using JavaScript. This will ensure it works perfectly. Let's get started on the coding part. We'll begin building this interactive image slider step by step. I'll see you in the next section. Let's start building our image slider project. Let's start by opening Visual Studio Code. Let's close the Get Started tab now. From the File menu, let's choose Open Folder to start our new project. You can create this project wherever you prefer. I'm creating my project on the desktop. However, you can choose any location you prefer on your computer. Let's head over to the desktop. Then, let's click the button to create a new folder. We will name this folder Image Slider for our project. We hit the Enter key to confirm our folder name. Then, we click the Select Folders button. Let's close that Get Started tab once more. Then, in the Explorer section on the left, we will right-click and select New File. Let's create our HTML file. We'll name it index.html. On the right side, you'll see our index.html file. It's currently empty. We can use an exclamation mark to generate the basic HTML5 structure. We just type an exclamation mark. Then, we select the first suggestion that appears. A helpful tip is to use Alt-Z to enable word wrap. This makes all the code visible. Now, let's take a look at a document type declaration. This tells the browser which version of HTML this page uses. In this project, we're working with HTML5. Next, we have the HTML tag that wraps around both the head and body sections. The lang attribute specifies the language for the page. We are setting the language to English. Now, within the head tag, we have important metadata and the page title. This first meta tag sets the character encoding for the HTML document. This encoding is called UTF-8. It is the recommended standard for HTML5. This is a fantastic choice. It includes almost every character and symbol we might need. The next metadata tag tells Internet Explorer to use its most up-to-date rendering engine. The viewport metadata tells the browser how to manage the page's size. The first part of the meta tag tells the browser to make the page width match your device's screen width. This ensures the page width adjusts to fit any mobile screen perfectly. The second part sets the initial zoom level for the page. We are setting the initial zoom level to 100%. This ensures that the page appears at its normal size when first loaded. Let's discuss the title tag. This is where we set the title of our page. To see this title in action, let's open the browser. To see this in a browser, we can use the Live Preview extension that we installed earlier. To display the live preview, we right-click on the file. Then, we select Show Preview from the menu. You can now see the browser preview on the right. It shows the default title, document, generated from this line of code. Of course, we can change the title of our page right here. Let's update the title to Image Slider. This will be the name of our project. We can see the updated title here. Now, let's add a container in the body section for our images. We will call this container the slider container. We're going to create a new div element. We'll give it a class called slider container. We'll use the autosuggestion to create the div element. Let's close the Explorer panel. To do this, simply drag the divider to the left. Now, let's create another div inside this container. This div will hold all of our images. Let's give this div a class name of ImageContainer. Then, we'll press Enter to accept the suggestion. For the image source, we will use a service called Lorem Pixum. This service provides us with images without needing to sign up. It's powered by Unsplash, which means we can get high-quality images easily. Now let's open our web browser. We will search for Lorem Pixum. I just realized I forgot to include the letter S. Let's click on the link for pixum.photos. This is the website for Lorem Pixum. The great thing about this website is that you don't need to sign up to get images. It's powered by the Unsplash service. The best part about using this website is that you don't need to sign up. You also don't need to get any kind of API key. For example, if you need a random image that is 200 by 300 pixels, you can use this link format. Let's copy this URL and paste it into the address bar. You'll see a new image appear each time you do this. While that method provides a random image, I prefer to choose a specific image for our project. To select a specific image, we add an ID with a number. The website has a huge collection of thousands of images. If you browse through the list of images, you'll discover a vast collection. Each image has a unique ID number. For example, if you use ID 1, you'll see this image. If you use ID 10, you'll see this one, and so on. The website has a huge collection of thousands of images. Let's copy that link by pressing Ctrl+C. Then, let's head back to Visual Studio Code and paste it directly into the src attribute. Now, we can see the image appearing. For the alternative text section, we will simply write image. For sizing, we'll set the image width to 500 pixels and the height to 300 pixels. Then, we'll duplicate this line 3 more times to create a total of 4 images. The best part is that any image you add will automatically appear inside the slider. To duplicate this line, we'll hold down the Alt and Shift keys together. Then, we'll press the down arrow key 3 times. We have copied the image tag 3 times. However, all the images are currently the same. This is because we need to change their IDs. For the first image, we will keep ID 1. The second image will use ID 2. The third one will get ID 10. And the final one will use ID 20. This gives us 4 specific images that are not randomly selected. The key point is that refreshing the page will always show these exact same images. Next, we'll add something outside this div with the class image container. Next, let's add 2 arrow buttons for navigation. These buttons will help users move between images easily. To create our navigation arrows, we'll use icons from the Font Awesome website. These icons will help us make our image slider more interactive. If you're not familiar with it, Font Awesome is a popular icon library. It's widely used by developers. Let's open a new browser tab. We'll search for Font Awesome and visit their official website. Now, let's search for the word angle. The specific icon we need is the double angle. Let's use the double angle icons for our right and left arrows. These icons will help us create navigation buttons for our image slider. First, we locate the angled double right icon. We click on it to reveal the HTML tag. This tag includes the classes FAS and FA for Font Awesome. The FAS class represents Font Awesome Solid. The FA angled double right class specifies the particular icon. We copy this icon by simply clicking on it. Then, we return to Visual Studio Code to paste it outside the image container. We can't see the icons yet. We need to add a link to the Font Awesome CDN in the head of our document. Let's open a new tab and search for cdn.js to find that link. We search for Font Awesome in the search bar. Then, we click on the first result. Now, let's return to Visual Studio Code. We'll paste that link right before the closing head tag, just under the title. Now we can see the arrow icon appearing on the right. We can duplicate this tag by pressing Alt, Shift, and the down arrow. Then, we change the first icon to a left-pointing arrow. We now have both the left and right navigation arrows we need. To style these icons properly, we need to add some classes to them. This will help us customize their appearance and behavior. To select both icons at once, we'll hold down the Control key. Then, we'll add a class called btn to each icon. After that, we'll press Escape and add the class prev to the first button. Finally, we'll add the class next to the second button. That completes the HTML structure for our slider. Next, we'll use CSS to style our project. This will make the slider look much better. See you in the next section. In the previous section, we finished all the HTML work. Now, we're ready to start styling our project with CSS. Let's begin by creating a new CSS file. To open the File Explorer, you can press Ctrl-Shift-E. Let's right-click in this empty space. Then, we'll select New File. Let's name our new file style .css and press Enter to create it. Before we begin styling our project, we need to link our new CSS file to the HTML code. Let's go back to our index.html file. We'll add a new link tag right below the one for Font Awesome. This link tag connects our HTML file to the external style sheet. It tells the browser where to find the CSS file. The href attribute tells the browser where to find our CSS file. Since both our HTML and CSS files are in the same folder, we only need to type the file name. With our CSS file properly linked, we can start styling our project. Let's close the Explorer panel by dragging this divider line. Now, let's focus on writing our CSS code. Let's start by styling the container that holds all our slider content. Let's focus on styling the body. First, we'll make sure all the images are contained within their container. Before we style the body, let's first focus on the slider container. We'll set its width to 500 pixels to match our images. We'll also set its height to 300 pixels. Right now, we have the container, but the other images are still visible. We need to use overflow hidden to clip them. Now, only the first image is visible. The overflow hidden property has clipped the other images. These images extend beyond the container's boundaries. Let's now focus on styling the body element. First, we'll remove the default margin from the body element. Then, we'll apply display flex to center the container horizontally using Justify Content Center. We'll also set the page height to 100% of the viewport height. This means it will fill the entire height of your screen from top to bottom. We can now center the items vertically. We'll use the Align Item Center property to achieve this. Let's continue with the rest of our styling. First, let's update the background color to a base shade. Then, we'll continue styling the slider container by adding a border radius. Let's give our container rounded corners. We'll do this by setting the border radius to 10 pixels. Now, let's enhance our container with a box shadow. This will give it a nice, subtle shadow effect. First, we set the horizontal position of our box shadow to 0. The next value sets the vertical shadow position to 4 pixels. Following that, we have an 8-pixel blur radius. We then use a custom color with RGBA. We're using black for the shadow, but we want it to be partially transparent. To achieve this effect, we will use the RGBA color function. This function allows us to set the color and its transparency. To set the alpha value for opacity, we will use 0.3. This value represents 30% opacity. Let's press Alt and Z together to enable word wrap. This will make our code easier to read. And that wraps up the box shadow styling for our container. Now, let's turn our attention to styling the image container. We're going to use Flexbox for this. We'll set the display property to Flex. Our goal here is to line up the images in a row. You might be wondering why you can't see the other images right now. It's because we have a property called Overflow Hidden Active. This property is currently hiding the extra images that extend beyond the container's boundaries. Let's temporarily remove the Overflow Hidden property. This will allow us to see all our images. Now you can see all the images lined up side by side. This is because we're using display flex in our main container. With JavaScript, we will change the transform property. Specifically, we will use the translateX function. Let's test this by applying the transform translateX property right here. Notice that when we change the value to -500 pixels, which matches the image width, the next image becomes visible inside our container. If we set the value to 1000 pixels, we move to the third image. Add 500 pixels, we reach the final slide. For the actual functionality, we will use JavaScript. We can delete this test code and restore the overflow hidden property. With the overflow hidden property restored, we can now focus on positioning the arrow buttons. Now, let's focus on positioning the arrow buttons. We will target the btn class, which we previously added to both of our button icons. Next, we'll focus on the button class. we'll set its position to absolute. You can now see the icons inside the container. However, we need to adjust their absolute positioning. This adjustment should be relative to the parent slider container. To position these icons correctly within their parent container, we need to set the slider container's position to relative. This will allow the icons to be positioned absolutely within the container. After refreshing, you'll notice that the icons are now positioned inside the container. To position the icons vertically, we set the top property to 50%. This aligns the top edge of the icons with the middle of the container. Let's change the icon color to white. This will make them easier to see. Let's make the icons larger. We'll set the font size to 20 pixels. This will make them easier to see. The default font size is 16 pixels. This isn't quite what we want. You can see we've used top 50%. However, the icon isn't perfectly centered vertically. This is because the top edge of the icon aligns with the middle of the container. To perfectly center the icons vertically, we use the transform property. We set the translate y function to -50%. This ensures the icons are perfectly aligned in the middle of the container. Perfect. Now the icons are perfectly centered. We will make these icons semi-transparent by setting their opacity to 50%. Then, we will position the left and right buttons using their specific classes. Let's focus on the button class for both icons. First, we'll style the previous button. We'll set its left position to 10 pixels. Next, reposition the next button on the right side. We do this by setting its right property to 10 pixels. Now, you can see the left icon positioned 10 pixels from the left edge of its parent container. Similarly, the right icon is placed 10 pixels from the right edge. To make the buttons more interactive, we can change their opacity to fully opaque when you hover over them. We can also change the cursor to a pointer. When you hover your mouse over these icons, you'll notice the cursor changes. It transforms into a pointing hand. We used the Hover CSS pseudo class to target the hovering effect. We changed the opacity to 100% by setting it to 1. Now, when you hover over the icons, they become fully opaque. This makes them much clearer to see. And with that, we've completed all the CSS styling for our project. In the next section, we will bring our project to life. We will add JavaScript functionality to the icons. This will make the images change when you click them. We will also add a timer to make the images change automatically every 3 seconds. Let's move on to the next section. In the last section, we finished styling our entire project using CSS. Now, let's make our project interactive by adding functionality with JavaScript. Let's start by creating our JavaScript file. To access the File Explorer, you can press Ctrl+Shift+E on your keyboard. Next, we'll right-click to create a new file. We'll name this new file index.js and then press Enter. Let's move this file over here. This way, we can see the browser preview. We can now close the Explorer section. We are finished with it. To get our JavaScript working, we first need to link our JavaScript file to the HTML. Let's return to our index.html file. We'll add a script tag just before the closing body tag. To do this, type SC and select the second autocomplete option. This option includes the source attribute. Since both our HTML and JavaScript files are in the same folder, we can simply type index.js for the source attribute. With our JavaScript file now linked, we can start adding the functionality. Let's move on to our JavaScript file now. Let's start by targeting the Next button. In our index.html file, you'll notice 2 icons. These icons have classes named Preview and Next. Let's focus on the button with the class Next. Next, we'll add an event listener to this button. This will allow us to respond to user clicks. When a user clicks this button, it will show the next image. In our JavaScript file, we will target the Next button's class. We will create a constant named NextElement. We will use document.querySelector with the class selector .next. We will target the class by typing a period followed by next. To see our code working in real time, we can press Alt and Z together. This will allow us to view the changes instantly. With the Alt-Z shortcut enabled, we can now add an event listener to our next element. Now, let's add an event listener to our next button. We'll do this by typing nextElement.addEventListener. The addEventListener method attaches an event handler to an element. It requires two parameters. The first parameter is the event type. In our case, it's a click event. We write this as a string inside double quotes. The second parameter is a callback function. This function will run when the click event happens. We are going to create an arrow function here. This function will run when the button is clicked. When a user clicks the button, this arrow function will run. Inside these curly braces, we can write the code that will run. Let's create a variable to keep track of the current image. We'll start by setting it to 1. Since we're starting with the first image, each time you click, our current image counter will increase by 1. Each time the button is clicked, we increase the current image by 1. To keep our code organized, let's create a separate function. This function will be responsible for updating the image. We will call this function right here. Then, we will define it below. Let's create a function. We'll name it updateImage. As I mentioned earlier, we will use the transform translateX property to navigate between images. This property allows us to move the images horizontally. You can see in our CSS file, we have already styled the image container. For example, if we apply a transform translateX of -500 pixels, the next image will appear. To implement this in JavaScript, we first need to remove this line. First, we need to select the image container from our HTML file. Let's focus on the image container. We'll use the query selector method to target it. We'll create a constant called imageContainerElement. Now that we have access to this element, we can modify its style. This is similar to what we did earlier. Now, we can modify the styles. We'll write imageContainer.style. We'll set the transform property to translate X. The value will be -500 pixels. To display the third image, you would need to translate by 1000 pixels. It's worth mentioning that the way we style elements in JavaScript differs from how we do it in CSS. To create dynamic pixel values that match our current image index, we'll switch from using double quotes to a backtick string. Within that string, we'll use a $sign and curly braces to insert our calculation. This calculation will multiply the current image index by 500. However, if we test this now by clicking the button, we will see the third image instead of the second one. The reason we see the third image is because our current image index starts at 1. When we increment it, it becomes 2, and 2 multiplied by 500 gives us 1000 pixels. To resolve this, we can add parentheses and subtract 1 from the value. By default, the current image index is set to 1. This initial position corresponds to 0 pixels on our slider. This means that we are currently looking at the first image. When we click the next button, the current index changes to 2. Then, 2 minus 1 equals 1. Multiplying 1 by 500 gives us 500 pixels. We can click next multiple times. However, after the last image, we see nothing. This happens because we've moved beyond the available images. We need to ensure our current image index remains within the correct range. At the top of our function, we need to add a condition. This condition will check if the current image index exceeds the total number of images. To determine the total number of images, we need to select all of the image elements within our JavaScript code. To count all the images, we will use the document.querySelectorAll method. This method helps us gather all the image elements on the page. We will use the document.querySelectorAll method to select all of our image elements. This method collects all the image elements and stores them in this variable. To see what we've captured, let's log the images element to the console. To see the console output, we need to open the developer tools. You can do this by clicking the hamburger menu icon. Let's check the console to see if we have all 3 images. You might notice an error appearing in the console. We're seeing an error because our code isn't finished yet. Let's remove that console log line to avoid the error for now. Let's check the console log output. It confirms that we have successfully retrieved all 4 image elements. Let's remove that console log and add our condition back in. We need to check if the current image index goes beyond the total number of images we have. If the current image index goes beyond the total number of images, we need to reset it to the first image. we will reset the current image back to the first one. This creates a continuous loop. When you click Next, it eventually cycles back to the first image. Let's enhance the image transition with a smooth effect. This will create a smooth transition effect between images. Now, let's enhance the image container with a smooth transition effect. We'll apply a transition to the transform property we're using in our JavaScript code. We'll set the duration to 0.4 seconds and use an ease and out timing function. This will create a smooth and visually appealing transition between images. Now, when you click to the next image, you'll notice a smooth transition. When you reach the final image, it seamlessly loops back to the beginning. Now, let's add the same functionality to the previous button. Let's go back up and create a constant for the previous element. We'll use the query selector to target its class. We want to target the class named Preview. To do this, we use a dot followed by the class name. Next, we'll add an event listener to the previous button. This will allow us to handle click events. For the previous button, we need to perform the opposite action of the next button. We will decrease the current image index by 1. For the previous button, we will do the opposite. We will decrease the current image index by 1. For the previous button, we will decrease the current image index. Then, we will update the display. When we click the previous button from the first image, nothing happens visually. However, the code still decreases the image index. This means we need to adjust the display to show the very last image. For the previous button, we need to add an else if condition. This condition checks if the current image index is less than 1. If it is, we set the current image to the total number of images. This total number of images is the last image. This creates a continuous loop, just like the next button, but in reverse. This creates a continuous loop. We can go back to the last image and then forward to the first. Next, we will add an automatic slideshow feature. This feature will change the images every few seconds. To make the slideshow run automatically, we will use the setTimeout method. We use setTimeout to create a timer. This timer triggers a function once a specific amount of time has passed. This method requires 2 parameters. The first parameter is the function that will run. The second parameter is the delay time, measured in milliseconds. We set the timer for 3000 milliseconds, which is 3 seconds. We tell it to increase the current image index by 1. Then, it calls the updateImage function. This function call will then run the updateImage function we created earlier. When the code reaches this line, it calls the function. The function then proceeds to the timer. After 3 seconds, the function inside runs again. This increases the image index and creates a continuous loop. The problem occurs when you click the buttons quickly. This action causes multiple timers to start at the same time. To prevent multiple timers from accumulating, we need to reset the timer each time these buttons are clicked. To reset the timer, we can use a method called clearTimeout. First, we need to create a variable to store our timer. We will call this variable timeout. Then, we will assign the setTimeout function to this variable. This way, we can clear the timer later when needed. We will set that here by writing timeout inside the parentheses. We must also do this for the previous button. To reset the timer, we use the clearTimeout method. We pass in the timeout variable to this method. The automatic slideshow starts smoothly when the page loads. The timer resets whenever you click the next or previous buttons. This prevents any interruption to your navigation. Another great feature is that you can easily add more images to your project. Simply copy an existing image and change its ID. You can see that it automatically displays 5 images instead of 4. You can see the 5th image appear. The buttons continue to work perfectly. The best part is that you can easily add or remove images. The project will continue to work perfectly. This is because we dynamically calculate the total number of images. We don't use a fixed number like 4 or 5. That wraps up our project. I hope you enjoyed following along and building it step by step. I also hope you enjoyed the process and learned several new and useful concepts. These concepts can be applied in your future projects. Thank you for joining me today. I hope you found this project enjoyable and that you learned something new. I am looking forward to seeing you in our next project. There, we will continue to learn and create together. Welcome back to another creative project where we will build something interactive together. In this project, we are going to create a button ripple effect that adds a smooth animation whenever you hover over or click the button. If you look at the final version of our project, you'll see that when the cursor moves over the button, a ripple appears from the exact point where it touches, creating a beautiful visual effect. For example, if you move your mouse from the right side, the ripple will start from that side and gently spread across the button, giving it a lively and modern look. We'll be using JavaScript to detect the mouse position as it enters from different directions, and CSS to design and animate the ripple in a clean and stylish way. This simple combination of JavaScript and CSS allows us to create an elegant and professional effect that makes any button stand out. In the next section, we'll start building the HTML part of the project, so I'll see you there to begin coding step by step. Let's begin building our project together. Let's begin by opening Visual Studio Code and closing the Welcome tab. Next, we navigate to the File menu and select Open Folder. I'm going to create my project on the desktop, but feel free to choose any location you prefer on your computer. We will now click on the desktop and then select the New Folder button. Let's name this new folder Button Ripple Effect, which is our project name. We press the Enter key to confirm the name and then click the Select Folder button. Let's close that Get Started tab once more, and then over in the Explorer panel on the left, we'll create our HTML file. We will right-click and select the New File option. Let's name this file index.html and then press Enter. On the right side, we have our index.html file, which is currently empty, but we can generate an HTML5 boilerplate by simply typing an exclamation mark. We can simply type an exclamation mark and then select the first autosuggestion that appears. Our HTML5 boilerplate is ready, and the very first line is the document type declaration which informs the browser that this page is written in HTML5. Next, we have the HTML tag, which acts as the top-level container for the entire page and wraps both the head and body sections. Inside the HTML tag's opening tag, we have the lang attribute which we set to English. Inside the head section, we find important meta tags and the title tag for our page. The char set attribute in that first meta tag defines the character encoding, and we are setting it to UTF-8, which is the standard for HTML5 and supports nearly all characters and symbols. Next up, this meta tag instructs Internet Explorer to use its most modern rendering engine, called Edge. The viewport meta tag instructs the browser on page scaling, where the first part of the content attribute adjusts the page width to the device's screen, and the second part sets the initial zoom level to 100%. Let's press Alt and Z together to enable word wrap, making our code much easier to read, and then we'll find the title tag which sets the page title for the browser. To see a live preview of our website as we code, we can right-click on the file and select the Show Preview option from the Live Preview menu. You can now see our website preview on the right side, currently showing the default title, Documents. Let's update the page title to Button Ripple Effect, and we can collapse the Explorer panel on the left to give our preview more room. Inside the body, we will place a button that will center on the screen and later enhance with a ripple effect using CSS and JavaScript. For our button, we will use an anchor tag with the class BTM, set the href to a hashtag to prevent navigation, and place a span element inside with the text saying button. We are adding a span element here because it allows us to add a visual effect to the button while keeping the text visible on top by using z-index. We will explore the purpose of this span in detail when we add the visual effects, but for the moment, let's proceed by writing the code as shown. That wraps up our HTML setup, and we will move on to styling with CSS next. In our previous section, we successfully completed the HTML portion of our project. Now we are going to style our project using CSS. The next step involves creating a new CSS file. To open the File Explorer, you can press Ctrl, Shift, and E together. Then, in the Explorer panel on the left, we right-click and select the option for a new file. Let's name this file style.css and save it. To get our styles working, we first need to link our CSS file from within the HTML document. Let's return to the index.html file and insert a link tag right after the title tag. We will type link and then select the third autosuggestion, which is the one for CSS. We have successfully created a link that connects our HTML file to the external style sheet. The href attribute defines the link's destination, and since both our files are in the same folder, this path will work perfectly. Since both files are in the same folder, we just need to write style.css for the URL. With that link established, we can now use CSS in our project. Now we are ready to start styling our project with CSS. First, let's close the File Explorer panel on the left by dragging this divider bar all the way over, then save our work with Ctrl+S, navigate over to styles.css, and begin by styling the body section of our project. Next, we write the word body and then open a set of curly braces. Our first step is to remove the default margin from around the body element by setting it to 0. Our next goal is to center this button. To center the element horizontally, we use Display Flex along with Justify Content Center. To center it vertically, we can set the height to 100% of the viewport height, which will use the full screen from top to bottom. To center our items vertically, we can use the Align Items Center property. Now let's add a background color to our project. Let's set the background color to Alice Blue, which gives us a nice creamy base color. Let's update the font family for this button to use sans serif styling. Now that we have styled the body section, let's move on to styling our button. Our button has a class named btn, which means we can target it in our CSS using .btn. Let's begin by changing the button's background color to make it more visible. We will set the background color to pink and then adjust the padding, adding 20 pixels to the top and bottom and 40 pixels to the left and right. This larger button size will make the ripple effect much more visible later on. Let's make the border rounded by adding a border radius of 5 pixels, and we'll also add a box shadow to give the button some depth. The first value we set for the box shadow is 0, which controls the horizontal shadow. The second value controls the vertical position of the shadow, which we are setting to 4 pixels. This shadow appears at the bottom of the button. Next, we specify the blur radius by setting it to 8 pixels. Currently, the shadow color is blue, but we want to change it to black. To set the color with transparency, we can use the RGBA function. We set the red, green, and blue values all to 0 for a black color, and set the alpha to 0.3 for 30% transparency. And with those styles applied, our button is looking quite nice. Let's get rid of that line under the button text by setting the text decoration to none. Next, we will change the text color to black. That will work for our button for the time being. Next, we will add a hover effect and include an element that produces a ripple animation. To add this, we can use the before pseudo element for the content. First, we need to set the content for the pseudo elements to empty, and then we can position them absolute. Let's go ahead and set its position to absolute. For this element to be positioned absolute, its parent container needs to have relative positioning. Now we set the parent container to relative positioning, but the element remains invisible for the moment. Let's set the color to orange-red for this element, but we still cannot see it yet. Let's add a width of 20 pixels and a height of 20 pixels as well. Now we can see our element appear, and we want to position it in the center by setting the left and top properties to 50%. The reason we need this adjustment is because we position the edge of the element at the center rather than its true middle point. To perfectly center the element, we apply a transform translate with both x and y set to -50%. Next, we'll add a border radius of 50% to make this element a perfect circle, and we want this circle to grow in size when we hover over the button. To create this hover effect, we can simply target the button hover state. When we hover over the button, we can target the before pseudo element and set its width and height to 300 pixels. You can see the big circle appearing when we hover, but it extends beyond the button's edges, so we apply overflow hidden to clip the extra parts. Let's add overflow hidden to the button to prevent that extra part from showing. Now we have this visual effect, and to make the ripple animation smoother, we can add a transition that applies to both the width and height properties. We will set a transition duration of 0.5 seconds for both the width and height properties. We will set the height transition to half a second as well. As we hover over the button, we can now observe the ripple effect in action. Let's set the width and height back to 0 to hide this element. Now, whenever your mouse enters the button, you'll see this hover effect originate from the center, as we positioned it using the left and top properties. In the next section, we will use JavaScript to position the circle based on the mouse. Now we need to make sure the button text is on top. If you recall from earlier, we wrapped a button text in a span element. To target that span element specifically, now we need to target the span element inside our button by writing .btn followed by a space and then span. Before we can adjust the z-index, we first need to set the position to relative. The default z-index value is 0, so setting it to 1 brings the text above everything else. As you can see, the button text now appears on top of everything else. That wraps up everything we needed to do with CSS. Next, we will use JavaScript to make the ripple effect originate precisely from where your mouse enters the button. In the next section, we will explore the JavaScript portion of our project. In our previous section, we completed all the CSS work for our project. Let's bring our project to life by adding some JavaScript functionality. Let's start by creating a JavaScript file. Let's begin by opening the Explorer panel using the keyboard shortcut Ctrl-Shift-E. In the left-hand panel, we can right-click and select the New File option. Let's name this file index.js and hit the Enter key. We have created our index.js file, but we must connect it to our HTML before it can be used. Next, we will switch over to the index.html file and add a script tag right before the closing body section. We can simply type the letters SC and then choose the second autocomplete option, the one that provides the source attribute. The src attribute specifies the file we are linking to, and since both files are in the same folder, we can simply write index.js. Our JavaScript file is now properly connected and ready for use. Let's go ahead and close that Explorer section now. The main element we need to work with is this button. Our next step is to target this button within our JavaScript code, and we know the button uses the class btn. To select an element using its class, we will use the query selector method. We assign the button element to a variable using document.querySelector. We will type .btn inside these parentheses. Next, we will attach an event listener to this button to monitor mouse movements. So we just say btn element.add event listener, and the event we want to listen is mouseover, and when the mouseover happens, we want to trigger a function, and here inside this parentheses, we can get the event, which is the position of x and y, and anything inside related to this mouseover event. Let's use console.log to display the events page xValue. Now, if we open the browser's console and hover over the button, we will see a number appear. As we move the mouse, the numbers in the console will change. Notice how the numbers are smaller on the left and larger on the right, as the x-coordinate measures the distance from the left edge. We can also get the y position in a similar way. This value represents the vertical position from the top of the page. However, we need the exact position relative to the button itself, where the top left corner would be 0 for both x and y. To get the exact position inside the button, we need to subtract the button's offset from the top. For the vertical position, we can use the offset top property. Let's see what value we get for the button's position from the top. You can see the values starting from 0 and increasing as we move toward the bottom of the button. You can see at the very top, the value is almost 0, showing as -1, while at the bottom, it reads around 57. For the horizontal position, we need to subtract from the offset left property. For the x-coordinate, we would get a value near 1 on the left side, and a value around 125 on the far right. This approach allows us to set the starting point for the ripple effect to the exact location where the mouse enters the button, instead of having it always originate from the center. Unfortunately, you cannot directly access the before pseudo element with JavaScript because pseudo elements are not part of the actual DOM. However, what we can do instead is create a variable and then update its value using JavaScript. Inside this before pseudo element, we will create a custom variable for the x position and another one for the y position, which we can then modify using JavaScript's setProperty method. Now, we need to store these calculated values. Let's save this value as x, and we can copy this line to create a similar variable for y. Next, we target the style because we want to modify it using setProperty, and the specific property we change is xPosition written in double quotes. We assign this value to our xPosition variable and add the pixel unit since the value itself is just a number. We want to set the base unit for left and top as either pixels or percentage. We will now do exactly the same thing for the y position by using the styleSetProperty method and assigning it the value we calculated for y. Now, as we move our cursor anywhere over the button, we can see the ripple effect starting from that exact point. This means the ripple effect now originates precisely from your cursor position and expands outward in all directions. Let us test this out in our web browser. Let's open up our project in the web browser. Let's take a look at the result in the browser. That completes the functionality for our project. I truly hope you found this project enjoyable and informative. This cool button effect is something you can add to your own website. I look forward to seeing you in our next project together. Welcome back to another exciting project, and I'm happy to have you joining in for another fun and educational build. In this project, we're going to create the classic rock, paper, scissors game, where you'll compete against the computer in real time. As you can see from the final version of the project, we have 3 options to choose from: rock, paper, and scissors, all displayed clearly on the screen. For example, if we click on the rock symbol, we'll immediately see the result displayed, and in this case, it happens to be a tie between us and the computer. As you can see, when the result is a tie, the scores remain the same. For both the player and the computer, it stays at 0. At this point, our score is 0 and the computer's score is also 0, which means no one has taken the lead yet. If we make another choice, we might still end up with another tie depending on what the computer randomly picks. Now, in this round, we lost the game. As you can see, rock beats scissors because the computer's choice was rock and our choice was scissors, giving the computer a score of 1. If we continue playing the game, this time we manage to win, since rock beats scissors and our score increases accordingly. That's because our chosen symbol was rock, and the computer happened to select scissors, resulting in a clear win for us. We're going to start by creating this project using HTML to build the structure, then move on to CSS to add a clean, modern design, and finally use JavaScript to generate random computer choices and compare them with ours dynamically. We'll also display the game's results in text form and track the players' and computer scores at the bottom of the screen so you can see your progress as you play. So, in the next section, we're going to begin by writing the HTML structure that will serve as the foundation for our rock, paper, scissors game. See you in the next section, where we'll start building our project step by step. Welcome back to our rock, paper, scissors project. In this section, we will build the project's HTML structure. For reference, I have placed the final version of the project here on the screen. Looking at our finished version, you can see we have a title, 3 emoji options for rock, paper, and scissors, and the score display. Let's start by creating our main heading. Next up, we have a paragraph and a containing div for our 3 buttons. At the bottom of our layout, we have the score display. The very first step is to create our HTML file. I will create this project on my desktop. I will now navigate to my desktop to create a new folder. I will name this folder Rock, Paper, Scissors after our project. Once we have created the folder, you can simply right-click on it and select Open with Code to launch Visual Studio Code. I personally use Visual Studio Code as my favorite text editor, but you can absolutely use any editor you're comfortable with. Now that Visual Studio Code is open with our project folder ready, we can create a new file and name it index.html. Now that we have our empty file ready, we can quickly generate an HTML boilerplate by simply typing an exclamation mark. To quickly generate the HTML boilerplate, simply type an exclamation mark and select the first auto-suggestion that appears. Let me explain this boilerplate code quickly. If this is your first time working with HTML, the doc type declaration tells the browser which version of HTML we are using. Since we're using HTML5, having just the word HTML here is enough to tell the browser we're working with the latest version. Next, we have the HTML tag itself, which wraps around both the head and body sections. The language attribute specifies which language our page uses, and we're setting it to English with the value EN. Our first metadata tag defines the character set, and UTF-8 is recommended by HTML5 as it includes nearly every possible character and symbol. For instance, if a user visits the website and wants to see these specific symbols or fonts, they will be displayed correctly because UTF-8 covers nearly all common characters. Next up is the compatibility meta tag that ensures Internet Explorer uses its most modern rendering engine, Microsoft Edge. Next up is the viewport meta tag, which makes sure your website's width perfectly matches the screen of whatever device someone is using. For instance, a person viewing the website on a mobile phone will have a much smaller screen than someone using a tablet or desktop. The initial scale property sets the initial zoom level to 100%. Finally, we have our title tag, which currently displays as Documents in the Browser tab. To view our project in the browser, we will use a very helpful extension called Live Server. If you already have this installed, you can skip ahead. Otherwise, open your extensions panel with Ctrl+Shift+X and search for Live Server to find and install it. If you have not installed it yet, you can install this extension, which will create a local server for you. Once you have the Live Server extension installed, you can launch it by clicking the Go Live button or by right-clicking your file and selecting Open with Live Server, which will automatically open your site in the browser and refresh it every time you save your work, provided you have autosave enabled in Visual Studio Code. You can see the document title is currently displayed in the browser. Let's update the title to match our project name, Rock Paper Scissors Game. If we check the browser now, you will notice the title has updated to Rock Paper Scissors Game. Let's arrange our windows by placing the website preview on the right and Visual Studio Code on the left. Now let's add our main heading tag with the project name so you can see it appear on the website as Rock Paper Scissors Game. Now you can see our title is appearing on the page. Next, we will add a paragraph that prompts the user to choose their move. Next, we will create our 3 selection buttons. I am going to add the 3 buttons now. Here we have our 3 buttons for rock, paper, and scissors. Now, I want these buttons to appear side by side rather than stacked vertically. To align these buttons horizontally, I will place them inside a container and assign it a class called buttons. Now, you can simply type .buttons and press enter to create our first button container, and you might notice I'm getting a code suggestion from GitHub Copilot here. Just to let you know, GitHub Copilot does require a paid subscription. The good news for students is that you can get GitHub Copilot for free, and it will suggest code based on your previous work and common online patterns. This AI pair programmer uses GPT technology to provide real-time suggestions directly within your Visual Studio Code editor. Of course, using GitHub Copilot is completely optional for you. Feel free to type the code manually yourself. I am going to accept this suggestion for the 3 buttons. Let's assign an ID to each of these buttons. Instead of just using the word rock for the text, I want to use something called HTML entities. HTML entities are special codes that let you display symbols on your website. For the rock symbol, you would write this code. Let me zoom in so you can see the rock symbol emoji clearly, and for the paper emoji, we use this symbol. You need to add a semicolon at the end. For the scissors emoji, we use this HTML entity code. And with that simple method of using HTML entities, we now have our 3 emojis displayed. If you are not sure which symbol to use, you can always search online for HTML entities related to Rockhand, Paperhand, or similar terms. You can easily find websites online that display these symbols for you to copy and paste. Now that our buttons are in place, we will add a paragraph to display the game results. Next, I will create a paragraph with an ID of result and temporarily hard code the word U1 into it, followed by another paragraph with an ID of scores. Inside this paragraph, we will display your score. Let's create a paragraph for your score and assign it an ID. For example, we could call this player score or user score. Next, we will add the computer score by creating a span element with the ID of computer score. We will use these IDs later in our JavaScript to update the scores. For this stage, we are using these hard-coded values because we will focus on styling our elements with CSS in the next section. As you can see, we have now built the complete structure with our title, the Choose Your Move prompt, 3 selection buttons, and a score display for both you and the computer. That completes our HTML structure for the project. In our next section, we will use CSS to transform our project into a modern design. So see you in the next section. In our previous section, we successfully built the HTML structure. In this section, we will style our project with CSS to match the final version, adding a background color and custom colors for the emoji buttons. Our main goal is to center everything on the page, and the first step is to create a CSS file. Let's open our File Explorer and create a new file named style.css, then we will link it to our HTML file. Let's close that File Explorer panel for now. This link needs to go inside the head tag. To add the link, simply type link and select the third auto-suggestion for the CSS option, then set the href to style.css since both files are in the same directory. The href attribute should point to our style.css file, which defines the styling relationship. With that link in place, we can now use our CSS file to style the project. The first element we are going to style is the body section. In our HTML structure, the body element wraps around our entire project. First, we will target the body tag by simply typing body. Let's start by changing the background color. For the background color, I'm going with a light gray that uses the hex code F1, F1, F1. That's the light gray background color we're using. Next, we will set the font family for our text. Let's change the font for all our text using the font family property. For the font family, I want to use Arial. We should add a semicolon to complete this code. Let's add that semicolon we missed. For the font family, we are using Arial as our primary choice, with sans serif as the backup option. We also want to remove any default margin and padding from the page. This step will remove the default margin and padding. That completes the styling for the body section. Next up, we are going to style the main heading, the H1 tag. Let's move on to styling the main heading. For the heading, let's set a font size of 2 rem. The value 2 rem means we are doubling the default font size, which is typically 16 pixels. Let me adjust the zoom level so you can see the changes properly, then we'll center the heading with text align and add a top padding of 100 pixels. This padding will push our heading down a bit, and next we will style this paragraph. Now let's look at the first paragraph, which says, Choose your moves. We should also style the other paragraphs. Next, I'll select the paragraph tag and adjust the font size. We can see the suggestion that appears is acceptable. Next, we will set the font size to 1.2 rem. Next, we will center this text using text align center and then add a bottom margin of about 0.5 rem, which equals 8 pixels, to create some separation between the elements. Let's move forward by styling these buttons next. Let's start by targeting the div that has the class of buttons. Next, we will center all of the items. Next, we are going to target the div with the buttons class. To target this class, we simply write .buttons since the dot indicates we are selecting a class. To center the buttons horizontally, we will set the display property to flex and then use justify content center. We can remove this margin property here. Using justify content center, aligns all our items horizontally in the center of the container. The key point here is that you must set the display to flex in order to use Justify Content Center. Now let's focus on styling the individual buttons themselves. Now we need to target each individual button element. Let's remove the border from these buttons entirely. We will set the border property to none. Let's change the color for these buttons. Actually, let's skip changing the color for now. Let's set the font size to 3 rem to make these buttons much larger. This will make the emoji buttons much larger. Next, we should add some margin around these buttons. We will add a margin with 0 for top and bottom and 0.5 rem for left and right, which creates space between the buttons, and we also add padding of 0.5 rem. Right now, the padding is invisible, but it will become clearly visible once we add a background color. To make the interaction more intuitive, we can change the cursor to a pointer when hovering over these buttons. This gives us a pointing hand cursor on hover. Let's add a background color now so the changes become more visible. Let's add a temporary background color to these buttons so you can see the changes clearly. Next, we will make the corners rounded by setting the border radius to 5 pixels, and then we can create a hover effect for these buttons by using the hover pseudo class. For the hover effect, we can change the opacity to 80 or 70%. You can observe that when you hover over a button, its color becomes slightly lighter, creating a nice hover effect, although the change happens very quickly. Let's add some transitions so the effect looks much smoother. To create a smoother hover effect, I'll add a transition that lasts for 0.3 seconds with an ease in and ease out timing function. You can see the transition effect in action as you hover over the buttons. Now we are going to remove this single background color. Now I want to assign a different background color to each of these buttons. Next, let's target the rock button specifically and change its background color to red, which looks good, and then we will move on to style the paper button. Let's use blue for the paper button, which has the hex code 296F3, and then we'll give the scissors button a green color. As you can see, GitHub Copilot is providing code suggestions for us. Initially, I planned to avoid teaching with GitHub Copilot, but with AI advancing so rapidly, I believe it's essential to learn how to use these tools for faster coding. While AI assistants like GitHub Copilot can speed up your coding, it's crucial to understand the underlying code. For instance, let's understand what this code does and why we use the pound sign. For instance, we previously assigned an ID called rocks. We use the pound sign, also known as the hashtag, to specifically target the rock element. Understanding these concepts is important, but you can use this assistance to code more quickly as we now style the player scores for both user and computer. Let's set the user score color to green and make the computer score red. To target the user score, we use the pound sign followed by user score. Let's take a look at the color suggestions we get. The user score is now blue and the computer score is red. The colors look good for our scores. That completes all the styling for our final project version. Now we are ready to bring this project to life with JavaScript. You can see we are now able to select the different emoji options. For example, when we click the rock button, we can see our score being recorded right here. As you can see, your score and the computer score are displayed separately here. In our next section, we will dive into the JavaScript portion of the project. Our design is looking quite good at this stage. In our next section, we will bring the game to life using JavaScript by adding event listeners to the buttons and writing logic to calculate the winner, including creating a random computer move. We will compare that user decision with the computer's decision. We will then compare the user's decision with the computer's decision to determine the winner and update the score display. Stay tuned for the JavaScript part coming up next. Perfect. We just wrapped up the CSS portion of our project. Now, let's get into the JavaScript to make our game interactive. Our first step is creating a JavaScript file in our project folder. To get started, let's open the File Explorer by pressing Ctrl, Shift, and E. I'm going to create a new file called index.js, but feel free to name yours something like script.js instead. Just like we did with our CSS file, we need to link our new JavaScript file to the HTML document. However, Instead of placing our script in the head section, we need to put it right at the end of the body to ensure the file loads properly before we call its functions. If we don't do this, the JavaScript code won't be able to interact with our page elements. Our script tag is ready with the file name index.js in my case, and since both files are in the same directory, the source path is simple. All we need to do is type index.js into the src attribute. With our JavaScript file properly linked, we can now use the index.js file within our project. The very first step we need to take is to access these buttons. To proceed with our JavaScript functionality, we need to gain access to these buttons. Now these buttons all use the HTML button tag element. To target these buttons, we can use a method called querySelectorAll. Let's create a constant called buttons that targets all the button elements on the page using the querySelectorAll method. Perfect. We now have full access to all of our buttons. The next step is to add an event listener to each button. When we click on a button, we can trigger a specific function to run. Next, we use the forEach method on our buttons to individually target each one, as you can see from the code suggestion, and then we attach an event listener to every single button. The event listener we are going to implement is for the click event. When we click on the button, it will trigger a function. For example, we can start by logging a simple message like, "You clicked me," to the console. I also want to display exactly which button was clicked. Since each button has its own unique ID like rock, we can easily target the specific one that was clicked. We can simply log the button's ID here. However, I think this should be placed outside of this current function. Let me check what's happening with the console output. Let's open up the browser console by pressing the F12 key. Let's bring up the console panel at the bottom of the screen. Let me just move the console panel up a bit. Let's clear the console first to start fresh. Let's refresh our page and then click on the rock symbol. When I click on the rock button, the word rock should appear in the console. As we can see from the console, we are encountering an error. Let's take a closer look at this error because I think we might have missed a closing parenthesis somewhere in our code. That's the issue. We're missing a closing parenthesis right there. Perfect. Now when I click on the rock button, the console shows, "You clicked me rock." If I click on the paper or scissors hand sign, we get the same console message for each. Now that we can access the button IDs, we should create a function to compare our choice with the computer selection. The first thing we want to do is create a function that will handle the computer's play. You can see the Copilot is already providing suggestions. For the computer's move, we will create an array of choices containing rock, paper, and scissors. For this, we are going to use a random selection. We use the random method to generate a decimal number between 0 and 1, and we multiply that result by the length of our choices array. Just to clarify, arrays are zero-indexed in JavaScript, meaning the first item is at position 0, the second at position 1, and so on. This method will generate a random number between 0 and 2, which we can then use to select a choice from our array. For example, if the random number we calculated is 1, then we would get paper. If the number is 2, we get scissors, and if it's 0, we get rock. This method will return our random choice, and we use math.floor because the random number can be a decimal like 0.1 or 0.2, and we want to round it down to the nearest whole number. Now we have everything we need to calculate both the player's choice and the computer's choice. Now let's get this computer choice stored in a variable. Let's start by logging our choice to the console. Let's store our selection as the user choice and also log the computer's random choice to the console before we proceed to call this function. Let's refresh the page and test our progress by clicking the rock button. Now when I click on the rock button, we can see my choice is rock and the computer randomly selected paper. This means we now have a random computer selection every time we click a button. For example, if I choose scissors as my selection, you can see my user choice is scissors while the computer randomly selected rock. Now that our system is working, we need to compare these choices to determine the winner of each round. Now let's take this a step further and create another function to handle the game logic. Next, we will create a function called playRound, which will take in two different inputs. This function will receive two arguments, our selected choice and the computer's generated choice. Now let's format the function name using camel case. Let's go ahead and create that function now. I'm going to create this function called playRound, which will take both the player selection and the computer selection as parameters. I'm going to accept this suggestion from Copilot using the tab key. I'll simply press the tab key to accept that Copilot suggestion. For example, if both the player and the computer choose rock, the function will return that it is a tie. Now, if you choose rock and the computer picks scissors, or you choose paper and the computer picks rock, or you choose scissors and the computer picks paper, the function will return a "you win" message. This will display which option you selected, like rock for instance. For example, we can return a message saying rock beats scissors. For all other cases, the game will return a "you lose" message, showing that the computer's selection beats the player's choice. Let's run the code and see what results we get. Now we are calling the playRound function. Perfect, we are now receiving both inputs we need. We pass the button's ID that we clicked along with the computer's randomly generated choice. We pass both choices into this function to determine the winner, and then we return the result as text. This function will tell us if you won, lost, or if it's a tie. Let's go ahead and log that result to the console. Let's take the result we get from this function and log it to the console. Let's store the result in a variable and then log it to the console. Let's check the console to see what happens. Let me click on the rock button and we are getting an error that log is not defined. Let's refresh the page and see if that resolves the issue. Let me click on paper and I lost because paper beats rock, but the computer had rock while I had paper. Let me choose the paper button this time, and I lost because the computer chose rock, which beats paper. In this case, I chose rock while the computer selected paper, which is why I lost that round. Let me try clicking on scissors this time to see if I can win. It looks like we have a tie again for the second time. It seems like the computer has the upper hand right now. Let me try to win one this time. In this case, I chose scissors, and scissors beat paper. The computer randomly selected paper for its choice. Now we are successfully retrieving the game result and displaying it in the console log. However, I would prefer not to just log the result to the console. Instead of just logging to the console, I want to update this hard-coded result text here with our dynamic results section. Now that we have our playRound function working, we need to process its results. We return the result from this function here. Now that we have the result from our function call, let's display it on the page instead of just logging it to the console. Now I want to target that paragraph element with the ID of result and update its content. Next, I need to grab that paragraph element. Now I'm going to create a constant called result element that we can target using query selector and point it to our result element. Another option is to use the getElementById method and simply pass in the ID result. Perfect. Now we have access to the result element we need to update. Next, we can update the displayed result by setting the text content of our result element to the outcome we calculated. Setting the text content will update what is displayed inside that element. Let me demonstrate by choosing the rock option, which results in a loss since the computer selected paper and paper beats rock. Let me choose a different button, and this time it's a tie. Now I've made another selection and lost again. This confirms our functionality is working correctly. The problem is that we are not currently keeping track of the score. Right now, both the user and computer scores are starting at 0. The next step involves keeping track of the score. At this point, we are returning the game result text, but we still haven't implemented the actual score tracking for the player. Now I'll create two variables using let to track the scores, one for the player and one for the computer, which will update whenever either side wins a game. For instance, when we return a tie result, the score value should remain unchanged. In the case of a tie, the scores will remain unchanged, but if we win, we will increase the player's score by 1. The plus plus operator increases the value by 1. For example, if the current score is 1, it will increment to 2. This means the score will increase from 2 to 3. The plus plus operator increments the variable by 1, and if we lose the round, we will increase the computer score. Now that we are updating the scores in our code, we also need to update the numbers displayed on the screen. To update these scores on the screen, we need to grab those elements. We need to grab those two score elements next. Now I'll also grab these two score elements to update them. Next, I will create a constant variable. Next, we need to create a constant for the player score element, which has the ID of player score. Looking at the ID in our HTML, this element is actually called user scores. Let's update the variable name to userScore for consistency, and we can use the same getElementById method to target the computer score element. With these elements now stored in variables, with these elements selected, we can now update the displayed scores. Now that we are updating the scores, we can also change the displayed values here. Now we will update the player score by setting its text content, and then we do the same for the computer score. Let's test this out and see what happens. We update the text content to display the current computer score. Let's test this out now. As you can see, I lost that round, which means the computer's score increases by 1. Notice how the computer's score has increased to 1. Let me zoom in on this for better visibility. Let me click on scissors this time, and I win because scissors beats paper. If we get a tie, the scores remain unchanged. As you can see, the scores are updating with every click, allowing you to keep track of your progress throughout the game. If you want to start a completely new game, you can simply refresh the page to reset the scores back to 0. Let's go ahead and remove that hard-coded text from our result area. Let me remove this hard-coded text so the results area will be empty until we click a button and see the score changes appear. That concludes the creation of our project using JavaScript alongside HTML and CSS. In this section, you have learned how to access elements using methods like querySelectorAll for all buttons and getElementById for targeting specific IDs. We also set up two variables to track the player and computer scores. Next, we added an event listener to each button using the addEventListener method, which then calls our playRound function with both our selection and the computer's randomly generated choice. We created the playRound function to receive both our choice and the computer's choice, compare them, and then return a result of tie, lose, or win. We then updated both the player and computer scores by changing their text content. That concludes our work on the JavaScript functionality. I hope you found this tutorial both enjoyable and informative. I'd love to hear your thoughts on using GitHub Copilot to speed up project creation. Using GitHub Copilot has also helped me save time while teaching these projects. I'd love to hear your thoughts on whether I should continue using Copilot to speed things up, or if you'd prefer me to type everything from scratch instead. I look forward to seeing you in the next project. Welcome back to another exciting coding project, where we'll once again take a creative idea and turn it into something fully functional and visually appealing. In this tutorial, we're going to build a background image scroll effect that adds a dynamic sense of motion to your web page. When you look at the finished version of this project, you'll notice that our main website layout is very clean, minimal, and easy to follow. It includes a stunning background image, a bold title at the top, and a few sample paragraphs of text that give the page a complete and realistic look. As we scroll up or down through the content, you'll see the background image smoothly zoom in and out, while its opacity gradually changes, creating a modern and elegant scrolling effect. We achieve this effect by tracking the scroll position of the page using JavaScript, and then dynamically adjusting both the zoom scale and the transparency levels of the background image in real time. In the next section, we'll begin by writing the HTML structure that forms the base of our project. Then we'll move on to styling it beautifully with CSS, and finally, we'll add the interactive behavior at the end using JavaScript. Let's begin building our project together. First, let's open Visual Studio Code and close the Get Started tab. Let's go to the File menu and select Open Folder. As always, I prefer creating the project on my desktop, but feel free to choose any location on your computer. Let's click on the desktop and then press the New Folder button to create our new folder. Let's name the folder Background Image Scroll Effects to match our project name. After pressing Enter to confirm the name, click the Select Folder button to choose our new project folder. Let's close the Get Started tab once more, then right-click in the Explorer section on the left and select New File. Let's name this new file index.html and press Enter to confirm. With our index.html file open on the right side, completely empty, we type an exclamation point and press Tab to generate the HTML5 boilerplate. Let's type an exclamation point and select the first auto-suggestion that appears. We now have the HTML5 boilerplate ready. The first line is the doctype declaration, which tells the browser the version of HTML used on this page. Since we're using HTML5 for this project, we simply write HTML in that spot. Next comes the HTML tag, serving as the root element in our HTML5 document, which contains the head and body sections. Inside the opening HTML tag, the lang attribute tells the browser the main language for our page, which we set to English here. Since we're using English for our page, we simply place EN right there. The head section contains the metadata tags, along with the title tag. Inside the first meta tag, the charset attribute sets the character encoding for our HTML to UTF-8. HTML5 recommends UTF-8 because it supports almost every character and symbol users might see in our project. Next comes the compatibility meta tag, which instructs Internet Explorer to use its latest rendering engine, Edge. The viewport meta tag guides the browser in resizing the page for various devices. Let's press Alt and Z together to enable word wrap and see the full code. The content attribute in this viewport meta tag matches the page width to the device's screen and sets the initial zoom level to 100%. Next, we reach the title tag, which defines the page's title shown in the browser. To view a browser preview right inside Visual Studio Code, we can use the Live Preview extension. Let's right-click inside the editor and select the Show Preview option. The browser preview appears on the right side, showing an empty page with the default title, Document. Let's collapse the Explorer panel by dragging the divider line to the left. By doing this, we've created more space on the right side. Let's update the title to our project's name, Background Image Scroll Effect. Notice how the Browser tab now shows our project title clearly. And inside the body section, we add a div with a class named Background Image. Let's type BG image inside the body to create a div with the background image class and ID. This is currently an empty div that we'll style later using CSS to add a background image. For the moment, we'll keep the setup just like this. Next comes the main container where we place the website's text and title. To target the container class, let's simply type .container. Inside this container, we include an h1 tag for the heading. Let's simply greet visitors with "Welcome to our website." Following the h1 tag, we will add a paragraph containing some simple placeholder text. Let's copy this paragraph a couple of times to add more sample text. As we scroll through the page, you'll notice the smooth scroll effect taking place. We're creating a simple website here that everyone can use easily. This step isn't crucial for our project right now. The key element here is the background image, where we'll apply zoom and opacity effects using JavaScript. In the next part, we'll begin styling our project by adding a background image with CSS. I'm excited to continue with you in the next section for CSS styling. In the previous section, we completed the HTML structure for our project. In this section, we'll begin styling our project using CSS. To begin styling, let's create a new CSS file. Let's open the Explorer panel by pressing Ctrl+Shift+E, then right-click inside it on the left side and select New File. Let's name this new file style .css and then press Enter to create it. Before applying CSS to our project, we need to link the style sheet inside the HTML file. Let's switch back to the index.html file and add a link tag right after the title tag. Let's type link and select the third autocomplete suggestion for CSS. This link tag establishes the connection between our HTML file and the external style sheet. This href attribute points to the location of the CSS file, so since both files are in the same folder, we simply use style.css as the value. With the CSS file linked, we can start styling our project elements. Let's save this file by pressing Ctrl and S together. Let's close the Explorer panel by dragging the divider line to the left, creating more space on the right side. Let's switch to the style.css file and start styling the body element. To style the body element, we type body and then open curly braces. Let's start by removing the default margin around the body element, which clears away the extra space simply by setting it to 0. To improve the text's appearance, we change the font family to sans serif. We've now wrapped up the styling for the body element. Moving forward, we'll style the background image and the empty div. To add a background image to our element, we'll target it using the .bg image class. Let's begin by setting the height and width. We just set the width to 100% and the height to 100% of the viewport, so it fills the entire screen. You'll notice the div positioned at the top. Right now, it's completely empty, so let's add a background image to it. To add a background image, let's use the free photo site Unsplash. Let's open Google Chrome to search for the website. Let's search for Unsplash right in our new search bar. Looking at the search results, the first option is unsplash.com. Inside the search bar, let's enter a term like nature. Here, we can select one of these images. I've selected this serene ocean image for our background. Next, right-click on the image and select Copy Image Address. Let's switch back to Visual Studio Code and add the background property right here. Next, we use the URL function to include the external image. Let's add double quotes here and paste the link inside them. You can now see the image positioned clearly on the right side. However, we actually want this image to stay fixed at the top, even as we scroll down the page. First, let's set the background position to center. You'll notice the image centers perfectly, so we adjust the background. Let's set the background attachment to fixed, which is for having a constant position. Notice how the background now stays fixed in place, even as you scroll down the page. When scrolling down, all we need to do is zoom out the image and adjust its opacity. Before moving to JavaScript, let's style this H1 heading and these paragraphs to complete our layout. So, right here, the div that holds this element has the class container. Next, we'll target that element and increase its padding to 100 pixels, which pushes everything inside more evenly. Let's check this out in the browser to see it working. This setup works well for our current screen size, but let's add a media query to handle smaller devices. Next, we create a media query that triggers when the screen width reaches 500 pixels or less. When the screen is narrower than 500 pixels, let's reduce the dot container's padding to just 10 pixels. When the search bar expands, it looks much smoother and the image scales nicely just like this. Let's adjust the size of this heading for better visual appeal. So, we target each element and set its font size to 50 pixels. Take a look in the browser, and you'll notice the image has repeating effects at the top. Let's easily fix this by setting the background size to 160%, for instance. If you look at the browser, you'll see it's in zoom mode, and scrolling down zooms out the image. Later, we'll create a smooth zooming effect using JavaScript for better interaction. Let's simply update the paragraph's color to enhance its appearance. we set the color to gray for a subtle look. That wraps up the CSS styling for our project. Now, in the next part, let's add JavaScript to bring our project to life. Let's add a zooming and opacity effect that triggers as you scroll down the page. Let's move to the next section to explore the JavaScript part of our project. In the previous section, we completed the CSS styling for our project. We've added a background image and styled the main area of our website. In this part, we'll use JavaScript to bring interactivity to our project. First, let's create a JavaScript file by opening the Explorer panel with Ctrl+Shift+E. In the Explorer panel on the left, right-click inside it and select New File to create our JavaScript file. Let's name this new file index.js. Before we dive into JavaScript, let's link the file to our HTML inside the body tag. Let's switch back to the index.html file and add a script tag right at the end of the body section. Let's type sc and select the second suggestion, the one with the src attribute. Since both files are in the same folder, simply enter index.js for the source attribute. With the script file linked, we can begin adding JavaScript to our project. First, let's save the file by pressing Ctrl+S. Let's close the Explorer panel by dragging the divider line to the left, then switch to index.js to begin writing our JavaScript code. First, let's add this background image that you see right here. It features both a class and an ID named background image. You can use the getElementById method to select and return an element based on its unique ID attribute. Let's open our JavaScript file and create a constant named backgroundImageElement, assigning it the element from document.getElementById using the ID background image. Let's press Alt+Z to enable word wrap, so we can view all our code clearly, and then add an event listener to the window to track the scroll position as we scroll. Let's add an event listener to the window for the scroll event, so that when scrolling occurs, it triggers a function to update the image's size and opacity. So, let's create a function called updateImage and then call it right here. So, we simply name this function updateImage. In this image object, we target the background image element and adjust its opacity by accessing the style property. Let's set the initial opacity to 1 when the page is at the top, and then gradually decrease it as the user scrolls down. We can easily calculate the scroll position using the window.page y-offset property. Next, we divide this number by a large value like 800 to make it smaller than 1, then subtract it from 1. As you scroll down, notice how the number's opacity changes, so we'll use console log to output two values, the window's offset and 1 minus that offset divided by 800. Let's open the console by clicking the hamburger icon to access the DevTools pane, then switch to the console section. Now scroll down the page and watch how the window's y-offset starts around 2.79 while the opacity begins at 0.99. As you continue scrolling, the opacity decreases gradually until it reaches 0 at the bottom. At that point, the y-offset shows 837, which could turn negative. To prevent that, we can adjust the value to 900 instead. Keep in mind, this number might change based on your zoom level and screen size, but it won't impact the final effect. With the opacity now in place, let's carefully adjust the background size, starting from a large 160%. Target the background image element's style.backgroundSize property, then gradually decrease it from 160% using the window.page y-offset value. Remember to always add a % at the end since it is defined as a percentage value. As you scroll down the page, the background shrinks noticeably, but that number still feels too large, so divide it by 12 for a smoother and more balanced zoom level. Let's go ahead and test this scrolling effect in the Google Chrome browser. Notice how the zoom level reduces smoothly while scrolling down, and how the top area gains more opacity along with shifting zoom details. This wraps up our project very nicely and successfully. I truly hope you found it enjoyable and picked up some valuable and practical skills along the way. We styled the background image with CSS to fix it at the top, and also used JavaScript to dynamically alter both the opacity and size while scrolling. See you again in the next exciting project. Welcome back to another exciting web development tutorial. We have a fantastic project for you today. In this project, we will learn how to add a video background to a website. This will make your website look more dynamic and engaging. Let's take a look at the final version of our project. You will notice a title displayed prominently on the page. In this specific example, the title is my name. We also have a control button for the video. You can use this button to pause the background video. You can also use it to play the video again. We will use the Font Awesome website for our icons. We will grab the play and pause icons from their collection. We will also explore how to find free background videos online. We will use these videos for our project. Whenever you refresh the page, you will notice a preloader animation. It appears briefly before the main website content is ready. We will learn how to find free preloaders for our project. We will use JavaScript to make the preloader show up first. The preloader will be visible while the website is loading. Once the background video and the rest of the website have fully loaded, the preloader will fade away. Let us begin our project by building the structure with HTML. We will create the foundational elements for our web page first. I will see you in the next section, where we will begin the coding process. Let us begin our project by creating a new folder on the desktop. Let's launch Visual Studio Code. Then close the Welcome tab that appears by default. We navigate to the View menu at the top. We then click on the Explorer option. This action opens the File Explorer panel. Next, we choose to open a folder. We browse directly to the desktop location. Finally, we create a brand new folder there. Let's give the folder a name. We will call it Background Video Project. Now we will select this new folder we just created. We close the Welcome tab that appeared earlier. This gives us a clean workspace to focus on our project files. Now we will create our main web page file. We need to create an index.html file in this left panel. We perform a right-click in the Explorer area. We then select the option for a new file. We will name this new file index.html. To quickly generate the HTML boilerplate, type a single exclamation mark. Then select the first autocomplete suggestion that appears. Next, we will change the text inside the title tag. We will replace it with a name of our own choosing. For this example, I am using my name Sahand Gabidel. Next, we need to create a header section for our page. We will place this header inside the main body area. Now we add a heading tag inside the header area. We use an h1 tag for this purpose. Inside the h1 tag, we simply type our own name. Let's save our progress by pressing Ctrl and the S key together. We navigate back to the desktop screen. We open the folder we just created. Inside, we find and click on the index.html file. We can see the result in the browser now. Our name is displayed on the page. Now we can head back into our VS Code editor. We are going to add a video tag into our code. We will place it just above the h1 tag. For our background video, we will use a website called Pixels. This site offers free stock videos we can download. Let's open up a web browser. We will search for the website called Pixels. Let's navigate to the Pixels website in our browser. We click on the video section from the homepage. Let's search for a video using a keyword. For this example, we can type in the word time-lapse. For example, I will select this specific video. Then, we can click on the Free Downloads button. We save the downloaded video file to our computer. We then drag and drop that video file directly into the VS Code editor. We place it right inside our project folder. Let's give the file a more descriptive name. We will rename it to backgroundvideo.mp4. Next, navigate back to the index.html file. Inside the video element, we need to add a source attribute. We type in src and set it equal to the file name, which is backgroundvideo.mp4. We saved the file with our changes. Let's switch over to the web browser to see the result. We can close the Pixels website tab now. After refreshing our own web page, you will notice the video is displayed right there. Let's return to our code editor now. We are going to add a couple more attributes to our video element. Specifically, we will add the autoplay and loop attributes. We save the file with these new attributes. Next, we check the browser again and refresh the page. You can now see the video automatically playing, and it is set to loop continuously. Let's head back to our code editor now. We are ready to add some styling to make our page look better. We are going to create a new file now. We will name this file styles.css. Let's start by adding some basic styling to the body of our web page. Let's start by setting some basic styles for the body. We will set the margin and padding to 0. We will also set the font family to a sans serif type. We save the file, and then we open the index.html file. We add a link tag just below the title element. This link tag will connect our styles.css file. We will save the CSS file now. After saving, we can check the result in the web browser. Notice how before we refresh the page, there is a margin around the content. After refreshing, you can see that margin and padding are now completely gone. Let's add some custom styling to make our video look better. We will return to our code editor now. Let us navigate back to VS Code. Let's add a class to this video element. We will call this class background video. We save the file and then open the styles.css file. Next, we add the background video class just below the body styles. Next, we open a set of curly braces for our new style rule. We then set the position property to absolute. Next, we set the top property to 0. We also set the left property to 0 as well. Next, we change the width to 100% and the height to 100%. We save the CSS file and then open the browser. We refresh the web page to see the changes. You can see the video has become much smaller in size. Right now, the video only covers the top and bottom. We should make it stretch to fill the left and right sides as well. Let's return to our code editor. We will add the object_fit property to the background video class. We set its value to cover. After saving the file, we can check the result in the browser. You can see the video now fills the entire browser window completely. It covers all the available space from edge to edge. There is a problem with our layout. The heading is now positioned behind the video. The video is currently covering the text. We need to move the video behind the heading by adjusting its z-index property. Let's head back to our code editor now. We need to add a z-index property to this rule. Let's set the z-index value to -1. Every element starts with a default z-index value of 0. By setting the video's z-index to -1, it will now appear behind the h1 tag. The h1 tag remains at its default value of 0. Let's save our changes to the style sheet. Then we can go back to the browser and refresh the page to see the result. The heading is now positioned over the video. It appears correctly in front of the background. Let's reduce the brightness of the video. This will make it appear a little bit dimmer on the screen. Let's head back into our code editor now. Next, we add a CSS filter property to the video. We set the brightness value to 30%. Let us open the browser to see how the page looks now. You can see the video is now noticeably dimmer. This makes the background much darker. However, there is a new issue. The text in the heading is now very difficult to read against the dimmed video. Let's head back to our code editor now. We need to make some changes to the h1 tag. Let's add some styling to make the heading text look better. Moving down in our CSS file, we add a rule for the heading. We set the color property to white. Then we can save the file and check the results in the browser. You can see the heading text is now white. This makes it much easier to read. Let me demonstrate a helpful technique for changing the font. This method makes the process quite simple. To open the web developer tools, you can press the keys Ctrl, Shift, and C together on your keyboard. We move our cursor over to the Inspector tab and click on it. Then we click on the heading tag in the Elements panel. On the right side panel, we locate and click on the Font section. We can experiment with different font settings here. we can adjust the size and spacing to our preference. For example, we can adjust the letter spacing to our liking. We can also change the font size right here. We click on the Changes tab. From here, we can copy all the generated CSS rules. We head back to our code editor. We paste the new font styles directly into the H1 rule. We save the modified file with our new font styling. Then, we return to the browser to review our changes. After refreshing the browser, you can observe that the font has been successfully updated. Let's center the H1 tag on the page. We want to position it right in the middle. Let's return to our code editor. We need to add a header element around our heading. Let's add a header tag around our heading element. This will help us style and position it. We set the min height property to 100 viewport height units. We also set the display property to grid. Finally, we use the place items property with a value of center. We save the file and switch back to our browser. We then refresh the page to see the changes we just made. You can now see the heading is perfectly centered on the page. This gives our layout a much more balanced and professional look. Let's close the web developer tools now. We are finished making changes to the font. Next, we will add a button to the page. This button will let us pause and play our background video. Let's head back to our code editor now. We navigate back to the index.html file. Next, we add a button element to the page. We can style the button more easily by using Bootstrap. This framework provides ready-made button styles we can apply. Let's open up a web browser. We will search for Bootstrap to get the code we need. We need to get Bootstrap for our project. We can find it by visiting the official Bootstrap website. We click on the Get Started button. We then copy this code snippet. This is the Bootstrap CDN link we need. Let's copy this code to our clipboard. Let's go back to our VS Code editor. We will paste this Bootstrap link above our existing style sheet link. This means we can now use Bootstrap's pre-built styles in our project. These styles will help us create a professional-looking button. We will now add a class to this button element. We use the BTN class from Bootstrap for basic button styling. We also add the BTN secondary class to give it a gray color. Let's save the file now. Then we can check the result in the browser. Let us refresh the page to see the result. The button should now be visible on the screen. We can now see the gray button has appeared on the screen. To make our button more visually clear, we should add an icon that represents the play function. We need to find the Font Awesome website for icons. Let's open a new browser tab and search for it. We navigate to the Icons section on the website. We use the search function to look for a play icon. To get this icon, we simply click on the play icon. We then copy the generated code snippet. Finally, we paste that code directly inside our button element. You can see this creates a simple icon tag. It uses two classes, one for Font Awesome and one for the specific play icon. To use these font classes from Font Awesome, we must first include their Content Delivery Network link in our HTML document. Let's go back to our web browser. We need to find the Font Awesome Content Delivery Network. We will search for CDNJS. We navigate to the first website in our search results. Then we look for the Font Awesome link on that page. We click on the first result that appears. This will take us to the page where we can copy the link we need. We go back to the VS Code editor. We find the line with the Bootstrap link. We paste the new link directly below it. We save the file to apply the changes. Then we check the browser to see the updated icon. Let's refresh the page in the browser to see the change. The play icon should now be visible. Excellent. The play icon has now appeared on our button. If we want to switch this to a pause icon, the process is very simple. We just need to update the class name. Let's test this change inside VS Code. We will change the play icon to a pause icon. After saving the file, we can return to the browser. We need to refresh the page. You will now see the pause icon displayed correctly. Now we are ready to add JavaScript. This code will give us the ability to pause and play the video. It will also automatically change the button icon from a pause symbol to a play symbol. Let's begin by creating a new file in our project. We are going to name this file index.js. Next, navigate to the index.html file. Find a spot just below the closing header tag. You will add a new script element there. Click on the second autocomplete suggestion that appears. Inside the script tag, you will write the path index.js. Make sure you save your file now. This step is very important. Let's navigate to the index.js file. We're going to add a constant here. We declare a constant variable named btn. We set it equal to document.querySelector. Inside the parentheses, we write a string containing .btn. This refers to the class name we assigned to our button element. Let's look at our index.html file. Inside the button tag, you will see a class called btn. We can use the query selector right here. This lets us target the button. We do this by selecting its specific class name. Let's move on to the next step. We need to create another constant for our video element. We use document.querySelector again. This time, we target the class named background video. We copy the class name from our HTML file. We navigate back to the index.js file. We open a set of parentheses for our query selector. Inside the parentheses, we use double quotes. We type a dot and then paste the background video class. Next, we need to set up an event listener for our button. This will allow the button to respond when it is clicked. Next, we will add an event listener to our button. We write btn.addEventListener and open parentheses. This tells the browser to run a function whenever someone clicks the button. We need to create the function now. This function will contain our click handling logic. Looking at the index.html file, we can see the button tag. This tag has two classes assigned to it. The classes are btn and btn secondary. Our goal is to add a new class called pause to the button whenever a user clicks on it. Moving to the index.js file, we write a conditional check. This check looks to see if the button element has a specific CSS class. We use the class list that contains method for this purpose. Inside the parentheses, we type the word pause. This condition checks whether the button currently has the pause class. If it does, the code inside these curly braces will run. We open up a set of curly braces for our function. Inside them, we write btn.classList.remove and specify the pause class to be removed. Therefore, if the button already has the pause class, we want to remove it. This action will then trigger the video to start playing again. Next, we call the video.play method to resume video playback. Otherwise, if the pause class is not present on the button, we will add it. We do this by writing btn.classList.add and specifying the pause class. We also need to pause the video at the same time. Let's save our work now. We can check the results in the browser. Let us refresh the page and press the button. You can see the background video has been paused successfully. When we click the button once more, the video will resume playing in the background. The current button shows a pause icon. We need to change this to a play icon instead. Now we need to return to our code editor. Let's navigate back to Visual Studio Code. Next, we need to create a new constant variable for our icon. We create a new constant named font. Awesome. This constant is set equal to document.querySelector. We will use it to select the element with the class fa. We write document.querySelector with the class fa. Next, we write fa.classList.add. We also need to remove the play icon class. This class is called faPlay. We copy this line of code. We change the word add to remove. We also change the word pause to play. Now let's apply the opposite logic for the else part of our code. We proceed to copy these two lines. We paste them into the else section. We then change the first add to remove. We also change the second remove to add. Let's save our file now. We can then check the result in the browser to see the changes. Let's refresh the page now. When you click the button, you will notice the icon has changed to the play symbol. When we click the button one more time, the icon changes back to the pause symbol. Our next feature will be a preloader for the website. This preloader will show an animation while the main content is getting ready. Let's go back to our index.html file in VS Code. We will add a new div element just above the header tag. We need to give this div a class name of preloader. Next, we place an image element inside our div container. This image will be the visual content for that section. Our next step involves downloading a preloader animation. We need a simple GIF image for this purpose. Open your web browser and search for preloader icons on the icons8 website. Let's click on the link for icons8.com/preloaders. This website offers a wide variety of preloaders. You will find many excellent options that are free to use. You can see many different styles here. This colorful wheel is a good option. This animated flower is another excellent choice. For this tutorial, I will select the fidget spinner preloader. This particular one is a great choice. We proceed by clicking on this fidget spinner. We will change the background color to transparent. This will make the spinner appear without a colored box behind it. We can adjust the animation speed to our liking. We can also change the spinner size. Let's adjust the size setting to 100 pixels for our spinner. We click on the Generate button. After that, we can download the picture file. We save the downloaded file to our computer. We then drag this image file directly into our VS Code workspace. Let's rename this file to something more descriptive. We will call it preloader. Now let's head back to our main index.html file. Now we will add an image tag inside this div element. For the source attribute, we set the value to preloader.gif. We will set the alt attribute for this image to the word preloader. Let's save our file and check the result in the browser. We need to refresh the page to see the changes. As you can see, the preloader is now visible on the page. It is positioned on top of the entire website content. Let us add some custom styling to our preloader spinner. We want to make it look just right for our website. Let's navigate back to our VS Code editor now. We need to add some styles for our preloader. We open the styles.css file. We need to create a rule for the preloader. We write the selector and then open a set of curly braces. Inside these braces is where we will add our CSS styles. We start by setting the position property to fixed. This makes the preloader stay in a fixed spot on the screen. Then we set the top, left, right, and bottom properties all to 0. This stretches the preloader to cover the entire viewport. We write top:0. Then we write left:0. Next we write right:0. Finally, we write bottom:0. We will set the background color to white for a clean look. Next, we change the display property to grid. We then center the spinner perfectly by setting both the justify content and align items properties to center. We set the z-index property to a value of 1. This will place the preloader in front of all the other elements on the page. The goal is to have the spinner appear in front of the entire website initially. Once the website has finished loading completely, we will change its z-index to -2. This adjustment effectively moves the spinner behind all the website content. Let's make this transition smooth by setting its duration to 0.3 seconds. We will set the timing function to linear. Let's save the file and check our progress in the browser. When you refresh the page, you can see the preloader is currently visible. The next step is to add JavaScript. This code will hide the preloader by moving it behind the website content after everything has finished loading. Let us go back to the VS Code editor. Next, we navigate to the index.js file. We will add a new constant just below the existing one. We will name this constant preloader. We write document.querySelector. We use it to select the element with the class name preloader. Next, we add an event listener to the window object. We set the event type to be load. This event listener waits for the entire window to finish loading. Once that happens, it will trigger the function we just defined. We write a function to handle the loading event. This function sets the preloader's z-index property to -2. We save the file and open the browser again. We refresh the web page to see the changes. If you reload the page before everything is fully loaded, you will see the spinner appear. To see the preloader more clearly, we can open the browser's developer tools. Press Ctrl, Shift, and C on your keyboard. Inside the developer tools, find the Network tab. Within that tab, you can change the network speed to a slower option like GPRS. Let's refresh the page now. This action will show the preloader in action. Now you can see the preloader spinner much more clearly. This happens because we have slowed down the network speed. This simulation allows us to properly observe the loading animation. And that concludes our preloader implementation. We have successfully built a complete project. I truly hope you enjoyed following this project. I hope you learned something new and useful today. Your feedback on this video would be greatly appreciated. I hope you found it helpful and informative. Please keep an eye out for future updates with more content. I am actively working on more projects. You can expect to see them added very soon. Thank you for following along with this project. I look forward to our next session together. Welcome back. Today, we're diving into another exciting web development project. In this project, we're going to create a pop-up window. The background behind this pop-up will have a nice blur effect. Let's see what the final version of our project looks like. You can see our main website displayed here. It features a clean and straightforward design. The website showcases a background image and a title. It also features a prominent call to action button. The button text invites you to click and join. When we click the button, a pop-up window slides down from the top. It glides down gracefully with a smooth transition. At the same time, the background behind it becomes beautifully blurred. Inside the pop-up window, you'll see an email input field. There is also a join button for submission. Finally, you'll find a close icon in the top right corner. When we click the close icon, the pop-up window smoothly fades away. This action removes the blur effect from the main website. The background returns to its original, clear state. Let's see that in action one more time. Watch what happens when we click the button. Let's start building our project. Let's begin by creating the HTML structure for our project. We'll start with the basic HTML structure first. That brings us to the end of our introduction. Let's start building the HTML structure in the next section. Let's start our new project. We begin our project by opening up Visual Studio Code. Let's close the Get Started tab that appears when you first open Visual Studio Code. We can close the Get Started tab by clicking the small cross button. We go to the File menu. We select the Open Folder option. I will create this project in my desktop folder. You can choose any location you prefer on your computer. We head over to the desktop on our computer. We then create a new folder by clicking the New Folder button. Let's name our folder for this project. We will name this folder Blurred Background Pop-up. Let's press the Enter key to confirm the folder name. Now, let's click the Select Folder button to move forward. We close the Get Started tab again. On the left side, we can see the Explorer section. We will create a new HTML file in that location. Let's create a new file. To do this, right-click in the Explorer section. We then choose the New File option from the menu that appears. We will name this file index.html. This will be the main file for our project. After typing the name, we hit the Enter key. The index.html file is now open on the right side of the editor. The file is now open and ready for us to start writing our code. Let's quickly create the basic HTML structure. Simply type an exclamation mark in the file. This will create the standard HTML5 boilerplate code. This will generate the standard HTML5 structure. We type an exclamation mark on the keyboard. We then select the first auto-suggestion that appears. Alternatively, we can simply press the Tab key. We have our basic HTML structure ready. The very first line is the document type declaration. This line tells the browser which version of HTML we are using. For HTML5, the declaration is straightforward. We only need to include the word HTML in this declaration. Next, we have the HTML tag. This tag is the main structure for your entire file. It has two main sections within it. The main sections inside the HTML tag are the head and the body. Next, we see the language attribute inside the opening HTML tag. This attribute specifies the main language used for the page's content. Since our website's content is in English, we set the language attribute to EN. This tells the browser that the page is written in English. Next, we come across the head tag. This section is important for our web page. It contains meta tags and the title for the browser tab. It also contains the title tag, which is what you see in the browser tab. The first meta tag has a character set attribute. This attribute specifies the character set used for the HTML document. It tells the browser how to interpret and display the text. The UTF-8 encoding is highly recommended for HTML5. It supports a wide range of characters and symbols used globally. This ensures that users can read the website correctly. Next, we encounter the compatibility meta tag. This tag specifically instructs Internet Explorer. It tells the browser to use its most recent rendering engine. This ensures better compatibility with modern web standards. This viewport meta tag instructs the browser. It tells the browser how to control the page's dimensions and scaling. It tells the browser how to manage the page's size and zoom level. Let's press the Alt key and the letter Z at the same time. This action will enable the word wrap feature. It helps us see all the code without having to scroll horizontally. Inside the content attribute, we set two different values. The first value controls the page width. The second value controls the initial zoom level. First, we set the page width to match the device screen. This ensures the page fits the screen perfectly. This initial scale setting determines how much the browser zooms in or out. We are setting it to 100%. This means the page will display at its original size. The title tag determines the text that appears in the browser tab. To view our web page within the editor, we can add a helpful extension called Live Preview. This extension opens a browser panel directly inside Visual Studio Code. To see a live preview, right-click anywhere in the editor. Then, choose the Show Previews option from the menu. On the right side, you'll see our browser preview. The page is currently empty, displaying only the default title, Document. Let's update the title of our page. We will set the title to match our project name. Let's set the title to Blur Background Pop-up. You can now see the new title in the Browser tab. This confirms that our change has been successfully applied. Let's create more space for our workspace. Let's move this line to the left. We will start by creating two main sections within the body of our HTML document. The first section will have a class named Container. The second section will be our pop-up window. We'll give it a class called Pop-up Container. Our project is made up of two main parts. The first container displays the website's title and a call to action button. The button text invites users to click and join. The second container is our pop-up window. It will display a special offer and include an email input field. Additionally, it will have a separate button for submitting the email. The first container we created is named Container. You could also refer to it as the main container if you prefer. We will keep the name as Container for our project. This container features a main heading. This tag acts as the main title for our web page. Let's add a welcoming title to our page. We can write, "Welcome to our website" as the main heading. After the main heading, we add a call to action button. This button encourages visitors to join our website. Next, we will create a button element. We will give it a class named btn. Inside this button, we add the text. The text says, "Click to join." You can now see the button and title displayed in the browser. Following this main container, we have our pop-up window container. Next, we will create a new division. We will give this division a class called Pop-up Container. Inside this container, we will add a heading. This heading will announce our special offer. Next, we will create a label for the email input field. This label will clearly display the text, "Your email." Finally, we will add a button. This button will allow the user to click it. First, we'll add a heading that highlights our special 20% offer. Next, we will create a label for the email input field. This label will clearly display the text, "Your email." We create an input element for the email address. We set the type attribute to email. This ensures that users enter a proper email address. We add a class to the input to style it. We'll call this class input as well. we hit the Enter key on our keyboard. This action confirms the auto-suggested code snippet for the input field. We have successfully added our email input field. This input field is designed to accept email addresses only. It has the same name as the label, ensuring they are properly connected. We don't need to add an identification attribute to this element. You can now see the input field in our live preview. For the input field, we need to add some placeholder text. This text will appear inside the input box. It will guide the user to enter their email address. Following the label and input fields, we add a button element. This button will have a class name. The class name will be popup btn. The text inside this button will say, Join. We press the Enter key to accept the auto-suggestion. You can now see our button clearly on the screen. It has the class popup btn and shows the word Join. We've finished setting up the basic structure of our pop-up window. Next, we need to add a closing icon to our pop-up. This icon will allow users to easily dismiss the window. We need to find a way to show a close icon. The Font Awesome icon library is ideal for this. It provides the exact icon we need. Let's find Font Awesome by typing it into the search bar at the top. In the search results, we can see the official Font Awesome website. We can see various sections on their homepage. We need to click on the icon section to move forward. The website takes a moment to load. We are presented with a vast collection of icons to choose from. Font Awesome provides a vast library of over 7,000 icons. We can easily search for the specific Times icon we need. Let's use this particular Times icon for our close button. You will see the HTML code that you can copy. We have an I tag with two classes. The classes are FAS and FA Times. Let's go back to our Visual Studio Code editor. We will insert this tag into our pop-up container. Next, we will create a new section for the closing icon. We will give this section a class name. We will call it Close Icon. We will now place the icon code into our newly created Close Icon section. The Times icon is now positioned inside our pop-up container. We can't see the icon in our browser yet. We need to include a link to the Font Awesome library. This link must be placed inside our HTML code. We need to add this link to our HTML code. Let's go back to our browser now. Let's head over to our browser. We'll open a new tab and type cdn.js into the search bar. CDN.js is a content delivery network website. It hosts popular libraries and frameworks. For example, it provides Font Awesome and jQuery. It also includes many other useful web development tools. Website allows us to search for many different libraries. We head over to the website. Next, we find the search bar on the page. We type Font Awesome into the search bar to find its library. We find the first result for Font Awesome. We then scroll down the page a bit. We locate the copy icon and click on it. This action copies the link we need. We go back to our Visual Studio Code editor. We copy the link we just obtained and place it right after the title tag. Once we paste the link, the icon appears right away. We can now see the small X icon in our browser. Let's increase the size of that icon. We want it to be more noticeable and easier to see. To make the icon twice as large, we can add a special class for scaling. This class will increase the icon size by a factor of 2. To make the icon twice as large, we can add a specific class. This class is called 2x. It will double the icon size. You can find detailed instructions for sizing on the Font Awesome website. Their documentation provides clear examples for all available icon sizes. To adjust the icon size, you can use specific classes. For example, to double the size, you would use the class 2x. You can also use 3x to make the icon 3 times larger. You can scale the icon up to 9 times its original size. We have finished creating the HTML structure for our entire project. That wraps up the HTML part of our project. We will now move on to styling our project using CSS. We have just finished the HTML part of our project. Let's move on to the next part of our project. We'll create a new CSS file. This file will help us style our website. To open the File Explorer, you can press Ctrl, Shift, and E on your keyboard. Alternatively, you can go to the View menu and choose Explorer. Look to the left side of your screen. You'll see the Explorer section there. You can right-click on any empty space in this section. Let's select the New File option from the menu to continue. Let's name this file style.css. Let's press the Enter key to create the file. Before we can use our new style sheet, we need to link it to our HTML. This step is crucial for applying the styles to our web page. Let's return to our index.html file. We locate the link tag for Font Awesome. We will add our new CSS link right after the Font Awesome link. We will place this new link just before the closing head tag. We type the word link. Then, we choose the third option from the list that appears. This option is specifically for linking to a CSS file. Our CSS file is now properly linked and ready for use. Let's begin adding styles to our project. We'll start by writing the CSS code. Let's save our work. Press Ctrl and S together. Let's close the File Explorer panel. This will give us more space to work with our code. You can do this by dragging the divider line to the far left. This will give us more space on the right side for our work. Now, we're ready to start styling with CSS. Let's begin by focusing on the body section. Let's start by targeting the body element. We'll write the body selector. We start by opening a set of curly braces for our styles. Our primary aim here is to eliminate the default margin. Let's remove the default margin from the body element. This will eliminate the extra space around it. We'll set the margin to 0. This will eliminate all the default spacing around the edges. Notice how the space around our main container has disappeared. This container holds our heading and button. It now extends all the way to the edges of the screen. Let's start by styling the div with the container class. Since it's a class, we start its name with a dot. We create a CSS selector for the container class. We start with a dot to indicate it's a class. We start by opening curly braces for our container styles. Our first goal is to center the items perfectly. We want them to be perfectly centered both horizontally and vertically. To center our items horizontally, we'll change the display property to flex. This will arrange our items in a row. Notice how the button is now positioned right next to the heading. To address this layout issue, we can change the flex direction to column. This will stack the elements vertically. By default, flex items are arranged in a row. You can see that both items are now positioned side by side. When we change the direction to a column, the items will stack vertically. The first item will be positioned directly above the second item. Now, let's center our content horizontally using the Align Items property. This centers both elements perfectly along the main axis. Next, let's set the height of our main container. We want it to take up the full height of the screen. This will make sure our website stretches from top to bottom. We achieve this by setting the height to 100% of the viewport height. Notice how the pop-up section has shifted downwards. This happened because we set the container's height to match the full viewport. Now, let's use the Justify Content property. We'll set it to center. This will align our items perfectly along the vertical axis. Our items are now perfectly centered both horizontally and vertically. Let's enhance the visual design of our main container. We'll start by adding a background image to it. To find our background image, let's visit the website Unsplash. This site offers a wide range of high-quality images. You can use any image source you prefer for your own projects. This allows you to customize the look and feel of your website. Let's open our web browser. Let's open a new tab in our browser. Now, let's type Unsplash into the search bar. From the search results, we can click on the official Unsplash website. Let's find a background image on this website. For our example project, we will search for images related to computers. Let's imagine this website is for a tech company. This image seems perfect for our tech website. We select the image we want to use. Then, we right-click directly on the image. We choose the option labeled Copy Image Address from the menu. We click on the option that says Copy Image Address. Let's go back to Visual Studio Code now. Let's add a background to our container. We'll use a property called background. We will use the URL function to add the image link. We copy the URL and place it directly into our CSS property. The background image now appears behind our website content. Let's press the Alt and Z keys together to enable word wrap. This will help us see all the code clearly. Now, we can see that the background image isn't showing up correctly. We can fix that by changing the background size to cover. This will make the image fill the entire container area completely. That wraps up the styling for our main container. Let's move on to styling the heading and the button. Let's focus on styling this heading element. It holds the main title for our website. First, let's increase the size of the heading text. We want it to be much larger. We will also change its color to pure white. Let's choose a new font family for our heading. Finally, let's add a nice text shadow to our heading. This will give it a subtle yet elegant 3D effect. Let's start by making the heading text much larger. We'll set the font size to 60 pixels. Next, we will change the text color to a bright white. We can also center the text on the page. This will make sure the text is perfectly aligned in the middle. We have successfully changed the text color to white. Now, let's change the font family to Impact. This will give our heading a bold and modern appearance. We will also increase the space between each letter. We can increase the space between each letter in our heading by using the letter spacing property. We can set this value to 4 pixels. This will increase the visual space between each letter in our heading. Next, let's enhance the heading by adding a text shadow. The text shadow property has several components. The first value determines the horizontal position of the shadow. We set this value to 2 pixels. The second value determines the vertical position of the shadow. We will also set the vertical position of the shadow to 2 pixels. You can now see the shadow effect appearing behind the text. Let's enhance this text shadow with a blur effect. This will make the shadow's edges appear softer and more gradual. The third value in the text shadow property determines the blur effect. We will set the blur to 4 pixels. This will soften the edges of the shadow nicely. We don't want a simple white shadow for our text. Instead, we want the shadow to be black. We will use the RGBA function to set this color. This function allows us to define a color using red, green, blue, and alpha values. The alpha value controls the transparency of the color. We set the red, green, and blue color values to 0. This combination results in a solid black color. For the alpha channel, we set the value to 0.3. This provides 30% transparency, making the shadow slightly see-through. We have finished styling our main heading. It looks great now. Now, let's focus on styling our button. We have given this button a class name called BTN. Let's start by targeting this button for our styling. We'll use its class to do this. Let's start by adjusting the padding for our button. We'll add some space around the text inside the button. This will make it look better and be easier to click. We will set the padding to 10 pixels at the top and bottom. For the left and right sides, we will set the padding to 20 pixels. We set the button's width to 200 pixels. This change significantly increases the button's size. We also changed the cursor to a pointer. This makes it look like a hand when you hover over the button. We set the background color to a vibrant orange-red shade. Next, we will remove the default border from the button. This will give it a cleaner look. We'll round the corners of the button. We'll set the border radius to 5 pixels. This gives our button a nice rounded shape. Finally, we will make the text inside the button larger. We will set the font size to 20 pixels. This will make the button text easier to read. Let's add a nice hover effect to our button. This will make it more interactive. We can create a hover effect using the CSS hover pseudo class. This will allow us to change the button's appearance when a user hovers over it. We will use a filter to adjust the button's brightness. When you hover over the button, it becomes slightly brighter. Watch how the button reacts immediately when you hover over it. Let's view our website in the browser to see how it looks. The button now looks much more refined and attractive. It has a sleek design that catches the eye. The website is shaping up beautifully and has a very polished look. Next, we'll focus on styling the pop-up section of our website. We will enhance its appearance, making it look more refined and attractive. Right now, the pop-up is positioned at the bottom of the page. We want to place it right in the middle of the screen. We will position it in a fixed spot on the screen. We will also give it a white background. This will make the container much easier to see. Let's add a new class to this container element. We'll call it Active. When the active class is applied, we want the entire background to become blurred. This effect will make the background appear out of focus. We also want to make the background darker for a dimmed effect. We will check if the container has the active class applied. If it does, we will add a filter to create a blur effect. We set the blur to 5 pixels. This creates a soft, gentle look. We also reduce the brightness to 70%. This makes the background look a bit darker and blurry. That looks much better now. The blur effect on the background is quite noticeable. Let's reposition the pop-up window to the top of the screen. This makes it much easier to see. Before we begin styling the pop-up, let's make a quick adjustment to the main container. This adjustment will make the pop-up window much easier to see. Now, let's style the pop-up container. Let's start by setting its position to fixed. The element has vanished from view. You can't see it yet because we haven't set its position. Let's position the pop-up from the left edge at 50%. We cannot see it yet because it lacks a defined width. We will set the width of the container to 400 pixels. We will also set its height to 200 pixels. We will also position it 30% from the top. Now, the pop-up container is clearly visible against our main background. It now appears within the main content section of our website. We need to center it perfectly. Let's make sure it's aligned just right. The left 50% rule only aligns the container's left edge. To center it perfectly, we need to adjust its position further. We use the transform property to shift it back by half its own width. To perfectly center the pop-up container, we can use a transform property. This property will shift the element by -50% along the x-axis. This adjustment ensures that the container is perfectly aligned in the middle of the screen. Let's give our pop-up container a white background for now. This will make it easier to see. We will eventually change this to a background image. Let's proceed with styling this element. We will add the display flex property to this element. This will help us arrange the items inside it. By default, items are arranged next to each other in a row. We can change the flex direction to a column layout. This will stack the elements vertically. Let's add some padding to create space inside the pop-up container. This will make the content inside the container more comfortable to view. The padding adds a comfortable space inside the pop-up container. Next, let's find a background image for this element. We'll use an image that fits well with our project's theme. Let's return to our web browser. Let's go back to the Unsplash website. Let's scroll down a bit more to look at the available images. Let's choose this specific image for our example. Let's copy the image address from the website. Let's go back to your Visual Studio Code editor. We'll change the background property and use the URL function. Let's paste the image link we just copied inside the double quotes. We need to adjust the background size to cover this new image. This will ensure the image fills the entire container. We applied the same approach to our main background earlier. The pop-up container looks quite good at the moment. Next, let's style the headings. Let's give our container a rounded border. This will make the corners look nice and smooth. We can also add a box shadow to give it some depth. The first value in our box shadow determines its horizontal position. We set the horizontal position of the shadow to 0 pixels. The next value determines the vertical position of the shadow. We set the vertical position of the shadow to 4 pixels. The third value sets the blur radius for the shadow. This determines how soft or hard the shadow's edges appear. We use a 10-pixel blur for a soft effect. We then set the shadow's color and transparency. We use an RGBA value for a black color. This black color is set to 30% transparency. The overall layout looks good now. It's coming together nicely. Let's add the final details to these remaining elements. Let's start by styling the heading. We'll make it stand out and look great. We will adjust the font size to 30 pixels. We also need to add some space around it. Let's adjust the top and bottom margins. We'll set them to 10 pixels each. We will set the left and right margins to 0. Next, let's switch the font family to a sans serif style. Finally, we will change the text color to a shade of blue. This color choice is just an example for our demonstration. Let's style this label element next. We'll make it look consistent with the other text. Next, let's move on to styling the label element. We will change the color of the label to blue-violet. This color matches the heading. We will also use the same sans serif font family. This will help keep everything looking consistent. Let's proceed to style this button. We can make it look unique by adding some special styles. The button has a specific class assigned to it. That class is called Popup BTN. Let's focus on styling the button for the pop-up. We'll use its class name, which is Popup BTN, to target it. This button is styled in a similar way to the previous one we made. Let's change the background color to a bright orange-red shade. We will change the cursor to a pointer when you hover over the button. We can also add some padding around the button. This will make it look better. We will also increase the font size. This will make the text easier to read. Let's change the background color to a vibrant orange-red. We'll add some padding around the text. We'll use 10 pixels for this. This will create space inside the button. We increase the font size to 20 pixels. This makes the text easier to read. We also change the cursor to a pointer. This makes it look like a hand when you hover over the button. For this specific button, I want to add a border. The border will be 2 pixels wide and solid. The button now looks much better with its new styling. It has a vibrant orange-red background and a clear, defined outline. The text inside is larger and easier to read. Let's style the input field. This field has a class named input. We will add a solid border around it. The border will be 2 pixels wide. We will set the padding to 10 pixels. This will create space inside the input field. We also need to add some space between the input field and the button. We add a margin of 10 pixels to the top and bottom. We set the left and right margins to 0. This ensures the input field stays centered within the pop-up container. The final step for our input field is to adjust the font size. We also want to center the text inside the input field. Let's adjust the font size of the input field to 20 pixels. This will make the text larger and easier to read. This will make the text larger and perfectly centered. Let's make the placeholder text color lighter. We'll change it to a soft gray. This will make it easier to read. We can change this text to a lighter shade of gray. We will use the placeholder pseudo element to achieve this. We'll change the color to a light gray shade. This will make the placeholder text easier to read. Our final task is to position the times icon. We want it in the top right corner of the pop-up container. Let's focus on styling the close icon. We'll target this element specifically. We have given this icon a class name called closeIcon. We change its position to absolute. This action takes it out of the normal document flow. Now we can position it in the top right corner. The icon is now perfectly positioned where we want it. We should also make the cursor change to a pointer hand icon. This will provide a clear visual indicator that the element is clickable. When you hover over this icon, your cursor will change to a pointing hand. This visual cue lets you know that the icon is interactive. Next, we will use the hover pseudo class on the close icon. This will change its color when you move your mouse over it. We will change its color to the same vibrant orange-red we used earlier. We finished styling our close icon. We need to add the active class to the pop-up container. This will make the pop-up window appear. This action will not cause the background to blur. Instead, it will make the pop-up window disappear completely. Next, we need to set a condition for the pop-up container. We want to check if the active class is present on the main container. If it is, we will change the visibility property of the pop-up container to hidden. This will make the pop-up container completely disappear from view. We need to verify if the main container has the active class applied. We will change the visibility to hidden. This will make the pop-up disappear. That wraps up all the CSS styling for our project. We have successfully created the layout and appearance of our web page. We've now added 2 different active classes to our project. Each class serves a unique purpose in our design. The second active class hides the pop-up window completely. The first active class is added to the main container. It applies a blur effect to the background image. Next, we'll dive into JavaScript. We'll use it to make our buttons interactive. We will add the active class and remove it when needed. When someone clicks the main button, this will happen. It will also happen when you click the close icon. That concludes our CSS styling work. We've successfully designed the layout and appearance of our web page. Next, we will explore JavaScript. We will use it to make our buttons interactive. In the previous section, we finished all the CSS styling. Our project's visual design is now complete. We have added an active class to both the main website container and the pop-up container. When we add the active class to the main container, it creates a blur effect. When we remove the active class, the pop-up container becomes visible again. We will set the active class as the default state. This makes sure our website looks clear and sharp when you first visit it. By default, we want the pop-up container to stay hidden. This ensures our main website content is clear and visible. We will now use JavaScript to manage our active class. This will help us control when the pop-up window appears and disappears. This code will add or remove the active class from our HTML elements. It will make the pop-up window appear and disappear. Let's start by creating our JavaScript file for this project. Let's open the File Explorer. You can do this by pressing Ctrl, Shift, and E together. Let's move over to the left side of the screen. There, you'll find the Explorer panel. We will right-click on an empty area in that panel. Let's choose the New File option from the menu. Let's name our JavaScript file. We will name our JavaScript file index.js. To make our JavaScript work, we need to connect it to our HTML file. We do this by adding a script tag right before the closing body tag. To connect our JavaScript file, we need to add a special link inside the body section of our HTML file. Let's switch to the index.html file to do this. We will add a script tag right before the closing body tag. Let's type the letters S and C. Then, choose the second option from the list that pops up. This option includes the source attribute we need. It's the one that links to our JavaScript file. The src attribute tells the browser where to locate the file. Both our HTML and JavaScript files are located in the same folder. We simply need to type the file name. For the source attribute, we will simply type index.js. Our JavaScript file is now connected to our HTML. We can now start writing our interactive code. Let's close the File Explorer panel now. This will give us more space to work with our code. We can slide the divider to the left. This action provides us with more space to work on our code. Let's save our CSS file. Press Ctrl and S together. Let's open the index.js file now. Let's start adding functionality to our project. This is where we'll make things interactive. Let's start by selecting the important parts of our web page. We need to select these elements and make them available in our JavaScript code. We need to focus on this button icon. It's the one we want to interact with in our code. We need to monitor when a user clicks on it. Next, we need to focus on the main container. We need to focus on this container. We will be adding and removing the active class from it. We will add and remove the active class from it. This will control when the pop-up window appears and disappears. We also need to select the container for the pop-up window. We also need to select the close button. This button is the times icon inside our pop-up. To select elements by their class attribute, we use the document.querySelector method. This method is a fundamental tool in JavaScript. It allows us to target specific parts of our web page. It helps us select and interact with specific elements on our web page. Let's start by creating our first JavaScript variable. We will declare this variable using the const keyword. First, let's select the main container element. This is the main background area for our website. Let's define a constant for our main container element. We will name this variable container element. We will use the document.querySelector method to select elements. This method helps us find and select an element based on its class attribute. We are targeting the element with the class name container. Let's press the Alt key and the Z key together. This action turns on word wrap in the editor. It helps us see the entire line of code without scrolling. Next, we need to select the button element. This is the button we want to bring into our JavaScript. Let's focus on the button we need to add to our JavaScript. We need to select the button element by its class name. The button is assigned a class named btn. We define a constant named btn element. We use the document.querySelector method to select it. We specify the class name btn as the argument. Next, we need to select the container for our pop-up window. This container holds our modal dialog. Our pop-up window uses a specific class for styling. This class is named pop-up container. This is the part of our website that shows the pop-up message. Our pop-up window has a special class for its styling. This class is called pop-up container. We create a constant for the pop-up container element. We use the document.querySelector method. We target the class named pop-up container. Next, we need to focus on the close icon. This icon is crucial for allowing users to dismiss the pop-up window. This icon is assigned the class name close icon. We define a constant for the close icon element. We use the document.querySelector method to select it. We select the element with the class name close icon. We have successfully gathered all the elements we need. Next, we need to make this button interactive. We'll do this by adding an event listener to it. This will make the pop-up window appear on the screen. It will also cause the background image to blur. We have already saved our button as the btn element. Now let's add an event listener to this button. The addEventListener method needs two main pieces of information. The first parameter tells us which event we want to respond to. When you click this button, it will trigger an event. The second parameter is the function that will be executed when the button is clicked. Let's add the active class to the container element. This will trigger the blur effect on the background. We will use the classList property to manage the active class. Then, we use the add method on that property. We will add the class name active using the add method. The active class has been successfully added to the background container. This action also removes the active class from the pop-up container. We will use the classList property on our pop-up container element. We will call the remove method to take away the active class. This action reveals the pop-up window. Let's test this functionality now. Click the button to see if it works as expected. Next, we will add an event listener to the close icon. This will allow us to handle clicks on the icon. We will add a click event to the close icon using the addEventListener method. We will add a click event to this icon. This event will cause a function to run. The function will carry out the opposite action. We need to remove the active class from the main container. This will make the background clear again. Next, we need to add the active class to the pop-up container. This will make the pop-up window visible again. We can copy the code block for the close button event listener. Next, we need to reverse the actions inside the function. We will remove the active class from the main container and add it to the pop-up container. Let's test the functionality now. Click the button to open the pop-up window. We click the first button to activate the container. This action also removes the active class from the pop-up container. When we click the close icon, it removes the active class from the main container. This action makes the background clear and sharp again. This action makes the pop-up container visible again. It adds the active class to the pop-up container element. We want this transition to be smooth. We don't want the change to appear abruptly. Let's go back to our style sheet. Let's make some adjustments to the pop-up window's look. When the pop-up is active, its opacity should be set to 100%. We will now adjust the pop-up's position to 10% from the top. This change replaces the previous setting of 30%. For the pop-up container, We set its top position to 30%. We also set the opacity value to 0. We added a transition effect for all properties. This will make the changes happen smoothly over time. This transition takes 0.7 seconds to complete. We can observe the effect now. We made a mistake. We set the opacity to the wrong value. The pop-up should start invisible and become visible. The opacity value here should be set to 100%. When the pop-up is visible, its opacity should be set to 0. The transition is now working as expected. The pop-up window gracefully slides into view and smoothly fades away. The pop-up window smoothly slides down from the top of the screen. It begins completely see-through and gradually becomes fully visible. When we close the pop-up, it smoothly slides back up. As it moves back upwards, its transparency gradually decreases until it completely vanishes. We also want the blur effect to appear gradually. It should not suddenly appear when applied. Let's add a transition effect to the main container element. We apply this transition specifically to the filter effect. We want the blur effect to transition smoothly. It should not appear instantly when applied. We set the transition duration to 0.7 seconds. This transition effect works smoothly. You might notice that some browsers could show slight issues with this transition. You should test this transition in your main web browser. This will help you see how it looks and works best. The animation might look smoother in your main web browser. You can see the transition is now much smoother. Adding these transitions may require more of your computer's processing power. This could slightly affect the performance for the user. Adding transitions can increase the demand on a computer's processing power. This might slightly affect the performance for the user. For the best user experience, it's important to keep animations simple. This helps ensure that your website runs smoothly for all users. We've now added all the main features to our project. You've created an interactive pop-up window that works beautifully. I hope you found this project both enjoyable and educational. You've learned a lot and gained valuable skills through this project. That concludes our project for today. I'm excited to see you in our next coding tutorial. Welcome back. I'm thrilled to have you join me as we explore something both enjoyable and useful. Today, we're going to create a dynamic image feed that changes every time you interact with it. This is a fantastic way to learn how to work with images and buttons using JavaScript. When you see the final version of our project, you'll notice that 6 images are displayed right from the start. Every time you refresh the page, new random images will appear. This gives our website a fresh and dynamic feel. We've also included a useful button at the bottom of the page. With a simple click, this button fetches new images. It adds them to the website, making the feed feel alive and interactive. To get these images for free, we'll use a website called Lorem Pixum. This website offers a wide range of random placeholder images. These images are perfect for testing and designing. Let's not waste any more time. Let's move on to the next part. We'll start by building the HTML foundation for our project. Let's dive right in and start our project. Let's start our tutorial by opening Visual Studio Code. Let's start by closing the Get Started tab. Next, we'll go to the File menu and select Open Folder. For this tutorial, I'll create the project folder on my desktop. However, you can choose any location on your computer that you prefer. In this step, we'll choose the desktop. Then, we'll click the New Folder button to create our new folder. Let's name this new folder Random Photos to match our project. Once our folder is named Random Photos, we click here to select it. Let's close the Get Started tab again. Then, in the Explore section on the left, we'll create a new HTML file. To create the file, we right-click in the Explorer panel. Then, we select the New File option. We type the name index.html for the file and press Enter to confirm. You'll see our index.html file open on the right side. It's completely empty at the moment. In the next step, let's type an exclamation mark. This will help us generate the HTML5 boilerplate. To make the code easier to view, press Alt-Z to enable word wrap. Let's take a closer look at this HTML5 boilerplate. It includes a special tag called the doc type. This tag tells the browser that we are using HTML5. In our HTML5 setup, we add the HTML element right here. Next, we have the HTML tag. It is the main element in the HTML file. The lang attribute on the HTML tag specifies the main language of our web page. In this case, it's set to English. After the HTML tag, we add the head tag. Then, we include the body tag. Inside the head tag, you'll find 3 meta tags. There's also a title tag. The character encoding for our HTML page is set by the charset attribute. HTML5 recommends using UTF-8 because it supports nearly every character and symbol. Following that, this meta tag instructs Internet Explorer to use its most recent rendering engine. This engine is known as Microsoft Edge. This viewport meta tag helps the browser resize the page. The first part of it sets the page's width to match the device's screen. Imagine viewing the page on a mobile phone. The screen is smaller than a desktop's. This allows the page width to adjust perfectly. It fits the display nicely. The second part of this setting sets the initial zoom level to 100%. Following the meta tags, the title tag sets the name displayed in the Browser tab. To see our title in a browser view directly within Visual Studio Code, we'll use the Live Preview extension. To start the preview, right-click in the editor. Then, choose Show Preview from the Live Preview menu. On the right side, you'll see a preview window that looks like a browser. It shows an empty page with the default title, Document. Let's change the title to better fit our project. Let's close the Explorer panel first. Drag the edge line to the left. With the Explorer panel closed, we'll update the title to Random Photos. After updating the title, we can see Random Photos displayed in the Browser tab. Let's make the preview window smaller. In the body section, let's create a container. This container will hold all the images on our page. Let's name it Container for now. But to make it clearer, let's change it to Image Container instead. Let's select the auto suggestion to add a div. We'll give it the class Image Container. To get our random images, we'll use a website called Lorem Pixum. This website provides a wide range of random placeholder images. These images are perfect for testing and designing. Let's go to our desktop and open Google Chrome. In the search bar, we type Lorem Pixum and hit enter. I made a mistake. I forgot to include the letter S in Pixum. Looking at the top search result, we find the website called Pixum Bot Photos. You'll notice that the website is named Lorem Pixum. Let's click on this website. Once you explore the site's tutorial, you'll find it's quite easy to use. This link allows you to create a photo that is 200 pixels wide and 300 pixels tall. Go ahead and copy this link. Open a new tab in your browser. Paste the link there and press enter. You'll see a photo appear. Try pasting it again and you'll see a different photo appear. To generate a square photo, for example, a size of 200 by 200 pixels, simply use the bottom link. Let's copy this link and try it out in the browser. Every time you paste this link into the browser, you'll see a square image appear. You'll notice that if you repeat this link, it will always show the same image. Sometimes, the browser saves the image and shows the same one again. To prevent the browser showing the same image, add a query parameter to the end of the URL. For example, you can use random1, random2, or similar variations. This helps us get a different image every time. To show these images on our web page, we'll add image tags to our HTML. In this step, we'll copy 2 image tags and then return to Visual Studio Code. After pasting those links into the image tags, we see 2 different images appear in our preview. However, these images are currently too small for our needs. For our project, we want these images to be 300 by 300 pixels. There we go, now we have 2 images displayed correctly. Let's add another image to our page. In this step, we duplicate the previous line. We do this by pressing Alt, Shift, and the down arrow keys. To finish our set of 3 images, we change the number from 2 to 3. This change results in a total of 3 images. With our images set up inside the container, we'll add a button right after it. Let's add a button right after the container. We'll give it the class btn. Let's add the text load more inside this button element. Let's choose the auto suggestion to add the button text. We've created a button with the class btn. It displays the text load more. Later in this tutorial, we will make this button work with JavaScript. It will load more images from the website when you click it. Now that we've finished setting up our HTML, let's move on to the next part, styling our project with CSS. In the previous section, we finished setting up the HTML structure for our project. In this section, we'll enhance our project's appearance by adding CSS styles. Let's start by creating a CSS file to add styles. To open the Explorer panel, press Ctrl, Shift, and E together. Then, right-click on the left side and select New File. Let's name the file style.css and press Enter. Before we start styling with CSS, we need to link our CSS file to the HTML. This step is crucial for applying styles to our project. Let's go back to the index.html file. We'll add a link tag right below the title tag. Let's type link and choose the third option from the suggestions. Let's select the option that says CSS. We add a link tag to connect our HTML file to the external style sheet. The href attribute points to the linked file. Both the index.html and style.css files are in the same folder. With this link in place, we're all set to start styling our project with CSS. After saving this file, let's close the Explorer panel. To do this, simply drag the line to the left. Let's start by adding some style to the body of our page. Let's begin by typing body and then opening a set of curly braces. Let's begin by removing the default margin. We'll use margin 0 to do this. Next, we'll use display flex to align the items horizontally. You'll see that the button has moved to the right side. To reposition the item properly, let's set the flex direction to column. This will stack it vertically toward the bottom of the screen. In the next step, we'll center the items horizontally. We'll do this by applying the Align Item Center property. This will bring all the items to the middle of the screen. You can see the button has now centered itself. However, the images are still aligned to the left. To address this centering issue, we can adjust the image size. To center all the images properly, we'll use a simple CSS trick. We'll apply text alignment to the center of that class. This will ensure that all images are neatly centered within their container. Notice how, when we make the browser window larger, 2 images appear side by side. And if we make the window smaller, only 1 image will appear. You can see that this layout is already responsive. Now, let's focus on styling the images to make them look better. Next, let's set the background color for the body. Let's choose a nice color for the background. For the background, I'm going to choose a warm brown color. With the background now set, let's focus on styling the images. Let's begin by typing image container and then img. This selector is used to target the image tags within the image container class. With this selector in place, we can now add some space around the images. Let's set the margin to 20 pixels. It looks a bit too spacious, so let's reduce it to 10 pixels. In the next step, we'll round the corners of the images. We'll use the border radius property to do this. This will give the images a softer, more polished look. We'll add a border to the images. The border will be 10 pixels wide. Next, let's add a subtle shadow effect to the images. The box shadow property starts with the horizontal position of the shadow. We set the horizontal position of the shadow to 0, meaning there's no horizontal offset. Next, we set the vertical position of the shadow. For the vertical position, we set it to 4 pixels. This determines how far down the shadow will appear from the image. You'll see a dark shadow start to appear below the image. We can also set the blur value to 8 pixels. The final value here sets the color of our box shadow. To set the shadow color, we use the RGBA function. This function allows us to specify the color using red, green, blue, and alpha values. We set the red, green, and blue components to 0. This setting creates a black color for our shadow. The next component is alpha. It controls the transparency of the color. We set the alpha value to 0.3. This creates a transparency level of 30%. Let's move on to adding a background color to our images. We'll set the background color to a light gray. This will give the images a subtle backdrop. Right now, you won't see the background color. The reason is that we haven't set the width and height of the images yet. In the next step, we'll set the width to 300 pixels. We'll also set the height to 300 pixels. This background color serves as a placeholder. It appears if the image fails to load. This background also acts as a preloader, displaying while the images are loading. This effect is particularly noticeable when loading a large number of images simultaneously. With the images styled, let's move on to the button. We'll give it a fresh look to match our project. We already have the button placed here on the page. To style our button, we target its class name btn. Let's start by typing .btn to target the button class. Let's give our button a background color of slate blue. This will make it look nice and stand out. In this step, we'll get rid of the border completely. To achieve this, we'll set the border property to none. Next, we'll add some padding to the button. We'll set the padding to 10 pixels for the top and bottom. For the sides, we'll use 20 pixels. In the next step, let's add some margin to the button. Let's add some space around the button. We'll set the margin to 20 pixels. You'll see the button now has a margin added to it. In this step, let's change the text color to white. Let's add a subtle border to the button. This will give it a more defined look. To give the button rounded corners, we'll use the border radius property. This will make the button look more appealing and modern. We'll set the value to 5 pixels. This will give the button a subtle rounding effect. Let's also add a subtle box shadow to the button. This will give it a more polished look. For the horizontal position of the shadow, we set it to 0. We set the vertical position of the shadow to 4 pixels. We set the blur radius to 8 pixels. This helps to create a soft, diffuse shadow around the images. For the shadow color, we choose a plain black. We set the transparency level to 30%. In the next step, let's make the cursor change to a pointer. When you hover your mouse over the button, the cursor changes. It turns into a pointing hand. In the next step, let's add a hover effect. When you hover over the button, we'll make it slightly transparent. This effect is achieved by reducing its opacity. To create this effect, we'll reduce the button's opacity. We'll set it to 90%. You'll see a slight change in how the button looks. We have now finished styling our button. We've also completed the CSS styling for our project. In the next part, we'll make these images load dynamically. This means that the images will appear dynamically on the page. They will load and display as you interact with the button. Whenever you click the button, more images will appear on the page. This dynamic loading will take place directly on our website. In the next part, we'll start working on the JavaScript for our project. In the previous section, we finished styling our project with CSS. In this section, we'll make our project interactive by adding features with JavaScript. Let's start by adding an event listener to this button. Every time you click this button, new images will load from the Lorem Pixum website. With each click of the button, you can keep loading new images. Let's start by creating a new file for our JavaScript code. To create the JavaScript file, open the Explorer panel by pressing Ctrl+Shift+E. Then, right-click on the left side and select New File. Let's name the file index.js. Then press Enter to create it. To integrate JavaScript into our project, we need to link the file within the HTML code. Let's go back to our index.html file. We'll add a script tag right before the closing body tag. Let's type SC in the code. Then select the second autocomplete option. The src attribute tells the browser where to find our JavaScript file. Since both index.html and index.js are in the same folder, we just write index.js as the path. With this link in place, we've successfully integrated JavaScript into our project. Let's start by selecting the div with the image container class. We'll store it in a constant within our JavaScript file. This will let us add new images to it later. We'll use the createElement method to do this. To select elements by class, we need to use the query selector method. Let's move to the index.js file. We'll create a constant named image_container_element. We assign it by writing document.querySelector. This method selects the element using the CSS selector image container. Next, we'll use the same method to select the button. Press Alt+Z to enable word wrap. This will help you view the full code easily. Next, close the Explorer panel. This will give you a clearer display and more space in the browser. We need to select this button as well. It uses the class btn. We'll use the same method as before to select it. Let's create a constant named btn_element. We'll assign it using document.querySelector. We'll select the button by its class, which is .btn. With the button selected, let's add an event listener. We'll do this by writing btn_element.add_event_listener. The event we want to add is a click event. This means that whenever someone clicks the button, it will trigger a function. We will define this function right here. To verify that the event listener is functioning correctly, let's add a console log that displays the word clicked each time the button is pressed. In the next step, let's open the console. To do this, click the hamburger icon. Then, select the Developer Tools pane. With the console open, clicking the button will show clicked each time you press it. Now, let's create a function inside this event handler. We'll name it addNewImages. This function will add more images to our container. To create an image element inside this function, we use the createElement method. This method allows us to generate a new image element. We create a new image element using document.createElement. We specify img as the type. This is necessary because an image element needs a source attribute to load the image. For the source attribute, we'll use the same URL structure. However, we'll change the fixed number to generate a random one. Let's copy the original link and place it within backticks right here. With the link enclosed in backticks, we can generate a random number. In the next step, replace the fixed number 1 with a dynamic value. Add a $sign followed by curly braces. Then, generate a random number using math.random multiplied by 2000. This will give you a range from 0 up to that value. Keep in mind that the result needs rounding. This is because math.random produces decimals between 0 and 1. To round this number down correctly, we need to use the mathFloor function. This function takes the entire expression and rounds it down to the nearest whole number. This setup generates a number that ranges from 0 to 2000. With the image created and its source set, we now add it to the container. We do this by using the image container element we selected earlier. We call appendChild and pass the new image as the child. When you click the button, the addNewImages function is triggered. Right now, you'll see 3 images on the screen. When you click the Load More button, 1 more image will appear. Right now, clicking the button only adds 1 image. To load more images at once, we can use a loop. Let's create a loop to generate multiple images. I'll show you how by typing the word for and then selecting the for loop option from the autocomplete suggestions. This sets up a simple loop that starts with an index of 0. We'll adjust the condition to run it for the number of images we want. Before we set up the loop, let's declare a variable named ImageNum. we'll assign it a value of 10. In this example, we'll generate 10 images. We'll do this by placing the Add New Images function call inside a for loop. This loop will run the function that many times. With this change, clicking the Load More button will add 10 new images each time. Wait a moment, it's not functioning as we expected. The reason it's not working is that we declared this variable using let inside the function. This keeps it inaccessible from the loop. To fix this, we simply need to remove that let keyword. With that adjustment in place, clicking the Load More button will now add 10 new images each time. In the next step, let's increase the initial number of images. We'll set it to 6 for a better start. To achieve this, duplicate the line 3 more times. Use the Alt, Shift, and down arrow keys together to do this. In the next step, let's open our project in the browser. To do this, click the hamburger icon and select Open in Browser. Let me show you by closing the Explorer panel and making the window smaller. Once the page loads in the browser, you'll see 6 images right away. Each time you click the Load More button, 10 new images appear. These images are completely fresh each time, thanks to our random number generator. This generator picks a number between 0 and 2000, ensuring that the images are always different. Occasionally, you might see similar images. However, since the random number ranges from 1 to 2000, it's quite rare. We've finished our project successfully. I hope you enjoyed building this project and learned some valuable JavaScript skills along the way. Remember, every small step you take in coding brings you closer to mastering these concepts. This process also boosts your confidence. I'm really looking forward to seeing you in our next project. We'll explore even more fascinating techniques and challenges together. Keep exploring, stay curious, and let's keep growing together as developers. Let's tackle one project at a time.